Welcome to the next section of the course. In this section, we take a look at the concept of arrays. We'll discuss why you need to use them, and we'll take a look at how you declare them, how you store them, how you calculate with them, and how you display the results. Now, there are two types of arrays we're going to take a look at in this section. Today's lecture, we're going to focus in on one-dimensional arrays, and I'm going to do a little bit of doodling to show you the idea behind them and why you'd want to use them. Now, let's say we had a situation where we wanted to ask people their marks and then possibly rearrange the marks from highest to lowest, or maybe find the largest mark or the lowest mark, or find the average marks. Up until today, what we would usually do is, and remember, I want to know every mark. So I can't keep using one variable mark. I want to know what the first person's mark was and the second person's mark. So I would basically have some sort of input box or some sort of way to get information into the computer. And then maybe I would store the first person's mark into M1. And then I'd have to have another line and type in the second person's mark into M2. And if I had 100 people, I would need 100 lines, and each one of them would have to have a unique name in which I would refer to them. Now here's where arrays decided to make this more efficient. With arrays, what you do is you name them basically all the same. So you name them all M for marks. But then you end up referring to them with this square bracket. And you refer to the first person as mark 1 like this. You refer to the second person's mark as mark with a square bracket 2. And you're going, well, that's still going to take up a lot of lines. Well, no. Now, these numbers, we can get to them using loops. We can cycle through the computer by saying go from 1 to 100. So we'd have like a for loop. And then from here to there, we would basically be typing in M square bracket I, and we would be feeding them in with an input box. Now, obviously, I'm doodling right here, right now. We're going to get into the specifics in a second. But what's going to happen is now, by using this new technique called arrays, you're going to refer to the indexes, the numbers inside these square brackets, by using a for loop. So if you had 1,000 pieces of information you had to store in 1,000 marks, you would still only need 3 lines with an input, okay, as opposed to having 1,000 lines. So obviously you can see one of the main advantages why you want to use arrays is they're going to make our programs a lot shorter, humongously shorter. In a few lessons, I'm going to show you how to write a 3,000 line program the old-fashioned way in 3 or 4 lines. Okay, so arrays are really, really powerful. Now, when you use arrays inside the computer's memory, you have to sort of make a reservation. So when you make an array, they all sit beside each other. It's almost like you're at a restaurant and you make a reservation for 100 people. So you have all these sections in memory that are going to help you store the marks. There actually is going to be a mark 0, which we will never use. And then the other ones are 1, 2 to whatever. So when you declare a reservation for 10, you actually only are going to have 9 spaces because I don't want to use 0. Okay, so that's the basic idea. Now we're going to talk more specifics about actually how you program them. Okay, what I've done is I've loaded in the demo for this lecture, and just to make sure you realize which one you should load in, you should have unzipped the demos for today's lecture, and inside of the demos there's one called Simple Array Intro, and that's the one I have now loaded up. And there are a number of ways to work with one-dimensional arrays. I'm going to show you 4 techniques. The last 2 are the ones that we're going to use the most, but they all are good ways to work with arrays. Now, let me just right away go into the underground and show you the code right off the bat. So as I mentioned briefly in the introduction, when you work with arrays, you have to tell the computer ahead of time how many spots to leave in memory. You just can't start using them. Okay, and the way that you declare to the computer that you need an array is you say the type of array it is, then you use that square bracket. So that's going to be our special array sort of symbol. Then you make up a name, and then you say new. Hey, that's that object-oriented stuff we did. Yeah, new, and then string, and then how many spots you want to leave. Now remember, when you say 6, you do leave 6 spots in the computer, but remember the first one's 0, and then 1, and then 2, and then 3, and then 4, and then 5. Now for our purposes, like I said, I don't want to use that one. So when you say 6, you're really going to only leave room for 5 people at this restaurant or whatever you're making a reservation at, okay? Kind of a stupid analogy, but I'm going to try to use that to get you thinking the right way. Okay, so this array right here is going to hold student names, okay? And I'll just short form it for a second. So these are going to hold words. This second array is going to hold the corresponding marks for those students. So again, it's going to have 5 spaces, okay? 0 to 5, okay? We're only going to use 1 to 5. Now, this first technique to feed the information into this array is just to use direct assignment statements. And what that means is basically you hand type in physically who you want to go into that first spot in memory. So Mary is going to go into this spot right here, and then her mark, 80, is going to go in there. All right, and this is how we're going to fill up the entire array, all the way to Peter at the end, who's going to be the 5th person, and his mark is a 45. Okay, now once you do that, once you do the filling up of the array, the rest of it becomes really easy and short. And this is the beauty of arrays, that you could have 10 million things. Once you feed them into the computer's memory, everything after that is a loop. Okay, and the favorite loop that we're going to use is what's going to be called a for loop. And we're going to start from 1 and go all the way to 5 by ones. And all this one does is feed a list box the final result of this information. And I'll just run it for you very quickly. Again, it's not anything spectacular, but it's just a theory right now of how to work with these different concepts. So when I press here, all that's going to happen is it's going to show us what all these people are and their marks. The second technique, again, we're not going to use that often. It's called direct instantiation, but it does get used once in a while, and I'll click it from here to show you. Okay, it's kind of a neat way too, but not used that often. Here what we're doing is, again, we're declaring the array, but this time instead of having the other side say new whatever, we're going to put the values in right away. And remember, we don't use 0, so you notice those 2 little quotes means there's nobody that lives in the first one, and which is 0 actually. And then the array number 1 is Mary, 2 is Jim, all the way to Peter, who is 5. And same with the marks, okay? So this one's called direct instantiation, and then we display the results again. And again, I'll show it to you very quickly. It does exactly the same thing. Okay, the next 2 are your bread and butter, inputs and data files. Let's start off with input, okay? And with an input, what makes this so cool is that you don't know ahead of time how many people you have. So you're not locked down. But because you don't know how many people you have ahead of time, what kind of a reservation can you make? Well, you're going to have to make extra spaces. And you might only get 10 people to show up. So you've wasted some tables, you've wasted a bit of memory, but don't worry about it, okay? There are other techniques that make it grow dynamically, but for now, because this is an introductory course, we're just going to go this way. So this is going to leave room for up to 100, well, actually 99, right? So 0 all the way to 99. Okay, so we're going to go from 1 to 99. So there's enough room for up to 99 people. If this was a class, you wouldn't have that many in a class. Okay, same with student marks. So we're declaring 2 arrays. Okay, they're going to go from 0 to 99. Remember, these numbers are called the indexes. That's not what's in them. What's in them is what gets assigned to them. Okay, so now, how do you make a program that works for any possible combination of marks? Well, you have to use a while loop. And it's a loop that goes on forever. And right off the bat, you ask the person, do you want to keep doing this? If they say no, we stop. So now we've seen this before, right? Next thing we do is we ask for their mark and their name. But we do a bit of dummy proofing. So before we let them actually go into the array, where it's almost like you're at a bar and there's a bouncer at the front and he's saying, okay, do I like you or not? So when the person types in a mark, the bouncer says, hey, do I like you? I like you if you're between 0 and 100. If you're like -7, you're being an idiot and I'm not going to let you in. Now, once I like you, I'm going to say you can come in, you're number 1. And I take those temporary names and marks and I feed them into the actual array. So I've got this gigantic array, okay? It has 0 there, it has 1 there. So if the counter is now 1. So we've got our first person. And we're going to feed that person. Remember, the stuff on the right always goes into the stuff on the left. So we're going to feed that person's name. Let's say that person's name was Sam. we're going to take his name and we're going to put him into the first box, number 1. And then we're also going to take his mark and put him into the marks array, which we called student marks. And we'll feed his mark, let's say it's a 90, and we'll feed 90 into here, and that's in the first box. Okay, and this is going to continue and continue and continue and continue. Eventually, we're going to say, no, we've had enough. And what will happen is this variable here, counter, will remember how far we got. So we might have typed in, let's say, 20 people. If we did, this counter will remember that we had 20 people. Okay, so now what's left to do? Now we have to print out the results. Well, how do we know how many people there are? Well, I just told you. We have a variable called counter. So now what we do is we go from 1 to, not to 5 or 7 or 8, we go to counter. And counter will remember that there was 4 people or 6 people or whatever. And that will display the results. Okay, now this one, just for fun, I'm going to step through it. So I'm going to put a little break in here. And as we run it, it's going to stop there and then we'll go into the underground and we'll go step by step to show you what's happening behind your back. Okay, so we'll press the input box. It goes right here. We'll press F11. Okay, so that fills up the arrays with nothing right now. We initialize some variables. We ask the person if they want to do this, and we'll say yes, want to do this. And we continue. Okay, and obviously it's not no yet, so we ask for their name, and I'll type in C, and then F11 again, and we'll type in their mark. I'll type in a 78. Okay, and those are good marks, so the counter gets done. The bouncer says, come on in, you can come into the array, and we fill up the arrays. Now watch this, this is really cool. I'm going to press this for a second. Look at that. There's the array. There's more than that underneath it, obviously. It goes all the way to 99, and there we have the S into that section number 1. Isn't that nice? Isn't that cool to see that? And we'll do this one too. There's S, and here's the mark, 78. Okay, see how the array is getting filled up? Isn't that cool? All right, and the computer just keeps doing that over and over again. This time I'm going to say no. Okay, I'm going to say N for no, and press F11. We'll go down, and now we're down to the part where it prints it out. Now remember, the computer's got to know how many times to do this. Counter's 1, so it's only going to do it once, and then it prints out the values in the list box, and we're done. Okay, and there is the first person. Now on to the last technique. So remember, these two are going to be my favorites, data files. Let's see if you remember how to do data files. So first of all, like we've done before, we tell the computer ahead of time we've got a reservation for 2 arrays, student name and mark. Counter is still good. Sort of remember this? Okay, this is how we're going to make the computer point to somewhere on our hard drive where we've stored raw data. Okay, information about the students. And in this particular raw data, we have their name and number underneath each other, underneath each other, underneath each other. This connects the Visual Studio program C# to the file, the stream reader. Okay, we've got a couple of variables that we're going to use, and then we have that Boolean thing which says, are you done? Are you not? Are you done? Are you not? Okay, so we continue this loop while we're not finished. Okay, we're going to read in 2 pieces of information. If either one of them is nothing, which means that we're at the end, we're finished. If we're not, just like the last example, we have a counter that counts, and then we take the value that we read in from the data, so the first one we read in, and we put it into the student's name. And then we take the second value, which is going to be read in as a string, and we got to convert it into an integer, and we store it in there. And that's it. It's exactly the same, except it doesn't have the inputs. And we load them in, and then from there on in, we have a loop that goes from 1 to counter, and it prints out all the students. So quickly, let me run that for you. Okay, and there are the results. Now, kind of dull, not really practical yet, but at least it gives you an idea how it works. Let me show you the last one. The last one works out averages, and it uses this technique with the input box. So I'm going to very quickly type in a couple of people. And then I'll type in a mark, and then I'll say no. So what this one did is it remembered who I typed in, those 2 people, and it worked out their average mark. So there is a practical application of arrays. Now let me show you the code behind it to wrap up to this particular lesson. So again, for the 4th or 5th time, you have to declare your arrays. You're going to use an infinite loop that's going to say, do you want to keep doing this? If you say no, you stop. If you don't, you ask temporarily for their name and mark. If they're good marks, you count them and store them, okay? If they're not good marks, you yell at them. Then you do an average, and I did something really cool here. I created it's kind of a method, a technique to display things, right? So the first one here does the display method, and I feed it the student name. Now look how I feed it the name. I don't put the square brackets on it. Now where is this display technique? The display thing is up here a little bit farther up. Okay, so look at what it does. It uses those parameters. You know how we had before integer x and integer y or string x or whatever? This one now is saying this method is going to catch some words that are an array. This is going to catch some numbers that are an array, and then one other number which will represent how far in the loop to do it. So that's kind of cool. That's a void method. The second method I use down here is where I use it to work out, and I'll click on this very quickly to get down to there. Use the average mark is, and this. This is the second kind of method that works out an answer and it comes back. Okay, remember that second kind of method? So this one's right here, right in front of our face. So it's easier for me to show you. So this one I'm feeding in the array. In this case, it's the student marks. So if I had 7 students, this would get filled up with 7 students' marks. And I also feed in the counter. Remember, the counter is saying, hey, you got 6 people, 7 people, whatever. And that goes in there. And then I have a loop that goes from 1 to, let's pretend it was 7. And this array is really this array, okay? But in here, it's kind of like a dummy variable. And this adds up all the people's marks, and then it works out the average. So this last one's a bit challenging. It does something practical, and I also wanted to incorporate this new idea of feeding an array to a method. Okay, so now we're tying in arrays which make programs efficient, and we're remembering methods which make it efficient. Okay, we threw a lot at you. Arrays, what they do, how to use them, but really, did you get it? What we're going to do now is stop this lecture, and then in the next lecture, we'll try some practice problems, and we'll base them basically on this one. So don't make this program go away. Keep it, and we're going to use it in the next lecture, okay? All right, let's practice a little bit. So I'd be remiss if we didn't actually try some of this ourselves. I threw a lot of ideas at you in the last lecture. So what I want to do in this lecture is just focus in on a set of problems, and actually we'll pick a particular one. Let's do number 2. So these are the practice ones. You can do 1 and 3 on your own if you want to try them, but if we can understand number 2, I think we'll be in good shape. So we're going to use this problem and modify the program from the last lecture. Now, if you forget what the program was, it was called Simple Array Intro, and we went through a bunch of the examples. And what I've done right now to prep ourselves for this lecture is I've made a button called Problem 2. I haven't put anything in it yet. And what we're going to do is we're going to use a data file. So let me go in here and basically copy and paste most of this so that we can use it in the next problem. Okay, so I'm going to go all the way down to there. So I'm basically grabbing the entire code in there, and I'm going to paste it in here. And hopefully I pasted it all right. Okay, now this stuff down at the bottom is where you display the student results. And that loads it in. Okay, so I think we're ready to go. Now, this isn't the right answer though, right? We got to modify it. We're going to change a few things. So let's do it one step at a time. So let's remember what the question wants us to do. The first thing it says is it wants us to load in 8 marks. So no names, just marks. Okay, so let's go back to the program. Because we're just loading in marks, we're going to rub this one out. We don't need that. And we're going to have student marks. Now we need 8 of them. So what do you think? What do we put here? Do we put 8? If we put 8, that would be 0 to 7. No, we got to always put one more than what you need, because we're not going to use 0, and then we can number them 1, 2, 3, 4, 5, 6, 7, 8. 0 and 8 of those is 9 altogether. This counter is good. We're not going to touch that. We'll keep this, and in a second, we're going to sneak down into the underground and change that. Okay, we need the stream reader. We don't need 2 lines now because we're not going to read in 2 things. We're only reading in 1. So we're going to rub out one of these, and we only need one of these lines also. Okay, and we need a counter, but again, we don't need the student's name, and we just need the mark. Now, if you say, sir, I don't remember this, or I don't like doing it that way. What's the other way to do it? Remember, it's that int parse. That'll work. Any one of those two will work for you. Okay, so there's int parse, and that shouldn't say line 2. That should say line 1. Okay, this stuff down here, again, we're not after the name this time. We're just after the mark. So I think we're good there. Okay, now we got to do one more change. We got to go into the underground, and I'm glad I used this example because it forces us to remember how to work with data files. So let me pop up my browser here, and you should have a folder called Introduction that you unzipped in the previous lecture, and we're going to snake our way down. There's simple array intro. Just keep going, bin, debug folder, and there's the students.txt. Now this students.txt has people's names. So I'm going to actually rub them all out, and we'll just make up our own. Okay, so I'm going to type in 90, enter, 40, enter, 30, enter. So that's 3 of them right there. So how many is that? So we've got 1, 2, 3, 4, 5, 6, 7, 8. Great. And I'm just going to press delete a little bit if there was any extra spaces. Now you notice that little cursor flashing at you? Remember, you should have at least one blank after the last legitimate piece of data. And that little blank at the end is going to be like a null record. That's going to be our signal to way for the computer to say, hey, we're at the end, stop. Okay, so make sure, and I can't go down any farther, so I know there's one there for sure, and we're good. Okay, and I'm going to press save because we need to save that again now. Okay, and I can drop that down. And I think we're ready to try out this program. Like, it doesn't do everything we want it to do yet, but it'll answer the first one to see if it works. So we're going to press run. Okay, give it a sec. Oh, we got some errors. Let's see what happened. Okay, the infamous semicolon error. Not a big deal. Run it again. Okay, we're ready to roll. We'll press this, and there's our 8 marks. Beautiful. So there is the first step. Hopefully it's going to start to make more sense from the previous lecture where I threw a lot of stuff at you. So let's review again. All I wanted to do in this first example was load in 8 marks into an array called mark. Now, I called it student mark, but you get the basic idea. This next one says display only the passing marks. So what you're going to start to see is every single question after the first one where you read in all the information and everything, every single question after that basically is a for loop. Okay, so here is the next particular thing. So what we're going to do in this one is, and we don't need to clear it again, but I'm going to do a for loop. Integer I equals 1. I less than or equal to counter, and then I plus plus. Okay, now this one, we're not going to print it out right away because we got some thinking to do. And if you're going, what do you mean thinking? What is there to do? Oh yeah, and that's an I there. It looks like a 1. And then I plus plus. And there's an I there, so threw everything off because I typed in a 1. Okay, so we're all good now. So remember, the thinking is going to be, I only want to display the passing marks. So that involves that decision-making stuff we did before, where you use an if statement. So the way you go like for that is you go if, and then what did I call my student marks? Student marks. So you go bracket, student mark, square bracket I. If that's greater than or equal to 50, squigglies, I'm going to display them. So I'm just going to cheat and copy this right now. Save me a bit of time. Okay, and you could have, just before this, printed, these are the passing marks. So just for fun, I'm going to put in here so it separates them. List info dot items dot add bracket passing marks. Okay, so that would be like the heading before we actually do the rest of the question. So what this does is it goes through every single number, 8 of them in this case, obviously. Now, we don't assume it's 8. Remember, you don't ever assume that. Let the computer figure it out. Goes through all 8 marks, and it says, listen, is this mark for the first guy bigger than 50? If it is, print it out. If it isn't, skip it. So let's see if that works. Okay, so we'll move this over here. Problem 2. So those are the original numbers, and now these are the passing ones. Okay, so remember there's a 33 here. That's a failing mark. And there's a 40 and a 30. They didn't get printed out this time. I only printed out the passing marks. All right, next one says calculate the sum of every other mark. So this is making us practice some accumulating now. So let's take a look at how you do that. All right, so we'll go back into here again. And surprise, surprise, we're going to use another one of those loops. Okay, so we're going to go for integer I equals, so the sum of every other mark. So for I equals 1, and then I less than or equal to counter, and then I plus equals 2. So we're going to skip, right? So we're going to do the first, the third, whatever. Now we're going to total up stuff, right? So I better have an integer total equal to 0 because we're going to accumulate. And then we're going to put a couple of squiggly lines. And then, and I'll slide this up so you can see it better, we're going to do total equals total plus student mark square bracket I. Now there's nothing really special about that I. It's just a way to get from the first one to the second to the third to the fourth. If you wanted to, and I'm going to, just because I want to make sure you realize there's nothing special about it, I'm going to change those all to X. Okay? Now, if I change them all to X, I'm going to change that one to X too. Okay? And what this will do is print out the sum of every other mark, and then we can do a little list info. List info.items.add, and then in bracket, sum of every other mark, and then we can attach it to total to string. Okay, so this one doesn't print out like 10,000 things. It only prints out one number. So that's how I would do it. Okay, let's see if that actually works. Okay, so those are the passing marks, and there's the sum of every other mark, 219. Okay, so that was a way to skip from 1 to whatever by 2s. Okay, and now we're bearing down almost to the end. And actually, I'm going to give you a little bonus one to do in a second. Calculate the sum of the passing marks only. Oh, a little tricky. So a little bit of if statements and a bit of accumulating. The sum of the passing marks only. Okay. Surprise, surprise. And hopefully you're starting to get this. Integer new total equals 0. And then for, surprise, surprise, this is how you get the computer to go from every mark, whatever it happens to be. So this one, we're going to go through the entire list. We're not skipping any. Not to say that we're going to use them all, but we're not going to skip them to see who's passed and who hasn't. All right, so basically I'm only going to add up the ones that pass. So if the student mark, square bracket I, is bigger than or equal to 50, squigglies, we're going to say new total equals new, and there's a cool way to do it too, but again, I'm just going to do it the old-fashioned way. And then we add up that person's mark. So that would be how to work out the sum of the marks for every passing student. Okay, and then that's the end of that loop. And then right about here, I'm going to sort of cheat here, and I'm going to grab all of that, and I'm going to copy that one and paste it right in there. Okay, and then it's a sum of every passing mark. All right, and we'll run it again. And there it is right there. Hey, did you see that answer? Were your eyes sharp enough? They're the same. How could that happen? I know we programmed it totally different, and I can tell you right now, maybe you caught it before I did. I I forgot to change this to new total, right? Because I was copying and pasting. That was the answer from the last one. So let's run this again, and I'm hoping it's a totally different answer. So 219 and 376, that makes more sense. To finish up, how about we do a little bonus question just to make sure, absolutely sure you know what you're doing. So it's not in here, but how about we work out the average mark? That's not that hard, right? So it's not a big deal, but again, it's going to reinforce one more time how you work with arrays and how we can reuse them. And you couldn't do that before when you had to make up names for each one of them individually. But with arrays, because you can put them in loops, you can do it in 2 seconds. All right, so this last one is just going to work out the average of a bunch of marks. So again, one more time. We're going to work out to do averages. We need 2 things. We need int, I'm going to call it grand this time. Start it off at 0 and double average. And we can make it initialize it to 0 too. And we're going to have integer I equals 1, I less than or equal to counter, and then I plus plus. So that means we're going to get to every single mark. And I'll slide this up so you can see a little better. Okay, and then we use the squiggly lines, and there's no, hey, do I pick you? Do I not? Do I skip you? No, everybody. So in this one, grand, and I'm going to do it the cool way this time. Plus equals, and then student mark square bracket I semicolon, and that's it for that part. That does the accumulating. To work out the average, nice little review, we're going to cast it. Remember when you have to do that to make it a decimal, otherwise it might not work out properly. And we're going to take obviously the grand and divide it by, how many do we have? Well, counter. That's how many we have. Don't say you know there's 8. I know there's 8, but don't do that. You never do that in computer programming. Okay, let the computer do all the work. And then hopefully this time I don't make the same mistake. I'm going to grab all of this and I'm going to paste it in here. And this time I'm going to put the word average, obviously. And this is also going to be average, but not spelled the long way, just the way I spelled it in the program. Okay, so one more final run. Okay, those are the original marks. Those are the passing marks. There's the sum of every other mark. There's the sum of every passing mark, and there's the average. Okay, oh, nice little review here. I don't want it to 3 decimals. How about we do it to 2 or 1? Do you remember that? That's where you go inside of here. Beautiful. We're reviewing all kinds of different concepts today. And 1, like that, and that'll be to 1 decimal place. Okay, and then we'll give it a run. And let's see what it looks like. 59.9. Okay, almost 60. All right, so there is a nice little recap review of using the concepts that I taught you in the previous lecture. Now, every year I do this, students go, come on, sir, this is kind of boring. Like, when are we doing the really good stuff? Well, you got to understand, you need to know all these mechanics to do anything else, all right? And everything we're going to do from here on in, almost all of those, are always going to involve arrays. But just as a little sort of tease in what's going to happen in the future, I want to show you where, once you understand arrays, the sky's the limit. And you can do some really cool things, like this one right here called Flipbook. Uses a different kind of array. Once you get comfortable with arrays that store people's names, words, and store people's numbers, you can also have them store pictures and have simple animation. So up until before arrays, this would have taken us tons and tons of lines. And if we have like 30 character images that we want to cycle through to create an animation, it would be a lot of work. But with arrays, you're going to be able to do this very quickly. Now, I'll show you the underground. You won't understand everything, but I'll just show you the key line here. An array of images. So you're going to be able to create a box or a bunch of boxes in the computer's brain that instead of storing numbers, they're going to store faces or pictures of objects or whatever. So the sky's the limit. So eventually, once you get comfortable with arrays, you're going to be able to use image arrays and then cycle through using a loop all the pictures and then display them. Isn't that cool? Okay, so that's what's coming. That's the fun stuff coming in a little while. But we got to do all this basic stuff, the theory and some typical numeric examples, practical applications nonetheless, but not as fun as these ones that we're going to get in the future. Okay, so thanks for listening, and we'll see you in the next example lecture. Okay, in this lecture, we continue with our series on one-dimensional arrays. And today what we're going to do is take a look at how would you find the highest mark or the lowest mark, or if we were doing temperatures, the highest temperature or the lowest temperature. So we're going to review the basic concepts and then extend it and figure out a technique or an algorithm to determine using arrays the highest or lowest of a piece of information. Okay, our base of operations in this lecture today is an intermediate, it's called. Okay, so if you've downloaded the demos for today, unzip the intermediate, and inside of there are several examples. We're going to focus in on the one called Simple Array Intermediate. Let's load it up. And we'll keep repeating ideas and just adding a little tidbit so that you don't get overwhelmed with different concepts. But here's what this example does today. I've got one that does it with inputs and one with data. So when we run this one's going to ask for students' names and marks. And I'll do one more student. And what it did is it took everything I typed in and remembered it. That's the beauty of arrays, okay? And then just to show off, I reversed the list. So the first person became the last and the last person became the first. And then what I did was, and this is what we're going to focus in on today, I figured out who got the highest mark. I figured out the number, 99%, and the person, okay? So it's kind of neat. This one here doesn't involve any sort of input. It just uses a data file and bang, it prints out the days of the week, the temperatures for those days, the average temperature, and the lowest temperature. So kind of neat, kind of a little bit of review and this new stuff. Okay, let's start looking at the actual code. So this first one here, I'll go through the beginning part fairly quickly. So we are going to accept names and marks, and we don't really know ahead of time how many we have. So we'll declare globally, or as we say publicly, to the entire world that we're going to have an array of student names and marks. I'm also going to declare globally or publicly, I'm going to have a counter. And the reason I say that is because we're going to be going in and out of different methods and buttons, so we want the whole world to know about what we're doing. Okay? Now, when I pressed this button right here, first thing it did is it called the data entry routine, which is nice. I'm showing you how to use methods, right? So in the data entry routine, it's a routine or technique you've seen me do several times now. It's your basic while true loop. And you ask the person, do they want to continue? You get the marks and the name of the person, check if they're good. If they are, store them into the array. So basic stuff. And the thing about this is we are going to know after we finish this first method what are stored in the student names and marks. Now, after we complete that method, we go to the display method. Again, kind of cool. Everything's in little methods now. Okay, it's a very nice little way to program. Okay, let's go to the display technique. All the display does is go from 1 to the counter. Remember, we don't know how many marks we have. Could be 5, could be 95. Okay, and this prints out all the marks. And then what we do is, just to show off, we call another method called display reverse. And it is basically the same as display, except we start from the back end and go to the front. Okay, so whoops, where am I here? Display reverse down here. So it starts at counter and goes to the first one backwards. Okay, now the new stuff. All right, now we're going to slow down and explain this. The last one is actually, first of all, another method, but this is the one that returns an answer. Okay, so that's kind of cool. Eh? It's a method that returns an answer, and it's going to return an integer. So let's go to this method called highest. There it is right there. And you notice it's going to return a result. And it's kind of cool. I returned a result that's a string, even though I'm working on a number. I take this answer and concatenate it into a big long string. Kind of cool. But let me focus in on the theory now. So here's my idea. I've got these marks in the computer: 72, 80, 40, 90. So what I do is I have a variable called big. And what I do is I make it something really stupid. So like when you're finding the biggest number of a set of marks, -1 would be stupid, right? And that's going to be like my Kickstarter. And now what I do in my loop is I start from the first one, this one right here. These are all in an array, remember? Okay? And I compare this one to -1. So I go, hey, is the first mark, 72, bigger than big? Well, obviously it is. So right away, big gets scratched out. It's no longer the biggest one. And student mark I, which is 72, gets put into there. Hooray. But I should also remember who the guy was. Was it the first guy, the second guy, or the third guy? So I make another variable in the computer's brain called POS for position. And right now, that's going to store 1, which means the first guy, the mark was 72, and that's the highest mark so far. Then I go back up to the top of the loop. Now I'm on the second guy. And now I go, hey, is the second guy, 80, bigger than big? Now remember, big is now 72. Yeah, 80 is bigger than 72, so I scratch out 72. I know it's getting kind of sloppy here. Follow with me. There's the 80. And I also try to remember what position it was. Well, this is the second guy, right? So now, pause is a 2. Okay, so you see the thinking? We're comparing it to the master, big, and position. Next one we do is 40. Now, is 40 bigger than big? No, 40 is not bigger than 80. So skip that one. We don't touch that one at all. Now the last one. We're at 90. Is 90 bigger than big? Is 90 bigger than 80? Yes, it is. So we scratch out the 80, and put a 90 there. And we also have to remember who that person was. So that was the third one. That was the fourth one. So I is 4. So pause, scratch that out, and we put a 4. Hooray, we're done. We now know the biggest mark is 90. So the highest mark is big, 90. And it was obtained by, now, do we say person 4? That would be stupid. Like, your name is not 4. But what we have in the computer, remember, at the beginning, we were asking people for their names and their marks. Okay, so let's pretend this was people's names. So the fourth person might have been Tom. So when I say it's the fourth person, I put that 4 in here, but I go student names 4, and that will pull out the word Tom. Okay, isn't that cool? So that's how you find the biggest of a set of numbers. Now, let's reverse this. A little challenge for you. How about we find the smallest of a set of numbers? Now, I'm not going to change this word highest mark, but I will change this. So if you're after the smallest of a set of numbers, you start off and you make small something stupid. Now, let's make it 1,000 because it couldn't get something that way, right? And now, if the mark is less than small, okay, so it's kind of like the reverse logic. We're going to make that mark the smallest mark. So we start off with something stupid in the opposite order. So 1,000 is the smallest. Well, obviously it isn't. Okay, so the very first number that we get is going to be smaller than 1,000, and then we basically go through the program. Now here we will change this to lowest mark, and we'll change that to small, and the rest is okay. And let's give that a try. So I'm going to run that. Okay, and I'll make up a couple of marks really quickly. So yes, I have some entries. CC, got a 56. Any more? Yes. G, got a 99. Any more? Yes. A, got 21. That's not good. Any more? No. Okay, so here are the original numbers. Here are the numbers in reverse order. 21 was obtained by A. Beautiful. Okay, so that is the idea for today. How do you find the largest of a list or the smallest of a list, the highest priced item, the lowest priced item, all kinds of different things. Now what I did in the second example is basically repeat what I just showed you, except using data files. Remember I said the bread and butter is going to be input boxes and data files, and this one very quickly shows you all the days of the week and their temperatures, works out the average, a little extra feature, and the lowest temperature. And very quickly, let's go through that one. I'm not going to beat this one to death. You got the basic idea. Okay, so this one again, I like using methods. All right, see how it's all compact? That's kind of like called the main line, and then we branch off into our routines. So the first method in this one is we call the data file method, which is your standard read routine. I'm not going to go crazy on that. You've seen that a million times. We follow that by echoing the input, which means redisplaying everything that we read in. So we go to the display temperature routine, which is actually it's above this. Okay, so we go to the display temperature routine. Where are you? Display temperature, there you are. Okay, so you have a loop that goes from 1 to the temperature counter. I used a different variable so it wouldn't get mixed up with the temperatures. Okay, and then we're in the home stretch here. The next one is, and this is the cool part, I'm using a method, okay, that's going to return the answer for the average. Okay, and the average is down here. It's a loop, everything's a loop that goes from 1 to the temperature counter, and we add up all the temperatures. Then we take the total divided by the counter and we turn the average. And while I'm down here, because it's right in front of our face, the lowest temperature, you just saw me do it, and now you see it again. You make small something really stupid in the opposite direction. You initialize your position and the result. And then we do a loop from 1 to the temperature counter. And if that temperature is less than small, it becomes the smallest temperature, and we store the position of where it was. At the very end, we know the answer for small, and it happened on day, so we don't say it was day 7 or day 3, we say the actual day, Wednesday, Saturday, whatever. Okay, so hopefully now I went through that one a bit more quickly, except for the new idea of biggest and smallest. This is another application that's going to be useful, because if you make a game later on and you remember people's scores, you want to know who got the highest score and the lowest score. This will be a way to do that. So what do you think? Are you starting to get your head around how arrays work and how they're useful and how they save time? Well, in our next lecture, this is going to be the lecture where I'm going to prove to you, if you didn't know arrays, the program would be thousands of lines, and we're going to do it in 5 or 6 lines. But anyway, if you still need a little bit of practice, I've got a problem sheet here that you may want to try. This one I'm not going to take up because it follows pretty well closely to all the things we've done. This one, the only extra feature it does is it adds another array called homerooms. Okay, so you can look at the one we just did and add to it. So this one, I ask you to read in names, homerooms, and marks, and work out the average mark, which we've done before, the highest mark, the lowest mark, and then here's a little twist: the names of the students in homeroom 121 with an average between 70 and 79. Oh, that one's a bit tricky, okay? But the other ones are pretty straightforward, and I figure if you can do A to D, you are pretty well knowledgeable right now on how arrays work, okay? So this one we're not going to take up, but if you think you need some extra practice, give that a shot. Okay, and thanks, and we'll see you in the next lecture. Just a little aside, sorry guys for adding on a little bit extra to this lecture, but some people have been noticing that in several of my demos, I have 2 versions. I usually do the simple array intermediate or simple whatever with you guys, but there also is, if you are sharp enough to understand it, a version that uses passing of parameters. Let me just quickly show you. I'm not going to go in depth with the explanation, but if you're so inclined, there is a cooler way, a more efficient way, a more structured way to do some of these questions. So this is the same question we just did in the lecture today. But in this one, instead of just calling the data entry method and making all these global, so the entire world knew about them, I declare them locally and pass them down to the method. Now, I've got a little explanation here about the different ways you can pass stuff. You can pass it by reference and by value. And when you pass something by reference, and that's what arrays are passed by automatically, it remembers what you do to them. So if you hit them, you change something about them, when you come back, they come back with that damage or that actual change. As opposed to when you have like numbers, like integers or things like that, when you pass them down in a method, they forget everything they were told. Now, after that explanation, which may or may not be confusing, you can have these regular variables remember stuff by adding this little word in front of them, ref. Okay, so this one right here, data entry, student names, that's an array, student marks is an array. So when I pass it down to data entry, I have as the catchers, so to speak, a string array to grab the student names and an integer array to grab the student marks, and there's that ref again for the counter. And what will happen is the computer will chug along here, you'll be changing all kinds of stuff, and then when it returns, it will have in here the actual amount of students you typed in, and these arrays which seem like regular variables, but are arrays, will have themselves filled up with information. Now, I know that's kind of weird, but that's the more advanced technique. So go through this whole program, and I use this technique throughout it. It's a bit more confusing, obviously. That's why I wanted to give it to you sort of straight and simple, but I use these parameters and pass things down as a more advanced way to do things. Okay, so if you're wondering why has he got that other one and how come he's showing the simple one, it's not because I think, oh, you're not going to get it, but I want to give you something straight and more straightforward, and this is a bit more challenging if you're interested. In this lecture, we will introduce the concept of sorting. As you know, sorting means to put things in order, whether that be alphabetical or numbers. Okay, you go to a website, you're looking for a pair of shoes, and then you sort them by price. You have the cheapest shoes to the most expensive, or vice versa. So sorting is a very important application in the real world. Now, this particular topic, this lecture, is going to really prove the point of why arrays are so important, because to sort anything of any meaning, several hundred names, several hundred numbers, it would take hundreds of thousands of lines if we didn't know how to use arrays. So you're really going to today appreciate the importance of arrays. All right, let's start off by loading in this program called Sorting Introduction. And we're going to go through and give you a little background into sorting and then introduce some techniques. Now, first example just sorts two numbers. Okay, so it's going to ask for the first number. I'll type in 6. Second number, I'll type in 9. And then it puts them in descending order, biggest to smallest. And let's take a look at the code. Now, this code assumes that we don't know anything about arrays. So basically, it would involve a couple of if statements. So after we declared our numbers and got them, we would say, listen, is the first number bigger than the second? Then put the first number first and the second number second. And if it's the other way around, put the second number first and the first number second. No big deal. That's not bad. But how many times do you only order two numbers? So let's take a look at the second one that asks to sort three numbers. So I'll type in, okay, and of course it worked perfectly. But let's take a look at the code for this one. And again, we don't know anything about arrays. This one here, when you're sorting three numbers, there's 6 possibilities. Now look at all this code here. If the first number is bigger than the second, and then if the first number is less than the third, then we've got this order. Else, what if the number 2 is bigger than 3? Then we got this order. Otherwise, you got this order. Oh my God. What happens is, and you have to know a little bit of math to realize this, when you have 3 numbers, they can be ordered. The permutations are 3 factorial, which means 3 times 2 times 1, which means there are 6 combinations you have to worry about when you have to order 3 numbers. So that means there's about 6 different decisions to make. Well, this is going to get crazy. What if we had even just something like 5 numbers that we had to order? That would be 5 factorial, which would be 5 times 4 times 3 times 2 times 1. 20 times 3 is 60, times 2 is 120. There's 120 if statements. Okay, we got to stop. We can't do it this way anymore. So obviously, when you don't know arrays, it would get out of hand. If you had to sort 100 numbers, it'd be in the hundreds of thousands of if statements. So what's an algorithm that we could use? So I thought to myself, the first and simplest way to sort numbers would be, you know what? You've got a list of numbers, okay? And I already know how to find the biggest of a bunch of numbers. So go through this list, and if this happens to be the biggest one, store it in another array, the sorted array. So this would be the biggest one so far. But then I have to go through this list again, and this guy's still here. So now what I do is I make this guy negative 1,000. And then I go through the list again. And maybe the second biggest is right here. And now that gets put into another array that's being sorted. But this guy again now is going to be the second biggest. So again, I make that one negative 1,000. So what I've done here is created an algorithm. Okay, let's give it a run and see what it does. So this one uses a data file. So I don't have to type in 20 numbers or 30 numbers. It's just going to take them from the hard drive. And then as you see, it puts them in descending order, biggest to smallest. Let's take a look at the code. The basic idea of this sort is I'm going to find the biggest number, put it in a separate other array, then make it something stupid, and then find really the second biggest number and keep doing it and keep doing it. Now, what makes this solution a little bit different is that I've decided to try to use that cool way of using parameters and passing them to a method. So right off the bat here, I declare an array with a counter, and then I pass that array, which right now is empty, and I pass that counter, which right now is 0, to the method. Now the method is up here a little bit farther up, data file. And what happens with the data file is I'm going to catch the array that I passed it, and I make a reference to the counter, and basically I read in all the numbers. As I read them in, I count them, and then I take the number and feed it into the array. When I come back from this method, what will be in here is a full set of numbers that I'm going to sort. Then I display that array that's not sorted yet, and I pass a counter, and that's in the display event. And the display event, pretty basic. It grabs basically the array that I'm sending it and the counter. Now notice it also grabs a title, so I make it have a little title at the top. So if you notice in here, slide down a little bit, I pass it the word original list, which goes into the parameter title, and I pass it the array and the counter. Here's where the dirty work happens. This last one here uses a method that returns something. It's going to return the whole array sorted. So I call this replacement sort. And there is, as a computer program, what I was trying to describe to you with my doodling. So first of all, this is going to be the brand new array that's going to hold the sorted list. This right here is the loop that goes through all of the numbers, and I start off and make big equal to something stupid, and then I go through the values, every one of them, and see if any number is bigger than this one. After I'm done this loop here, I will take that answer and put it into this new array called sorted. So this will have the biggest number, which I think in my example was 99. Then I make that number 99 equal to negative 1,000. Okay, so I don't know where it was in the list. Let's say it was right around here, maybe the fourth one in the list. So now I make the fourth one in this original number list equal to negative 1,000. Okay, and this outside loop basically says if you got 7 numbers, find the biggest one 7 times. Each time really finding the second biggest or the third biggest. And that's how it works. And you'll notice we return not an int or a string, but an int with square brackets. So we're returning an entire array. So when this returns back to here, this whole thing is replaced by the array, which is now sorted. And the last step is to call display again and feed it in the word sorted list, the array now that is sorted, and the counter. So that's kind of cool. Okay, as people invented techniques to sort, they wanted them to be probably a little bit smaller in terms of the number of lines of code, but even more importantly, they wanted them to work faster. Because sorting actually, if you have a big list, tens of thousands of numbers, and you press run, you might be sitting here for a minute or two. So people want that to be faster. So different algorithms were invented. Now the one that we're going to do in an introductory level class is the bubble sort. And I want to, before I show you the program, go through the thought process of how it was developed. Now, the basic idea of the bubble sort is basically that you compare numbers that are side by side. If they're in the wrong order, we swap them. So I've got a little scenario here that you can look through. It's in my notes. And these numbers here are the indexes. So let's pretend we have 5 numbers, and this is the original list right now. Okay, so let's work our way through as we go through what we call passing through the array. So the first time through, what's going to happen is we're going to compare this number to this number, and right now they're okay. Let's pretend we're going to put them in smallest to biggest order. Okay, so those are good. So then we compare this number to this one. Well, those are bad. So I want this one to come over here and this one to come over here, and that's what happens right here. So now really we've got 7 to the number 9, and those are good. And then the last part is we got 9 to 6, and those are bad, so we're going to convert that one over there and change that one over there. So what happens is we basically cycle through the entire list once and compare adjacent numbers. If they're in the wrong order, we swap them. Okay, let's do it again now. So now we're going to take a look at the next iteration, so to speak. And now we're going to swap again. So now we've got 3 and 1. Those are in the wrong orders. So we put that one over there and this one over here. So now 1 is there and 3 is there. 3 and 7, those are good. 7 and 6, those are in the wrong order. So 6 moves over here, 7 moves over there. And then we have 7 and 9, and those are in the right order. And what do you know? After 2 passes, we now have a completely sorted list. So you can see in a simplistic kind of way how this is faster than the one I just did. The one I just did, if I had 10 numbers, I would have to go through the loop at least 10 times. I had to go through it exactly 10 times, by the way. In this one here, with 5, you would have thought, okay, it would have taken you at least 5 times to go through the loop. But it only took us 2 times to go through the loop. So you can see how this technique, in essence, is a faster technique. Now, how do we know when to stop? And how do we get switching things around and everything else? Well, let's go through a bit more theory. One of the important things you have to know is, how do you make things switch? So we got to compare things. So how do you compare 1 to 2? Well, what we're going to do is we're going to have like a value here, like a k, and we're going to compare it to k plus 1. So you know how you have like an array and then you usually put like a variable inside of it? Well, to compare that one to the next one that's side by side, you would have to compare ak to ak plus 1. So that's one issue that we need to do, and that's what you do. The next issue we have to worry about, and we'll slide that down here, is how do you swap things if they're in the wrong order? And I'll give you a scenario. Let's say you've got A2 and A3, and this is a 7, this is a 1. So really, this number has to go over here, and this number has to go over here. So at first glance, you might say, oh, just do this. A2 equals A3, and A3 equals A2, which means take A3 and put it over here. Well, let's do that. That would mean that we would take the 1 and put it where the 7 used to be. Now, do you realize what happens? Now that's a 1, and that's a 1. And the poor 7 just got destroyed. So we can't swap things that way. What we have to do to swap is use what's called a temporary variable. So you'll see it down here. When we're swapping stuff, what we do is we take the variable that we're going to move to the other side and put it temporarily somewhere else. Okay? Then we take the second value that we're going to move into the first and move it in. That's okay now because we've taken that first value and stored it temporarily there. So that will save us. And again, if you're looking at this particular example, what you would have done first is taken the A2 and stored it temporarily into T, then moved the A3 into the A2. Okay, so you were saying, okay, so A2 is now in a safe place right here. So even though this got destroyed, okay, the 7 would be in a place called temp. So that 7, even though it's getting destroyed, we put it safely over here. So now this one right here is a 1 or whatever, right? But it doesn't matter. We've got the 7 over here. So then in the last step, we take the temp and we put it into A3. So we actually get it to work that way. So you use this temporary variable so that it doesn't get destroyed. Now the last step. How do we know when to stop? Well, we're going to use what's called a flag technique. And basically, if we go through every one of these numbers, so if we've got 5 numbers and we go through it and we don't switch anybody, then it must be totally sorted. Now, how do you tell the computer, hey, did you switch or not? Well, we're going to use a variable, like a flag, we're going to call it, and we're going to make it equal to false, which means we haven't switched anything. And the instant we do switch anything, we'll make the flag true. And then we'll have to do it again. Okay? So we want to go through the entire loop, and when it stays entirely false the whole time through, we're done. If we even switch one thing, we have to go through the entire list again and see if we have to switch anything else. So that is kind of like the theory of the bubble sort. Now, remember, what I'm showing you is an algorithm. It's not real computer code. So if you're wondering, hey, that doesn't sound like C#, don't worry about it. This is right now sort of code, pseudocode. So here is basically the program now. So we're going to have some kind of loop that keeps going around until the flag is yes. So we're actually using the reverse of what I told you. I'm going to set the flag to yes initially to say, yes, everything's good. And then I'm going to have a loop go from 1 to n-1. And if you're saying, what does that mean? Well, if I have 10 numbers, I'm going to go from 1 to 9. Because what I'm doing is I'm comparing k, let's pretend that's a 1. And then k plus 1 would be 2. I'm comparing 1 to 2. And then 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, 9 to 10. Okay, so I don't need to go to 10. I go to one less than that. Now, if this is bigger than that, the first one is bigger than the second, then that means they're in the wrong order if we want to sort them in descending order. So if the first one is bigger than the second and we want to switch them, we do the swapping technique. And there's the swapping technique. It takes 3 steps to do the swapping technique. You hide the first number into a temporary, then you move the second number into the first, and if it destroys it, big deal, because we have put the temporary number here, and that goes into the second. Now, if we switch even once, then we set the flag to no, and we have to do this all over again. We keep doing this until the flag is yes. That's pseudocode. Let's take a look at to finish up the real code. The real code is actually pretty short. Okay, so basically just like before, I'm using kind of like the cool technique. I'm going to call my data file. I'm going to feed it the array and a reference to the counter. Then I call the bubble sort. And the bubble sort, again, I feed it the array and the counter. And here is the bubble sort. Okay, so like you saw in the pseudocode, I have a string called flag. I'm going to have an integer called temp. And I do while the flag doesn't equal yes. So I'm going to keep going around in circles while the flag doesn't equal yes. So initially, flag is yes, which means everything's good. Nothing's in the wrong order. And then I have a loop that starts at 1, and it goes all the way to k, where it's up to u minus 1. So the upper limit, minus 1. So if we have 25 numbers, we're going to go to 24. This compares the first one to the second one. If the first one is bigger than the second, then we're going to swap it. Okay? So if the first number is bigger than the second, we're going to swap it. Let's give it a run. So there's the original list, and there's the sorted list. So you realize with this logic, we are now sorting these ones from smallest to biggest. So this is saying if the first one is bigger than the second, okay, that's the wrong order. I want it to be less than, right? So we will swap those and set the flag to no. And that is the bubble sort. Now there's this cool site on the internet which compares a number of the sorts. And like I told you, we're just scratching the surface. And each of these newer ones are faster and faster and faster. And just give you a little run for a second to show you what they do. They're going to show you mathematically and with a picture what happens when they rearrange things, and you'll see which one's faster than the other. Okay, so you see things changing. The heap sort's really fast, and you got the quick sorts going. The bubble sort's still going, and so is the selection sort. It's not one of the fastest techniques. It's not the slowest, but it's not the fastest. Okay, it's kind of a cool site. You can compare them. These are much more advanced. In a more senior class, I would do a shell sort and a merge, but for us right now, the bubble sort is all we could do. Okay, so there you have it, an introduction to sorting and the importance of arrays to make it a much more short and efficient program. This is our last lecture on one-dimensional arrays. In this lecture, what we're going to do is cover what are called array counters. And again, for the second time, I'm really going to try to really get you to understand how important arrays are and how they make your programs much more efficient. In this example, I'm going to show you a program that's going to take probably 300 lines without arrays, and we can do it in one line. And this is one of my all-time favorite examples. And this will really show you why arrays are so important. They become one of the most important concepts in computer programming. Okay, before I go into this actual question you see on the screen, I'm going to doodle a little bit and give you a scenario. Let's say I wanted to write a program before arrays that asked the person for their mark. So I had a whole class and I was saying, what's your mark? What's your mark? What's your mark? And I'm going to keep track of the frequency. So let's say we had a test out of 100 and I ask Tom, what's your mark? And he says 75. And then I ask Mary and she says 80. Then I ask Joe and he says 75 also. And I go, oh, so now there's two 75s. So how would I do that without arrays? Here's what I would do. So, and again, I'm just going to sketch it out. It's pseudocode. I would have some kind of loop, all right, where I'd ask the person with an input box, give me your mark. So I would save their mark into M, let's say. Now, once I know their mark, how am I going to figure out how many times that mark happened? I would need some if statements. So I would say something like if the mark equals, I guess somebody could get a 0, right? Then I'm going to have a counter for zeros, so maybe I'd have something like z equals z plus 1. Else, if the mark was equal to a 1, I'm going to have a counter for the 1s. So 1 equals 1 plus 1. Else if, and I would do 2 all the way to 100%, and that's a lot of writing. So that alone is about 200 lines. Then I'd have to have another 100 lines to display each of the results. How many people got a 0%, 1%, all the way to 100. So obviously not a good way to do it. So how am I going to do that with this new thing called arrays? And again, I'm using pseudocode right now. This isn't the exact thing. But what I'm going to do is I'm going to have something like a count with a square bracket. So I'm going to make an array counter. And it's going to have a bunch of boxes. So I'll declare an array counter to hold up to 101 actually, right? Because you have 0 and it's got to go all the way to 100. So it's got to be 101. So I'm going to declare an array with 101 spaces. Okay, and now I start my program again. So I've got my program that's going to be in a loop. And again, I'm going to have my input box where I'm going to ask the person, what'd you get as your mark? Now, every time I show this to students, they don't get it the first time. Like they go, no, that's crazy. You can't do it that simple. So watch what I'm going to do now. After I've got that mark, I'm going to do the following. Count, square bracket M equals count, square bracket M plus 1. And we are done. We are done, at least the first part. You know that part where I had all those ifs and all the counters? This one line does all of them in one shot. Okay, now let me give you some example scenarios. So let's pretend the first student says their mark's a 75. So we get to this line right here, and where the M is, I'm going to have count 75 equals count 75 plus 1. What that means is go knock on the door of the array for 75, and there's nothing there yet, and put a 1. So that one line has figured out where to go and also counted it. Okay, let's pretend the next person, Sarah, also says her mark's 75. So where the M is, we take her mark of 75 and we say, okay, count M, 75 equals count M. Well, there's a 1 there now. Plus 1 is a 2. So what this line is doing, a very powerful line, it is figuring out where to put it and how to count it. Let's pretend the next person says their mark's a 40. So this would be the index 40. We would say count 40 equals count 40. Nobody lives there yet, plus 1. So that one line is doing all the dirty work. Then to print it out or display it, we would have a for loop. And then we would print out or display the count bracket, whatever you had as your variable in your for loop. Okay, so that would only take 3 lines also. So this is about 3 lines, that's about 3 lines, and the other program had about 300 lines. And tell you the truth, this is your bread and butter. That one line magically is doing everything. And this is the power of arrays, and this is right there called an array counter. Okay, so let me show you a typical example, and we'll run it. And what this program does is basically prompt the user to type in a bunch of marks. Okay, so I'll type in, now I got to make sure I type in a couple that repeat. And I think I'm done. Okay, so let's see what we got. So these are all the marks I typed in on the left-hand side. So I typed in a 45, 78, 55, 44, another 75, a 78, and another 75. Okay, so I typed in a couple of 75s. So there's the frequency. So I typed in 2 75s and 2 78s. So this is the frequency of the marks in my class. So there it is, okay? And this would have taken at least a couple of hundred lines, and I'm going to show it to you. And obviously I made it a bit fancier. And this question here, I again tried to incorporate the more advanced techniques of working with arrays and passing parameters. So when you look at this, you go, oh, he's using that neat technique that he's been talking about, but now we're using it quite a bit. So first of all, like I mentioned before, I'm going to ask for marks. Okay, and I'm going to keep track of the frequency. That's kind of like the fancy way to count. So I don't use the array counter per se. I use frequency, but same thing. And here's a counter for the number of marks. Now, the first thing I do is I prompt the user to type in the marks. So I have a data entry routine, okay, and we're passing the mark array. That's going to remember all the marks I'm typing in, and I'm also going to try to get back from that method the number of times I typed in stuff. Okay, so here is your standard routine, which we've seen a ton of times now. Almost always looks the same. The only thing is here, I'm passing in an array, and remember, it's by reference, which means that when I pass an array down there, first of all, I don't need to write down the square brackets here. I only have to write them down here. And when it returns, it'll be full of what's stored inside of its brain. Okay, and then we have the reference to the counter. This continues in a loop. We do a little bit of dummy proofing as we always have done. This counts and stores the mark into the array. And what I'm going to do is I'm going to stop the program right around here for a second, just to show you what happens when you do this. That's a breakpoint, if you remember. So I'm just going to do a couple numbers here. And I'm going to stop. Okay, now let me hover over this for a second. Okay, so do you see how right now we have returned from the data entry and it's filled up this array mark with a couple of marks? We've got 3 marks here. Okay, and they're going to be ready to be transferred to our next stage. All right, and the next stage, and I'm going to press F11 right now just to show you the next stage. The next stage is where we just display the numbers that were just typed in. Okay, and then that'll display the marks. Now, frequency. This is the next stage. Now, the next stage, when I do the frequency, this is where it gets a bit crazy, because the one that I did with you guys a few seconds ago, I had just stored it in just a regular variable. Okay, so when I asked the person for their mark, I put it into M for mark, not an array, and then I just said counter square bracket M equals counter square bracket M plus 1. The only difference in this question is that this one is not just F with an M inside it, because we are passing a whole array. All right, so I didn't store, as a simple example here, I didn't store it into just a regular variable. I stored my marks in this example, because it was a bit more sophisticated, into an array. So it's almost like you have an array counter, and inside of there is an array. Okay, so that's what makes it a little bit different. So let me stop the program for a second again, and we'll do a little recap. So first stage was to get the marks from the input. This one displayed them, and this was your bread and butter. This feeds the whole array called mark. This is the frequency array, which is going to come back with it filled up with information. And then here's the number of marks that we're passing down there. Okay, so again, let me repeat. When we pass this down, it's passing down the whole array that is filled up right now with stuff. This one's not filled up. It's going to get filled up with counters, and this is the counter. Now again, I'm going to sneak in those little breaks because I want you to see what happens when it comes back, and I'll put the break right there. So I'll run this again. This is kind of cool to see as you go through it. Do you have any entries? Yes. 77, yes. 45, yes. 77, yes. 44, yes. 76, yes. 77, no. Okay, so again, I like to hover. So here is my original list with all my marks. Okay, so I got a 77, 77, I got 3 77s. And I think that's the only one that repeats more than once. Okay, also let's see the frequency now. When I go over the frequency, I'm going to have to go all the way up much higher, right? Look at this is going to be frequent. Well, there's a couple. Let me slow down because I meant close to the ones that I want. There's 77 has a 3. That's the frequency. So you see how it went down to the frequency method, and when it returned, it had those numbers in that. And the last step is then to actually print out the results. Now, as we print out the results, usually you don't have a lot of students in your class, thank God, that get 4%, 5%, 8%. So it's a waste to print those in the chart. Only really I want to print out the ones that don't have a 0 in it. So as you see, I do start a loop that goes from 0% all the way to 100. But what I do is right in here, if in that frequency, it doesn't equal a 0, okay, and I'm trying to hover over it so I can show you again. So all these ones with zeros on it, I don't want to display those. So as long as it doesn't equal 0, so the first one I think is in the 40s. Once we get to the 40, yep, there's a 44, then I'll display it, okay? So this says if the frequency doesn't equal 0, display the answer, okay? And that's how it's going to print out the results. So it's going to go through all the 100, but it's only going to display the ones that actually have something there. Okay, so there is an array counter example, and I love this example because of how short it is. It's all basically that one line is reducing 100 if statements and 100 counters. Okay, are you getting this stuff? Are you starting to see how arrays are so important? This one is always a challenging topic for many students. And I've got a little review sheet here just to give you a recap of some of the ideas we've covered and to see if you could do this on your own. What I usually have students do when I give them this kind of review is I have them doodle the answer here. Pretend you're the computer and tell me what would happen if you ran this program. Now, it's not perfect code, but at least it gives you an idea what would happen. So if you see this kind of a line, what's that do? Well, in your mind, what you should realize is the computer creates a bunch of memory cells from 0, 1, 2, all the way to 16, not 17, remember, okay? So it makes a bunch of boxes. So that's what you got to realize first. What's this S1? That's a box in the computer too. And we'll put a 1 in there. Now, this is a loop. And this loop basically figure out when to stop right here as opposed to at the top. So what's this? So S is 1. So we get to this line here, and we're going to put something in this box in a second because S is 1, so we're putting something in that box, which is 3 times S, which is 1. So 3 times 1 is 3, minus 2 is 1. So 1 is going to go in that box. Okay, that makes sense. Then S equals S plus 1. So we scratch that out and put a 2. So now we start up at the top of the loop again, and now we're going to be going into box 2. When we go to box 2, 3 times 2 is 6, minus 2 is 4. Okay, I'm starting to see a pattern. We'll do one more. So now the counter is 3. 3 times 3 is 9, minus 2 is 7. So it looks like it's going up by 7s. Okay, so we keep doing this. Okay, so that's 5, that would be 13. Okay, 6 would be 16. 7 would be 19. 8 would be 22, etc., etc. And I'm not going to go through the whole thing. This one here then says, okay, after you've filled up the entire array, print out AR5. All that means is who lives in box 5. And the printout or the display would be 13. This one here says take the value that's in the fourth one, so that's a 10, okay, store it into a variable x, so 10 goes into x. And then this one right here would say, okay, take that 10, add 5, and now you have 15. Tell me who lives in box 15. So you would have to calculate, after going through this, who lived in that box. So it's kind of a way for you to visualize what happens with arrays, how things change and move around in memory. So it's a nice little refresher without actually doing any computer programming. You're pretending you're the computer. Now, could you do these questions? We've done some ones similar to this over the last couple of lectures. In this one, basically, we're going to remember students' names and their history marks. And we're also going to have a variable called counter. Now, could you write a program that would enter all those people's names and their history marks and make sure that it was dummy proofed? Could you write a program that would print out who passed and who failed after you put in all the marks? Could you create a program that displays the names of the people whose marks are between 50 and 70? Now, I'm going to give you one hint for all these questions if you totally forgot already. After this one, which is a while true loop, all of these other ones are for loops, okay? Every single one of them. And the counter would start at 1, and it would go all the way to counter, because you don't know how many people you're going to type in, I plus plus, and then squiggly line, and in here there'd be some if statements, some counters or whatever. And hopefully you remember how to do that, okay? How would you deduct 5 from everything? Okay, so if you assumed you had a history mark, let's just pretend it was H for history mark. You would go H history mark I equals H history mark I minus 5. So I guess your teacher was mad they took 5 marks off of all of the marks. Okay, so could you do that? If you can't remember how to do any of these, go back and watch some of the previous videos. But that's where we're at right now. So our next couple of lessons kicks it up another notch. Next, we're going to take a look at what are called multi-dimensional arrays, two-dimensional in this case. And those are things where information is given to in a chart. It's not just a list, but it's a chart that has rows and columns, almost like a spreadsheet. And we're going to learn how to program those. In this lecture, we begin the second part of arrays. Today, we are going to look at two-dimensional arrays, which are information that is basically stored in a chart or a table format. What we're going to do today is introduce you to the concept of two-dimensional arrays. We're going to show you how to declare them, how to store them, how to display them, and how to do calculations with them. All right, let's start off with some background. What are two-dimensional arrays? How are they used? How are they different than one-dimensional arrays? So let's start off with how are they different than one-dimensional arrays. So first of all, when you're dealing with one-dimensional arrays, you're usually dealing with lists, a list of names, a list of numbers. As soon as you start getting information that's in a chart format, a table format, that has rows and columns, then that's a suitable candidate for two-dimensional arrays. Now, what can you do in this type of thing? Well, you can do analysis of data. Like, for instance, from a chart or a table like this, you can say, well, how much stock of item 4 is there on hand, all right? So this is item 4, and you would go to each of the warehouses, add up all that information, and do a result, a piece of information that you would give your boss if this was for a company and you were doing analysis, okay? Are there any items out of stock at a particular warehouse? You could scan the entire chart and say, oh yeah, warehouse 1 is out of item number 2. So there's all kinds of things that you can do when you work with two-dimensional tables. Now let's discuss some of the terminology that you need to understand with working with 2D arrays. First of all, this stuff right in here is the actual data that we're going to store in the two-dimensional table. These things up here, as we get more sophisticated, we'll store into a one-dimensional array, and this stuff up here, we're going to store into a one-dimensional array. But for now, don't even look at those. Just look at the raw data. Now, this information that goes across, that's called a row. Information that goes down is called the column. All right. So a typical two-dimensional array consists of rows and columns. So in this example, we have 3 rows and 4 columns. Now, why is that important? Because just like with one-dimensional arrays, you have to tell the computer ahead of time how big, how much room to leave in memory, right? So in this one, we're going to tell the computer, could you leave 3 rows and 4 columns in your memory to hold the information that I have, okay? So you got to make sure you realize rows go across, columns go up and down. Okay, so for instance, if I said to you, let's call this table stock, STK, and I said, what's in 3, 2? You would go down to the 3rd row, and then the 2nd column, and there would be a 1 there. Okay, and it's kind of funny the way they do it, but it's a little bit like arrays, right? You go stock, and then you use square brackets, but now you say 2 numbers. So if this one was the one we just did, 3, the first number would be the row, and the second number would be the column. Okay, and that's pretty well a standard way to work with two-dimensional arrays. When you reference them, first number is the row, second number is the column. Now, let's do a little recap of all the different stuff we've been doing so far. So we've had the basic regular variables, okay, like if you have a variable r, you can store it in a regular spot. We've had one-dimensional arrays, okay, which live side by side, and you refer to them with the 1 square bracket. And then now we've got these two-dimensional arrays. Okay, so there's all kinds of different ways to refer to information, and each one has its pluses and minuses. Okay, just for fun, let me just do one example for a second. What if I wanted to know the contents of t square bracket r comma c? Well, t is this table here. R, what's r? Well, it's a 2. Okay, so we're looking at t. We went to a basic sort of memory cell, and there was a 2 that lived there. Now we're going to go to a C memory cell, which is this guy right here, and there's a 3 there. And then we would tell the computer, okay, we're going to go to row 2, which is right here, column 3, 1, 2, 3, and we would be right there. And the value of this would be 8. Now, I'm not going to go through all these different examples, but now you're starting to see all these different ways to have the computer remember stuff. Just regular variables, arrays, and now two-dimensional arrays. Okay, so now what we're going to do is do some programming. I'm going to show you all the real basics, how to store it, and everything else. Okay, we'll start off and we'll load in my demo program for today's lecture. And you should have unzipped some of the demos that I've got in the references or the resources for today. And we're going to look at Simple 2D Intro. Remember, there's also a more advanced version just called 2D Intro. And actually, if we have time, I'll go through that one also. But let's focus in on this one first, Simple 2D Intro. Okay, and I'll even give it a quick run, and then we'll discuss what it's doing and how it works. So all it's going to do, and it doesn't even print the words out on the sides. We'll do that in another lesson. Today, really just the guts of the program, the core data. So this just prints out a table for a company that has 3 warehouses and 4 different items, and it did a little math too. It printed out the grand total of all the stock on hand. Now, when you create a database, in this case, the information that we need to load into the computer, we're not going to use input boxes. We're going to load it all from a data file, like I said, and you got to write it down a certain way when you do the data file. And I just want to show you for a sec. On your hard drive, and we'll work our way up to where this program is. So we're in Simple 2D Intro, and we're going to work our way down. We've been here before in the debug folder. There's the stock table. Okay, and actually I'm going to get this out of the way, and I'm going to run this one more time. Okay, and then I'm going to pop that stock table back up again. Okay, so look, see how we're doing 3, 18, 20, and 2? So we're reading in one row at a time, and then the next row, and the next row. So what you do here is you basically write them down one after each other, but do one complete row. So there's one complete row. Then we do the next complete row, and then the next complete row. And then always at the very end of your data, always put a blank. Okay, so that's how you're going to write down the data for a two-dimensional array when we're going to load it in using a file. Okay, now let's take a look at the code to do all this. So kind of like one-dimensional arrays, the way that you tell the entire world that you're going to use an array, it's pretty well like the one we did before, except now it's not just a single square bracket with nothing in it. You put a comma. It's kind of weird, I know, but that's what you do. Okay, and you start off and say int, string, whatever it happens to be, and then you give it a name. So we're going to call our two-dimensional array stock. And we only have 3 warehouses and 4 items. But remember, just like the one-dimensional arrays, when you create a two-dimensional array, it actually has a row 0 and it actually has a column 0. But I don't want to use those. Okay, I don't want to use 0 for anything. I want us to remember that the first thing is the first thing. So first thing is row 1, and the first column is column 1. Okay, so that means I have to add 1 extra to make up for the fact that we're using, it has a 0. Okay, so that's why I say 4, 5. All right, the rest of it should sort of ring a bell. All right, we're going to point to where on the hard drive you have your information. I already showed it to you. We're going to use that stream reader to connect to that location on the hard drive. And now, like I mentioned a few minutes ago, we're going to read them in row by row. So in that chart there's going to be a set of numbers here and a set of numbers here, right? So what this is telling the computer is start off at row 1 and go all the way across, and then take the first column. Then take the second column, then the third, and then the fourth. So it's almost like it's a loop inside a loop. So this outer loop is right now stuck on 1, row 1, okay? And then we chug along all 4 of these, and we feed those numbers into the array. So whatever the first one is goes in here, then the second one, and the third one, and the fourth one. And the only thing extra is, remember, those are with quotes on them, so we have to convert them to a string. So this is how you read in a two-dimensional array, row-wise, okay? Then the row becomes 2, and we focus in on this one, and then again 4 times, we read in the next 4 numbers, and then goes there, and then the last 4 numbers. And now the array is totally filled up. Now, once it's filled up, we can do all kinds of things to it. The first and simplest thing is to actually print out those numbers again. Now, you got to be careful when you print out the numbers, and I'm going to play dumb here in a second and get rid of a line, but I'm going to show you. We have all that information on the computer, and surprise, surprise, we're going to use a loop again. And we're going to start with row 1, and then we're going to go column, 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 column. Now, as we put into the text box all those things, we have to make sure we're attaching it. So we've done this before with a plus equals. It's going to attach this one to this one, to this one, to this one, with a little bit of a tab, so it's spaced out a little bit. But here's what the problem is. When you get to the end there, where do you go next? Well, you have to tell the computer to go down a line. So we attach a go down a line. If we didn't do this, it would try to write it all in one big line, which would look awful, right? Then we go back up to the top, and now we're on row 2. And it's going to display, 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 and then we go down to a new line, and the last one, display, 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 display. All right? So that's how you declare a two-dimensional array. This is how you load in a two-dimensional array. This is how you display a two-dimensional array. And just to finish up, how do you do math on a two-dimensional array? Well, surprise, surprise. You know how we always said with one-dimensional arrays, almost every question has a for loop? This one, every question has 2 for loops. Okay? And since we want to add up everything, we're going to have to get to the computer to go to every one of these spots, grab the number that's there, and then do like a grand total. Now, there's other kinds of math that we can do, and we'll take a look at them in a few minutes. But this is how you're going to get the computer to go to every single spot on your table. And again, this is the long way. If you don't like this way, we can write it out the other way, but this is going to add up whatever is in this one, to this one, to this one, to this one, and onward and onward. And again, let me write this out the long way just in case you still don't like doing it that way. Okay, and that's going to work out our grand total. So now, hopefully, what you see here makes sense. Okay, so to finish up, why don't we step through this program one time just to get you a feel for what's happening inside the memory. Now I'm going to do it a little bit different than I've done it before because a lot of times I'm wasting time going through some steps that you don't need to see. So what I've done is I'm going to put a little stop right around here, okay, right there. Okay, and I'm going to run it. And now I want to show you how the math was done. All right, so we fed in all the information to the computer, it got stored in there. And I just want to show you what's happening when we go through the math steps. So remember, in this stock, we have right now a value for R is 1 and column is 1. And let's see, 1, 1 is 3. So once we've executed this line, the total should be 3. Let's go back up one more time. Now notice it stays inside the inner part. And now the column is going to be 2. So the row is still going to be 1, but we're going to be on column 2. And let's see, what is in row 1, column 2, 18. So we had a 3 there and an 18, so the total should be 21. So it's adding up every single number, and that's how it's working through. So there you have it. There is the basics of how do you work with two-dimensional arrays. We're going to get a bit more sophisticated in our next example. Now, you've seen me use several different versions of programs. So like, for instance, in this one, what we did today was the simple 2D intro. But I also like to make a bit more sophisticated program. So I'll show you a bit more sophisticated version of this. Works the same way, gives the same results. And the only difference is that I resort to methods, which makes it a bit more structured and efficient. Okay, so I created a method called DataFile, and I feed it the 2D array stock, and it gets fed into here. I also send down 2 numbers, which get stored into rows and columns. There's your basic data file setup. And then I go from 1 to, and I don't use a number this time, right? So it's a more general version of the program. So it works from 1 to the number of rows. In this case, obviously 3, but it's stored in a variable. And 1 to the number of columns. In this case, 4. And then we store each of the numbers that we read into that two-dimensional array. When it returns, now stock is full of information. And I'm just going to put a little stop right there for a second. I'm going to run it. Okay, and so when I hover over this now, it is full of information in our two-dimensional array. So there you see the information as it got filled up. This last one uses a method that returns a value. And look what I do in this last one. I feed a method called TableTotal, the entire array, and the numbers 3 and 4 for the rows and columns. Let's press F11 and see where it goes. Here it is. It's down here in the total table, and it has sent to it the array, and it gets stored into the two-dimensional array S, and the rows are 4 and 5 is the column. And you saw me already step through this, but this is kind of like a generic totaler. And look at the very end, it's going to return an integer value for the total and put it up here at the top. Okay, and let me just quickly go through it just to show it to you. Okay, we're almost there. We're on row 3. Okay, and then at the very end, the total is going to get worked out. All right, and the total is at 670. We return up here, and we put it into the display. Okay, and there's the results. So there you have the bit more sophisticated version of the program. Now, I won't always go through the more sophisticated version all the time, but at least you have an idea how to do kind of a simplistic one and a more advanced one. So there you have it, our introduction into two-dimensional arrays. In our next lecture, we'll kick it up a notch and add the totals for the rows, totals for the columns. We'll add the words on the side and the words on the top to make it look like a real complete total and two-dimensional table. Welcome back, and this is the second lecture on two-dimensional arrays. Today we're going to take a look at a full application which involves data analysis of quizzes for a particular class. Okay, what we're going to do is take a look at a fictitious class and assume that there are a number of students in the class. They have written 4 quizzes, and these are their results. So the numbers I just circled right now, that's going to be a two-dimensional array. And then this information, the quiz names, are going to be one-dimensional arrays. The student names are going to be one-dimensional arrays. And then we're going to do a series of things, like we're going to figure out who got over 80 on any particular quiz. Work out who got the highest mark, maybe work out the average mark for Mary, work out the averages for quizzes. So we're going to do all kinds of analysis on this information. Okay, the program we're using is called Simple Quiz Score, and if you want to remember, I've got two versions of it. I'm going to stick with the easy version today, Simple Quiz Score. And what we're going to do is, and I'm going to run it again, is go through a series of analysis on this particular piece of data and come up with all kinds of different results. So we'll go through all of these in a second, but let's focus right now on the pure data and how it's going to get stored in the computer. So we actually have to store these names. We've got to store the people's names. We've got to store the marks. And we're going to store one more thing because we're going to do this thing called a weighted average. So I just want to show you where the data is and how I set it up. Okay, so when you unzip this file, you should see a couple of these. And we're going to go into Simple Quiz Score. We're going to go into the bin folder, debug, and there's our quiz file that stores just our raw data. Now remember, we're going to store all those numbers, but we also have to read in the student names, the 4 quizzes, and these are the percentage weights for each of the 4 quizzes, okay? And you'll see how that comes into calculations later on. And then you always leave a blank at the very end. So remember, when we type in these numbers, there are the numbers in the table in a row-wise fashion. So they're 65, 57 all the way across. So these first 4 are for the first student, the next 4 are for the next student, and the last 4 are for the last student, Karen. Okay, let's get into the program and take a look at the code and each of its component parts. So first of all, we're going to do a lot of declarations. Our chart is actually 3 names of students and 4 quizzes, but remember, we're going to make it always one more than what it is because we're not going to use the 0 values, okay? So this declares a two-dimensional array. Now, those names of the students we're also going to store, and there's 3 students, and we're going to store them in a one-dimensional array. The quiz names, there's 4 of those, and I'm going to store that into a one-dimensional array. And this one here you won't understand until the very end, but there's going to be weights for each of the quizzes. There's 4 quizzes, so I'm going to declare those. And remember, we always make them one more than what they are. Again, these ones you won't understand until later on, but we're going to do name totals, like we're going to add up all the marks for Mary or whoever, and then we're going to do quiz totals. We're going to add up the totals for all the quizzes. We're also going to work out later on in this program, for each quiz, we're going to figure out the lowest mark on that quiz. This prints out the titles as we start our program, and this prints out that we have the original data. And then we start loading in all the information. Now remember, we're going to make a path to the hard drive pointing to quiz.txt. We open up the stream reader, and then we use a double for loop to read in the information. So we have 3 rows, 4 columns, and this is going to read in the raw numbers, not the people's names or anything like that, but the raw data that make up the table. Okay, so it's going to have 4 pieces of information for each person. Okay, so this will do all of that for us. Then what we do is we read in the names of the students. That's this part of the chart. And lastly, we read in the quiz names. Now, in here, we're going to use some weights later on in our calculations. So right now, you won't understand why we're doing this, but each of these quizzes is going to be worth a different percentage. So when we work out the average for Mary, it's going to be a weighted average. Okay, and that's it for reading it in. We close the file, and now we're into the next part. Now we're ready to display the results, and I'll just run it a second to show you what I mean. So now we're ready to print out the chart. So that's like our first step in there. So I want to know how to do this. So let's slide this over a bit so I can show you the code at the same time and compare it to the results here on the right hand side. So where is all this happening? Well, the first thing you should notice is that I've got to slide over a little bit to print the word quiz 1, 2, 3, 4. How do you do that? Well, see that line right there? What that does is tell the computer to tab over a little bit. Okay, and then wait there. And now, in a loop that goes from 1 to 4, this will attach these quiz names with a little tab to the next quiz name with a little tab to the next one, to the next one. And then remember, after that line, I have to go down a bit. Okay, so that is how you get the top part to print out. Okay, let's now focus in on the bottom part where we're typing in all the people's names and their marks. So where that happens is right in here. This is going to be a double loop. Starts off with r equals 1 to 3, and right away we attach the student's name right there. We're on row 1, so we print out student 1, which is Mary, and then we tab a little bit. Then we go into the second part of the double loop, which goes from 1 to 4, and that's going to print out all of these marks. All right, so we're going to display in the text box the quiz r comma c, which will be the first one there, 1 comma 1, all right, row 1, column 1, and we'll tab over a little bit and keep doing it and doing it. When we get to the very end, this line right here will make the computer go down to the next line. And this basically cycles through, so all of this code in here will print out everything about the student. And then at the very end, we print out a new line to go down one more space. Okay, this next line just gives you an indication of how you could change a mark if you had to. Let's say I told you, change John's mark on test number 3 to 97. So John's mark on test 93. John would be row 2. Quiz number 3 or test number 3 would be column 3. So what this does is change the mark stored in this location right here from 91 to 97. Okay, let's continue. Let's say we're going to reduce the marks for every single student by 3. How would you get the computer to do that? Well, this would be a for loop that goes from 1 to 3 for the rows, 1 to 4 for the columns, and then this line right here goes to each and every one of these little boxes, the numbers in those boxes, and deducts 3. Okay, let's go through some other ones. Next one says, go through all of these marks and figure out who got over 80. All right, interesting question. Fairly straightforward. Basically what you do is, and again, you keep seeing, for the most part, when you work with two-dimensional arrays, you always use 2 loops. So this one goes from 1 to 3, 1 to 4, and it says, hey, when I'm on this mark right here, 1, 1, is that greater than or equal to 80? Because if it is, display it. If it isn't, skip it and go to the next one, and the next one, and the next one. So no marks, Mary has got no marks over 80. Then we go to John. Oh, there's an 80. Okay, and you notice here when I print it out, John on quiz number 2, you got 87. Now, you might say, but 80, how come it didn't get displayed? Well, remember, in the previous loop, we had deducted 3, so now that guy's mark there is 77. This one right here, which used to be a 90, is now an 87, but it's still over 80. So that's why it's displaying those answers. But this is what you do, okay? So it's always a double loop, and then some if statements, some counters, whatever. Okay, next question was to find the biggest mark in this entire chart, okay? So what we do there is, remember that trick we used with one-dimensional arrays where you made big equal to something stupid? Same idea here, works exactly the same way. The only difference is that we have to remember 2 things when we find this biggest mark. We have to remember what row we're on and what column we're on. So that's why you see these 2 variables, pos n, position for the name, and position c for the columns. So I go through all of them, and if any particular mark is bigger than big, that becomes the biggest mark, and I remember the row that I was on and the column I was on. And at the very end, I print out who got the highest mark. All right, so that's that. And then the student who got it, so that would be stored in position n for the name, the row. And I'm going to slide this over just a little bit so you can see it. And the quiz name, position C. Okay, and if you're wondering when we ran it, how come the highest mark is 94? Because right here it says 91. Remember, I changed this guy's mark to 97, and then we deducted 3, so it's 94. So it's correct. We're doing it right. Okay, let's slide down now to the next one. The next couple we use what are called array counters, which we've done before, okay? So what we're going to do next now is work out the totals for each student. So Mary's total, John's total, Karen's total. And what we're doing is basically row totals. So we're going across this way and adding up every single number. And the way you do that is you always base it on what you're going to do. So this one, we're doing row 1 to 3, column 1 to 4, and the number in the bracket, this thing right here, is going to be a row total. So when we're on row 1, I want to add up everything in that row. Okay? Now, again, if you're not crazy about this plus equals, okay, the other way to write this, and I'll have to stop the program to show you. Okay, so we'll slide down a bit. So right there, the plus equals, we'll rub it out, and we'll write down n total square bracket r. And the trick here is, if you're doing a row total, keep the index in there as r. So the computer will know I'm on row 1 and I'm going to add up all the numbers in row 1. If I was doing column totals, I would change that to a C. All right, so this will work out the column totals, and if we run it again, you'll see what that works out to. Okay, so here's what we're doing, student totals for Mary. So if we added up all those numbers, you'd get that. Same with John and Karen. All right, now we go on to the next question. The highest mark total. So from all of these numbers here, which one was the biggest one? So we can see obviously it's Karen 312, but how do you get the computer to work that out? Well, once we have stored in the computer's brain that array total, all we have to do is go through those numbers and find the biggest one. So pretty straightforward. So we've got already from the previous question the n total worked out. So now I just store my biggest number as -1, and I compare the row total to big, and obviously the first time through this is going to be bigger than big, so I remember it and I store the position, and then I say the biggest one was that particular mark and it was obtained by that student, POS, which would be the row of that position. Okay, and if we show you that again, so for this particular one, the highest was 312, obtained by Karen. All right, now we're going to do the reverse. What we're going to do in this one is work out the column totals. So I want to know what all of these numbers add up to and put it there, what all of these ones add up to and put it there. So this one, what I do, and you didn't necessarily have to reverse the loops, but because I want to focus on the columns now and not the rows, I'm going to start off with the column totals. And notice here now, I'm using another variable called qtotal array, and this variable in here is a C, which means we're doing the columns. And then we print out the results right below. Okay, now, next one says, let's figure out the averages for each quiz. So kind of almost like we have it done. We've worked out the quiz totals, so the overall average for each quiz. If we know this number already, all we got to do is divide by 3. So what I do here is, because I already worked out the quiz totals, what I do in this one is just a single loop that goes from 1 to 4, and I go to each quiz total I already worked out and divide it by 3. And because there's 3 people, and that'll give us the averages for each quiz. And that's what I get right here. Okay, last two are the most challenging ones, a little bit tricky to understand. Let's go back up for a second. Okay, and you got to remember that I've taken 3 off of these, so when you see the answers at the bottom, they're going to be slightly different. But what I want to do is go through here and figure out which is the lowest quiz score for quiz number 1. And then I want to know who did it. So that one would be Mary. Who got the lowest quiz on quiz number 2? I think it's poor Mary again. Okay, and we go through each one of these and we work out who got the lowest value. So we're kind of doing the low a whole bunch of times. So this is probably the hardest question of the whole thing. Okay, so what we're doing here is we're going to go through each quiz. So we make the C column be the first loop, And you know how we always make something stupid? Well, we got to make something stupid 4 times. So we're going to have an array thing be our low or small equal to something stupid. And it's got to be stored in an actual array because it's not just one variable, it's 4 of them. Then we go through each of the students and we see if that quiz is lower than quiz C, which is 1. If it is, we store that number into low quiz. And we also got to remember the position. So we store that there. And then at the very end, we have a loop that goes from 1 to 4 because there's not just one answer this time. And we print out the lowest quiz mark. And it was obtained by, now look at this in here, student, and then it's low quiz square bracket C. Okay. Now the last one. You may get this, you might not. What happens a lot of times when you take tests in university or college or high school, certain tests are worth certain marks. So your teacher might say that quiz number 1 was worth 20% of your mark. Okay. And then she might say quiz number 2 is worth 80% of your mark. So if you got a 70 on this test and you got a 90 on this test, here's what your average would be. The teacher would take 20% of 70, which is about 14, and then she would take 80% of 90, which is 72. So then your mark is 86. This is called a weighted average. Certain tests are worth more. This might have been a small little test, a little review test. This might have been a big humongous test. So this one was more important than that. So what we want to do now is take these percentages and multiply them by each test to get the average for each student. So let's take a look at how you do that. Okay, so remember, at the very top of my program, I read in the weights. All right, and in this particular example, the weights are based on the quizzes. Okay, quizzes are columns. So that's why when I times the weight here, it's with the square bracket C. It's a column. So I go through a double loop to go through every single thing, and I work out a final mark, and it's based on the total of whatever you got on a certain quiz. So R is the person, so we're on the first person, and we're going to take that answer, times it by the weight, and then add it to this answer, times it by the weight, this answer, times it by the weight, this answer, times it by the weight. And when we're done, we'll have a final mark for that person. After we've done every single person, we will display the results here with the final mark. And that's where you get the following. Okay, so down here, that's the overall marks for those students. So quite extensive. I know it's a lot to throw at you. And what we're going to do in the last lecture in this section is sort of step back now and make you practice a nice problem nice and slowly. But this is all the basis of what you need to do that question. So we're going to take a break now. Don't erase this program. Keep it on your screen, because when you do the next lecture, basically you're going to either copy and paste and change this or use this totally as your guide and just type over it. Okay, so that's going to help you do the last question. So a little bit confusing today, a lot of stuff to throw at you, but this is data analysis using two-dimensional arrays. Welcome to the last lecture in this section on arrays. What we're going to do in this lecture is practice what we've been learning. And specifically, we want to take a look at yesterday or the previous lecture that you worked on and apply that knowledge to an application similar to it. So what I'd like you to do today is take a look at the supermarket problem data analysis. And what you're going to do is, first of all, you're going to have to create data, and I have not typed in the rest of the numbers, but I want you to come up with, well, there's 12 months and there's 3 years, so you're going to have to come up with 36 numbers, which represents the sales of soap detergent at a particular supermarket, okay? Then you're also going to have to store the years as a one-dimensional array and the months as a one-dimensional array. And then there's one other feature that you probably will see down here at the bottom, which mirrors the last lecture. You're going to store the prices of detergent in different years, okay? And you'll see where that comes in as you do the questions. Now, how should you do this question? What should be your technique? Well, like we've done in other examples, we're we worked on simple quiz score, right? So what I would do is right click on it, copy and paste it. And I did that, and I renamed it Supermarket. It still got all the quiz stuff inside of it, but I would use that as your basis, okay? And then what I would do next is I would go into this folder, and because we're doing Supermarket, right? I would rename this quiz text to Supermarket, but then obviously the numbers have to change. So what you're seeing here is 36 numbers, which would represent the sales for the various years. Now, when I get down to the last one, the 36th one, then these three numbers represent the 3 years, 81, 82, and 83. And then we've got the months right there, okay, that are going to go along the top of the columns. And those are those three prices for the 3 years, okay? So that's kind of the hint to get you started. Now, I want you to then start up this program. And you'll see that the questions mirror the solutions that you have here, okay? And really don't change, I changed the button name a little bit, and then double click in here, and then I'll get you even started with some hints. So then what you do is you basically look at each line, okay? And I'm even a little reminder to you and to me, I'm just typing over the quiz score program. Now remember, in the quiz score program, we had some core 2D and 1D arrays that you needed. And I've just changed the names a little bit. I think here I had quiz scores, and now I've changed it to Supermarket. And then I had student names, and I had the quizzes, and now I've got years and months and prices, okay? So you're gonna have to go through this entire program, line by line, modify what you need. Now, of course, for the Supermarket, we have 3 years, and of course, 12 months. And remember, you always make it one more than what it is. So that's a little hint to get you started. And what you're going to do is go through the entire program and make the changes to match the solutions to the question you're going to work on. Okay, so I'm going to stop right now. Give yourself whatever, half an hour or even more if you need it. And then when you think you've got it or you've given up, come back, restart the program, and we'll go through the solution. Okay, let's knock off these first 3 questions right off the bat. They're going to be pretty straightforward. So this is going to say, read in all the data into a 2-dimensional array called quantity. I called it Supermarket, it doesn't matter. Read in the months of the year and years into 1-dimensional arrays and print out the exact table. Okay, so let's take a look at how you would do that. So this is how I set up all my new arrays. These ones here, although I'm not going to use them right now, we're going to be working out year totals and month totals, so I changed that, and hopefully they are the correct numbers, okay? We're also going to work out the lowest sales for each month, okay, and we'll need those. This is how you print out Supermarket analysis and original data, and now we're ready to read in the information, okay? So all of this is pretty well the same. I changed this to supermarket.text. Now we're going for our 1 to 3, column 1 to 12, right? Because there's 12 months. And this reads in all the pure numbers, the guts of the program, the sales, into the 2-dimensional array. We've got 3 years. This will read in the years. 12 months. This will read in the months. And we've got prices for the 3 years. That'll read the prices for the 3 years, okay? And I could have actually used R there. It doesn't matter what you use, tell you the truth, but I made it match. So actually, to be more correct, let's change that to an R. Okay, and then we'll change that to an R. Didn't change the answer one bit, but because prices are going to be based on years, and years are rows, I'd rather use that. Okay, now how do you print out the original table? Pretty straightforward. Remember, you're going to have to tab over a little bit when you print out the table, because you're going to print out the chart here with the months. Okay, so you're going to have to tab over a little bit to get started. And then the rest of it is pretty well identical to the one we did before. You're going to have a loop that goes from 1 to 3. This will print out the year, 81, let's say. Then this will print out the 12 months, January, February, March, all the way to the end. Then we go down a line and we keep doing it until we print out the entire chart, and then we print out an extra blank line. Now, next question says, change the sales for March 1983 to 117. So 1983 is row 3, March is column 3, and we change it to 117. And the way you do that is quiz. So we don't want to call it quiz anymore, right? So we're going to call it Supermarket 3, and we're changing it to 117. Okay, and there is the answer for question number 4. Question number 5 says add 10 to all the sales. So the one that we did in a previous lecture basically said, I'm mad, take 3 away from everything. And this one, I'm not mad. I'm giving the sales a little bit more. So first of all, the rows go from 1 to 3, and these comments obviously would have to be changed too, but let's just worry about the main program. So row 1 to 3, column 1 to 12, and it's supermarket. And what are we doing? We are giving everybody added 10 to the sales, right? So we're going to come back in here, and instead of minus, plus, and then 10. Okay, so that's how you do that question. All right, so that was number 5. Now this one says print out the months and years sales were above 100. So see how this one said print out the quiz marks over 80? Well, we're going to do the same basic idea. 1 to 3, 1 to 12. Okay, and supermarket obviously. Okay, and sales were above 100. Okay, so we change that to 100. So you see how you're just using mine as the base. Now we're not printing out the student. We're going to print out the year. Okay, I think I spelled it as year, not with an S on it. Let me just check. Years. No, I did put an S on it, and the other one has months. So I'll make sure it's years with a cap with an S, and then this is months. Okay. And this is supermarket. Okay, so far so good. All right, so that was the answer to question number 6. Okay, we're rolling pretty good. Number 7, compute and print out the sales quantity totals for each year. Store each in a one-dimensional array called year total. So we're going to change that a little bit, but you get the basic idea. What we're doing in this question is we're going to go across all the way and add up all those numbers for 81, and then 82 and 83. So it's very similar to the one we did right here. Now this one actually is not one of the ones we did. Okay, so actually I'm going to rub this out, or should I rub it out? Because is there going to be one like this one? Let's see. Sales, compute, sales for the term which, okay, print out the year and month which had the greatest sales. Oh, so it's number 11, the year and the month which had the greatest sales. So that's right in here, actually, the year and month that had the greatest sales. So I'm going to stick with that. So I'm doing question number 11 right now. Okay, and sort of I want to use everything I can in this program to save us. So this is the answer to question 11. So we're sort of skipping a couple for a second, and it's 1 to 3, and then 1 to 12. And that's supermarket. Okay, and then supermarket. Okay, and then this is okay. Position N is okay. You could call it position row. All right, you know what? Just so you know what I'm talking about. So we'll make that an R. And the other one's position C. So the highest sales was big, and it was it was obtained by, so we're going to change that to year. It was in year, and we'll put the word years there. R, and we'll slide that over a little bit, and we'll put down months and pause C. Okay, so I jumped the gun a little bit because I want to use every single thing I've got here just so that I can maximize the potential of the previous question. So I slipped down to number 11 here, print the year and months which had the greatest sales. Now we can go back to number 7. compute and print out the sales total for each year. So now that's this one right here. Okay, we're going to go across. We're going to do everything for the year. So we change that to a 12. And it's not N total anymore. If we slide up for a second, okay, we have Y total for year and M total for month. So where it says N total, what I'm going to do is instead of that, put Y total. And this is supermarket. Okay, and then it prints out the final results. Okay, and this is going to be year total. So it's actually just with a Y. Actually, should I print out the year there? Yeah, that should print out the actual years. So I'm going to print out years, and then this is year total right there. Okay? Okay, we're going to do a little bit of jumping around again. Number 8 says print out the totals for each month. So let me come back in here, and that's not this answer. Okay, it's this answer below. So for column 1 to 4, I'm going to change that from 1 to 12. So we're going to do the month totals. So instead of that, I'm going to use M for M total, so that's month totals, and we change that to supermarket. Okay, and then instead of quiz totals, it would be month totals, obviously. And we would go from 1 to 12, because we're going to go through all 12 months. This is going to print out the actual month, so months. And this will be the M total, which stands for month totals. Okay, rolling along here. Okay, so now we're on number 9. Compute the average sales per month for 81, 82, and 83. So what you do is we already have the total for the entire year. And if we divide it by 12, we're going to get the average. Did we do a question like that somewhere in here? Okay, yep, something like this one right here. Okay, so we're going to do averages for each year. And we can call it Q average if you want. But what we're going to do really is call it just average. Okay, and we're going to have 3 of them, right? So we're going to call it as an array of 4. And then we're going to go from 1 to 3. Okay, and I guess we should change that to an R because it really is for rows. All right, and we're going to take the average for the row, okay, the year, and we're going to take the total, which we worked out before, which was our year total, and divide it by 12. And then the overall average for each year, and so we'll change that for each quiz to each year. And then we're going to go from row 1 to 3, okay, plus plus. I also notice I should have an R there. And this one's going to be an R. And then it's not quiz name. Okay, we're going to do the years. And this is going to be the average. And that'll be the R. Okay, and this will be R. And that'll be R, okay, because it's working out years. Okay, before we finish the remaining questions, let's clean up a bit of stuff. There's no question like this one, so I'm going to delete that. Actually, I'll delete this part too. Okay, so we won't use that. Okay, and I think we've gone through quite enough of these questions. Okay, this one would print out the average sales per month. So we've already know the total sales per month right there, this one right here, and you could use that to calculate your average sales per month. What I want to do is to finish up and do what I consider a bit more of a challenge question. I want to do this one right here to make sure you know how to do it. Number 12. Suppose that the price of detergent in 81 was 4 57. In 82 it was 503. In 1983 it was 633. Print out the total sales for each year based on those costs. So what they're trying to do there is, you know how they sold 23 detergent boxes in January? Well, how much did that cost? Well, it was 23 times 457. And I got to go across and multiply those out and get a grand total. So what I'm trying to do is figure out the year totals for each one. Okay, so that one is a lot like this one down here. Okay, so this is going to use this last part of the previous example. So we're going to call it final prices or final amounts. Okay, so final amount sounds better. And there's going to be 3 of them. Okay, so that's okay, that makes sense. We're going to have a loop that goes from 1 to 3 and then 1 to 12. Okay, everything looks good there. And then this one should be final amount. And it's based on the row. And obviously it's not quiz, it's supermarket. And it's not weights. I think I called them prices. Okay, now, is it a C or is it an R? Well, the prices are per year, so we're going to have to change that to an R because there's only going to be 3 different prices, one for 1981, 82, and 83. Then we print them out. And then, obviously, it's not student, it's years, and not final mark, but final amount. And there you have all the different ones. Now, I'm going to get rid of one part for now because we didn't end up doing it, but you can try it yourself if you want. It's similar to the one we did in the previous question. It says for each month, print out which year had the lowest sales amount. So what that would mean is go through January, figure out the lowest number, and then tell me what it was and the year it occurred in. Okay, so it's very similar to the one we did before, and you can see it right here. It's where you have to figure out the lowest quiz mark for every quiz. Okay, and then tell me when it happened, and then in this case the name of the student who got it. So it'd be very similar to this. Now I'm going to rub this out right now because I want to try to run this program, and this is going to give me an error if I leave it in. Okay, so we'll test it out and see what happens. Okay, I've widened the screen a little bit because we have to print out from January to December, and let's take a look at the kind of results we get. So there's our original data. Okay, it looks nicely formatted. I was kind of lazy with the numbers. I just repeated the same numbers for each year. Hopefully you made up something different. And these print statements here obviously are still from the quiz score problem, but this at least gives you a rough idea of some of the things we had to do. I think this was show me all the sales that were over 100. And you might be saying, well, I don't see any sales over 100 here. How come you've got sales there? But remember, one of the questions said to give all the months extra 10 in sales. Okay, so some of these numbers do go over 100 if you're wondering how they get this. Okay, and I think even one of them I changed to 117. Okay, so there is the nice solution, little wrap up. I know this has been very dry, this topic, but trust me, hang on. We're going to do random numbers next, and we're going to get into gaming, and that's when the real fun begins, but you had to know the basics before you could get into that. Thanks for listening, and we'll see you in the next new section. Welcome to our next section, probabilistic simulations. It's kind of a fancy word. Can you tell probabilistic? It sounds a little bit like probability. So what this particular section is going to do is we're going to simulate events of chance. Now, in the world of computer science, there are several ways to simulate things. What we're going to do in this particular section is simulate things via random numbers, okay? And the fancy word, as I mentioned in the opening for this, is called probabilistic simulations. There is another type of simulation called deterministic simulations, and what that does is it uses things like math and science, physics formulas to plot the trajectories of missiles. If you're playing a pool game, how a ball is going to bounce off the edge of the side of the table and bounce in a certain direction. Now, in this course, we are not going to take a look at deterministic simulations. That's for a more advanced course. We are going to stick with random numbers, playing dice games, rolling, flipping coins, that type of thing. Okay, so it's more a game of chance based on picking a 1 or a 2 or something like that. Okay, let's get into the specifics and take a look at how you generate random numbers and how they work. So we're going to go into the code, and the special class that you use for random numbers is called random. And does this look familiar? Isn't that like that object-oriented stuff we learned before? Now, this is the most generic way to do random numbers. Now you have to realize that they're not really random numbers. They're what are called pseudo-random numbers because they're really based on a computer formula, pretty complicated computer formula. And this computer formula is going to generate a number, okay? Now, when you use this formula, and if you remember formulas, like here's a simple formula, 2x plus 1. Don't you have to always have some sort of number that goes into part of the formula? Well, you can seed a random number generator. Now, if you don't put anything in this bracket, it automatically generates its own seed, a special number to sort of kickstart the formula. Some random number generators use the clock, and other ones use something else. But for our purposes, we're going to use this way and let the computer do all the dirty work. Now, if you want to use your own seed, you can. And let me rub this out for a second. You'll see as I type it that there are two different versions. So there's the generic one that automatically generates the seed for you, and there's one here where you can just make up a number. So you could type in some number and use that to kickstart this formula that's inside C# that would make generating random numbers based on that number. Now, the next number that gets generated after you generate the first one is based on the one that you just got. So it's how it feeds in the formula for the next time around. So if we fed the random number generator 234 and it came up with a random number of 7, that number would go in to make the next one. Okay, so that's the two techniques that you can sort of activate the random number generator. Now, that doesn't actually make the number. Now what we have to do is say, let's do a number, and r dot. And there's a number of methods associated with random numbers. The one that we're going to use is called r.next, which says generate the next random number. If I was playing a dice game, and there's 6 possibilities, this is how you would generate it. Now, there's going to be 3 techniques I'm going to show you, but this is my favorite. Okay, and then I'm going to do a little message box here to prove to you that it's going to pick a number between 1 and 6. So it's always the low number, and then 1 more than the high number. Random number picked is, and then you attach the number to string. So what this is going to do is generate a random number for us. Let's give it a quick try. Okay, so remember, low number to 1 more than the high number. So we'll put this over here, we'll generate it, and we get a 1. 3. 5, okay, and it's 5 again. So generating random numbers, eventually if we press them enough times, we should get every possible number up to 6. Not 7 though, remember, up to 6. Okay, and there's a 6. Okay, so that's the basic background for random numbers. Pretty straightforward, pretty easy. Okay, so all you do is you have to wake up the random number generator. So you instantiate it, remember those fancy words we learned before, and then you just tell the computer from what variable values you want to go from what low number to what high number, and it's always 1 more than what you need. Let's look at a pre-made program now, and if you've unzipped the files for this particular lecture, I want you to load in the one that's called random number intro, and we'll pop it up and see what it does. So basically it just shows you a series of possible numbers to generate. So this one generates numbers between, I think, 1 and 9, okay? And then this one obviously between 1 and 6 for a dice game. We just did that one. This one between 7 and 20. So you can generate numbers between any range that you want. Now let's look at the code for a sec very quickly to review what we just covered a few minutes ago. There is how you wake up the random number generator. And this one, instead of having just one statement and then having a message box pop up, I want to do a whole bunch of them, right? So this is the power of the for loop, all right? It saves us having to type each one down 100 times. And as I mentioned before, there's 3 possible ways to generate random numbers. The way that I showed you is my favorite way, but there are other ways that you may see if you ever look at programs on the internet. This one would generate numbers between 0 and 9, okay? Not crazy about that way, but that is another way. So if you ever see that and it doesn't have two numbers inside, you realize that it's going to generate numbers between 0 and 1 less than the upper limit. Okay. The second example, between 1 and 6, which we already sort of did, there's a loop that goes from 1 to 100, and this is the other technique. And again, I'm not crazy about this one, but you may see this one also, and you need to know why and how it works. So this one is r.next, and inside here you write down the 6 and then plus 1. And the way that you come up with this 6 is you always take the highest number that you're trying to get, take away the lowest number and add 1, and that becomes the number in the bracket, and then you always add outside of the bracket the low. And again, not that crazy about it, and remember, we just did it this way, which I like. All right. Okay, one more, 7 to 20. Same kind of idea. This is kind of like that other way I just showed you. All right, and that should be high minus low plus 1. Okay, so if you were trying to figure out numbers between 7 and 20, all right, you would go 20 minus 7 is 13 plus 1, and you get 14. All right, so that's how you got the 14, and the low number was 7. But again, my favorite way to do it is that way. To finish up, let's look at a little simple problem. We're going to generate heads and tails. Not that big of an issue, right? Now, you're either going to get a head or a tail, which means that you're going to generate two numbers. How about the numbers between 1 and 2? And you can arbitrarily say, listen, if I get a 1, to me that means it's a head. And if I get a 2, that means it's a tail. Okay, so fairly straightforward. I'm going to run it for a second to show you what it does. Okay, just press it, and we generate 100 tosses. And what were the chances of that happening? I mean, that's probabilistic-wise, that's what it should be. But usually you don't get lucky and have it 50-50. You get it usually like this. Okay, so it's almost 50-50. The chances of that happening again are very slim. Okay, but there it is, and that's what the program does. So let's take a look at what we actually did behind the scenes. So first of all, we're going to keep track of heads and tails, right? So we got to remember we're going to use these counters, okay? And they're called counters because they're going to go up by ones, not accumulators. Every time we play the game, we cycle through it, we're going to toss the coins. So I'm going to have a variable that's going to represent the toss at that moment. Remember, this is how you wake up the random number generator. And now we have a loop. So we love these loops, okay? Make things so efficient. And we're going to do this experiment, so to speak, 100 times. And what are we going to do? We're going to pick a random number between 1 and 2. And remember, it's always, and I like this way the best, the first number is always the low number. Okay, so that one's always easy. The second number is 1 more than the high number. So whatever you think you're going to make as your limit, add 1 to it. And this will generate numbers between 1 and 2. And I have arbitrarily decided that if my toss, and remember double equals 1, to me that means it's a head. And this is like the cool way to count heads, and this one will count tails. When I'm totally done the loop, so I've left the loop and now I'm outside the loop, I'm going to display in the list boxes the two results. And there you have the most basic of sample application of probabilistic simulations. But this is a kickstart. This is how we're going to start writing some really decent games. Okay, so I love this topic, and it's not that hard, right? You can see you're not really learning anything crazy. Everything you see here you've done before, except this new thing called random numbers and next. Okay, so on the next lecture, we're going to take a look at a couple of problems to make sure you understand them. And as we always do, we're going to stay in this program and just widen it a bit and add some buttons so we can refer to this one as our helper. Theory to practice time. Let's go through now a couple of problems to make sure we understand the concepts we learned in the previous lecture. Okay, first, a quick recap. We learned in the previous lecture that there is a way to generate random numbers, and what you do is you instantiate the random class, and there are 3 techniques, of which this second one I like the best. Okay, and once you understand that, you can generate random numbers between a number of different values, from 0 to 1, 1 to 10, 1 to 1,000, whatever. Okay, just for fun, let's do this one right here. If we had already instantiated the random number to generate this one, you would go r.next, and then you would write down the low number and then one more than the high number. And this would generate random numbers between 20 and 36. Now on to some programming problems. Okay, we've got a series of 3 questions that we're going to cover. Let's take a look at the first game. The first game is a spinner game. And basically it says you've got these 2 players that are going to play against each other. And there's like a spinner. And when the dial stops in the spinner, that person gets that number of points. And the spinner has numbers 1 to 9 on it. Now each player is going to get 10 plays. And it even gives you an idea how to do it. We're going to use a for loop for sure. Okay, we're going to generate random numbers between 1 and 9 for the first player. And that represents his number of, or her number of moves. Immediately following that statement, accumulate the player's moves. So we're going to keep like a grand total. Then do the exact same thing for the second player. Perfect. And after 10 plays, figure out who won by comparing the accumulated number of moves. Okay, and here is just a sample of what it could look like. It doesn't have to be exactly like that. But hey, pretty neat game. Let's do it. As I've mentioned throughout this course, when you're not sure what you're doing, why don't you use one of my programs as the base? So for this spinner game, we're going to go into the pre-made button that I made. And I'm just going to, even though I'm not sure if it's going to be exactly like this, I'm going to grab all this stuff in here, okay? Because it saves me having to do the list box stuff and things like that. And there might be some other information that actually I might be able to use word for word. Okay, now this is a spinner game. So instead of heads and tails, there's going to be a player 1 and player 2. All right, so those are going to be like the totalers, the accumulators. There's also going to be a spin, like what did you get on a particular spin? Okay, and we don't need 2 different ones. We can use the same variable for both players. Okay, and I'm going to get rid of this toss. Okay, so now we've got a random number generator. We're ready to roll. Now we're going to play this game 10 times. So this loop here, instead of going from 1 to 100, is going to go from 1 to 10. And now we're ready to play the game. So we're going to have the first person spin. Now he's picking numbers between 1 and 9. So I'm going to make that 1 and 10. Now that we have the spin for player 1, all we got to do is add up. So I'm going to get rid of all of this actually. All I'm going to do now is add up player 1's total. So player 1 equals player 1 plus his or her spin. Okay, and now we'll do the same thing. And actually, I'm just going to copy and paste. We'll spin again, but this time we'll pretend it's for player 2. And so we'll change this to a 2 and this to a 2. And that's the basic game. They're going to do this 10 times, and then we're going to figure out who won. And we don't need this anymore either. Okay, and basically we're going to say if, and I guess there could be a tie, right? But let's just go with one's bigger than the other or vice versa. So if player 1 is greater than player 2, squiggly, message box, player 1, I'll put it in quotes actually, player 1 wins with, and actually let's attach, what are we going to attach with player 1 to string. And I'll also tell you what the other person got too, though, just to be nice. And I could have put that in actually in the list box. Okay, so I'll put down what player 2 had. Now the next one is exactly the opposite. And of course we could have an equal. They could both be tied, but for now let's just go with these two. So I'm going to copy that. Else if player 2 is greater than player 1. Okay, player 2 wins. All right, and this is that person's total, and player 1 had that. Okay, And I think we're ready to go. Player 2 greater than player 2 should be a 1. All right, let's give it a run. All right, so player 2 wins with 56. Player 1 had a 49. Player 2 wins with 59. Player 1 had a 43. Okay, so fairly decent. Our first simple game, so to speak, and there's the solution for it from beginning to end. On to question number 2. So in question number 2, what we're going to do is roll 2 dice, and what we want to do is find out how many times you get a 7 when you roll 2 dice. And we're going to do this experiment 50 times. All right, so fairly straightforward. Let's go in here, number 2, and I'm going to beg, borrow, and steal again from this one. And we will copy it down into the next button. So in this one, I'm rolling dice, right? And I'm going to keep track of how many times I get a 7. So in terms of counters, I'm going to call it 7, and I'm going to start it off at 0. And this is going to be dice 1, and this is going to be dice 2. Now this isn't the only way to do these answers, but this is one of the ways, all right? And I'll get rid of this. Now we're going to do this experiment this time 50 times. So I'm going to change that to a 50, and I'm going to rub this out again. And most important thing is I'm going to roll 2 dice. So dice 1 equals r dot next. Now remember, dice go 1 to 6, so we're going to put a 7 there. Dice 2, same thing. All right, and then we have to add them together. Now you could have a separate thing that adds them together, or you could do this. If dice 1 plus dice 2 equals our lucky 7, then we're going to count it, and we're going to say 7 plus plus. That's the cool way. If you don't like that way, you can go 7 equals 7 plus 1. Okay, and then we're done. And then again, you could do the list box. Actually, this time I'll stay with the list box. I'll rub one of them out. I only need one statement. So we'll go in here and we'll say the number of 7s rolled in 50 experiments is, okay, and then plus, and we're going to go 7 to string, bracket, bracket, and that looks like we're ready to try it out. Okay, we'll give it a run. Okay, and the number of 7s rolled out, you know what, let's widen this a bit so we got room to see our answer. So we're going to stretch out this and stretch out the list box, and that should give us plenty of room now. Okay, and there you have it. So the number of 7s rolled in 50 experiments is 11. Let's try it again. This time you got a 9, 8, 5. Doesn't happen that often, but 11 was the most. That's the most. Oh, 13 there even. Okay, so there is question number 2. Done. Now the last one. Last one's the most challenging, but as it should be, it gives us a bit of time to think about it. And there's more efficient ways to do this question and inefficient ways. So I want you to write a program which determines how many times a toss of 100 coins. So you've got a pile of these coins. There's 100 of them. Okay? And you're going to throw them up in the air. I don't know how great of an idea this is, but after they all fall on the ground and they're lying down on the ground, what you have to do is go around and look and see how many were heads, okay? And we're looking for this particular combination. These 100 coins you tossed, when you looked at them on the ground, if there was exactly 47 heads, bingo, that's the event that we want to happen. Otherwise, put them all back in and start again. Now I want you to try this experiment of tossing 100 coins 50 times. Okay, let's take a look at how we would do this. So 50 experiments, you have 100 coins all the time. Now, like we've done in the other ones, and I wonder if it'll remember what I pasted in before. Yeah, it does remember. Okay, so we're going to go with this. Now, we're keeping track of heads, so we definitely need that counter. I'm going to be tossing coins, right? So I'll have a variable called toss, and actually I had it right there too, but I'll rub that one out. We need random, obviously. Now this one here, we're going to do the experiment 50 times. Okay, so make that a 50, and we're going to toss coins. So that's good, but we got to toss 100 of them. Does that mean I got to write down this line like 100 times? Don't do that. Let's get efficient. We know how to get efficient. We're going to make another loop inside a loop. And actually, you know what? Let me get rid of all this for a second, even though we could have used it. But just to really emphasize what I'm doing here, for integer, we'll use t for toss equals 1, and then toss less than or equal to 100, and then toss plus plus, and then squiggly lines. So what's going to happen is, instead of me writing down every time that r.next 1, 3 for the coins, I'm going to do it in a loop. It's going to save us a ton of lines. That would have been 100 lines there if we did it the other way. Okay, so let's take a look at how it looks. So t for toss, so toss equals then r.next 1, 3. All right, now we're still going to need an if statement. And what we're going to do, whoops, got to the semicolon. So now we go if toss. We don't really care about the other one, to tell you the truth, so I'm not even going to have the other if statement. So if toss equals 1, which to me means you got a head, heads plus plus. Okay, so we stay in this loop for 100 times. Now, after this loop is done 100 times, look where I'm going to go, right there. So right there I'm going to say, and I notice I'm going to have another counter. We're going to have an int count 47 counter, and we'll start that off at 0 initially. Okay, so in here, what I'm going to need to do is now say if the heads equals 47, bingo, we got what we wanted, and counter 47 equals counter 47 plus 1. All right, and that's the basic program. We'll worry about the print statements in a second. Now here's one other problem. After we've done our first time through, where we've had 100 tosses and we've been keeping track of these heads, and we've got a total, maybe sometimes it comes out to 48, sometimes it comes out to 49, but once in a while it does come out to 47 and we count it. Then we got to go back up here again. Okay, so now we're on experiment number 2, and we start tossing coins. And when, let's say we do get a 1 again, which means we got a head. But hey, I want to start fresh. This is another experiment, not the old one, because the old one had 47. And if I add now, it's going to have 48. So right around here, I have to reinitialize the counter for the heads every time I play this game or do another experiment. So I'm going to have to say here, heads equals 0. Okay, and then I'll rub this out, and I'll have heads, and then how many times it happened right here. Heads 47 times, and I'll just attach the C47 to string. Now, what are the chances of getting 47 heads? It doesn't happen that often, all right? So I'm thinking we're not going to get a ton of numbers here, but we might. We'll see. Okay, I think I'm ready to demo it. Let's give it a run. Heads 47 times, 6 times. Not that bad. 4 times, 6. Like I said, it doesn't happen too often. Okay, we did the experiment 50 times, so only once in a while, maybe every 2-3 times, it does happen. So that's a cool program. This one here is starting to get you to think about how you make sure you make your programs efficient. And there would have been a problem if you didn't know how to do a loop inside a loop. This right here would have taken, especially this line here, 100 extra lines. No way. We're getting better now at programming. You don't do that. That's the stupid way to do it. Now you start getting more efficient. And there's even more efficient techniques than this. But for what we know right now, perfect. Okay, so there is a nice little recap. We covered 3 problems to give you a better sense for how you work with random numbers, and it's not that hard, eh? This is kind of more interesting too. What's going to happen once we get through this section, we're going to get into graphics, and we're going to start simulating these graphically. We're going to have 2 maybe coins flip or dice roll as an actual image, not just numerically. But for now, this is what we've got. Welcome back, and in this lecture we're going to do a bit of review and then extend our knowledge of random numbers by taking a look at a couple of other practical problems. Let's start off with a little bit of review. So remember, in computer science there are basically 2 types of simulations you can do. You can do a simulation where you simulate the real system, a real mathematical system, and the fancy word for that kind of a system is a deterministic model. Okay, we're not going to do that in this course, but there are tons of simulations that do that. Car crashes where you simulate how a car would deform, all kinds of neat things you can do, but it's much more advanced, obviously. The one that we're working on in this section is called probabilistic simulations or probabilistic models. These depend on chance, probability, that they can also mirror real world events too. Okay, if you were going to do something deterministic, I don't know if any of you even realize what some of this stuff is, but this would be something like a physics formula, right? We're not doing that. We're doing things that involve probability, flipping coins, that type of thing. Let's review a little bit about how you pick random numbers. And I've got the solutions right underneath it. The last one's a bit tricky, but if I wanted numbers between 1 and 10, remember you take the low number and then you add 1 more to the high number, so 1 more than 10. There are other techniques to do these also, but this is the way that I like it the best, okay? So for instance, this one here between 3 and 17, you could also use this technique if you wanted to, okay? And remember, to get that 15, you would take the high, take away the low plus 1, so that'd be 14 and 1 is 15, and then you write down the low. The next 2 are actually kind of neat, because it shows you a concept that even though you think you know the formula, you still have to do a little bit of thinking. This one says I want even numbers between 0 and 10. Now, in mathematics, if you have a number of this form, 2n, like 2 times n, where n is a number, this will always make it an even number as long as this is an integer. So what I did is I used that idea, and then I came up with this formula. This was how you would generate even numbers between a certain value and a certain value. Now the last one, odd numbers between 1 and 9. Again, I've got to resort to a little bit of mathematics background. Any number of this form will always be odd, meaning as long as this is an integer, if you double that number, 7, double it, plus 1, you get 15. That's an odd number. So using that idea, this is the solution to generate odd numbers between 1 and 9. All right, so you would take this. Now remember, this would give you numbers between 0 and 4, and then you would double it, you'd get up to 8, right? Plus 1 is 9, so that's how it works. And if you got a 0 there, times 2 would be 0, and you get a 1. So that's how you get numbers between 1 and 9. So these last 2, make a little note of them, okay? Kind of cool. If you're doing some sort of games or simulations where you need to have that type of thing, this would be one of the ways you could do it. Okay, problem time. Okay, we're going to go through a number of problems today for practice. Right now, we'll take a look at the solutions to the first 3, and then I'm going to get you to do number 4, the gambler problem. You can stop the video and then give it a try. Okay, the first question should look kind of familiar. I want to write a program which simulates the tossing of 4 coins 50 times. Display the results of each toss of the 4 on a separate line. If exactly 3 heads occur on any given toss, follow that line with an asterisk. So it's almost like the one we did in the previous lecture where we were keeping track of how many times we would get 47 heads. In this one, we're trying to figure out how many times we get exactly 3 heads for 4 coins. Okay, and we do the experiment 50 times. Here is the solution. Now, these demos are already pre-made. All right, and if you go in here, it's in the more random numbers section. We're going to load it up. All right, so this is the first one we're talking about right now. And it's kind of a cool solution. I wouldn't expect you to always have to do it so cool. You could just generate the numeric answer, but I thought it was kind of neat to do this. This sort of shows you through the whole experiment, all 50 experiments, what's happening. So if you notice there, I had a tail and then 3 heads. Great, that's what I wanted. Then I had a tail and 3 heads again. Great. And then I had a head, tail, head, head. Great. And then I had a head, tail, head. Great again. I'm on a great roll. And then we got nothing there. We had tail, head, and then 2 more tails. Eventually, at the very bottom, it ends up that there were 3 heads in 50 tosses, 18 times. So that's quite a bit. 18 times out of the 50, I had 3 heads. Let's take a look at the code for a second. Without getting too crazy about the pretty stuff, let's just focus in on the most important part, the mathematical part. So this one right here, I have a counter for 3 heads. And obviously, as I'm flipping the coins, I need to know which coin I got. Okay, so let's have the counters in here initialized to 0. And this string result is just for the pretty stuff to make it look nice in the text box. So this experiment is going to happen 50 times, okay? And each time I'm going to do a 4-coin toss. Now remember, I could write this line down 4 times, but that's a stupid way. You know, after you have like 1 or 2, like 3 or more, I would switch to a loop, okay? And obviously if you had 100, I definitely have to use a loop. So this flips a coin. If the coin happens to be a 1, that's a head, count it. And also attach to a string that we're going to put in the text box the letter H. Otherwise, you got a tail and attach the T. Now, when this 4-coin flip is done, not the entire big loop, but this inside loop, check if you've got exactly 3 heads. Because if you did, bingo, put a little asterisk and also count 3 heads. It's just like the one we did with 47 heads, actually, but just a slightly different numbers, obviously. And then at the very end, we print out the results. So here it is one more time. And this time we got 10 of them. Next problem I really like because it's going to help you review another concept we did a couple of sections ago. So what makes dice such a good tool in a game of chance is that if they are fair, every side has an equal chance of coming up. So I want you to write a program that simulates 15 rolls of a die and then prints out the number of times each number is generated. Okay? And if you forget what the point of this one is, so you're going to roll some dice. And obviously you can roll a 1, a 2, a 3, a 4, a 5, a 6. Now I want to know how many times I rolled a 2. How many times did I roll a 4? Maybe I rolled a 2 3 times. Maybe I rolled a 4 once. Okay, so we're doing something like frequency. Now a stupid way to do this question would be to have sort of like 6 if statements. We're going to do it a cool way. Okay, remember array counters? Well, we'll see if you do or not in a second. Here's the program running. Okay, so there's the number, rolled a 1, 2, 3, 4, 5, and here's the frequency. Now, I changed this program up a little bit because 15 wasn't a lot. So what I did was I made it 100 times. But here's the most important part. That's that array counter stuff. So what we're doing here is we're letting the computer create side-by-side boxes, 6 of them, and instead of having 6 if statements with counters, when I do this experiment 100 times, what I do is I figure out what I rolled, and then I accumulate it or count it. Now again, if you don't get this part here, this is the counter, this is an array counter, okay? And this is the slower, more simplistic way, but either way will work. Okay, so what that one line does, remember that one I did, I was going to tell you it would have taken 300 lines of if statements? Same kind of idea. This would have taken 6 if statements and 6 counters, so it would have taken 12 lines, and we did it in 1 line. So after we roll the dice, this figures out which dice we rolled. Okay, so if I rolled a 2, okay, here's the memory location for 2, and it would put a 1 in there to say the number of times I've rolled a 2 is once. Okay, so it sort of figures it out and accumulates at the same time. This second loop, just after we're all done. So when we're totally done going through the loop 100 times, I print out the solutions. I go through here and I print out the variable, like roll 1, and this prints out the frequency, the number of times you rolled a 1 or the number of times you rolled a 2. Okay, so there is the solution to the next one. So I skipped over this one for some reason, and we ended up doing this one, the third one, before this one. Doesn't matter. But this one's kind of neat too. Okay, so this one's saying write a program that simulates the roll of 2 dice. So we're using dice again. But instead of writing like a 1 or a 2, actually write down the words 1, 1, 2, TWO, whatever. Okay, so this one here just forces us to remember something else. And again, it's the array stuff. Okay, we just did it with the counter, array counter. Now we're going to do it with this as an array. Let's take a look at the solution. And it's kind of cool, and you probably saw me do it by accident just before I took up the previous question. So I press this button, and there's a 4, it rolls, and then a 2, and then a 4 and 2 is 6. Okay, so how do I do that? Well, if you didn't say arrays, then you still haven't caught on to that concept, because arrays are so powerful. Try to widen this a bit more so you can see it better. Okay, so what we need to do is declare a one-dimensional array that stores all the words. Okay, now remember, I don't like using 0. All right, so I declare a string array called dice words, and those are all the words. And this will be dice word 1, this will be dice word 2, and those are the indexes, right, all the way to 12. Now the cool stuff. After I tell the computer we're going to use random numbers, I have a loop that goes from 1 to 20, because I'm going to roll 20 sets of dice. So here is one roll of the dice, here's the second roll of the dice, and here's what it adds up to. Now, those are the numeric answers. Now I'm going to take that dice roll. Let's say I rolled a 3. So right here, it's going to say dice words 3. So it's going to go 1, 2, 3, and actually print out the word 3, not the number 3. Same with dice number 2. If I roll a 4, okay, it's going to go to dice word 4 and actually print out the word 4. Now, 4 and 3 is 7, so the sum right here is going to go to dice word 7 and print out the word 7. Is that cool? Okay, so that is a little recap. We're going to give you a nice little problem to try in a second, and then I want you to do it. Okay, here's the one I'm going to leave you with. You're going to stop the video, try to figure it out, and then restart the video, and we'll take it up. Love this game problem. This is called the gambler problem. So there's this fictitious game in a casino, and there's 2 choices. The first one, when you come to play it, they charge you $8. Okay, and basically you get to roll 2 dice, and you get back as money what you rolled. Okay, so if you roll a 6 and a 6, that's $12. But it's not really $12 because it cost you 8, so you only win 4. Okay, but you got to keep that in mind, right? The second game costs more money, $15 to play, and you get to roll 2 dice on that one too. But this one you get the product of the numbers, and that mathematically means, like, if you roll a 6 and a 6, that's $36. But it cost you 15, so you still won $21. So what I want you to do is write a program which will simulate the game being played 1,000 times, and then calculate the average winnings per game for each one, and figure out which one the gambler should choose. Give it a try. Okay, so now we're getting very practical. Neat little game. Give it a try, and we'll take it up in a few minutes. We're back. How'd you do? You think you got it? Let's take a look at my interpretation of the solution. And again, this isn't the only way to do it, but well, it's one of the ways. So we're going to have integer game 1, and we'll initialize it to 0. Integer game 2, and we'll also initialize it to 0. So the first thing we should realize is that we're going to do this experiment 1,000 times. So I'm going to have actually, let me put this in here while I've got a chance before the loop. It doesn't really matter, but I want to put it in there. Okay, so now we have, and I'm going to start using G for game or simulation or experiment. Okay, equals 1, and then experiment less than or equal to 1,000, and then experiment plus plus. Okay, so just to do something different. So we're going to do this experiment, this game, this simulation 1,000 times. Okay, so the first game, basically what happens is you get to roll 2 dice. So again, as we're sort of roughing this thing out, integer roll, okay, and we'll initialize that to 0. whether you need to or not. So in the first game, you get to roll 2 dice, and the way you say roll 2 dice is you have next 1,7 plus another one, right? So that's your 2 dice roll, and whatever you roll goes into that variable right there. Now, after we do that, we're going to accumulate. So game 1 equals game 1 plus roll. Second game, same kind of idea, except we're going to times them together. All right, so I'm going to paste those in, and we'll put a little times there, and then we add them together, but it's game 2. Now, as you see me taking up the solution, you should have something pop into your mind. This isn't what you get to win. You don't win that. What did you forget? Well, remember, each one of these games costs money. The first one cost $8, the second one cost $15. So what I need to do here is take away the $8. You don't win it all, okay? And take away the 15. So what we're doing here is that's the basic game. We're basically done the game. So we're having a loop go to 1,000. We roll 2 dice, and remember what we rolled, and then we add it to our sort of grand total winnings for the first game. Less $8. And then grand total winnings for this one, less $15, okay? Now it asked us to work out a total and then get an average, right? So I'm gonna say here, double average 1 equals game 1, and we better put that casting on just in case. So that's gonna be game 1 divided by, we did it 1,000 times, right? Double average 2, and we're going to cast it also, and that's game 2 divided by 1,000. Isn't this neat how we're working it all out? And now we're going to go if average 1 is greater than average 2, message box dot show game 1 is better, and then average winning. So this could be money, right? So let's do this. AVG 1 to string. We'll put it in currency. Hopefully that'll work out. And then message box show game 2, and then it's not better, so we're not going to say it's better, and we're just going to write down the average for that one to string with a semicolon. Okay, and did I spell message box wrong there? No, I don't think so. Okay, and then we'll continue from there. And again, there could be a tie here, but I'm just going to do these two for now, because you get the basic idea. You could do one more else if statement to take care of the tie. Squeeze that in there, and else if. Move this back a little bit, and we'll paste in this, but again, now it's the other way around. Game 2 is better, average 2, and game 1, and this is average 1. Okay, so there we have our solution. Let's cross our fingers and see if it actually works and see what kind of answers we get. So game 1 is better. You lose $1.08. And how much did you lose in the other one? You lost $2. Oh, and I forgot to put the currency on it. So let me squeeze that in while we're here. Okay, and we'll give it a run again. So you don't win in any of these games, and that's true about a lot of casino games, right? That's the whole point. They don't want you to win. Let's take a look again. So game 1 is better because you only lose 99 cents, but you still lose. So it's minus, because this one you lost $2.63. Okay, you know what? I forgot to put currency on a few of these. There's currency on this one too. Okay, but you're starting to see, and it looks obviously it's working. So this one is better. You lost $1.15, and this one you lost $2.95. Let's try it again. Game 1 is better. Game 2 you lost. So game 2 is, I don't think, ever better. Game 1, even though you think, oh, I'm going to win the big money with game 2 because I can multiply the numbers together, it ends up that you end up losing more times with that one. Let's just try it one more time. Game 1's better. You only lose 96 cents. In game 2, You lose on average $3.28 after 1,000 plays. Beautiful, love this. Kind of a very neat thing, and this is what casinos do. They do this kind of simulations to make sure that they win, not you. See you in the next lecture. More random number problems. In this section, we're going to take a look at some sample applications of random numbers. We're going to take a look at, first of all, a math game. Then we'll do a game that simulates the card game War. And then we'll finish up with something that maybe you've seen on TV on The Price is Right. We're going to simulate how you would figure out the Plinko game, figuring out what would you put as the values at the bottom if you're familiar with that game. Let's start off and show you a simple little math game. All right, and we're going to load all these in there in my next folder. Now, more random numbers is what we just finished up. If we go up here, there's applications now, which we're going to focus in on. And we'll look at math game. All right, and I'll just give it a run for a second so you get a basic feel for what it does. And then we'll take a look at the coding. So it just gives you a little bit of math practice. So let's say you needed some multiplication practice and you press start game. And you'd have to write down the answers. And this would tell you whether you're right or wrong. Okay, those are some big numbers there. Next question. And it's generating random numbers. Okay, so let's go with 840 on that one and see if I'm right. Okay, so that's the type of thing it is, and I could switch to any of these other ones and then generate some new questions. Okay, so this one would now become an addition question. Okay, if I switch to this one, we would get subtraction questions. All right, so it's kind of cool. Why has it got random numbers in it? Well, the numbers that I'm making pop up obviously are the random part of it, but let's take a look at all the code so we see how it works. So we're going to click in the underground, and as we start the program, we generate random numbers obviously. So we initialize and declare the random number generator. This one, it doesn't use R, I use random NO for number. I'm going to be generating two numbers, right? There's either going to be two things I times or add or subtract. And I also have a symbol that I'm going to use in between, okay, depending on the problem type. And this symbol will change depending on what the little circles are clicked onto. Okay, now when you start the game, all right, a couple of things get initialized. So we basically initialize all our values to certain set numbers or circles. Okay, so certain things are visible, certain things are invisible. So watch, when I press start, this part in here is not visible. Okay, as soon as I press start game, and the coding is right in here, certain things that used to be invisible become visible. Okay, so that's what these lines do in here. You'll notice I do use a method. This says generate question, which means it's going to call the random number generation questions. Okay, so what that does is basically call this method, and this method picks random numbers between, that's one of the other ways that I'm not crazy about, but it still works, between 0 and 99. Okay, so it picks a random number for the first one between 0 and 99, and the second one between 0 and 99. Now it checks depending on which button is pressed. So you know these little things here, which one's pressed? Is that one pressed? Is that one pressed? Depending on that, I'm going to write a different symbol in to represent what is going to be done, addition, subtraction, or multiplication. Okay, so depending on what radio button's pressed, the problem type is going to be a plus or a minus or a times or multiplication, right? And then what I do is I place the random number that was generated right there, add the little symbol, whether it's plus, minus, or times, and then the second random number generated and put a little equal sign. So watch what happens here. When I press start game, all right, it's already on plus. Okay, now if I go like that and do the next question, it changes to minus. So depending on what is getting picked up here in the radio buttons, this question's little part in between will change. Now it's time to check the answer. So when the person presses check answer here, we're going to have to see if they got the right answer. Now, depending on the problem type, we're going to write down the result. Okay, so when we know the two numbers and we check, hey, was the problem type a plus, a minus, or a times, we actually do the math. All right, so we have to do the math. And then we basically check what the person typed into that box. That box is called answer, okay? And we're checking if that person's answer, .text obviously, equals the result that we got to string. Remember, this is mathematics, this is words, so we got to make them match, so string to string. And then we either say the word correct in the feedback section or incorrect, all right? And then when we press next question, basically it calls the method generate question and it initializes these back to nothing. So kind of cool, and it shows you how, and the star of this show was not obviously random numbers, it was just a small part of it. It has all the other concepts I've taught you, especially the methods, right? Which was kind of cool. So let's see this one more time. Okay, start off with subtraction, start the game. It starts off and tells us our first subtraction question. I'll type in a wrong answer first, and then we check the answer is incorrect. We go to the next question. Okay, let's type in negative 23. Let's see if that's the right answer. Okay, and that's the type of thing. So it's kind of neat, and that's one application of random numbers. Second one I want to show you is a card game. All right, so this one is called Card Wars. Double click on it. Now I'm not going to go in depth on every one of these. When we do the last one, I'm definitely going to beat that one to death. Like I'm really going to explain it really well. This one here, just for fun, I just want to show you where you can take this if you start understanding a bit of graphics, and kind of cool. Press new game, and this is you, this is the computer, and obviously this one's bigger than that, so 2 points for that. Next card. Ace, queen, again, this one's bigger. Heart, but this is a 9 of hearts, so you get 2. You get the basic idea, all right? So what's happening is, in these spots in here, we are going to store one of these pictures, all right? And we'll talk more about graphics as we go along, but randomly we're going to pick some numbers, obviously, and then we're going to feed them in there, and we're going to have some logic too. Now, again, I'm not going to really go through this one in depth, but there's the random number generator. That's the whole point of this, right? You're making games, so you have to use random number generators, all right? And because it's a new game, we initialize stuff, and we're simulating the 52 cards, and we're going to store each of the cards in an array, okay? And then as we pick cards from the list, we take them away, so we remove the cards. Right. So if you have time, go through this. It's kind of a neat program. And obviously then here are the if statements to figure out the particular type of card and the image that you're going to use to display it. In this one, we use not only if statements, but those switch commands, right? So depending on the card value, jack, queen, king, or ace, we assign it a certain number, your number. Okay, and there's some more if statements down there. So if you have time, you can go through that one. Just a neat example, a little bit more advanced for what we know at this moment in time, but I wanted to show you that random numbers, with that knowledge, you can do some cool stuff and make a kind of interesting game. All right, now the focus of today's actual lesson. I'll load up the program because I'm in here already, but we're going to do some doodling for a little bit before we show you the full code. But it's called Pinball. It's actually Plinko, but I use the name Pinball. And we'll leave it like that for now. What I want to do is I want to pop up the actual theory behind this. Okay, so there's a game on TV, and what they allow the users or the people, the contestants, to do is they stand up here at the top of a little ladder, so to speak, and they drop a ball down this sort of device that has these little pinballs on it, and they sort of block the passage of the ball. So sometimes the ball goes a little bit to the left, a little bit to the right, a little bit to the right, a little bit to the left, whatever, and it just keeps bouncing its way down, and then eventually falls into a hole. Now, what the show Price is Right has done is they figure it out either by making their own little model and have somebody run, like play it 1,000 times. They figured out that it's probably the hardest to get into this one or this one. So they make these ones worth the most money. Okay? Now, we're computer scientists now. We could simulate this without having to spend money or time creating this, having carpenters or people come in and actually make a big physical model of this. We can model it in a computer simulation, okay? Now, there's a little bit of thinking that's going to have to be involved, but we can model this. And here's the steps or the algorithm to model this situation, okay? And I've written it down here in the program development. Basically, what we're going to do, first of all, is we're going to assume we have this variable that we're going to call P, and it points directly over the 4. Now, there's a good reason for what we have here. 3 on one side, 3 on the other, 4 is in the middle, so there's an odd number of spots that the little ball could land into. Now, what we'll do at each stage of the drop is, it's almost like there's only 2 places to go, right or left. So we'll pick like a random number between 1 and 2. And sometimes we'll go a little bit over to the right, and sometimes a little bit over to the left. Now, a little bit over brings us to like right here. So like it's not fully on 4 and it's not fully on 5. It's like it's about 4.5. So there it is. That's actually the idea. When we pick a random number and the ball's dropping, if we pick a 1 to mean go this way, we're going to actually go over 0.5 to the pointer. So the pointer starts at 4, and if it's a 1, we're going to go slightly to the right of 0.5 or slightly to the left of 0.5. Now you're going to go, well, as you work your way down, could you end up with a 5.5? No. Here's why. 1 level, 2 levels, 3, 4, 5, 6 levels. 6 is an even number. So it's going to balance out. When it eventually gets down here, it's going to be a whole number representing one of the 7 possible numbers, okay? And you obviously have to plan that out too. If you had 5 levels, you could end up with 6.5, okay? So that's one of the other requirements of this simulation. All right, so let's recap all the ideas we just discussed, okay? And they're written down here for you. So you're going to have a variable P for pointer. It's going to start at 4. There's 6 levels, okay? So we're going to use a loop that goes from 1 to 6. And each time in the loop, we're going to pick a random number, and we're either going to go 1/2 pocket to the right or to the left. And we'll do that mathematically by doing that line right there. Okay, so that is the background. That is the algorithm, sort of like your mindset of how you think through the program. Remember when we did that unit on problem solving? So you can't just run away and start, typing in this code. We thought it out mathematically with words, whatever, until we understood what we have to do. Now it's time to program. All right, I'll give you a quick run first. So basically, obviously it's not the pretty stuff. It doesn't have the graphics. It's coming up soon. We're almost there, but not yet. It's all numerical so far. So we're going to press this button, and this is going to print out the frequency, how often the ball, when you dropped it from the top, landed in one of the boxes down there. So it looks like the ball had a hard time getting into this box right there. And the ball had a hard time getting into this one. So it makes sense that these two should have the most money. So if the person playing the game ends up in one of these two, give them $10,000, something, right? So these are the clear winners, so to speak. These are the worst ones, hardest ones to land in. Let's take a look at the code. Now, we're keeping track of where it lands, right? And it could be 6 if statements, but you better not think that way anymore. You should remember that we should be using array counters. Let's go into the code and we'll get rolling. Now this one here, I try to be, a little bit of the more advanced technique. It doesn't have to be done like this, but first of all, as I just talked about 2 seconds ago, we're going to need array counters, okay? And 0 we don't use, and we're going to use 1 all the way to 7, okay? And that's why you always make it 1 more than what it is. This first line initializes everything, okay? So this pocket count is probably set to 0 anyway, but just to be nice, I go down here, I pass it the parameter for the array, pocket count, and I pass it the 7, which is the upper limit. And all this does is set everything to 0. Nice. That's just called the initialization. Then we have another method. Love this. Look at this. This is the whole program really in a nutshell. This is your mindset. You initialize, you simulate, and then you print the results. Beautiful. Okay? So now we go to simulate. Simulate is where everything happens, obviously. We're passing it down the entire array called pocket count, and it's going to return with the numbers for the frequency filled up. Let's take a look at it. Let's see if I can get this all on the screen in all one shot. Yeah, you can see it all in one shot. So, first of all, we're using random numbers. That's the theme of this section, right? We're going to keep track of where the pocket count eventually ends up at. We're dropping, in this simulation, 100. You could do it 1,000 times, 1,000,000 times. The more you run it, the closer we'll get to the true answer, or at least the best case scenario. Okay, so like I said, when we drop it from the top, we're going to make it point over the 4. Okay, so that's why pocket count is 4. And I'm using a decimal here, okay? So that, remember I use double, because we're going to be going left and right by 0.5, so you can't use integers. That would not work. We're going to work through 6 levels. Beautiful, that makes sense. And now we pick a random number to go left or right. So we're only picking number 1 or 2. I've decided that if I pick a 1, I'm going to the right 0.5. Otherwise, I'm going to the left 0.5. Okay? Now, once you work your way down, and you've done it through the 6 levels, you're going to get probably maybe like a 4.0. Okay? And what we're doing here is we're going to take that off and then store it into a variable C. And then we're going to go P4 equals P4 plus 1. And the reason we did this int, this array is an integer array. Okay, and this array stores, as you saw up here, the values in the different boxes. And so it's an array counter. We declared this array counter so the entire world would know about it, right? Right up here. All right, and once it's embedded in there, it'll follow through. Now, once we're done, last step is to now take the pocket count results and display them. So we do a loop from 1 to 7, and it prints out the actual I value, which is pocket 1, and then how many times something got put in there. All right, and here is the program one more time. So again, this is what happens in real life when they start making these games or developing games. Nowadays, once in a while they'll do the model, like physically draw the model, build the model, whatever. But a lot of times it can be cheaply done and more accurately get a result by doing this. How would you get a guy to drop the ball 1,000 times or 1,000,000 times or whatever? So if I just snuck that in there, made it 10,000, let's run it. It'd be impossible for a person to sit there forever and do that. And we can do it in a second. And again, it sort of proves our point. 1 was 166, 7 was 163. And there you have it, a nice practical application of random numbers where they're used in the gaming industry, so to speak, and how it can be simulated fairly easily with our knowledge, a very basic knowledge of random numbers. Practice, practice, practice. I hope you're starting to realize that I've slowed down the pace of the course because we've learned the main commands that you're going to need for the remainder of this course. As you can see with these random number problems, we're using loops, if statements, we're using counters, we're using array counters, we're using arrays. So, we've got everything we need to do. We just got to now improve our thinking through problems. So I got another nice little problem for you to look at today, and hopefully you do it on your own first, and then we will take it up. Now don't cheat, because the actual solution is in the resources for today's lecture. At the bottom of yesterday's handout, PDF file, the pinball stipulation, there was a nice little question. I'm going to go through it with you for a second, and then I want you to give it a try. So we're going to simulate a shooting gallery at a carnival, okay? And this man who's running the carnival game, he charges you 25 cents, and you get 3 shots, and you shoot at clay plates, which break when they get hit, hopefully, okay? Now, if you break 3 plates with your 3 shots, you win a big prize, okay? Now that prize is going to cost the man an extra $1. That's all he paid for it. Okay. Now each time you break a plate, it also costs the man 4 cents to replace the plate. Now the probability that a person hits a plate on a single shot is 1/2, 50-50. Okay. So I want you to write a program which simulates 1,000 people playing this man's game, and determine the average amount of money the man makes or loses. So sometimes you can do these games from your perspective, the player, or the owner of the game's perspective. So in this one, I want it from his perspective. So when he charges 25 cents, he's up 25 cents, right? When you break one of his plates, he's down 4 cents or whatever. Okay, so you're going to keep running track of that amount and then work out the average per game loss or win for 1,000 people. So it's kind of a cool game. Take a break. I'm going to take a break. You try it, and in about half an hour or so, start up the video again, and we'll see how you did. All right, so let me show you where the solution is. Hopefully you didn't look there too soon. It's called Shooting Gallery, and this is kind of an enhanced version. You could have done just a raw solution. This one has some nice display on the screen, which isn't crucial to the solution, but we'll give it a run, give you an idea, the type of thing that I wanted to have it look like. Okay, I'll widen this up a bit, and when you run the simulation, what you're seeing here is that here's the first person, and they hit a plate. Then they hit a plate again, and they hit a plate again. Oh, that's it. They win a prize because they hit 3 plates. So the owner of the game is down 87 cents. Next time they play, you miss, you hit, you miss. Too bad for you. You only hit 1 plate, so it cost him 4 cents. He's up 21 cents. Okay, so remember, you paid him 25. You only broke one of his plates, so he's up 21 cents. So we go through that, and we do it for 100 times. At the very end, okay, basically, we've kept track of the basic result. Okay, let's press exit again and give it one more run. So I wanted to see this part this time. So in this case, the average amount made per player is 9 cents. So he's winning. Let's do it again. 6 cents. 6 cents. Okay, so it doesn't look like you fare too well usually. So he ends up winning about 4 or 5 cents per game, and over 1,000 games, he can win a bit of money. All right, he can make a bit of money. Okay, so there is the solution. Now we're going to go into the code, obviously. Now, I'm going to repeat again. I've made this a bit more enhanced version. There is a more simplistic answer, so if you look at that and you go, I didn't get that crazy, it's fine, as long as your answers are close to my answers. The display part especially, you didn't need to do that, but I just did it to make it look more informative. Anyway, let's take a look at the variables we are going to use and how we're going to use them. So we're going to keep track of, obviously, the plates we hit. We're going to keep track of the total money made. So that one, if you did it on your own, you needed that one for sure. The one where I keep track of the money made this game, not that crucial. It's nice to see, but you didn't really need it. And of course, we're going to work out the average. You definitely want that. And, you know, we're using random numbers, obviously. So you wake up the class, the random number class. Okay, and now you start your simulation. I did the simulation 1,000 times, and remember, it's from the perspective of the owner of the game. Okay, so this line is absolutely crucial. Okay, this one here you don't really need. I just made it look cool. But this one here, he puts 25 cents in his pocket. This is his first customer. Great. Now let's keep track of how many plates this customer breaks. So that customer gets 3 shots. So you see how we're doing a loop inside a loop? Really, you know, the most efficient way to do things. So keep your eye on this section in blue. So they're going to take 3 shots, and it's a 50-50 chance of breaking a plate. So you pick a random number between 1 and 2. And I've arbitrarily said that if I pick a 1, you've broken a plate. So bang, the counter goes up by 1. This part here is just to make it look cool, to print that H. It wasn't crucial to the game. This, again, is not crucial to the game. This is. The owner of this game just lost 4 cents because you broke one of his plates. Otherwise, it didn't cost him anything, and you missed. And you go back up. And you do this 3 times. Now, at the end of the 3rd time, you check and see if the counter for the plate hits is 3. If it is, that means that person got 3 shots in a row, and now you owe him a big Kewpie doll or some big doll or whatever, a bear or something, and that's going to be more money out of his pocket. He's going to lose an extra $1 because he has to buy those bigger prizes. They cost more money. Then we go back up to the top. Now, the most important variable to reinitialize when you start the next person to come to your game is that one right there. Because I don't want to remember how many plates I broke last time. I want to start fresh. And there's the game. Okay? Now, I've got to work out some averages. After we've kept track of this total money made, and it's probably going to be a fair sized number, I divide it by 1,000 people that played my game, and that's going to be the average winnings per game. All right, so isn't that cool? All right, that involves all the kinds of different ideas we've been doing: loops inside of loops, if statements, counters, okay, reinitializing counters, and we'll run it one more time. Okay, so he won 5 cents per game over 1,000 games. And here's a nice little display. The display part, if you just had shown me the message box, that's fine. But there's a display showing you what's happening for every single person, all 1,000 people that played his game. So there you have it, a nice little short little lecture with more problems. Okay, and the next lesson we're going to take a look at a different aspect now, where you play a game where you don't want to repeat things, or you give away prizes and you don't want the same person getting the same prize. Or you play a roulette game where if you land on the same spot twice, you lose. Okay, so there's all kinds of things we're going to cover in the next lesson, which is going to be called the random selection without duplications. There's all kinds of cool things you can still do. Gaming. See you next lecture. Welcome back. And in this lecture, we're going to take a look at the concept of random selection without duplication, which means we're going to try to simulate events where everybody has to get a prize, or something stops if there's a repeat answer or a repeat number. Okay, so those kinds of situations involve an extra piece of logic that we're going to introduce in this lecture. Okay, so I've loaded up the PDF for this particular lecture, and it's always as usual in the resources. And again, let me repeat. Random selection without duplication. Sometimes it's necessary to generate random numbers in a certain range where every number is accounted for and there are no duplicates. So we're going to learn how to handle that situation. And we're going to focus in on kind of a corny example, but it might happen. Let's say they give away prizes in a sort of a gumball machine type thing, and your son or daughter or little boy wants to get every different type of helmet, okay? And let's assume, it's not obviously true, but let's assume there was 28 different kinds of NFL team helmets in these gumball machines. And each time you got a gum out, it cost you 25 cents. How much would you totally have to get so that you would get every single team? Now, you got to realize, you put your quarter in and you get a team. Put another quarter in, you get a different team. Put another quarter in, you might get the same team you got the first time. So you're going to be wasting a bit of money. So, in the optimal situation, if you put in a quarter and you got every single team the first time, what would that cost you? That would cost you like $7, I guess, because a quarter of 28 is $7. So it could happen. It's not going to happen, okay? Chances are you're going to get one that you already had before. So it's this kind of logic that we want to learn how to program. Okay, let's go through the solution. So this is the program called Helmets. And again, if you don't know where we are, you should have unzipped the folder. In applications, I have a program called Helmets. All right, so I loaded it up and here it is right here. We'll give it a run right away just to show you what it does. Okay, and first off, it says on average, to get 28 helmets is going to cost you $27.25. So you're not going to only spend $7, as I optimally said. And here are all the simulations, and let's see, did we ever get any really low number simulations? 13 bucks, that's not bad. Did we ever get lucky? 17, 15. It's going to cost you some money, okay? So let's go through the solution. Now, you got to realize, as we pick the numbers, we're going to pick numbers between 1 and 28. How are we going to remember what we picked? Well, our friend, Mr. Array, all right, you know how you had counter arrays? We're going to sort of use like a counter array, all right? And remember that stuff with the square bracket? We're going to use an array counter. And what we're going to do is we're going to use an array counter that remembers. Now remember, we're not going to use 0. It's going to have the number 1 all the way to 28. So as we close our eyes and turn the knob and hope for the helmet to come out, let's say helmet number, and we're obviously just saying this, helmet number 7 comes out. Great. Now as soon as helmet number 7 comes out, we have to put a number in here. Now we don't necessarily have to count them. all we have to do is just put in a number 1 in there, and that's it. Because the next time we pick the helmets, we're going to have to check to see if this already has a number in it. If it is, that means that we got the same helmet again. Sometimes instead of the counter word, we like to use another word, and actually this is the one I use in this program. I call it, we have a flag array, which sort of signals whether we've got a repetition or not. Okay, let's take a look at the actual code. So, again, there's like the fancy stuff, which you don't need, and the most important stuff. So this is the most important stuff. How much money did you spend on all the simulations? Because we're going to work out the average. And then we're going to figure out what you picked. There is the helmet flag. This is the main trick. We're going to use a flag array to remember whether we pick something or not. Okay, we create an object of the random class, and now we start our simulation. Now let me see if I can get most of this on the screen. Yep. So the simulation we're going to do, in this case, 1,000 times. All right, and as we start the simulation, each time we have a fictitious person who's sitting there turning the knob on the gumball machine, getting the stuff out, we need to reinitialize the numbers that are in our flag array. So we want them all to be 0 as we work on this next person. Okay, so that's what this does right here. It initializes all our flag array to 0. Okay, now we get into this loop. Okay, now in this loop, we know eventually we got to get 28 helmets, unique helmets. So we're going to do a loop from 1 to 28. The only problem is we might spend a lot of time right in here. So this is the most important part of this whole solution. We're going to be in a loop that really doesn't have a definite ending. It only ends, so you do while the helmet flag for the number you just picked equals 1. So that means if you, well, the first time it's definitely not going to be a 1 because nothing's ever getting picked yet. But after that, you could get a 1. So let's pretend it's the first time through and nothing's gotten picked. So I'm picking a number between 1 and 28, and I magically picked 7. 1, 2, 3, 4, 5, 6, and we'll add a 7. Actually, that's 0, so we can't use that. So 1, 2, 3, 4, 5, 6, 7. So I pick a 7. Okay, so while the flag picked is equal to 1, well, it isn't, it's 0. So we get out, and now we're at this line. And what this line does is say, okay, you picked helmet number 7, now put a 1 there. Okay, great. All right, no problem. All right, now remember, this is a loop that goes from 1 to 28. So we've got one unique helmet now. So this is the second time through the loop. And now we cycle around here. And of course, it's costing us 25 cents every time to put our money in to get the gumball out. We pick another random number. Now this time, let's pretend we do pick 7 again. Well, it says do while the helmet picked equals 1. So it's a 1. We've got to do it again. So it's going to cost me another 25 cents. Eventually, we pick something that hasn't been picked. So we pick a 3. So now, obviously, the flag for that particular 3 is a 0. It's not a 1. So we can get out. Now, as soon as we get out, we make it a 1. So this is keeping track of whether you got picked or not. Did you get picked? Yes. Did you get picked? Yes. Did you get picked? No. So a lot of time is being spent here, costing me 25 cents, picking a random number, checking if it's already 1. If it is, go do it again. Eventually, we are totally done and we find 28 unique helmets, and it's cost us a pretty penny. And we leave this loop, and now we're left to do the averages. Now what I'd like to do in this one is I'm going to stop it for a sec. We're going to add like a little break. Where should I put the break? I'll put it right there. Okay, and I'm going to stop the program, and I'm going to give it a run. Okay, so we press here. Now let's, just for fun, we got to get through this 28 times first. Now we're at 20. Okay, we're almost there. and now we start the game. Okay, so we're on unique helmet number 1, and it's cost us 25 cents. Which one did we get picked first? Number 2. Great. So is the flag for number 2? No, it's totally empty. So leave. All right, now the flag is going to be 1. So notice now flag number 2 is set to 1, which means it's been picked. Now we go back up, and now we're going to be on unique helmet number 2. 25 cents. What did we pick this time? 9. Beautiful. That helmet has not been picked either, because only right now the 2 has been picked, so we leave. And now we check that flag, and for that one is now set to 1 also. So see how number 9 is being set to number 1? And there's the process. Okay, so from beginning to end, this is how you know if something's been picked or not. And eventually we get all 28 helmets done. Okay, let's give you a little challenge, the casino problem. So it incorporates the idea I taught today, random selection without duplication. Let's take a look at the specifics. So in this casino game, you're going to spin a roulette wheel, and you're going to pay the banker $7.50, okay? And then you get to spin. Now there's 36 numbers on the roulette wheel, and so you start spinning, and every time you land on a number, you get $1. Okay, and then you spin again. Now suppose this time you get 24. Great, you get another $1. And you keep going and going and going and going. So let's pretend so far you've spun 17, 24, 18, 31. Great. So right now you've gotten $4 back. But the next turn you spin an 18 again. Game over. Okay? So what I want you to do is simulate, and so at the ended up you lost $3.50. Okay? So I want you to simulate 200 of these games and display the number produced by the roulette wheel, the amount the player wins or loses each game, and the player's total loss or gain. So this game is from the player's perspective, not the owner of the game's perspective. Give it a try, and then come back and work out the solution. All right, let's take up the solution, and the solution, as you probably know, is in the demos, but hopefully you didn't look at it and you're honestly trying this yourself. So it's called Casino, and we'll load it up. So the most important part here is that you're going to take these numbers as you spin the roulette wheel, and you got to sort of remember them. Then you go, hey, did I pick this one already? Because if I did, game over. Let's take a look at the code. And again, I've embellished this. I've made it a bit fancier than it needs to be. You don't need to make it this fancy, but here is, and I'm going to smooth this down a bit. Here is a typical session at the roulette wheel. So this first one, that didn't go very well at all. I spun a 22, 33, it was looking good. And then right away I spun another 33, so I lost $5.50. Okay, so remember, it's from the player's perspective. This one went a little bit better. This one I like. Look at this one here. Holy smokes. I started with 31, 33, 14, and then, right near the end, 23 and 23. So I won $12.50. Not bad. And, you can go through all of them. At the very end, the grand total amount of wins or losses after 1,000 simulations, I was still down $278. You're not going to win against the casinos, okay? But at least it gives you a rough idea, the total amount. Okay, so let's take a look at the code and see how we did it. Now, I'm keeping track of game wins and losses and the total wins and losses and the number spun. So that's really important. And here is the most important part of this particular lesson. I'm using a flag array of 36 spaces. Remember, you always make it one more than what it is. And this string is going to keep track of how I'm doing per session at the roulette wheel. Okay, now I'm going to do the simulation 1,000 times, and again, I'll try to get this all on the screen at the same time. I think I'll be able to get it, yep. Okay, so obviously random number generator gets started here. We initialize the class and make an object of it. Here is the simulation 1,000 times, okay? And as we did in the last example, and hopefully you use that as your guide, we initialize all our counters to 0, okay? So that we assume that we haven't repeated anything yet. Now, it's from your perspective this time. You're playing the game against the casino, and it costs you $7.50, so you're already down $7.50. And now you got to sort of get out of the hole and work your way up. This game string is here to make it look cool. That's where I kept track of how you were doing per game. It makes for a nice display. If you didn't do that part, don't worry about it. here is the most important part. So now we're in an infinite loop, okay? And it's not like the prize one where I had to win 28 prizes. So I don't use a for loop here. I just do everything, every single thing in here, okay? So what do? Well, I spin, okay? And now I go, hey, check the flag. I just spun let's pretend I spun the number 30. Check the flag. Is there a 1 there? Because if it is, get out, you're done. But there isn't, obviously, the first time. So now I go to 30 and put a 1 there. All right, so it's not that bad. It's not that crazy of a concept. And then I create this game string where I take a look at what you spun and attach it or concatenate it. That's the fancy word, attaching strings to strings to strings. Then you won, right? So you get $1 and your total wins are up $1. So you're still down $6.50. Then we go back up and we spin again. And maybe this time you get, I don't know, 2. Is anybody there? No, nobody's there. So you don't get out yet. But now put a 1 there. Do your little concatenation. Give yourself another buck, and keep going. Now let's pretend third time through you spin a 30. Okay, so you go, hey, is the flag for number 30 on the roulette wheel equal to 1? Yeah, it is. Get out. Break. Break means you leave this loop. And now at the very end, we display the final spin, and we display your wins or losses for that particular game. Okay? And we continue this process over and over and over again. And each time we reinitialize our flags, okay, take off 750 from the total. And at the very end, we will have a grand total that we were going to display wins or losses. Let's try this one more time. All right, minus 382, try it again. Minus 491, try it again. 304. So we're definitely losing. You're not going to win this game. But it was kind of interesting to simulate it. And the most important idea in this example was this idea of the flags to track whether things have happened or not. So another cool technique that you need to use in these simulations. Thanks for listening, and we're on to the last lecture in this session. Welcome back to the final lecture in this series on probabilistic simulations. And what we're going to do in this last lecture is take a look at building a discrete random distribution. Kind of a complicated title, but it's not as hard as you think. And what we're going to do through a series of a couple of examples is give you an idea of how you randomly pick objects or things from a list of things. And we're going to use some probability rules and do a couple of neat applications. Okay, I've popped up on the screen the PDF for this particular lecture, and as usual, it's in the resources. And the best way to explain this concept of discrete random distributions is to go through a typical example. So here's the scenario. I've got this bag, and it's got 5 white balls in it, 10 black, and 3 red. And what I'm going to do is I'm going to put my hand inside and pull one of them out. Now, in terms of probability, what are the chances of getting a white or a black or a red? Well, you have to know a little bit of theory. So the probability of getting a white is 5 over, well, there's 5 and 10 and 3, that's 18 altogether. So the chance of getting a white ball from the bag is 5 out of 18. The probability of getting a black is 10 out of 18. And the final one, the probability of getting a red is 3 out of 18. Okay, so that's the first part. But now, how do you get the computer to pick random numbers so you know which one you picked? Here's my first thought. I guess you could say, well, you know what? There's 18 possible choices, right? So if you pick, this is kind of weird. If you pick a 5, do you get a white? Or do you say, like, if you pick 5 or less, you get a white? And then how do you do this one then? Do you say if you pick 3 or less? Well, it starts getting confusing. But this number line idea actually is pretty close to how we're going to do it. And that's where this distribution comes in. We're going to distribute these answers across a number line. So 1 at one end and 18 at the other. But they all have to be separate. So 5 white. So that will mean the 1, 2, 3, 4, and 5. So if you pick a 1 or 2 or 3 or 4 or 5, we're going to say you picked one of the white balls and you pulled it out. Then 10, black. So you're at 5, 10 more would be all the way to 15. So if you pick 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, that's 10 things. So from here to here, it's white. From here to here is black. Now there's only 3 left over, right? 16, 17, 18. So from here to here, that's going to be the red. And now what we've done is we've made a random distribution. So in terms of if statements, we're going to have something like we're going to pick a random number between 1 and 18. And we're going to say if it's less than or equal to 5, bingo, it's a white. If it's more than 5 and less than or equal to, I guess, what, 15, it's black. And then if it's none of those two, then it's automatically red. So that's the kind of thinking you have to do. The other key concept is this word replacement. When you pick one of these balls that are in this bag and you take it out, you look at it, but then you put it back in. Because if you don't, then what happens is if you pull it out, all the probabilities change. Because if you take out a ball, now there's only 17 and we've got to rework it. That becomes a more challenging question, all right? We're not going to do that one. We're going to do the one that says with replacement. All right, let's take a look at the code. This program is called Balls in a Bag, and you can load it up. And here it is. Let's give it a quick run so you see roughly what we're going to display. So I'm looking for a particular combination, right? So when I begin the simulation, it says the number of occurrences of 1 white, 1 red, and 2 black. So when you pull out those 4 things, how often do you get that exact combination in 1,000 sort of trials? And it ends up being 157. And you can see in this display, and I tried to make it kind of like a nice little display, very detailed. There's one of those examples where you hit a white, 2 blacks, and a red. Okay? And if you went through the entire thing, you would see them all. Okay, let's look at the code. Not that bad. Remember, we're going to keep track of the number of white, black, and red balls that we pull out of the bag. This will be our generic variable to keep track of the ball that we pulled out. And this isn't crucial, but I wanted a nice display to show you what's going on. And we need obviously a counter to keep track of how many we have. Now, we're going to do this experiment 1,000 times. And again, I'll try to get most of this on the screen. I don't know if I'm going to get it all on this time. It's pretty long, but we're close there, okay? So every time we go through a session of pulling out balls from the bag, we initialize these counters to 0. And now we put our hand in the bag 4 times. All right, so it's crucial to understand that. So as we put our hand in the bag 4 times, remember we're picking numbers between 1 and 18. And we've now made a discrete random distribution. So we've decided, or I've decided, that if the number I pick in here is less than or equal to 5, to me that's white. Okay, and I also concatenate it to a string to make it look cool. Else if, and the way the computer works, if this is false, then what's the opposite of less than or equal to 5? Then it's automatically greater than 5, and then this is saying now, and also less than or equal to 15. So that's black. So it sort of cascades down. If that's not true, then it's the opposite of less than or equal to, which means it's more than 5. And then this has to also be true, which is less than or equal to 15. Now, those two aren't true, then the only thing left is red. So you see how it's discrete? So we had 10 blacks. We had to go from 5, 10 more is 15. All right, so that sometimes throws people off, how you make that discrete random distribution. Now, we are done the initial process of those 5 draws, and now what we do is figure out if we had this combination. If we got that exact combination, we count it. And the whole process ends when we display our final results, and it's way off to the side there because it's fairly long. And there's the very right-hand side of the screen with the results. So we're keeping the total. So there you have it, just how you do a random distribution. All right, to finish this lecture, I'm going to do a little bonus activity. Over the years, students, when I teach this topic, they really enjoy it. And they go, "Sir, you keep talking about this mysterious black box called the random number generator. Can you actually show us maybe a random number generator instead of having us depend on C# or Visual Basic or wherever else to use theirs? So here's a little problem I created, and it's going to incorporate a homemade, so to speak, random number generator. So let's take a look at it, and we'll show you the code in a second. So darts thrown at a dartboard land in regions. Okay, so there's 3 regions: the dead center, a little bit off from the center, and way off from the center. And depending on what region you land in, you get a certain number of points. Okay. Now, the 2 views of the dartboard shown below are the ones that have the actual regions and the scores. Now, here's the first key line in this problem. Assume that regions 2, 3, and there's another region up here, which is a little bit off the screen, that is worth only 1 point. So regions 2, 3, and 4, the far away ones, are 3 times more likely to be hit than region 1. So how do you write that as like a probability? 3 times more likely. So you can give them like 3 points each, so to speak. Okay, so 3 times more likely. So that's 3 times more likely. So region 2, 3, and 4 have those weights, and the dead middle only gets a weight of 1. So 3, 6, 9, and 1 is 10. So there's a grand total of 10. So the chance of landing in region 2 is 3 over 10. Chance of landing in region 3 is 3 over 10. Chance of landing in region 4 is 3 over 10. And dead middle is only 1 over 10. Now, why did I write them like that? Well, I could say pick random numbers between 1 and 3, but the random number generator I created only outputs decimals. Decimals that are between 0 and 1. So we got to write this as decimals. So that's 0.3, 0.3, 0.3, and 0.1. And those add up to 1, which is standard for probability. Okay, let me move the screen down a little bit, and you'll see this made up random number generator. So, the first thing you do with a random number generator is you have to seed it, right? So here is the seeding values, and it's still a little bit tricky. Now, these actually are exponents. So there's going to be a seed value J, a seed value M, and a seed value L. All of those are going to get fed into the random number generator. And here is some weird formula that takes all of those numbers, and then you notice that it has a J, L, and M, and then it goes back into L. Isn't that interesting? Okay, and then L divided by M is R, and that's what we return. That's the random number. Very weird. Now you notice that these answers that we're getting, when you do the next random number generator, they use some of those values. So the value for L is here, it gets divided by M, and it equals R. So we keep reusing them, and that's the basis of a random number generator. Okay, so eventually what we want to do with this information is create a chart that keeps track of the number of hits in a particular region and then the total points. Now here's the funny thing. When we seed the random number generator with an initial value of L1 and all this other number, these are going to be the exact answers, period. Okay, so that's the funny thing. Once you have that seed, they follows a particular pattern so that the next random number depends on the previous one. So we are definitely going to get these answers. So if we did this with a regular random number generator that belongs to C#, we'd get different answers. But this one is guaranteed to be those exact answers. Okay, let's look at the code and see if we can figure out what's going on here. And again, this is a bit of a challenge. Nothing spectacularly challenging, but it's something different and interesting to see. So this program, if you're wondering, is on your demos, and it's called Dartboard, and I think I've got it loaded up already, and I'm going to give it a run just to show you what it does. Okay, it displays the regions, so obviously getting a bullseye doesn't happen too often, okay, and you hit the bullseye 32 times, and then the other ones that many times. Okay, let's take a look at the underground code. So the first thing is that we have to match up the fact that when you hit a particular region, it's worth a certain number of points. So I have an array, can't forget arrays, a region point value. So when you hit region 1, region 2, region 3, and region 4. And remember, I don't like using region 0, no such thing, so I'm not going to use it. And then we're going to keep track of the count. And remember, we're going to use an array counter. So I don't want to use 7 or 8 different ifs, or in this case, 4 different ifs. I want to use an array counter. Here are some of our variables that we're going to initialize. And now this is the weird stuff, okay? But you wanted a taste for it, so I'm going to give it to you. I created a class. Whoa, look at this over here. Called rand. Okay, a special class that's like a random number generator class. I invented my own one. Let's go over here and take a look for a sec. So this is the rand class, and I've created some static variables. So I've got a static j, m, and l, which you saw me talk about on the PDF file. There is the constructor. It's a blank constructor. It doesn't need to be fed anything. Here is a method. This is the initialization method. And it's going to be fed in the 3 initial values that you send from the outside. And those initial values from the outside world get put into these that are private. And this is the random number generator. And that's a L, not a 1. And it takes these values, does a little bit of crazy math to them. Then it takes the final result, divides it by m, and it returns it. So this is going to return like a decimal value, a fraction. Okay, let's go back to the main form for a sec. So right here, what this does is it takes and feeds into here those values. Now you might be saying, well, how come you don't do that thing with the rand equals new rand because of this word here? These are static. Okay, so you don't have to instantiate static methods in the class, right? So you just basically say them and they're done. All right, so there's no rand x equals new rand x or something like that. All right, here's the rest of the program. In a loop, I start and throw my first dart at the wall. Now, what does it come out as? Well, this is the second method that's in the rand. Okay, this is this one down here. And it's going to return a fraction, a decimal number. All right, and what I'm going to do is when I get that decimal number, I'm going to say, listen, are you less than or equal to 0.1? Then I hit the bullseye. Region 1. Now remember, the next ones are 0.3. So to go from 0.1 to 0.3, that's up to 0.4. And then another 0.3 brings you to 0.7, and another 0.3 takes you to the very end, which is region 4. So that's kind of weird, eh? But that's how you use the random number generator. Now, after we get the region, we have to count it. Remember, this would have involved 4 if statements and 4 counters, but we're using the counters, array counters. And again, if this is freaking you out, you can write it like this, no problem. Region hit count, square bracket region plus 1. All right, same thing. And I got to put a little equal sign there in the middle. Okay, and then what this does is work out the grand total. So remember, you know what region you've gotten, and now I'm going to take the point value for that region and add it and make a grand total. When I get to over 1,000, I stop. All right, this prints out the final results, 1 to 4, and it prints out the region count and the region point value, which is the number of times you hit a region times how much it's worth. And then you get this to come out. All right, so a little bit weird. All right, you asked, and so that's why a lot of times all that stuff is treated like a black box, because it can get a little bit crazy, but it's neat to see, okay? And that's kind of one of the crazy formulas. Sometimes they use other kinds of math involved too, but just you get a taste for what it looks like. Okay, so that ends probabilistic simulation, and now we're in the home stretch. For some of you, this is going to be the most exciting part of the course. It took us a while to get there, but we're going to get into graphics now. We're going to learn how to draw objects on the screen, animate objects on the screen, make them move across the screen, figure out when they hit the walls, figure out when 2 objects hit each other, introduce sound effects, and start creating a couple of semi-professional games that involve, first of all, some low graphics skills and then a little bit higher skills using a technique called back buffering. Okay, so that's what we're going to finish up this course with. So hopefully you'll appreciate all the different things you've been doing to get up to this stage. Okay, and we'll see you in the next section. Welcome to Graphics, the last section of the course. In this multi-lecture section, we're going to introduce the basics of graphics, learn how to draw lines and circles and rectangles and other shapes on the screen, take that knowledge and then create a bar chart program. Once we feel comfortable with that, we'll start using the mouse, programming the mouse and figuring out how the computer can activate the mouse. We're going to then continue to animations, learn about timers and image arrays. Once we feel comfortable with that, we'll move objects across the screen using several techniques. Then we'll learn about collision detection and how to use the keyboard to move our objects back and forth. We will then learn about sound effects, incorporating those into our game development. And then to finish up, we will take a look at some advanced animation techniques called double buffering and develop a couple of games. So hopefully you'll find this last section entertaining, interesting, and a nice way to wrap up this particular course. This first lecture, what we're going to do is introduce graphics coordinates, figure out where things are on the screen and how to tell the computer to put things at a particular spot on the screen. Then we'll learn about the graphics class and draw things on the form. Things like text, things like circles, lines, rectangles. And then we'll finish up by showing you how to take an image that's stored on your hard drive and display it on the screen also, and finish up with a nice little dice simulation that we can now do graphically. All right, let's get started, and we're going to get our hands dirty here. I'll do some demos later on, but let's learn ourselves, first of all, how to do some simple graphics. So don't call this program graphics, though. Graphics is a special word, so why don't we call it graphics demo. All right, then we're going to press OK. And we'll go through the same scenario, but you're going to see the twist today. We're not going to use a button or anything to activate this form. It's going to be kind of cool. So first of all, this form, I'll call it FRM graphics demo. And I will rename the title at the top, graphics demo. Now here's the thing. When I press run, all right, and you'll see it pop up in a second as it compiles, which is actually nothing right now, but it still moves it. Every 60th of a second, this screen is refreshing itself, whether we want it to do it or not. And what it's doing, without our knowledge, is the paint event. We didn't click on anything or anything else, so we're going to incorporate that power that the screen redraws itself constantly to incorporate the new graphics that we're going to learn. Okay, now, first thing before we can do that is, how do we tell the computer to put stuff on the screen? Where is stuff put on the screen? Well, we have to get used to graphics coordinates, okay? So I don't know if you remember your math, but when you do graphing in math, this is the origin. So when you tell the computer to put something here, you have to tell it two numbers. An X, how far over this way to go, and then how far up to go to get to that spot. Well, in computer science, they consider this corner up here, to be 0, 0. And then you go across for the X and down for positive Y. So it's a little bit upside down, okay? So that's the first thing you have to realize when you work with graphics now in computers, all right? That the origin is at the top left corner. And then depending on the screen size, there's hundreds or thousands of little dots. And you are going to draw in those little dots certain things, okay? And those little dots are called pixels. All right, now let's start programming. Now, as I mentioned, we're going to use the paint event for the form to draw our graphic symbols and images and everything else. Now watch when I double click on the form. I'm in the form load event, but that's not the one I want. So like, how do you tell the computer to do the paint event? Well, you click once, not twice, like don't double click and go into the underground. Then over here on the right hand side, there's a little lightning bolt. Those are events. So even though most of the time all we've ever used for the form is the load event, which we have right there, There's other ones. There's a key down, key press. Actually, we're going to use those later on in this last section of the course. But there's other ones. Mouse down, that's kind of cool. But I'm looking for paint, and I'm going to double click on paint. So that's important. We've never done that before. It's another event associated with the form. Now, don't erase this. You can leave it in there if you want. We may use it later on, but this is where all the action is going to happen. This is going to refresh the screen constantly, and it's going to redraw things. Okay, so how do you use this? How do you wake up the computer to use graphics? Well, like I told you, don't use the word graphics for anything because it's a special word. Okay, and what we're going to do is we're going to sort of wake up the graphics method or class. Okay, and that's how you make an instance of that class. There's other examples where you use the word new, but for us right now, we're basing the class on this E event, paint event, right? So this is important. That wakes up the graphics class. Now, the first thing we're going to do is draw a word on the screen. Kind of weird. Draw a word on the screen? Yeah. You're going to draw text on the screen. And the way you do that, and I'll write a little comment here so you have a better idea what I'm doing, is we're going to use a special class called the font class. And then we're going to say new font. And then, you know how you have Times Roman and all that stuff? You make the name of the font there, and then you give it the font size, okay? And we'll make it 30. Okay, so that's the first thing you do. Now the next thing you do is you create a brush. So you're going to draw with a brush. And the way you create a brush is we're going to use this special class again called solid brush, and we'll call it B for brush equals new, and then solid brush bracket, and here you give it a color. Now colors, you type in like that, dot, and then you make up a color, and we'll just use blue, something really basic for now. Okay, we're almost ready to draw a word on the screen. So draw a string, and you actually use the command drawString. So you say G dot, so everything is based now on this G. This is the instance of the graphics class that we're going to use. And then there's a bunch of different commands you can use. We're going to use one called drawString. And then the first thing you do is you type in a word like hello, comma. The second command you type in is the font that you want to use, and we're going to use the font that we've labeled as F. You also name the brush, which I named B, and then you tell the computer where on the screen you want to go. So remember, we're at the top left corner, and we're going to slide over 40 and down 40. And that is our first program. Now when we run it, you don't press anything. As soon as you press run, instantly it's going to type the word hello there. And roughly speaking, I was just guessing where to put it. I'm telling the computer to go over 40 and down 40, and that puts us right there. And then you type the word hello, and it's in this font, Verdana, and it's in blue. Okay, so that's the first simple, basic idea of using graphics to do text. Okay, next. Next thing we're going to do is draw like a line. Okay, now to draw a line, you have to use a pen. So first of all, we have to create a pen. And the way you create a pen is you say capital pen and then P for pen. You can use any variable you want there, really. New pen, bracket, and again, you give it a color. I'm going to say red this time. And then comma, how thick you want the pen to be. I'm going to use 4. I'm not sure how big or small that is, but I'll use that. Now we draw a line. Now the way you draw a line is you base it on the G, that's the graphics. You're going to draw it right on the screen, and then you say draw line, bracket, the pen you're going to use, comma. Now what you do is you got to know a little bit of math. You got to say where do you want to draw from to where you want to go from. So you may want to draw a line from there to there. So you're going to have to give the computer 2 coordinates and 2 more. So you have to know a little bit of your math. You got to have a rough idea where you're starting and where you're going to end. Here's some numbers that I know will work for sure. I guess I could start right at 0, 0. That would be the top left corner, comma, and then I'll make up, I don't know, 140 and 100. Okay, and we're ready to try that one out. Okay, so you notice it goes from that top left corner and down to right there. So that's how you would draw a line. Okay, let's try drawing a rectangle next. Now with a rectangle, you do it quite a bit like the one we just did. You draw a rectangle, and then you feed it the pen. You give it a starting point. How about this one? We'd start at 50, 50. But then the last two numbers are not where you end off at, but it's how wide and high you want this rectangle to be. So I'm going to make it kind of tiny. I'm going to make it 20 by 20. And then I'm going to press semicolon. Okay, and let's see what happens with that. So there's that little rectangle right over top of the H. All right, and that's rectangle. How about we try to create a filled-in rectangle this time? Now to do that, you have to create a solid brush. So you have to use the brush class. And here I've declared solid brush class, and I'm going to refer to it with the letter S, and I'm going to use a purple color. So now we use G dot, but we don't say draw rectangle. We're going to use a fill rectangle. And then the rest of it's pretty well the same. You refer to your brush, this time not pen, and then you give it a number that you want to use. So we can say, let's go over 120, go down 40, and then draw it as 50, 50. And this will draw a solid rectangle at that location. All right, so there it is right there. How about a circle? Well, for circles, there actually isn't a circle command, but there's one thing called an ellipse, which is like a football shape that can be squished in from the sides to look like a circle. So the first thing I do is I declare a solid brush, and I'm just going to use a different color instead of the purple this time. And then I go G dot fill ellipse. Okay, and then bracket S new. So you always start off with the color or the brush in this case that you want to use. And then let's go over 100, down about 40, and the last two numbers have to be exactly the same. That's going to be the height and the width. Now if you make those two the same, then you'll get a perfect circle shape. If you don't, it'll be stretched out and look more like a football. And here it is, and there you see it right there, dark blue over the LL in hello. Okay, and we've sort of squished them all here. We could have gone over a little bit. Those are your basic shapes. Okay, so this is the basic idea with graphics. You're going to declare certain classes that are going to draw fonts for you, or have a pen that will draw a line or a rectangle, or fill in shapes. Now that's kind of the straightforward stuff. There's other things that you can do, like put a whole image and throw it on the screen. Now what I'm going to do is stop right now, and I'm going to show you the demo. That's the full demo of this, and just in case you couldn't get something to work, you know that you can always refer to this one to help you. So let me just load it up, and it'll be in your demos that you downloaded for today's lesson, and hopefully you downloaded a folder. And let me just go up a little bit here. Okay, hopefully you downloaded a folder called Intro Graphics, and in there, the one that I just did is called Graphics Class Intro 1. And if we load it up again, this will give you like the full sort of enhanced version. It's got all kinds of different things. It's got lines, it's got the words, and it's got this image here. Okay, and let's take a look at that. Now the first thing I want you to realize as we do this last command to wrap up this lecture, this image has got to be on your computer somewhere. So let me just go to my hard drive for a second and show you where it is. So we're in Class Intro 1. We're going to have to snake our way down into the bin folder, which you've seen me use before. And there is the image of this school. Okay, so somewhere on your computer you have to save this, and usually this is the best place to put it, in the bin drive and then debug. Now, how do we tell the computer to go there and get it? Well, let's go down to the bottom of all this code here. And remember when we did data files? Same kind of idea. You're going to have to make the computer point to where your images are. And the application startup path always, points to that bin debug folder. Then what you do is, now that we've stored the location of the file there, is you use a new kind of variable, an image variable. You know how you can have int and double and string? Well, now you can do image, and you make an object of that image, and then you say image from a file. That's how it's going to load the picture of the high school into this variable. That's not enough though. Now we have to do a command. You know how we did draw string? Well, there's one called draw image, and what it'll do is it'll take that image of the school and put it 370 over and 5 down, and then draw the image 50 by 50. Okay, and just for fun, although it might go off the screen a little bit, let's make this 80 by 90 and just give it a run. It's going to distort the picture, obviously, and there it is now, a little bit off and down. So those are your basic commands. Now this one we will review in our next lecture as I show you a sample application. And just for fun, before I wrap it up, let me give you a little problem. Okay, I want to draw a big X. I'm going to leave you with that little problem. Then we're going to stop the tape for a second and then come back and show you the answer. I want to draw a line that goes from there to there and a line that goes from there to there to draw a big X. And then I guess as a challenge, maybe you can even draw a line from there to there and there to there that draws a cross. But let's keep it as an X for now. Okay, think about it. We'll come back in a few seconds and show you how to do it. Okay, here's our problem, and we'll try to break it down as clearly as we can. When you draw a line, you're going to have to tell the computer what corner to start at and what corner to finish at. Now that corner I know, that's 0, 0. This corner, I don't know what that is. And depending on the size of your screen, it might be a little bit bigger or smaller than mine. So you have to try to make a program that works for anything. So this is the width of the screen. And there actually is a command called this dot width that we'll use. And it's not the best one to use, but it's one of them. And then you have to go down all the way to the bottom, and that's the height. And we'll use this dot width. Let's give that a shot first. So we've got a pen that we can use from before. We'll use, which pen should we use? We'll use the red pen. So just see this word here, pen. Okay, I'm going to use that one for this question. So all I'm going to do is say G dot draw line bracket pen comma 0, 0, this dot width, and then this dot height. Now it's yelling at me because I think I didn't spell width with a capital. Okay, and then semicolon. And if you remember way back when we did some other programs at the beginning of the course, and I said don't ever use the word width and height, and that's why, because they're special words to the computer. Let's give it a run and see what happens. Not bad, but not perfect. It's at the top left corner, beautiful, but this is a little bit off. So there's even a more exact technique that you can use called client rectangle width, okay, and client rectangle height. And I think that's the most dead on, and that's the most correct way to do it. And there it is. All right. Now, let me stop again, and I want to see if you can do the second one. See now if you can figure out how to go from the right-hand corner all the way down to that bottom corner. Okay, did you get it? Here's the answer. All right, and I'll doodle on the screen for a second just to make sure you understand how it worked. We're going from this corner down there up to this corner, or vice versa. It doesn't matter the order. But what is this corner down here? Well, I'm not going across at all. So 0 is the X, and then I go all the way down to the bottom, which is the height, right? Then in this one, I go all the way across, and then I don't go down at all. Okay, and that's why the last one is that answer. And let's give it a run to make sure it works. And there's your big X. Welcome to the next lecture in the graphics section. In this lecture, we're going to first of all do a recap of what we learned last lecture, and then show you a quick application related to a dice rolling game. And then we're going to focus in on one key concept today, the concept of creating graphics inside a panel. It's almost like doing a picture inside a picture. We're not going to display our graphics right on the form, but a little window inside the form. Let's start off with a little bit of review. So what we did last lecture was introduce the coordinates of the screen, and at the very top left corner, that is 0, 0. And then we can go across for the X and down for the Y. Now you see the screen here, it has nothing on there. When we press run, things appear. How'd that happen? Well, what we did is we used not the form load event, but a new event associated with the form. And when we press the lightning bolt and we go down to P for paint, we are now accessing what is called the paint event. And this event occurs every time the screen is redrawn. So we leveraged that ability and incorporated all our graphics in that event. And just a little recap of the different techniques within it. This is how you instantiate an object of the graphics class, and then allows us to draw right on the form. And what we did in the last lecture was create a font object, a brush object, and then use, in the first example, the drawstring method to draw a text, a word on the screen. Okay, it sounds kind of weird. Usually you would put it in a label or a text box, but now you're actually drawing text on the screen. Then we introduced the object called the pen. And we made an instance of the pen class, which is going to allow us to scribble something on the screen. And in this particular first example, we drew a line on the screen. You could also draw rectangles. By incorporating the solid brush, we can fill in these shapes, and we filled in a rectangle, and then we filled in an ellipse, which is kind of like the football shape. And then if you make the last two numbers exactly the same for the width and height, it becomes a circle. The last idea that we showed you in the last lecture was this idea of having an image off screen in your file folder somewhere on your hard drive. And by pointing to that location and then using an image, we can take that file from that location and store it in an image. All right. Now that does not draw the image on the screen. Then we learned a command called draw image, which takes the image, puts it at a certain location, at a certain width and height. Lastly, I wanted you to recognize that the left and right hand side, the top and bottom of the screen, has limits. And these commands here allowed us to draw an X starting from the left hand side, working its way down to the bottom, and from the bottom left all the way to the top right. To finish up, I want to show you a little simple application which takes advantage of this. Now, on our previous section on probabilistic simulations, we did a lot of numerical simulations, but we didn't do anything with pictures, and that's when it starts to become fun. In the previous lecture, when you unzipped the file, you should have all these file folders show up. I want to load up the one called Dice Roll Problem, and when you load it up, it looks like this. There's nothing on the screen, there's no pictures or anything. What we're going to do in this particular graphical simulation is roll 2 dice. And as I roll the dice, it displays the images and tells me the total of the two numbers. Okay, so nothing spectacular, it's nothing fancy, but now we're taking the ideas from our previous section on probabilistic simulations and adding a graphical component to it. Now, let me just give you a little background. On this particular folder, I'm going to work my way down and show you where I've loaded in all these images. So I found these 6 dice images on the internet, and I stored them in the debug folder. Okay, so what I'm going to do now is take those when I randomly pick a number and display them. Now you should notice the way I named them: dice 1, 2, 3, all the way to 6, because I'm going to almost create a little equation so that I can write it in a very compact way. Let me pop this down and we'll look at the code. So basically, when I click on the button, I make the screen the object that I'm going to write on. Okay, now this is a new technique that doesn't involve the E dot. Okay, this one you say this, and this is the form. Okay, create graphics. So this is another way to create the G object from the graphics class. Okay, this just clears the screen to the default color. If it was white, it's going to stay white. This is how I picked a random number between 1 and 6. Now here is the key line. What I want to do now is, because I picked, let's say I picked a 3. What I want to do is have the computer point to where the dice 3 lives. Now here I use 2 slashes. I could have also used that little @ sign that you've seen me use before. This attaches the word dice to the number I picked. So like I said, I picked a 3, and I convert it to a string. So this is going to say capital dice 3, and then I'm attaching that to the .gif. So as I was mentioning, I created almost like an equation that will, when it's done, have in here the exact location of dice 3. Then, from what I taught you last lecture, I create an image object and I take from the file the actual picture and store it in here. And then this places it on the screen. This line picks another number between 1 and 6. This creates another equation that will attach the entire path to, let's say I pick up 4 in this one. It'll say dice, attach it to the number 4, and then attach it to .gif, and also display it on the screen. This adds the two numbers together that I randomly picked. And remember, I have to also display that answer, and so I have to draw that text on the screen, and that's what I do here. Okay, so kind of a neat, simple application of using random numbers from our previous section, and now this image from a file, which will load an image and put it on the screen after you draw it. All right, so the focus today is on a panel. It's like a little window on top of the form. And the demo I'm going to load in is called Graphics Class Intro 2. Load it up. Okay, and we'll make sure it's in the center of the screen. Just going to run it for a second. So you can barely make out there's a little window here now. And when I press here, it's just displaying some objects. And I'll press this one again. It displays some more objects on that window. So I'm going to widen this a little bit more too. This is called a panel, and if you were to drag it onto the screen, you would go over to the left-hand side where all your tools are, and you would drag a panel right here. Okay, and this first panel I called probably panel 1. Okay, this one here is probably automatically panel 2, and in a second I'm going to make something else show up here instead of here. Okay, so that's the first thing. We're going to drive a little window, and sometimes when you create games, you're going to put them in a little window and play everything inside of there. It's kind of a nice way to control your displays. Let's take a look at some of the code here so we understand what's going on. First of all, when the program loads, so this time I do use a form load. So I click away, and behind your back, I instantiate this window. Now, here's what I do first of all. I declare graphics G so the whole world knows about it up here, not inside of anything. And then here, remember what I did a few minutes ago with that this.create? Well, when I said this, it put it right on the form so I could draw anything on the form. In this one, because I specifically want a certain section of the form to become active, I say panel.create graphics, and that wakes up that little screen of the form. And now anything that I use with the letter G will draw right in here. Okay, so that's the first part. That all happens in form load. I don't really press anything to do that. It just automatically creates it. Now I click on the button, this first one. Let's take a look at that code. First thing you see here is that there's a clear command. I didn't show you that before. And what it's going to do is going to clear whatever's on the panel to the back color, its original back color. Okay? Then what I do is I draw a line. And this one here, you can sometimes, without having to instantiate the pen class, write it right in there. So I'm saying I'm going to have a red pen, and I'm going to draw a line from 0, 0 to the panel width and panel height. Now, that's interesting. Let's take a look at what that did. See that little skinny red line that went from the top corner 0, 0 all the way down to the bottom, which was the panel width and panel height? That's what happened. Okay? Next thing. This is a really cool command. This one here uses a brand new command that we haven't used before. I create a new pen, so this time I do use it the way I showed you in the last lecture. And this pen has a color that's not just blue, green, red, whatever. What it does is use this new command called from RGB. And every color can be made from red, green, and blue. And these numbers in here can go from 0 to 255. 0 meaning no red at all the way to 255, which means solid dark red. Same with the green, same with the blue. So what I did in this one is I made it a lot of red, fair amount of green, just a little bit of blue. Okay, and then that 10 means the width of the pen, and then I drew that. So let's take a look at what that did when I ran it. Okay, so it drew this sort of rectangular shape and kind of a yellowish color. Okay, now next button. And the next button I'm going to modify in a second. But the next button, it clears the panel, okay, and it draws a rectangle again, and then this other one draws another rectangle filled in. So if you want to run it again to review what it would look like. So there's a rectangle and another one. What's going on with that other one? Well, this rectangle you can obviously see, right? Okay, and that was the one just like the one we just did. This one here, which is the sort of, it's red, green, blue, so there's a lot of blue in it. That's the solid one, but look at this one right here. You can almost see through it. Ah, that's interesting. Well, there's another parameter that you can use when you work with colors, and this is just a fabulous command. This one right here, that's called the opacity, or the alpha. And if the alpha is 0, that means it's totally invisible. If it's 255, that means it's solidly dark. And we've put it at 100 to make it sort of faint, right? If you want me to, I can fool around with that. Let me make it a little bit higher. Let's make it 200. Now when it's 200, it's going to be a lot darker. See how it's not as light as it was before? You can still see through it, but not as good as you could before. So that's kind of cool, all right? So just a little different commands. Now just for fun, what I'm going to do here right now is I'm going to make another instance of the graphics class. Okay, so that one's called graphics. This one I'm going to call G1. I'm going to create another instance of it. So G1 is going to be equal to the panel create graphics. Okay, and this one down here where I would have put it into the first one, what I'm going to do this time is I'm going to have it shoot over to the other one instead. So everywhere there's a G, I'm going to put a G1, G1, and G1, just to show you how cool this is, so that you can actually draw in separate windows. So this one draws in this window, this one draws in that window. Isn't that neat? So you can have their own two little worlds all in sort of a main form. So there is the use of panels, okay, in graphics. Little bonus action here. Hey, did you really like that RGB stuff? I think that's cool, eh? We may have done this program before, and now hopefully you'll start to make some sense out of it. This isn't really anything to do with computer graphics per se, but it's kind of a neat little application I created to show you how. Remember, I told you you can have 0 to 255 for the red. That's solid red. Now we're going to add some green, and I'm going to add a little bit of blue. Okay, so what's going on there? Well, it's using, via those numeric up-down controls, the RGB color technique, right? And what it does is it's feeding into the text box. So that text box, okay, that text box right there is called text color. And one of the properties of a text box is that you can change its back color right there, right? So what I'm doing when I'm clicking on these is I'm feeding, as I move the numeric up-down control, the value, right? Now, here's the thing. When you feed the value, you're going to feed it the red value, the green, and the blue. And I cast it with int because the colors have to be solid numbers, whole numbers, okay? So just in case it's a decimal, it has to be converted into an int, all right? And what that does is take the red of the first scroll bar or scroller, okay, numeric up-down control, the second value and the third one, and feed it into that box. Isn't that cool? All right, and that's all from this RGB technique. Second bonus example. We talk about object-oriented programming and then we stop doing it. So I want to show you how we're going to keep touching upon it as we go along. And here's an example of how I used object-oriented programming to do a little bit of graphics. First, I'll just run it. And what it did is it drew 3 faces. Okay, now I could have written separate routines to all 3 faces, but what I did is I created sort of like a master class called the face, okay, or just the face. And each face basically is the same, right? Except certain ones have a different color. All right. So, and different colors for the eyes and everything else. So that's kind of a classic example of how you use object-oriented programming. You create the mother, and then the children look a lot like the mother, but maybe with one or two small characteristics that are different. Classic example of object-oriented programming. Let's take a look at how I did it. So over here, on the right-hand side is the face, okay, which is a class. And the face is going to need some information. It's going to need to know where the face is going to be put on the screen and the color, okay, of the whole face and the smile. Now, this first thing here, this is what we call the constructor, and we're going to feed into this constructor the initial position, the color of the face, and the color of the smile. And those will be stored in the private variables. Hey, is this starting to ring a bell like from what we did before? This is the method for the color, which will take the color. This is the method for the smile color. These are the positions, the X and the Y, that we could use as accessors and mutators. Here is where everything actually happens, and this is where I'm going to slow down for a sec. This is the paint method that I've created that will actually draw the face. Okay, let's see if we can show you some of the math behind this. This one's a bit more complicated for sure. So this line right here, when I tell the computer that I want to draw a circle at 5, 5, that means it's going to go over 5 and down 5, and it's going to start drawing the circle there. And then it's going to be 80 by 80, and that'll draw that circle, okay? Now, the rest of it, the eyes, how do you do that? Well, from where you were, that corner there, the X, you're going to go over 20. All right, so that's what that line does. Go over 20 and down 30. So that's going to line you up at roughly where you want to draw that little eye. And that eye is going to be 15 by 7. So that means it's like 15 that way by 7 down. And that's how you draw that eye. The other one, X plus 45, means that you're going to go over 45 and then down, and that'll draw the next eye. Okay, 15 by 7 also. Now the pupils, okay, those little things in between. So that one's X 25. So see how you went over 20 here? You got to go over a bit more to line yourself up right there. And once you get there and go down 31, do 5, 5. So you're 5 over and 5 down, and that draws those little eyes. Okay, same with this one here. You go over 50, and that brings you like right to that middle eye, and you go down. Now the last part, the mouth. The mouth is a command I didn't show you. It's called draw arc, and you use the pen, and it basically draws from there to there. So that's kind of cool. All right, I don't want to get crazy with this, but basically then how do you call this? Well, the way you call it is in the class routine. You feed it where you want to draw, the color of the actual face, and then the color of the mouth. All right, and there you see how you call the class face and make an object of the face class, an instance of it, and then call the method in there. So it's kind of cool, a little extra bonus, and kind of getting excited about all the different things we can do with these. The next thing we're going to do now is learn how to make bar charts from all this that we've learned. Welcome back, and in this lecture what we're going to try to do is apply some of the knowledge we've learned over the last couple of lectures and use it to create a practical application. What we're going to do is take a look at a set of information, data, and create a bar chart through a series of mathematical calculations and then a graphical interpretation of those results. Okay, so if you're not familiar with what a bar chart is, it's kind of like from an idea from Excel. You take a bunch of numbers and you make a chart that represents, in our case, the frequency of a certain value. And let me go to the demos to show you which section we're in now. We're in bar chart, and we'll load this in. And I'm not going to explain the code yet because there's a lot of background, but I just want to quickly run it for a second so you can see what kind of things we're talking about. This is a bar chart, and these are sales, and 2,000, the bar is right there. 3,000 is a bigger number, so it's a bigger bar. And let me do it vertically. Okay, so we're going to try to figure out how do you do that? What's all the process? So we're going to first of all look at the algorithm to develop a solution for this question. So algorithm, what do you mean? Well, let's try to remind ourselves of maybe something you did in high school. So let's say we had a screen like this, and the sales for 1999 or whatever were 10. So you would make 10 little bars to represent those sales. Okay, it wouldn't have to go necessarily to the top. And if the sales for 2000 were 5, you would make 5 bars. Okay, so about halfway. Now there's a problem though. What if I had sales of 1,000 and my screen is only, let's say, 15 high, 15 pixels, which it isn't obviously. How do you make it shrink so it fits in there? So that's our first dilemma. So what we're going to do first is figure out how to scale information to fit any size screen that we're going to work with. Okay, so let me clear this screen out again and I'll give you a for instance. And we'll work with some nicer numbers this time. Let's pretend our screen is 100 pixels wide. So from here to here, it's 100 pixels. And we'll do our graph sideways just for now anyway. Okay, so let's say I had sales in one particular year, 1999, of 50. So that would be about halfway, right? So I would use 50. Let's say in 2000, it was 100. 100 would go all the way to the edge. And one more, let's say it was 2001 and it was 25, so I'd be a quarter of it. Okay, now here's the dilemma. Let's pretend, and I'm going to redraw the screen down here. Okay, and it's still 100 wide, but let's say this time the sales for 1999 were 200. How the heck are you going to describe 200? So this one, I'm just going to put to the side of it, it's 200. 2000, sales are 100. And for 2002, it doesn't matter what year it is, it's 50. So this 200 has got to fit in here, but it can't right now if we represent one pixel with one number. So if we take the 200 and divide it by the size of the screen, we get an answer of 2. This is what we're going to call our scaling factor. Okay, so we're going to take each one of these and divide it by 2. So 200, when you divide it by 2, you get 100. So this one will take up the entire width of the screen. This 100 divided by 2 is 50. So that'll take up half the screen. And this 50 divided by 2 will take up 25. So it's all relatively the same in terms of how it compares to the other one. But what we've done now is we have to worry about numbers being too big to fit on our screen, and we have to scale them down, usually not up, but sometimes they're up also. Okay, so let's devise our first algorithm. So what we're going to do when we have to create a bar chart is first of all, determine the biggest number, which we know how to do already, right? Remember how we did that big stuff? That big stuff was in arrays. Couldn't stand arrays, can't run away from them, okay? So first thing we're going to do when we're given the data is we're going to figure out the biggest number of that data, okay? Then the next thing we're going to do is figure out our screen size, where we want to put it, how big you want your screen to be. So even if we had a big screen, and let's say you didn't want to use even the whole screen, you only wanted to use up to like almost near the end, but not quite, you'd have to figure out the screen size, okay? You might say it's the whole width, take away 200 pixels, okay, because you don't want to go right to the end. Then 3, you work out the scaling factor, okay? And the scaling factor would be the biggest, okay, the biggest number divided by your screen size. And that would be the most important part. Then the fourth part would be to take your data and divide it by the scaling factor. And that'll tell you how many little pixels you have to use to represent that number. All right, one more for instance, okay? Sometimes you want to stretch things out, not just shrink them. So let's say our screen size is 20, and we've got numbers like 2, 4, maybe 10's our biggest number. So what's the scaling factor? Well, the scaling factor is the size of the screen divided by, oh no, is it the size of the screen? No, it's the biggest number divided by the size of the screen. Hey, oh, this is going to be like a fraction, a half. So what's going to happen this time? No problem. So we take the 2, like we did in the other example, and divide it by the scaling factor. Now you got to know a little bit of math. When you take 2 and divide it by a half, it's 2 times you invert and multiply. So that 2 is actually going to be represented by 4 blocks. The 4 divided by a half is 8. That'll be represented by 8 blocks. And the 10 divided by a half, there you go. 10 times 2 will be 20. Okay, so sometimes you scale down and sometimes you scale up depending on your scaling factor. So there's some heavy-duty little mathematical calculations you have to do in your head. So there's a bit of problem solving, right? That's what goes on. And now we have to take this idea, which is kind of like pseudocode, and convert it to a real program. All right, which brings us now to this bar chart. Okay, we'll run it again one more time. It does a horizontal and a vertical, and I'll explain really in depth the horizontal. The vertical is basically the same kind of idea. Okay, and this is a beautiful question because it's going to review a bunch of different ideas that we've covered over the previous sections. Okay, so first thing, what do you think that is? That's a panel. All right, we just did that in the last lecture, like using a panel. It's like a little window inside a window. Beautiful. So there's a panel. And I like the panel because what we're going to do with the panel is we're going to decide how much of the panel we want to use. So the panel has a property called width. So we're not going to use the whole width. We won't go right to the edge. Maybe we'll take off a little piece. And here's the proof of it. When you run this, I don't go right to the end. I go a little bit, almost to the end, but not quite. Okay. Let's double click on the form for a second. All right. And actually, let's go all the way to the top. Okay, there I sort of call the whole world out and say, listen, I'm going to have a G variable, which is an object of the graphics class. Okay, so everybody knows about that graphics class. Now I should go to the form load. Now we make an instance of the graphics class and say, make it point to the panel. So whenever I use G, it means it's going to be drawn on the panel. Okay, let's continue. And now we're ready to actually press the button that kickstarts the whole thing. And I love the way I did this, okay, because it makes us review methods and all that kind of stuff. So first of all, I'm going to be reading in the years, okay, and I'll put those in a one-dimensional array. And I'm going to read the sales, and this one's super important. I have to have that in an array because I'm going to find the biggest of that after, okay? And if you remember your array stuff, we know how to find the biggest of a set of numbers. This is the counter. And I'm going to read in a bunch of data. I don't know how much data I have, so I'm going to have the computer count it, and then we'll work with it. Hey, remember that method stuff? This is a method called data file. I'm going to pass it the year, which is going to be an array. I'm going to pass it the sales. Those are really important, which is going to be an array. And I'm going to pass it a counter. Now, a counter doesn't pass by reference, so I have to force it to be a reference. And when it counts, it's going to come back and store the number in there. And then this bottom part, you should know. We've done it a bunch of times now. This is how you make the computer point to the data. Then we grab two things at a time, the year and the sales. If we get to the end, we're finished. If we don't, store the years into the array and store the sales. Now the sales have to be converted because they're numbers, and store that into the array. When we come back, this will be filled in with information. Now it's bar graph time. I love this one. This is a method. Let's go to the bar graph method. Okay, the bar graph method accepts from the user the year, the sales, and the counter. Okay, now this random, I just did it to be cool. What I mean by that is I did it so that I would get different colors on the screen. So if you're wondering, what's this got to do with random numbers this time? Well, in a few seconds, you'll see down here. I don't want to overemphasize this one because it's not the most important part of this question, but I pick a random color. So the bars that I draw are random colors. Okay, so this is more important right here. What I'm going to do now is I'm going to call a scaling method. So I'm in a method and I call another method. Isn't that cool? And what I do is I pass it the sales. I need that. I don't care about the year, really. Year is kind of there to make it look pretty, but the sales are really important, and the counter. So let's go down to the scaling factor, and look what it is. It's that stuff I showed you when we did arrays. This is how you find the biggest of a bunch of numbers. So I pass down the variable, okay? And remember, it's the sales. Okay, so the bar graph, I pass down here the S, which is the sales. And what I do is I go through every number, and if I find one bigger than that, I make it the biggest one. Now, I don't really care about the position this time. I just worry about the number. Once I get that number, as I told you, I'm not using the entire screen. I'm going to stop short. I'm going to go like right to there. So to me, I'm going to go as far as the panel width less 200 pixels. So the biggest number I've got divided by the size of the screen is going to be my magic scaling factor. And that's what I return with. That's the number I'm going to use to do all my displays. Okay, so I'm going to work my way back up here again. So when I'm done my biggest routine, this number here will have the magic number that I divide everything by. Okay, now it's time to draw. And I'm going to try to have a sort of a split screen here. I'm going to show you the code and try to show you the logic as I run it. So let me just run it for a sec. And let's see if I can just move that a little bit over. You won't see the whole thing probably, but it's good enough to show you. Okay, we're ready to now put that stuff on the screen. So let's take a look at each line. So I'm going to create a font. You know, I got to create fonts because I'm writing these words here. So I need some sort of font that I'm going to keep using. I made it Verdana 8. I'm going to need a brush. Okay, and then we're ready to draw the words and then obviously draw the pictures. So G, drawstring, bar graph program, that's that right there, obviously. Okay, and I was trying to figure out sort of where the middle is, so I sort of invented a formula. I figured it was the width cut in half less 30, okay, and then 10 down. Okay, and then again, it's really trial and error. You just got to guess. There's no set formula. Just got to figure it out. As long as it looks right, pretty, you know, it's good enough. So this right here prints the year, obviously, and this prints the sales. Okay, let me scratch those out, and now the important stuff. Now what we've got to do is figure out a way to, instead of having to write down 10,000 lines, in a loop, we got to figure out a way to write that number, and then make this bar. And then go down to the next one and the next one. Well, we're going to have counter number of things what we have to work out. So on this one, we went from 91 to 2000. That's about 9 or 10 things. Okay. This right here, drawstring, is going to print out that year, all right, with that font, that brush, and it's going to be 10 over. So from here, it's 10 over. And then, oh, this is weird. It's 48 plus I times 30. So it's 48 down, which makes sense, plus I times 30. So I is 1. So it's 1 times 30. So it's actually 48 and 30. That's 78 down. Now here's why it's a formula. Because the next one I have to do after I finish this one has to shift down. If I keep this without the I times, it's always going to go in the same spot. So that's why when I is 2, it'll be 48 plus 2 times 30. And then it'll go down and down and down. So that's really important. Later on, we'll mess around with this to show you if I didn't put it with a plus I times 30, they would all go in the same spot, which is stupid. This one here prints out the $2,000. Okay, same basic idea. You have the font, the brush. This one's 50 over. Okay, so you get that. So you see how this was 10 over. So this one's more. It's got to go over about 50 and then down. Okay, now it goes down the same amount though. All right, so even though they go over across a different amount, they go down the same amount because they're going to be at the same level in terms of the Y. Okay, we're in the home stretch. Now we got to draw that bar. Now to draw that bar, we got to know how big to make it, right? How many pixels to make it. So we take the sales, okay, the 2,000, divide it by the scaling factor. Now when you do that, you might get like a whatever, and I want to sort of make it like round up. So what I do is I add 0.5 to round it up, and then take the integer of that to get a whole number, because it has to be whole. You can't draw 4.5 pixels. It's got to be 7 pixels, 20 pixels, whatever. So this value now is how many pixels to draw, how far to make it go across. All right. Now this is where that random color comes in. Each one of these is a different color. I'm not going to go crazy with that. Okay, but here's the most important line now. Okay, how do you draw that bar? Well, first of all, I go 120 over, so that means I'm going to go over to right about there. Okay, that's good. And they're all going to start at 120 over. So that's what that number is. So it's always going to be 120. This part here is a little bit tricky. Okay, now watch. 50 plus, so this is now how far down to go. So it's about 50 down. All right, which, hey, matches this right here. Okay, that makes sense. All right, matches right around there. So it's 50 down plus I times 30. Hey, I get that. All right, that's going to always go down another 30 at each one after going 50 down. All right, so that's the first part. Now the next part. I got to go over that much, X, and down 10. And that draws a rectangle like that. Kind of messy there near the end, but do you notice how this changes? Now, let me try to prove it to you. What if I made this 2? So this is the width of the bar, just to see that you appreciate what we're drawing. Okay, so I just had to experiment. I didn't know exactly what was right or wrong until I fooled around with it. You can make it 10, you can make it 20, whatever. Okay, so there is the bar graph program. You can, if you want, it's not crucial. Take a look at the vertical one too. It goes through the same logic. In the next lecture, what we'll do is give you a little practice now. There's a lot that I threw at you. Now you have to sort of absorb it and try to practice and see if you understand what we did. Okay, see you in the next lecture. In this lecture, we're going to practice what we've learned. I'm going to give you a small problem to try, which will create a horizontal and vertical histogram of a simulation of a dice roll. 2 dice are rolled, and I want you to keep track of the frequency of each number that could occur, and then create a graph that will visually interpret that information. Now, the actual solution is in the zipped up files for the previous lecture, but don't cheat, don't look at it right away. I'm just going to give you a quick run of how I want the program to look when you try it. It uses the panel from before, so you could actually use the old bar chart program to help you. It's going to have a horizontal and vertical solution. Even if you just get the horizontal one, that's fine, but this is the type of results that I'd want to have displayed. You're going to have a nice title. You're going to have 2 columns. One's going to be the roll and one's going to be the frequency. Now, these are not going to be read in. They're not going to be from a data file. You're going to get rid of the data file part, and instead of the data file, you're going to have a roll dice part, okay? So when you roll 2 dice, you're never going to get a 1 with 2 dice, right? So you can get 2 all the way to 12, and actually it's a little bit below the screen. It's not showing up, okay? And then I want you to print out the frequency, obviously, of each one, and then display a bar chart to represent those frequencies. And just to stretch this out a bit more, if you don't get the whole thing to show up, watch what I'm going to do. Move these down a little bit. stretch this out to give it a bit more room, and we'll give it a run again, and this time we should see all of them, 2 to 12. Okay, and it prints out those numbers. Those are the frequencies. Looks like the ones in the middle are the most, and then a bar graph representing them. If you get that and you want to try a little bit of a challenge, here is the vertical version of that. Okay, so stop the video now, give it a good try, and then when you think you've got it or you've had enough, restart the video and we'll take up the solution. Okay, how'd you do? You think you got it? Okay, let's take a look at the solution. Now here is the formal question. It was a PDF as the downloadable resource for today's lecture. And what it basically said, it was to write a program which will model the rolling of 2 fair dice. The program should complete 100 iterations and then produce a frequency histogram summarizing the possible occurrences. And it should look something like this. Okay, and then there's the vertical version of it. Let's take a look at the solution. Okay, hopefully you didn't cheat. Here is the solution one more time to view. Let's take a look at the code. Now, first thing, we're going to double click over here on the side. This is a panel, of course. I'm going to double click on the side so we get into the form load. And here we tell the whole world we're going to have a G instance of the graphics class. Here is where we actually instantiate it so that anytime we use G, it's going to put its stuff on panel 1. Okay, and now we get into the actual code. Now, like I said in this question, we are not using data files. We're not going to load in like years and sales. We're creating our own data, so to speak, because we're going to generate random numbers. And once we generate those random numbers, we're going to do some thinking. And the stupid way to do that would be to have, I guess, 11 if statements. So you'd say, hey, if the roll total or something equaled 2, then count the 2s. Else if it was a 3, all the way to 12. No way. You don't do it that way. You try to be efficient, right? So what you do is you use array counters, our friend the arrays, all right? They always rear their ugly head. What we're doing here is making 0, 1. 0 definitely never going to happen. We don't want to use it. 1 is never going to happen. Then 2 all the way to 12. Okay, so this array counter is going to do our thinking and our counting for us. Remember that from before? Now we get into the actual program. Here we have what we call the main line. And all it is 2 methods, nice and succinct. That's the beauty of creating nicely structured programs. This passes this array down to here, and it's caught by DC. This passes 1,000, because we're going to do this experiment 1,000 times, into that variable there. This initializes the counters. So all of these in here become a big fat 0 at the beginning, right? Next, we're going to roll some dice. So remember, we got to use the random number generator. This makes an instance of the random number generator, and we use R. Now we do the experiment 1,000 times, okay, from 1 to U, and U is 1,000. And we roll a dice, and we roll another dice, and we add them up and count them. Now this is kind of a slick line here. If you don't get this, let me write it down the old-fashioned way. Either way is good. So this is the array counter. Okay, and what this does is figure out, hey, if I rolled a 2 and a 4, that's 6. So DC, array counter 6, equals DC, array counter 6 plus 1. It would add 1 to the little box where the 6 is to say, I've gotten a 6 once. If I roll again and I get a 3 and a 3, that's a 6 also. And I would have 2 6s, okay? So that's keeping track of everything. Isn't that beautiful? That removes at least 11 if statements and 11 counters. It's all done by that. Okay, now, once we have that, that's where all the information is. That's the most important part of the program. That is going to remember everything. And now we call the bar graph program. And the bar graph program more closely mirrors the lecture from before that did the graphs. Okay, so let's go down to the bar graph program. Oops, it's actually up here. Okay, so the bar graph program, all you got to really do is feed it the array. All right, and it'll take care of everything else. Now, because we know it's going to be 2 to 12. So this is the array that we feed it. Now, we got to do some work, right? This array has a bunch of numbers in it, okay? It might have that we rolled a 6 120 times, we rolled a 7 200 times. So what we're going to do now with all the numbers in an array is work out the scaling factor to figure out, first of all, the biggest number and then divide it by the size of the screen. Let's take a look at the scaling factor. Okay, scaling factor expects us to send down the whole array, which we do, and 12. Okay, so we're going to go from 1 to 12. 1 obviously is never going to happen. So we're going to find the biggest number. We're going to make big something stupid at the beginning, and then we're going to go from 1 to 12 and see if the counter for 1 is bigger than big, counter for 2 is bigger than big. Once we find the biggest one, we'll store it into big. To get the scaling factor, we take the biggest answer we got, and we're not going to use the whole width of the screen. We're going to use a little bit less than the edge. This returns the magic scaling factor, whatever it happens to be, right? And then what we do is we kickstart the drawing of the screen. All right, and I doodled this the last lecture, so I'm not going to overburden you with that again, but just realize this is the key number. This is going to be the scaling factor we're going to use. Now we have a loop that goes from 2 to 12. We don't really care about 1, right? Because you're not going to get anything right. This will display the particular number. So when it's 2, it'll put a 2 there. So this is the screen, right? And then this will print out the frequency. So let's pretend the frequency was 140. And I probably should have made the screen a little bit bigger. Okay. Then this will take the 140, divide it by the scaling factor, add 0.5 to set it over, round it up, cast it as an integer, so it's a nice whole number, and now we've got our magic number here. So let's pretend the magic number is 40, which means we're going to use 40 pixels to display this bar graph. All right. This picks the random number color just to make it look cool. And now I'll slide this up a little bit. This figures out how to draw the rectangle. And the rectangle is drawn based on the screen. I'm going to move over 120. So it's exactly like what I did with you guys in the last lecture. Okay, I'm going to move over 120. I'm going to go down 50 plus I times 30. So the first time it's going to go 50 plus 30 is 80. So I'm going to be 80 down. Okay. Now I've got to go X. That means I'm going to go over X amount and down 10 for the height. And then I'm going to draw a rectangle. Okay. When I is 2, 3, whatever, and it's going to be 50 plus the number. So 2 times 30 is 60. And then it would move down some more. Okay, so this is how you're going to get it to move down. Now, I want to take a glance at the vertical one. Vertical one, it's a little bit weirder because it's a bit more challenging in terms of which way it's going to go. Let's focus in on this for a second. What we're doing there is we are displaying the chart, but going up this way. Okay, now look what I did here. These particular ones, we're going to make them go over here and over here and over here. So you'll notice that this is a little bit different, okay? Especially this line here, because when we shift over this much, that's going to bring us here. When I is the next number, we got to shift to here. So this one, it's not how much they're going down, down, down by, which was the second variable. This time it's the first one, so I times 50. The next part is how much to go down by, like how far down do you go? Well, you're going to take the panel height, and I took out just a minus 50 because I don't want to go all the way to the top, minus the height that I'm going to get from my scaling factor. So this one's a vertical one that I'm working out, right? So that'll give you a rough idea where it's supposed to go. Then it's 10 across, and then the height, okay? So it'll draw it at that moment. This one's not as crucial, but it's kind of cool to see how you think that type of thing out. All right, so that's the basic idea. And let's run it one more time. There's that one, and there's that one. Let's do a little bonus taking up of information here, because some people have said, yeah, I really want to know how to do this vertical. Let's zero in and do a bit more detailed analysis of this one, like I did with the horizontal. So let's focus in down here. You know, how did I get that 2 down there and then the 31 up there? So let's start off with how did I get the 2 down there? So think of this. This is the entire panel from there to there, right? So what I did was I have basically created a formula to move over. So when I is 2 times 50, I'm moving over about 100, which puts me right about there. Okay. And now I got to figure out how far down to go. Okay. So that's the next part. The panel height, there's the entire panel height. So I'm all the way down here, panel height, but then minus 50. So that shifts me to right about there. And that's where I write down the number 2. Okay, so it's the whole height less 50. And again, it's mostly through trial and error. Then I work out the scaling factor, obviously. I pick my random color, which will be used in the solid brush to actually draw it. And now let's figure out the next math. So now to draw that, I'm going to clear the screen out again to get rid of some garbage here. So now we're focusing in on this part. So I'm going to use solid brush, okay, and it's going to be in blue or whatever the random color is. It's going to be I times 50. So again, it's going to be shifted over a certain amount. Okay, so it's going to line up right there. Okay, a little crooked with the line there. And look at this formula this time. It's the panel height, so it's all the way down to the bottom. Go down all the way to the bottom. Less 50. Okay, so that's that part in there. Less the height. So that's going to shift me up to right about here now. Because for this first one, that would be the height right there. Right? Now we make the computer draw a rectangle that's this wide, 10 wide, okay, and then this amount high, and that's how you draw it. So in essence, what's happening, especially with this line, is the computer's always going over 50 times whatever. So if it's number 3 now instead of 2, it'd be 150 over, and then so it'd be right about here. So line that up right there. Then what it does is take away 50. So we've gotten up to that level. Then take away the height. The height is whatever we work out here in the scaling factor, which brings us up to this level. And then when we get to this level, we draw something that's 10 wide and this much height. So that's what magically makes those bars appear. Okay? A couple things to realize if you're still not sure. This 10 is the width, right? And that's the height. So basically it's drawing it from down and up and across to make that rectangle. Okay, so hopefully it's a bit more detailed explanation, and that's the dice roller experiment problem. In this lecture, we look at using the mouse. One of the key ways for a person to interact with the screen is to use the mouse, and we're going to show you how the computer will detect when you've moved the mouse, when you've pressed down on the mouse, when you've pressed it with the right button or the left button, when you've hovered over things. So it's kind of a neat concept and lots of neat applications that you can do with it. Let's start off and do something together, and then we'll take a look at some demo programs. So I'm going to create a new project, and we'll call it mouse. Okay, and we'll call it form mouse. And we'll put a little title up on top. Using the mouse. Okay, I want to create a simple application that will, when I move my mouse, detect that I'm moving it by drawing a circle. Okay, so what we'll do first of all is we will go into the underground, and we will declare a couple of variables so the whole world knows about them. We're going to declare a graphics G, and we're going to declare a pen P. Now in form load, we'll instantiate them, or we'll sort of wake them up. And that's where you go this create graphics. And we also have to instantiate the pen, and we'll say new pen, and we'll give it a color red. Okay. Now here's the part that's kind of cool. The mouse, when I move it on the form, I want it to do something. So I'm going to go over to the lightning bolt, and there's lots of different things that you can do on the form. Mouse down, mouse enter, hover, leave, mouse move is what I want. Next, we are going to have it draw a circle, but remember, it's not circle, it's going to be an ellipse. So what we'll do here now is, upon movement, we are going to say G dot draw ellipse bracket. Now we have to feed it the pen. We have to feed it where it lives. And this is new. This is how you're going to tell the computer where is the mouse at this moment in time. And then we're going to draw a circle. And so to draw a circle, you give it two numbers that are exactly the same size. So what this does is draw an ellipse with this color red, and at this moment this will tell us the exact location of the mouse as I'm moving my mouse, and at that location it will draw little circles that are 5 by 5. Let's give it a run and see what it looks like. So watch, as I move my mouse, it's drawing little circles. If I stay still, it's just at that spot. If I go really fast, it skips some of them. So at every moment, it knows exactly where I am. Isn't that cool? Let's now look at some other cool things you can do with the mouse. And for this, I'm going to load up some demos. If you've unzipped the demos for this particular lecture, in mouse events, you will find a number of different things. The one that I just did with you, if you didn't get it to work, is in there. It's called Mouse Move Intro 1. Let's take a look at Mouse Move Intro 2. All right, I'm just going to run it for a sec. And, oh, what happened there? I hovered over this and it turned colors. And, oh, look at this number down here. It's telling me exactly where my mouse is in terms of a position as I move around. And what's this other thing in here? Oh, as I went over it, it opened, and then I go away from it, it closed. That's kind of neat. So some more mouse events, not all of them necessarily mouse move, but let me see one other thing I want to show you. When I press down here, it says, oh, you clicked on it with the left button at position 5124. So see now, we're starting to learn all the little details that you can pick apart about the mouse, where it is, how you pressed it. Was it with the left, with the right button? Let's take a look at the code. Let's take a look at the neatest thing first. Hopefully you realize what the trick is. There's actually two images, okay? This one is called pick closed, and this one is called pick open. Now this pick open initially starts off as visible false, which means it's invisible, and this is the one you see. So even though I've dragged this one on top of it, it's the other one that you see. So like, how did I get that to work? Well, when I go over it, and I'm really going over this one right here, let's take a look at the code. Okay, now you notice when I clicked on it, that's the click event, but I don't want that event. So when I click on this, I click on the lightning bolt, and the event I want is not the click event, but the move event. So when I move my mouse over that, I want something to happen. Let's take a look at what I wrote. Well, when I go over the one that's closed, I want to open the one that's open and make it visible, and make the one that's closed invisible. Now when I go away from that, okay, so when I hover away from it, I go over here. I'm not moving my mouse anywhere near here, but I'm moving it on the form. Watch what I've got on the form. I'm not clicking on this guy. I'm clicking on the form. I go over to the lightning bolt, and it's another mouse move. We'll slide down to mouse move. There it is. Double click. And now I put it back to normal. Now I make the open one invisible and I make the closed one visible. And all along, while I'm moving along the form, I'm feeding my X position and my Y to a string text box, and it's converting it. So that's why when you see me moving around, there's a little text box down here, and I'm feeding the number. Now watch, when I go up to here, it should be close to 0, 0, right? So when you put it up here. So that's kind of a cool effect. Next, how did I get this to change colors when I went over it and then go away when I left it? Well, you could have used mouse move on this one too, but just for the sake of showing you something different, what I did with this one is do a different kind of event. And again, it's a mouse, but this time it's a mouse hover. So when I hover over the text box, or the label in this case, I change the color to red. When I leave, I change it back to black. So isn't that cool? There's a hover and a mouse leave. Now, one other thing, and this is probably important later on when we do our games. There is like a click, but I don't want to click on it. I want to put my mouse down. So watch, I'm going to click on the lightning bolt, and I have a mouse down. And this one we'll refer to quite a bit more as we develop games. But when I put my finger down on the mouse, this is like an if statement, okay? And it's being fed this button. You know how they have E.X, which is the position of the mouse button? This is feeding what the mouse did. And there's two possible if statements, or in this case, cases. You can have mouse buttons left, which means I used the left button to press. And you can have mouse buttons right, which use the right button to press. And just to prove it to you, because I didn't do the right button, this is the left button. Now I'm clicking with the right. Okay, so now you're starting to see some of the powerful things you can do by having complete control of the mouse. My favorite technique is obviously the hover, which is kind of cool up here. But even this one down here with just the regular mouse move is a neat effect. All right, all of them are very useful. We'll see them over and over again as we develop games when we click on something and make it shoot. I've got a couple of cool applications I want to finish up this lecture with, just to show you some of the capabilities of using the mouse. And don't worry, we'll be coming back to this over and over again over the next couple of lectures. But let's load in this one called Mouse Problem. And this has multiple forms and kind of like a menu system to show you the, you know, where you go over it and then you come back. All right, you should see it just changing a little bit. And then when I press this, it goes to a different screen, another form. And watch this down here. I hover over it, nothing's happening. When I put my finger down, it moves to another image. And when I lift my finger up, it goes to another page. So this one's doing like a mouse down and mouse up. I didn't cover that before. I wanted to show you that little trick. So let me stop this for a second and I'll show you how I did it. So as you probably guessed, there's two images here, right? And initially when we start, as you saw, we have the red images and they turn to blue. So these blue ones are invisible and the red ones are visible. For these red ones, I don't use the click event, obviously. I click on the lightning bolt and then I have mouse move. So when I move over this, it turns to the blue one. Now when I move away, that means I'm just on the form. My mouse move event tells me the following. It says make the original pictures A, true, B, false. And second one true, B, false. Third one true, B, false. So even though I only work with one, you have to reset all of them. That's just basically how it works. And then as you go over each one, obviously, you turn one on and the other off. Now, when you eventually click on one, all right, we're not using the click event though, when you press down, and what's going to happen is when you are ready to press down on it, it'll be on the blue one, which we have named. I'll slide this over here a bit so you can see it better. Okay, so move it right up. So what we've named this one is pick 1B, and this is pick 1A. And when we click on this one and press down on it with the mouse, see if you remember this, I want the second form to pop up and show it, but I use a show dialog, so it's a little bit better even. Let's go to that form one. I mean, they're all the same after this, but again, there's two images, okay? And obviously the one that I just dragged over is invisible and the other one's visible. So when I press on page one, it's going to take me there. Now when I show you the code for this, the code is in here, so that when you press down on it, there's the mouse down, and when I press down I make the other image appear, and then as I lift my mouse up I close this form and I return back to the other one. So it's kind of cool, right? So you get your mind going. There's all kinds of different things you can do. Mouse down, mouse up, mouse over. Those are my favorite ones. All right, last example. Let's click on this one right here, Blackboard. And what this program is going to do is simulate sort of an Etch-a-Sketch program. Here's what this program looks like when you run it. So you get a choice of colors. I'll pick this blue. And then as I move my mouse, I'm sort of drawing on the screen. Now if I go really slow, you'll notice that they're not really drawing smooth curves. They're itsy bitsy tiny little lines. And when I go really fast, it's fairly smooth. But when I go really slow, you can almost see that it's a straight line. But there's a little bit of, magic going on to make it look like it's almost a real Etch-a-Sketch, and then this erases it. Let's take a look at how I did it. Here are some of the specifics of the program. First of all, that black screen right there, that's a panel, which I've called Panel Blackboard. This is a group box that has a bunch of radio buttons. Right now they all seem to be colorless, and when we start the program in form load, we're going to add color to them. All right, so that's the first stage. Let's take a look at the underground. And first thing is I declare a number of public variables. Bool, which stands for Boolean, we've used it from time to time, is going to be true or false. And that's going to say, hey, have you pressed your finger down on the mouse or is it off? Okay, so it's going to be on or off, true or false. This is going to remember where I am at any moment in time. And actually it's going to remember the last spot I was at, and I'm going to be at a new spot. And that's how I'm going to draw a line from the last spot to the new spot. This is my standard graphic class, and I've called this one not G this time, but my graphics. And since we're drawing, we're going to use a pen. Okay. Now in form load, as the program starts up, we create an instance and we make sure it points to the panel. So anytime I use my graphics, it'll draw on the panel. And initially, I'm going to have a pen that's a gray color, but we'll change it as we go along. This right here is how the back color shows up on the side panel where all the groups are. I just want to run it for a second to remind you. So the instant, see, it's all got colors now. So what that line did right here is add back colors to all of those. So every one of the radio buttons has a property called back color, and I changed the colors to match whatever I wanted. Okay, so that's the next thing. Initially, when I start, like I mentioned, I will have it in gray color and the mouse will be false. So initially, if I start drawing, it's in gray. All right, so that's the default, and then I can change it to whatever I want. Now, as I press each one of those radio buttons, like I'll press this third one for a second, I'm using the changed event. And what I do is I feed the radio buttons back color. So this is green, and it becomes the pen dot color. Okay, so you notice how I initialized the pen, my pen, to that, and then I can change it to anything I want. Okay, getting closer. Now, how do you know when to start drawing and when to stop? Well, when you put your finger down and not before, you put your finger down on the mouse and not before, and then you start dragging the mouse and then you put your finger up, that will be part of the squiggly line that you're going to make. So we're going to have to remember when you put your finger down, that's the mouse down, and when you let go, that's the mouse up. Now let me do it with actually the program running. So I'm moving my mouse around right now, but I haven't put my finger down. So nothing's showing up. Now I got my finger down and then let go. There's a little tiny thing. My finger's down and I'm going to make a bigger thing. Okay, so we got to keep track of, hey, fingers down means something. Fingers up or mouse up, it means something. Let's take a look at how I did that. So that one is one of the mouse events. That's the mouse down event. So the instant I put my finger down, and it's the left button down, then I make this flag or boolean equal to true to mean, listen, he's got his finger down, get ready. And what this does is it remembers where I am right now. So this is the location of the mouse, and it stores them into these two variables. Now I start moving around. Now I go, hey, is mouse, hey, there's nothing else equal here. Well, that's kind of a fancy way to say mouse true. All right. So if you're wondering how come you don't have the equals, that's kind of like the cool way to do it without having to say true, but that's what it means. So basically it says, is mouse press true, which means did he have his finger down the mouse? Because if he did, I'm going to draw a line with my pen from the last spot that he was maybe a half a second ago to where he is now. And then remember that, put it back to the last position. So it's almost like where you were a few seconds ago. Great. And now remember this one as you go over here. And then I'll remember this one as you go over here. So it's always taking where you were just a few seconds ago and putting it into the last position. So we always draw from the last position to the new position. All right, and now the last thing. So mouse move, mouse down, started it going. Mouse move, made some objects or lines show up. And then when you put your finger up, then first of all, did you put your left button up? Because if you did, I'm going to draw one more time, and then I'm going to tell the computer that mouse press is false. So now, watch, if I draw, great, now I put my finger up and I start, that won't let me draw. And then I put my finger down, lets me draw again. Then I put my finger up, it doesn't let me draw. Okay, so you want even a fancier version than this? Well, if you've got a few minutes, you can look at this one. This is sort of like the updated one. I'll load it up very quickly before we run out of time here. And I've just added a couple of new features in this one. Basically, it's the same, except you also have now the option with the numeric up-down control to change the width of the pen you're using and also change the background color. Now this is going to make everything disappear, and then I'll go back and draw in blue. So that's kind of cool, and you can look at the code for that. That's just a little extra, but I thought I'd throw it in there just to show you some other enhancements that you can make. So that's the end of it for now for mice. And next we get into computer animation. All right, and what we're going to do is start creating objects that move around in place and then make them move across the screen as we get closer to developing a game. Thanks for listening. We'll see you in the next lecture. In this lecture, we start the concept of animation. I love this stuff, and I hope you will too. What we'll do is we'll start off with the concept, what exactly does animation mean, and then we'll take a look at the two key concepts that you need to understand to animate in C#, the concepts of timers and image arrays. Now, when you animate, what you basically do is you display some object on the screen, keep it there for a fraction of a second, then erase it and display another object almost the same as that one, but maybe with one small change. Keep it there for half a second, then display another object and almost the same one and have another change. And as you cycle through these frames of objects, people, displays of cars, whatever, you simulate the concept of animation. Now, first idea. How do you get the computer to stay on the screen at a certain spot and keep an object there for half a second? Well, that's the concept of timers. I'm going to show you that. How do you get the computer to cycle through a number of images? Well, they have to be stored somewhere. So that's the concept of image arrays. So those are the two ideas I need to show you. Let's start off with the concept of timers. Okay, as I usually do, let's get our hands dirty in there and do some programming ourselves first before we do some demos. Okay, and we'll call this timer demo, and we'll press OK. Now this first example just gives you the concept of a timer. It's not going to do any kind of animation, but at least you'll appreciate how the computer says, hey, wake up, go back to sleep. Hey, wake up, go back to sleep. Let's call this form timer demo. Okay, and we'll put a little title on it, as we always do, and actually I'll make sure it starts in the center, and we'll call it timer demo. Okay, now there's a little control we've never used before. It's over here on the left-hand side. It looks like a stopwatch, if you know what that is. And there it is right there. Now what I'm going to do is drag it on the screen. It's not going to probably show up there. What it does is it shows up near the bottom of the screen, way down here, and actually I'll move my screen up a little bit so you can see it. Okay, so there is the timer down at the bottom. All right, now what does it do? How does it activate? Well, the way that a timer wakes up is that it has a property called enabled, and right now it's asleep. All right, and we can turn it on right away here. We can also do it in code. The second key property is the interval, and right now it's set to 100. If I set it to 1,000, that's about 1 second. And that'll do something every second, then wait a second, and then do another something in another second. So that interval, you can make it as big, or, well, you can't get too small, but I mean, 100, something like that would be reasonable, and you would notice the difference. That'd be 1/10 of a second. Okay, so how do you program it? What do you do when you use the timer? Well, you actually double click on the timer, and then that's where you put your code in. So I'm going to do something really simple. Message box show, and every 1 second, actually I might change it to something a little bit farther apart because it's going to get a little bit annoying. Let's make it every 3 seconds, so 3,000, I'm going to have a message box pop up and say hello. Let's give it a quick run and show you what it does. Okay, so there's hello. That was about 3 seconds. 1, 2, 3. There it is again. There it is again. So it's starting to get a little annoying. I'm going to stop it for a sec. Okay, so that's the first idea of timers, that you can have it do something every set amount of time. Now, you can have multiple timers, as we're going to when we do animation. We might have one timer controlling a man's movement, another timer making a move across the screen. Two different kind of ideas, right? So they'll cycle through and wake up and go to sleep at certain times. Let's do something for fun. Why don't we, every couple of seconds, also change the color of the screen? All right, let's grab another timer. So again, remember, you're going to sort of drop it there, but it's going to show up down here, timer 2. Timer 2 will also enable. This one here, let's do it every 1 second. Okay, and let's do some code. Now this one, I'm going to try to change the color randomly. So we're going to use that random stuff that we did before. So this is how you activate the random class so that we can use random numbers. And this dot back color, a command that we may have done before, equals, and then color, and then dot, and then I think we can pick a certain color, obviously, but we want it to be, well, there it is right there, from red, green, blue. Remember that? Now this is expecting 3 numbers, okay? But we're going to try to make numbers random. We're not going to know what they are every single time. So what we need to do here is that r dot next bracket, and we're going to have it go from 0, comma, 256. It's always one more than what it is. So you can go from 0 to 255, comma, and then we're going to repeat this for the red, green, and blue. This is going to be cool, actually. 0, comma, 256 for that one. And we got one more to go, comma, and then r dot next, and then 0, comma, 256, and I think we're set. So what this is going to do every second, this might get freaky, it's going to display a background color, a random color, every 1 second. Let's see what happens. Okay, so there it goes, switching colors. Isn't that cool? And every 3 seconds, the message box pops up. Oh, there it goes again. Message box pops up. Isn't that cool? Okay, so there is the basic concept. If I can stop this now, there's the basic concept of using timers. You have multiple events going at the same time. One is indicated by a certain time limit and another one is indicated by another time limit. And we're going to incorporate that idea with the next one called image arrays to make an object dance around. Let's load in our first demo for this lecture. So we're going to go to Open Project, and hopefully you've downloaded the resources for today's lesson and unzip them. And we're going to start off with this one called Array of Images demo. Load it up. Okay, and I'll give you the screen. All right, and I'm just checking everything out. Okay, so here's the first technique we're going to discuss today. First of all, as you had me mention when we doodled that man on the screen, the basic concept of animation is that you have images that are kind of similar that you keep playing through. Now, this is going to be like our home base, and what we're going to do is cycle through these images and put that one there, leave it there for a second, then put that one there, leave it there for a second, then put that one there, leave it there for a second, and then put that one there and leave it for a second, and then cycle back up and do it again. Now, this is the first technique where you don't have a ton of images and you can put them all on the screen. These are all picture boxes, obviously, okay? And we'll slide up and I'll show what they're called. This is PicSign 1, and this last one goes to PicSign 4. So we're going to cycle through 4 pictures. This one right here is kind of like the home base. So I've just called it PicSign. And we're going to put these images to there. I'm going to show you how it is. It's not that hard. There's our timer down there. Okay. This timer is asleep right now, this time. And the interval is 100. So you're saying, well, who's going to wake up that timer? That's going to happen right here in the start. All right. And actually double click on it right now. And this is how you wake up the timer. You use this word called not. Now, you've seen me use it before. It just says do the opposite of whatever it is. So timer enabled is false. The opposite of false is true. Later on, when we want to stop this timer, we'll press it again. And if it's true, the opposite of true is false. So it's kind of a cool line that does a couple of things all by just saying one statement. All right. So that says not whatever the timer is. True, false, false, true. Okay, so like I said, you can't run away from arrays, and this is going to be our bread and butter. We have 4 signs that we're going to cycle through, and we're going to make an array. And we don't like using 0, not that I've never used it for image arrays, but I don't like using it. We're going to have one called 1, 2, 3, and 4, and altogether that makes an image array of 5. And again, remember, you say image, not string or int or double. You use the square brackets, you make up any word you want, and then you say new image, the size of the image array. This one is going to start at 1. You'll see where that counter comes in a second. And now in the form load, so this happens behind your back. You know, when you double click here and it goes to form load, what I manually do, and there's going to be a better way in a second, but this is what we're doing right now. I physically take the image in PicSign number 1 and store it into that array. And then I store the second one into that array. So all of these happen behind your back when we start the program. Now the sort of like the guts of the program where all the action happens. See, what you have here is you've got that little box there, which is called PicSign. And that's the home base. And what we're going to do is, now remember, count is 1 when we start the program. We're going to take signs, and it'll be 1 the first time. Okay, remember signs 1 right there. And what it does is it takes whatever picture's in sign 1, I think it was the up arrow like this, and it puts it in that box. Okay, that's what that line does. Then this line says make the counter go up by 1. So count was 1, and now count is going to be 2. Now, hey, is the count bigger than 4? Because if it is, we're done, because there's only 4. So if you make the count go up by 1 and you make it 5, go back to the beginning. Count 1. All right. Well, it's not 1. It's not 4 or 5 yet, so we're not even close. We're on 2. So now the computer takes the second image, whatever it is. Let's pretend it's the down arrow, and it takes it and puts it into this box right in here. And if you do it fast enough, it looks like it's actually rotating through the images. So it's kind of show-off time now. Let's actually run this and see what it does. Okay, so there is like the initial picture, but it's going to change. Watch when I press start, stop. It cycles through the images. And there you have our first animation in C# using a timer and image arrays. And again, watch this when I stop it. It does the opposite of whatever it happened to be. Isn't that cool? All right, so there is our first example of animation. Now our second example, let me close this solution first to stop running it. Now our second example is going to have a ton of pictures, okay? And it's called Logo Animator. And I'll load it up for a second. And the first thing you're going to notice when I load it up is there is no picture box of like 7 or 8 pictures. There's like the main one that's right in front of your face, but all the other pictures are not there. They're in a file, and that's going to be actually the more proper way to do major animation. I just want to show you what they look like on the hard drive. So this is called Logo Animator. We'll sneak our way down into the underground, into the debug folder. I actually made a subfolder in there called images because there's so many, so that it wouldn't get too messy. So when I click on this folder here, there's all these pictures, and I'm actually not going to use this 0 picture, but I intentionally named each one of these the same name, 1.gif, and then 2 all the way to 29. So remember, it goes from 1 to 29. So those are all your images. And in a future lesson, I'll show you how to create these little frames yourself. Anyway, make sure you realize that that's what they are. Okay, so let's run it for a second. It's kind of cool. It just shows a little rotated title that I found on the internet. Okay, so that's what it does. Now let's take a look at the dirty work. So timer. This timer, again, is asleep. We'll wake it up formally with a button as opposed to just doing it at the beginning. And again, the interval is 100, so it's about 1/10 of a second. So it's a pretty decent speed. This box right in here is going to be like our master location for our pictures. I've called it Pick Logo. All right, now let's go into the underground. And first off, remember there's 29 pictures, so you always make it 1 more than what it is. This actually count is wrong. That should be a 1. If you're looking at your demos and you noticed I was using zeros, I've changed them to 1 because I want to be consistent, okay? So anyway, 29 pictures. The count starts off at 1. That's going to be the first picture. Now here is the tricky part. You know how we loaded in the pictures in the last program where we had 4 pictures? I wrote down 4 lines. Well, if I had 29 pictures, I got to write down 29 lines? No way. I want to kind of invent a pattern or a formula that will load in whatever. If I had 2,000 of these, it didn't matter. That's the most important thing, that it would work for anything. All right, so you got to realize that when you work with these things. Okay, so 1 to 29, you get that, obviously. Now here's the important part. We're going to grab from the hard drive an image from a file, right? And this points to my debug folder. And now that I'm in the debug folder, remember that little @ sign, you have to use that to attach it. I'm not just there, I'm in images subfolder, and every one of my pictures is called Deedle. Then I attach whatever number I happen to be on in the loop. Okay, so I'm going to attach a 1 to the word Deedle, and then I'm going to attach the word .gif to the end of that. Then when it's 2, I'll attach 2. And all of these pictures are getting stored in an image array. Now, initially, I should put at least one of the pictures in the sort of main picture box in the middle, just to start it off. Okay, and what this does is it sizes the picture box to the same size as the image. So the picture box image size is going to match the picture that I've got there. Okay, so it's kind of a standard technique, sort of it scales it to that size. All right, now the dirty work. This is where all the animation actually occurs. And we saw it in the last one. Count starts off at 1, so it takes the first image and stores it into that picture box, which is this guy right here. Then I make the counter go up by 1, so it's now on picture number 2. If we get to 30, there is no 30, so if you get higher than 29, make the count go back to 1. And there is, in a nice little succinct package, the usage of timers and image arrays to start doing some simple animation. It's really cool. I love this stuff. Let's show you one more time, and we'll wrap up today's lesson. And that's fairly smooth. So obviously the more frames you have, it's not going to look herky-jerky. So if you want to do a really slick computer animation, something for a game, you want to add more frames. You want to have as many frames as possible to make it look smooth. Okay, so now what we're going to do is let you create some. How did I get those frames in separate pieces? I'm going to show you in our next lecture how to tear apart animated GIFs, or even how to draw them yourself. Okay, so we'll see you in the next lecture, and I hope you enjoyed this one. Welcome back, and this is our second lecture on animation. In this lecture, we're going to source our own images. We're going to show you a way to strip out each frame out of an animated GIF, or if you are so inclined, draw your own images and then use them in an animation. For this lecture, we're going to use as our base of operation the program we used last lecture. It's called Logo Animator, and we'll use that as our main program that we can type over. And if you forgot what it looked like, it's the basic one that just goes through a series of images, and then it actually has a pretty smooth animation. Okay, so that's the first thing we're going to use. Second thing is, this first technique uses an animated GIF that we strip out frames from. Now, you could actually put an image right on the screen and it would probably rotate, but the disadvantage of that is that you don't get to control it with the timers. It's got its own speed basically from what you took off the internet. And second of all, if you don't want every one of those frames, too bad. That's what the animation is made out of. So by you stripping out the individual frames and then programming it yourself, you get total control. Now, where do you go get these pictures? Well, there's lots of places on the internet, obviously. If you just search animated GIFs, you'll pop up a bunch of different things. You can click on images and you'll find stuff. And that's going to be our first base of operation, actually. I've got one that I put in the resources called gifsgifs.com, which are totally free animations that you can also access. So lots of places to get animated GIFs. Now, another thing, I'm going to press this one right here. This looks like a little banana. You'll kind of notice in the background here, I don't know how clear that looks on your screen, but it's transparent. All right, it's got almost like a checkerboard behind there. It's not like a green background or a solid white. That's kind of important. That saves you a little bit of work. In a future lecture, I will show you how to make things transparent. But for now, by having this image transparent, it's going to save me a lot of work. And the first thing I'm going to do is I'm going to right-click on it, and I'm going to save the image. And I'm going to put it basically where that program I'm showing you, Logo Animator, is. I'm going to put it in the exact same folder. So I'm going to go into Lecture Demos here and sneak my way down to Logo Animator. And I'm still going. Sorry, this is quite deep down. And there's the images folder. And what I'll do is I'll call this one, actually it's got a really funny name there. I'm just going to call it Banana. Okay, and I'm going to save it. So that's the first step. Now I don't need this anymore for a while anyway, so I'll drop this screen down. Okay, and the next thing I have to do is I have to pop up a program that's going to strip this content out. Now, this is a program that I've purchased called Animation Shop. I'm going to demo it first, and then I'm going to show you a free version of a program that you can reasonably get on the internet. Okay, so what you do is you go look for that file that you just downloaded. Okay, so we'll go to my C drive and work my way down to where I have my stuff in the temp drive. And we'll get there. Okay, we're almost there. And it's in timers and arrays, and then go down a bit more. Logo Animator, we're almost there. Whoa, here we are, finally. So there's the dancing banana. Now what happens as soon as you load it into this Animation Shop? First of all, you see the checkerboard in the background, which means it's transparent. That's good, really helpful. Then you see all the frames that made up this animation. It looks like there's frame 1, 2, 3, 4, 5, 6, 7, 8. There's 8 frames. Okay? Some of them have 25 frames. It depends. You may not want to use all of these frames. I'm going to use just a couple to show you the basic idea. But that's the power of being able to take an animated GIF that has multi-frames and pick and choose what you want. Here's what you do next. So click on the frame that you want, and then you go to File, Save Frame As, and now again there's a bit of work involved, although I might be lucky. And is it pointing to the right spot? No, it's not in the right animation folder, so I've got to work my way down. And once you do it the first time in this program, and like a lot of programs, it remembers the folder you're in, but it's a bit of a pain at the beginning to sort of sneak your way down to all the folders to the right spot and everything. But we'll get there. Okay, down here, almost there. There's Logo Animator. And there we are. So First of all, I'm not going to save it as a .iff. I've never heard of that one actually. We're going to save it as a GIF. Okay, I'm going to rub out this name and we'll call it B1. Remember, we're going to try to keep a pattern to it. I could have typed in the whole name too, but I'll call this one Banana1. Save. I'll grab the second one, same idea. I'll go save frame as, not save as, but frame as, and I'll save it in that folder. But this one I'll call B2. I'll just do 3 of them. Okay, and the last one, I'll click on that right there. And at least this will give you a good idea of the process. And this is going to be called B3. Okay, so I'm done with this program for now. That was called the Animation Shop. And now I'll pop up Visual Studio. And now we're ready to type over the program that's here. So it's going to save us a bit of work. You know, I don't want to have to do everything. So what I'm going to do first is I've only got 3 pictures, right? So first thing I'm going to do is change that to a 4. I'm going to have picture 1, 2, and 3. All right, you always don't count 0. Start my counter at 1. My loop is going to go from 1 to 3. I've only got 3 pictures. And I'm going to load an image from a file. It's in the subdirectory images, but it's not called that anymore. It's got the letter B. Then I attach a number to it. Okay, and then I attach GIF. So that's all good. This is okay. I take the first image, put it into the image box. Everything's good here. This is how I'm going to take each image and feed it into the main little image picture box. That's the counter. Here's the last thing. I've only got 1, 2, 3. So if I get bigger than 3, I got to go back to 1. All right. And I think we're ready to run it. We might have to do a little bit of tweaking, but that's basically ready to go. Let's see what happens. All right, and we'll stop it for a second, and we'll hover over this for a sec. Now it appears that when it's loading the file, it can't find these images. All right, that's kind of funny. And let's investigate, because this may happen to you too. Let me go into the folder where all the images are, and we'll do a little investigation. So I'm going to go to my temp drive, work our way down, okay, into the demos. And I know the answer already, but I want to sort of kind of play dumb here, so you go through the process, because this happens quite often with my students too. And one of the sort of weird things about the program I was using, it might not happen with the second kind of program we use, but watch what happens when I work my way down to images. I could have swore I called that first banana B1. I don't know why it added the 1. Either it was either an accident on my part or something. So when I say find B1, it's not going to find it, because for some reason it's called B1 space 1. That's stupid, but we'll fix it. Okay, so you got to be able to roll with the punches, so to speak, and we'll fix them up. All right, there's the second one fixed, and we'll fix this last one. And that was the error. I was pointing at a line, it's trying to load in the image, and it's going, I don't see no image with that name. Okay, so we'll stop the program, and hopefully this time it'll find the images and then hopefully display them. Okay, so let's give it a run. Okay, so now I see another problem, but we'll fix it in a second. Start, and there it is, dancing around. All right, so it looks kind of cool. All right, and we'll stop it. To make it look a little better, why don't we stretch things out, because it's a fairly big image. There are other ways to fix this up too. I could change the size of each one of those animated GIFs to make it a little bit more in line with the screen size, but let's just for fun right now, just want to show you. I'm going to make the screen a little bit bigger, and we'll give it a run again. Okay, so there it is. Now you can see it lights, and there it is dancing around. Okay, now if you don't appreciate the part about the transparency, let me do one thing here also. I'm going to change the background of this form to a different color. Now if this was a picture that had like a solid white background, it would look kind of stupid, but by having it transparent, it blends in. So let me change the background to, it doesn't really matter what color, but something besides white. And I'll pick orange, and we'll give it a run, and you'll see that it's going to blend in. Okay, and then actually, because it's transparent, notice the colors went through the little banana's hands. All right, but that's transparency. You're seeing right through it. But that's actually not that bad of an idea, and it blends into what you're playing when you develop a game. Now, most of you are not going to have this program called Animation Shop available to you and you don't want to buy it or whatever. So that's fair. I'm going to show you another program that's actually in your resources that if you unzip it, you can use that as your program. And let me work my way up a bit and I'll show you where it is on your demos. Okay, so in your demos for this lecture on timers, image arrays, there's several multi-lecture section. There's a folder you should have called GIF frame. I'm going to go inside it for a second. And it's just an executable. This is a totally free program, and I'm going to double click on it right now for a sec. And it's just a cute little program, and it just does one thing. It's just like one trick pony. It just does one thing, and it does it fairly well. First of all, I'm going to open and find that original image of the dancing banana. Okay, I'm working my way down into the debug. And there's the original picture right there. It's called banana. Now, when it loads it in, it also knows that there are 8 images, which it's called 0 to 7. And what we're going to do is you can go and save each frame individually. You can go to each one, okay? And it's a pretty big picture. That's why it's not showing up there. But I mean, it's basically doing what it needs to do. So you can save each one individually. Or there's a really cool feature here, which I like. Let's say you want to take them all. All right? You can press Save All. And then you got to make sure you tell the computer where you want to save them. Okay, so again, it's going to be a bit of a pain to work through and figure out exactly where on the hard drive you're going to put it. So I'm going to work my way down for the 7th or 8th time. Almost there. And then Logo Animator. So that's Logo Animator and sneak in there, bin, debug, and images, finally. Okay, and then I'm going to press OK. Now, it's got the path. It's got the output name. I don't want it to be called frame. That's kind of stupid. This time I'll call it new B, all right? And I'm going to press OK. So they'll all be called new B, and then I think they're going to name them 0 to 7. We'll change that in a second, but at least it saved me a bit of work. Now I'm going to drop this down, and I want to prove to you it's actually done the dirty work, I hope. Okay, so we'll go into Logo Animator, in the debug, images, and there they are down there. Okay, now notice that they've named them differently. PNG. PNG is kind of a neat, it's a progressive kind of JPEG that also supports transparency, which I actually like. A lot of the new images are in PNG. Now what I don't like is that it named them from 0. Okay, so I'm going to go to each one and change them. Actually, let me start the reverse. Otherwise, we'll overlap stuff. So we'll make that one an 8. And we'll make this one a 7. Okay, and then you would change every one of them, right? So I make this one a 6. Okay, and a rename, we'll make that one a 5. Make this one a 4. Just about there. And I'm only going to use the first 3, so actually I probably didn't need to do all that, but it doesn't matter. Okay, and this one I better be careful that I name it right. There's a space there now, so I'll name that one a 1. Okay, so loaded them all in, stripped them all out, beautiful. Saved them as PNGs. So if you were going to use this in your program now, you'd have to make a small modification. First of all, it's called new B, and then it's not a GIF, it's a PNG. So PNGs work, there shouldn't be any problem at all. The rest of it is good, okay? And we're only going to go from 1 to 3. Let's give it a run and make sure it looks good. Okay, so there's absolutely no difference at all. It's the same basic pictures, only as PNGs instead of GIFs. So there you have it, a way to beg, borrow, and steal, so to speak, from a site that lets you have free animated GIFs, strip them apart, and then apply them to your program. And then we're going to use this idea later on to make games that will be kind of easy things to do, because you're leverage the power of having all these people draw things for you ahead of time. But that brings us to our last example. What if you know how to draw? Even simple stuff. as you're going to find out in a second. I'm going to show you one that I drew myself that I applied to a program. Okay, to wrap up this lecture, I've got a folder here called Flipbook, and you may have seen me demo this one before. Don't laugh, okay? This is one that I drew myself. Little stick man with a little red circle to represent a basketball, and when he starts the timer, he's dribbling. That looks not that bad, right? Simple thing. I'll quickly go through the code for you. And actually, you know what I'll do first is I'll show you where these images are on the hard drive. And I think I used Paint, Microsoft Paint. You could use whatever program you want. But make sure you save them as a GIF or a PNG. All right, so that is kind of important because then they support transparency if you want to add them later on to a more enhanced program. Okay, so let me work my way down and I'll show you where these images are. There they are. And actually I saved them as BMPs. BMPs work too, actually. The only thing with BMPs is you can convert them later to a GIF to make them transparent. For this one, I did something really quick and dirty, and there it is right there. All the images, just drew them as stickmen and drew the little red circles there, and that became Dribbler 1 all the way to Dribbler 7. And of course, let's go through the mechanics just to make sure we're all on the same page. Actually, I'll go up to the top. There's 7 pictures, so you declare an array of 8. Start the counter at 1. You do a loop that goes from 1 to 7. And this one, they're all called dribble something. And I don't have them in another subfolder, so I don't go slash whatever, like images or something like that. You could have. And then this one here attaches the number to the word dribble and then attaches the .bmp. So there's all kinds of different graphics that Visual Studio C# supports. BMP is another one, but I'm going to tell you right now, the bread and butter one is .gif, and the one that's coming up and becoming a lot more popular is PNG. These two are the most popular because they also support transparency. Okay, so that's going to be our 2 favorite kinds. So there you have it. Our second lecture on animation. This time we sort of did our own thing. We created our own animation, either by leveraging the power of images on the internet or doing one yourself. And the most important thing is, do you see the technique now? How we're using these image arrays, how we're using the timers. And actually I didn't really show you that timer part, but there it is down there. Pretty basic. You've seen it a couple of times now. And that's the technique for animation. Hey, it's your turn now. Why don't you go on the internet and find a nice little animated GIF that you like and go through the whole process. Strip it apart, put it into its separate little frames, and then load up a program like that Logo Animator, or do one yourself and just do a little simple animation just to prove that you understand the concept we've learned over the last 2 lectures. Good luck, and we'll see you in the next lecture. In this lecture, we're going to take a look at a couple of sample applications of in-place animation. I know that sounds kind of funny, but the 2 applications I'm going to show you, they animate on the screen at a set position. They don't actually move across the screen. That's what we're going to get into in our next lecture. But in this lecture, we'll take a look at a sample dice game and a slot machine game as sample applications of in-place animation. So the first application we're going to look at is a dice game. And these are always learning situations, okay? So even though you might say it's a simple game, it shows you a couple of extra features that we remember from before. So I'm always going back, taking stuff from maybe 7 or 8 lectures ago so that you always remember some of the key ideas. So let's load it up. It's called Dice Roll Application. Okay, and these are in the resources. So I'll give it a run and then we'll talk about how it works. Nothing spectacular about it. It's going to have dice rolling on the screen. They don't stop until you say so. Okay, when you press the button again, they stop and they show you what you rolled. And I also have something about a lucky 7. If I roll a lucky 7, I'm going to say something special. And I didn't. Where is that lucky 7? There it is. You rolled a lucky 7. Okay, let's take a look at the code. So first of all, I'll show you the screen. These 2 that I'm showing you in this lecture, all the images are on screen. Remember, there's 2 techniques. You can store them all on screen in a picture box, or you can store them in a file externally. And we've used a little bit of both. Okay, both have advantages and disadvantages. And this one here obviously is a little easier because we don't have to do that file programming technique, which makes it a bit more challenging, but either way will work. Okay, so we've got all our images here, and I'll just show you what the first one's called. It's called Pick Dots 1 all the way to Pick Dots 6. Okay, and we'll go into the underground, and we have 6 dice numbers, right? What we're going to do is use 1, 2, 3, 4, 5, 6. And we're going to roll 2 of them. We're going to add them together. We're obviously going to use random numbers, so we initialize our random class here so the whole world knows about them. We're also going to have 2 rolls, and again, we are declaring them outside of any sort of method or routine so that they are known publicly to everybody. Now here's something that I haven't done before. Usually I did that thing with the not timer enabled, but this time, because more than one thing's going to happen, I've set it in a separate technique. I've said, listen, if the timer's off right now, which it would be the very first time you play the game, then turn it on. Now, if the timer is on, turn it off. Okay, so if it's false, turn it on. The opposite of false is it's true, then turn it off. And then this is a method. When I stop the timer, then it's time to figure out what you rolled and the total. And that will take me down here at the bottom, and you'll understand more about this in a few minutes, but that's a method that I use. So, always going back, learning new ideas, remembering things we did from the past. Now, as the timer works, and we might as well show you here, this timer is called timer 1, and it's set to an interval of 100. When this presses and starts the timer, here's what the timer does, okay? It takes the random number between 1 and 6 and stores it into roll 1. And then figures out, okay, I rolled a 2, so I want to show the picture for roll 2, which reminds me, here's all our dirty work in form load, okay? This is how you took each one of those picture boxes and placed them into an array. Now, second time you roll, you pick a number between 1 and 6, store that number there. If you rolled a 5, this is going to print out or display an image of dot 5 in that picture box. So I have 2 picture boxes, obviously, this one right here and this one right here. And they get stored either the first roll of the dice or the second roll of the dice. And now I've got one more thing to do. And this is why, see those words there, roll 1 and roll 2? That's why these were declared globally or publicly. I wanted the whole world to know about them, because when I work them out here, we're not done. See, what happens next is I press down to stop the timer, and now we have to go to display total. And it's got to remember what were in those 2 dice. And this is what's telling us what was in the 2 dice that we rolled. So now in display total, we take those 2 answers that are known to everyone. They're not just known to inside this routine. We see if it added to a 7. If it does, we say you got a lucky 7. If it's not a 7, we just say whatever the answer happens to be. Okay, let's wrap it up and run it one more time just to show you how it works, and then we'll go on to our next example. So now remember, when I press down, the timer wakes up, all right, and it's going crazy, picking numbers, displaying them, picking numbers, and until I press down again to stop the timer, it doesn't do anything. The instant I stop the timer, it calls the display total routine. It adds up the numbers that the computer remembers, 5 and 3 in this case, adds them up to get 8, and then displays the result. So there is our first simple application of in-place animation using timers and image arrays. Okay. Now our next example involves a slot machine game, a little bit more sophisticated, and it's also in your demos. We'll load it up right here. Let's run it first, just to show you how it works. Nothing spectacular. I could have used better images and stuff like that, but at least it gives you an idea. Here we start off with a bankroll of 100, and we start the slot machine game. Now, after a random number of times, the slot stops. So this time I don't press the button to stop it. And I didn't do very well that one, so I lost $1. Start again. Okay, and there's going to be a couple of possibilities. I hope to get one in a second. You can get obviously 3 in a row. Oh, I got 2 in a row. Okay, you can get 2 in a row, the first 2, the second 2, and I guess you could also get the first and the last ones. Those are sort of non-consecutive 2 in a rows, two things at the same time. And that's the basis of this game, right? And I want a bit of money there. And I'm going to quit for a second, and now we'll take a look at the overall. All right, so I've mentioned before that we're using in-place animation in this example and the previous dice roll example. Our images are being placed on the screen, not from a file. I've got 4 images here of maps that I'm going to use, and I've got 3 placeholders. You know how we did the dice game with 2 placeholders? This one's going to have 3. So first of all, let me go over here and show you what the names of the maps are. So this one's called Pick 1. Okay, and this one here is called Pick 3. So this one's 2, I guess. And then the last one's 4 down here at the bottom. Okay, so that's the first thing. These placeholders, okay, that one's called Pick Slot 1. This one's called Pick Slot 2, and then obviously Pick Slot 3. There's a text box that we're going to keep track of our money. And now let's go into the underground and take a look at what's going on. So first of all, we have 4 images. So we tell the computer ahead of time to leave room for 5. We don't like to use 0. Now, if you're looking at the solution that I gave you on the resources, it may have a 0-based solution. I've changed it because I like using 1s, okay? So if you want to follow along with me, I guess you could change that program too. But I like using 1s, so if it's not the one that you see here, just modify it to match mine. But anyway, I leave room for 4 images. That means I make the array 5. I'm going to be using random numbers, obviously. I want the whole world to know about slots 1, 2, and 3. When I pick them, I want to know what the numbers were. Okay. I'm going to do a random number of spins, which is kind of cool. When I press down on the button, I'm going to pick a random number, and the slot machine is going to spin. Maybe sometimes it's going to spin 10 times. And the next time it's going to spin 30 times before it stops. Okay, which is kind of cool. Makes it more realistic. And this is going to keep track of. So if I pick a number of spins to be 20, this counter will count from 1, 2, 3, 4, 5, all the way to 20, and then say, hey, we're at 20, stop. Okay. And also, we're also keeping track of the money in this game. Now, when I click the start button, obviously, I got to do a couple of things. If you've run out of money, game over. Okay, we stop the program and that's it. Now, if you haven't run out of money, I take away $1 from you because it costs $1 to play the game. All right. And I start the spin counter at 0. I don't know how many spins it's going to take. And then I pick a random number between 10 and 49. I just made it up. You can do whatever you want. And now I turn on the slot machine game. I actually turn the wheels to make them spin. All right. Now remember, this is going to be a random number that I'm going to spin a certain number of times. This is counting for me as I spin, 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 and it's counting. All right, here is the timer. This is where all the mathematical calculations occur, obviously. So this starts, hey, it's the first time through the counter. It's first time to spin. Let's pick a number from 1 to 4 for the 4 flags that I can pick from. If I pick number 2, it'll take the image of flag number 2 and put it into the slot machine game. And again, I'll be remiss if I don't show you the form load. This is some of the dirty work we do at the beginning to take those images of pictures in the picture boxes and physically put them into the array. And I start at a bankroll of 100 and put it in the text box. Okay, let's slide back down. So we do this 3 times, and each time we take the random number, we put it into the individual slots, slot 1, 2, and 3. Now, this counter is, poor guy is counting and counting and counting, and it says, hey, am I done? Do I match what you randomly said I should spin to? Because if I do, beautiful. Turn the timer off, and as you saw in the dice game, we have a method that I'm going to call to figure out how I did. Okay? Now, this determines winning method basically starts off and says you've won nothing. Now, let me see if you actually got something. Now, the way you're going to tell the computer, and a lot of times when I show students this, they go, sir, can't we just say, does this picture, let's say it was a happy face, match this picture with a happy face, match this picture with a happy face? No, you can't say that. Although there might be sophisticated programs that can do sort of image capture and say, does that picture look like that? Really, the easiest way to do it is, these are numbers. Whatever picture is there, let's say it's picture number 1. At least I know it's a number 1. I can work with numbers, no problem. So the way that you tell the computer, hey, did you get 3 in a row? Is you basically say, tell me if the number for the picture of the first one matches the number for the picture for the second one. So do these 2 numbers match? And then if they do, does the second one actually match the third one also? So you notice how I have that little N sign. So both have to be true. Does the first match the second? And does the second match the third? If it does, you got 3 in a row. Whoopee! And you win the big prize of $10. Okay? Now, what about this combination? The first matches the second, or the second matches the third. So either one can be true. And if that's true, then you got 2 in a row and you get $5. And I told you also there's one combination that's not like 2 in a row, but you did get 2 of them. That's where the first one matches the third, and that's how you say that, and then you get $2 for that. You don't get any one of those 3, sorry, you lost. So you paid $1 and that's gone. Now, the winnings will be basically maybe 0 or maybe one of these guys. All right, so we'll either add 0 to this accumulator or we'll add a $10, $5, or $2. Okay, so this is a simplistic version of a slot machine game, and we'll run it again. But again, you're starting to see how you can apply the knowledge I've showed you: if statements, arrays, loops, methods, accumulators, counters. They all come into play as we start developing these games. So you can't just say, well, I'll forget about that, I don't need it anymore. No, you need it all the time. Let's play it again and see how I do. Not doing too well. Okay, now, have I ever gotten 3 in a row? I don't know. I want to get a couple in a row. Let's see what happens. Okay, I got 2 in a row, $5. And that's a typical application of in-place animation. So it just means that those little slot machines aren't running across the screen, hitting the wall and doing stuff like that yet. But next, now that we've done this lecture, is the real good stuff. Now we're going to start to learn how to get these guys, whatever they are, cars, objects, animals, people, to move across the screen, then control them with the keyboard, control them with the mouse, shoot at them, hit them, make sound effects, and we start to build on all our knowledge to make a half-decent game. Okay, so thanks for listening. We'll see you in the next lecture. Welcome back, and in this lecture on animation, what we do now is introduce the concepts of the left and top properties so we can start moving our objects across the screen, up, down, back, diagonally. And this will lead us to, in a future lesson, to create a simple car race game. So with that in mind, let's get started. Our base of operations for this lecture will be a program called Moving Flipbook. Okay, so hopefully you've unzipped the demos for the Using Left Top folder, and inside of there is a program that will do a lot of things to Moving Flipbook. So let me just start it off and give you a rough idea what it does, and then we're going to fool around with it a little bit. So there's my basketball player, but this time it's not going to just stay still and dribble, it's going to move. So we're going to introduce, the first thing here we're going to introduce is the idea that there's going to be 2 timers now. We're going to have a separate timer that's going to make the basketball player dribble, but we need another timer to move them, move them, move them, move them. Okay, so a lot of different ideas here. So first thing, first timer you're familiar with from before. It's timer 1. That's what's going to make the player dance. The second timer is going to make the player move across the screen. We've turned it off right now, and we'll wake it up when we press the start and stop button. Next thing is, I don't see all my pictures. Where are they? Well, this time we're going to load them from a file, okay? And this thing right here is called Pick Player, and we'll feed those into that particular place. Now, before I start getting into the exact computer commands, got to do a little bit of doodling. You know how the very top left corner of your screen up here is 0, 0? Well, when you move a picture box that holds a picture that we're going to animate and move maybe that way, that top corner there is an important number. That's what we're going to move across the screen. So that picture box has a property called .left, which basically implies how far over do you want me to move that way. Okay, so that's the X, so to speak. It also has another property down, which it calls .top. And by moving one or the other properties, and sometimes both together, you will get motion, because you'll change the number of the position of that corner, and as you change it to a bigger, bigger, bigger number, or smaller, 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 it'll either go forwards or backwards or up or down. Okay, so those are the commands we're going to fool around with. And as I show you each command, I'm going to get you to stop the video, try it yourself, and then start the video up, and you can watch me take up the solution. Now let's go into the specifics for this one. All right, let's go into the code and make sure we know what's going on. So first of all, this basketball player, there's 7 pictures of him. Okay, so you've seen me use this before. I had it as Moving Flipbook, and before that it was called just Flipbook. Counters 1. Okay, so you've seen those before. This is how we're going to point to the hard drive to where the dribbling pictures are, and we're going to load them up. This will take the first picture, feed it into the pick player image, and resize it appropriately. Okay, now remember, there's two timers. This first timer you've seen before. This is how I cycle through all the pictures of the basketball player. So when I press run, it's not only going to move, see how it's dribbling already? So how come it's doing that? Well, I wanted to emphasize that there's two different timers this time. So this one I woke up right away. So it's set to true automatically. I could have had it go to sleep and then both start up at the same time, but I wanted to emphasize that there is a separate timer controlling the movement. So you notice how that's dribbling right now. That's the first timer doing its thing. Now we introduce a second timer to do its thing. The second timer, if we double click on it, what it does is, as I mentioned before, at the very top corner of that basketball player, like right at the top corner of his head, right there in that corner, there is a left command. And what we're telling the computer is, wherever that left is, move it over about 5 pixels. Okay? Move it over about 5 pixels. Okay? Move it over about 5 pixels. Okay? And it keeps doing that and doing that. But it's got to know when to stop, right? So when does it know when to stop? Well, I got to doodle a little bit here to show you. And actually, before I do that, I'm going to put this back to this instead of client, because when you look at the demo, that's probably what it has in there. Client will also work, but I'm going to stick with this one for now. So here is the screen. Here is your basketball player. Okay, and you have to also realize the basketball player really has a bounding box, which is a rectangle like that. It's an imaginary rectangle. You don't see it. Okay, now how do I know when it hits this wall? Because if it does, I want it to stop. So here's what we do. All we know is right now that it has a left side. It doesn't have such a thing as a command as a right side of the person. It's only the left side. So what I'm saying is, if we add up where this left side is right now, plus how wide the person is, okay, so pick player width. If we see where he is and we add the width to it, when we add up those two numbers, we get basically the edge of the screen. Then I want to turn the timer off. Okay, and let's see. It sort of gets there. It's not dead on, but it's pretty close. And I'll tell you a couple of things that could throw it off. So there the player goes. We're not going to press a button to stop him. When he gets really close to the edge, he basically turns off the movement. He's still dribbling, but he's at the edge of the screen. Now, sometimes you'll see that it'll stop what you think is early, but it doesn't really stop early. It all depends on how you drew your image. Sometimes when you draw an image, what you'll do is you'll draw the image, but the way you save it, you didn't trim off all the fat. So when you save it, there might be like white space around it. Okay, there are techniques and programs like Fireworks and other editing programs, Paint Shop Pro and Photoshop, that will let you trim this. But if you don't trim the fat, the size of this image is actually this big. So you've hit the wall, but you see this guy right here and you go, whoa, he's not even close to the wall. Well, what you got to do is trim that image. Trim it right down so that when you get closer to the wall, it's more realistic. So that's sometimes what throws it off. But there you have it. There's our first player movement across the screen. So now here's my first challenge. Then we'll stop the video and we'll do the second challenge, etc., etc. How about now, we're going to move this object over here, and I want you to write the program that makes the player go backwards and stop when he hits this wall. Give it a try, and then we'll take it up. All right, here's what you do. So I moved it over here, and I want to go backwards. So let me go into this timer, because nothing else has to be changed. So first thing is, and I hope you got this, you're going to go backwards. All right, you're going to go to the left. So we're going to take 5 away all the time. Now this is all got to be changed too. How do you know when you've hit that edge? Well, that edge is actually 0. So if it's less than, should we even say equal to 0? Let's go like that. So when the left position hits the wall, stop. Let's give it a try and see what happens. Okay, so he's over here, minding his own business, and now he's coming across the other way. And again, remember, the bounding box is going to throw this off a little bit, but it's reasonable. So that's a big bounding box, okay? We stopped quite a bit earlier. So the image itself has a lot of white space. Now again, if you don't understand what that is let me sneak into the underground for a second, and I'm going to show you the pictures. All right, the raw pictures that I used in here, just so you get this idea and how you can fix them later on. I'll do that in a future lecture. For now, it's not crucial as long as you understand the key concepts. So let me sneak in here. I'm working my way down. Okay, We're in here, we're in debug. Now look at these pictures. There's so much extra white space on them. I don't know if you can tell exactly, but look at the white space around here. Not as bad over here, but there's a little bit of white space, but look at the white space over here, okay? So when you think you're hitting the wall, it stops right here, but the image of the picture is, you know, a couple of pixels shorter than that. So it does make it less realistic. So what you need to do, and as I told you, we are going to learn this, we're going to trim this right down so that it's nice and tight when we make a more realistic program. But anyway, that's why it's doing a little bit of that. Okay, so that should help you understand a little bit of that. Okay, next challenge. I'm going to move this button out of the way here. I want you to grab it, put it there, and make it go down. All right, we'll take it up in a second. Back to timer number 2, double click. Now we're not worried about going sideways, we're worried about going up and down. So we're going to say the word top, and to go down is kind of like the reverse of what you would think of in graphing if you learned that in school. We're going to say player top plus 5, so that's going to make it go down. Now this is going to get tricky again. All right, so we're going to say basically if the head of the player plus how tall the player is, so pick player dot height is greater than or equal to this dot height. Did you get that one? A little bit more challenging. We turn it off. Okay, let's see what that one does. Okay, so we're up there. Let's see how close we get to the bottom. Should be fairly realistic because we don't have a lot of a little bit over, but we're getting the basic idea. Okay, so if you got close to that, you did it the right way. All right, so there it is. That's how you make the player go down and then stop when he gets to the bottom. Okay, here is the next part. So what we're going to do now is we're going to go into the timer and we'll take a look at this part right in here. We're going to make the player move up. The logic for moving up is that you actually subtract. So that's how you work your way back up. So the bottom is a big number, and when you work your way up to the top, you get to 0. So that's why you subtract, and all this logic has to be erased. And now we want the top of his head to be, if the player is less than or equal to 0. So if it gets to 0 or it almost gets into negative territory, stop. And let's run it and see what happens. So yes, there he goes, going up, 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 and hopefully he doesn't go through the roof and he stops. So he's getting close. There are little things we can do to tweak that, but for now, the most important part of this lesson is that you understand how these players are moving and how you can sort of get to stop them and things like that. Here's the next challenge. This one I'm going to hold your hand on, so I'm not going to leave you and then you come back. What I want to do in this one is have the player go right through the wall, not stop when he gets to the wall, and then come back around the other side. That's kind of crazy, but you see that sometimes in games where they come around another way. So that's going to be a bit more challenging. Let's see. So first of all, we're making the player go across, so we're going to use that left again, and we're going to use the plus 5, but here's where it gets crazy. Now, we're going to have to figure out when he goes through the wall. So this time, when, do I even have to hit the right-hand side? No. Basically, when the left is totally through the wall, so on the left-hand side of his body, he's totally gone, is greater than, we'll say greater than or equal to the width. Now how are we going to get him to come around the other end? So I don't even want to stop this time. I'm going to comment this out for a second. So I don't even want him to stop. What I want him to do is come around the other end. So in a way, what I've got to do is I've got to say, pick player dot left equals minus the width of the player. Yeah, pick player dot width. So he's going to be coming out of the left hand side. Let's actually my first shot at it. I want to see if it actually does what I think it's going to do. Let's hang on and watch this. Okay. So he's keep going. Now he's going right through the other end. And watch, he's going to slowly come in. Yes, it works. Okay. Now you might say, why don't you, when he came out the other end, say pick player equals 0? Because that would be too drastic. It would be like bang, he'd come out right away. What you're doing by saying pick player dot left equals minus width is you're letting them gradually reappear. And I'll doodle some stuff here so you can really appreciate what's going on. So he's gone through the side of the screen, okay? So the left side of his body has become greater than or equal to the width. And now what I'm doing is I'm not making him start right there. Because if I did, he would sort of pop up magically and it wouldn't look as smooth and clean. What I do is I make him show up over here a little bit. So he's really in, like, you know when you're past 0 but backwards, you're in negative territory? So in a way, he is right now at negative his body width. And then he's going to go back by 5s, by 5s, by 5s. So he slowly introduces himself back into the picture. Isn't that cool? All right. All of these little tricks you start to learn as you use animation, how to move players around, how to make them show up in certain spots and then reappear very smoothly. Now, I'm not going to do every combination. They would all be basically the same kind of idea, but that's how you make them appear and reappear. Okay. Now, our last tweak is definitely the most challenging. What I want to do in the last tweak is have the player hit the wall and then bounce back the other way. Now, let's just consider that one situation. We won't write it for the left-hand side yet, but just the one situation. And even that's going to be pretty tricky. So what I'm going to do, first of all, is you got to realize that you go over to the right, and then you're going to have to go backwards to the left. So it's not always going to be +5. So like, how do you do it so that you write it in a nice succinct form? Do you need like 4 or 5 if statements? What do you do? Well, I'm going to show you a little trick. First thing I'm going to do is up here, I'm going to declare a variable called direction. And I'm going to start the direction off as a +1. Okay? And then we're going to write almost like a formula. So there's the direction variable, and then you'll see where I use it here. So here I'm going to say, I'm going to go to the left 5 times direction. Okay? So direction is 1, right? So it'd be 5 times 1. Looks good, right? Now, when I get to that wall, first of all, I'm going to comment this out. And the reason I comment it out is it's nice to remember the answers from before so you don't, erase them, but the computer's not going to look at that line. Now, here's where it gets tricky. Now, watch what I'm going to do here. Direction equals minus direction. It's almost like I've invented a formula. Now, think about what happened here and how it's going to work. Direction was 1. So what this line says now is make direction equal to -1. So when it does this formula, it's going to be, I'm adding 5 times -1. So I'm adding -5. So in a way, I'm going backwards now, -5. Now that's kind of cool. That's how you start problem solving and thinking in a more efficient way. There's lots of ways to do this solution, but this is one of the shortest ways. What I'm not doing in this part is you would have to also consider when you hit the other wall. But for now, at least this will give you an idea of how to think about hitting the wall, what we call collisions, and then bouncing back off the wall. Let's take a look at how that works and if it does work. Okay, so he's bouncing, and whoa, and he's going to come back. Please come back. Please come back. Yes, he's coming back. Now I'm going to do another fix because I didn't want him to actually do that. But at least we got it to show up. What I also want to fix here is I didn't want him to go through the wall first and then start bouncing back. So what I'm going to add here is plus the player width. Okay, so this one he should stop a little bit shorter and then bounce back. It's a nicer simulation that way. Okay, so he's going to hit the wall, and then he's going to bounce back the other way. Isn't that cool? All right, so there you have now some of the basics of movement, having players move left, right. Now, you heard me mention also in the opening intro that you can also do diagonals, all right? And the way you would do a diagonal, I'm not going to do it here, is you would actually have 2 lines here. You would have the player move a certain amount to the left, going over to the right, and then have them move down a bit. And by going over a little bit and down a little bit, you simulate a diagonal movement, okay? And I'm not going to do this one, but right here would be another line with top left. So what would happen is it'd almost be like he's going a little bit like that, a little bit like that. So in essence, he's moving that way. A little bit like that, a little bit like that, and he's moving in that way. So there you have our introduction into player movement now across the screen. Now in our next lecture, what we're going to do is going to pose you a little challenge. Okay, let's really practice now. And what I want you to do is take this knowledge of player movement and have 2 images and have like a race. Press a start button, the timers start, and you make the players go across the screen, and then you figure out who won. Okay, we'll leave you with that in our next lecture. The car race challenge. You think you're ready? Let's try to now apply some of the concepts we've been learning over the last couple of lectures on animation, and specifically the last lecture where we learned to make our objects go across the screen. And let's do something fun. So we're going to create a simple 2-car race or 2-boat race or 2-airplane race type simulation that goes from one side of the screen to the other, or you can make it go from the top to the bottom, and then I want to know who wins at the very end. Now, as a little tease, I want to show you what some of my former students have done given this little challenge. Here's one example that I really liked. 2-car race. And remember, I'd like you to have both your cars, motorcycles, whatever, make sure they're animating in place. So both of these are animating in place, and then I press the start. This one even had a nice little red-green stop sign type thing going on, and the bus won. And then you can also reset it. That's kind of a cool feature. And then we've also got, again, red, yellow, green, and they take off. And see if their car wins this time. Oh, it's a tie. Okay, so there's one type of simulation that I've had students do. Okay, I really like that one. Show you one other one. Now, these are in your zipped up files. Don't look at them first, okay? Try to do it yourself, see what you can come up with. Here's one that I showcased in a previous demo, I think, and I'll show it to you again. This one is a really neat one too. It involves 2 airplanes, which I'll move in down here. You got the clouds moving and everything. Really, really neat one. And again, they have a restart. It just positions them back to the beginning again. Okay, so the Red Baron wins. Isn't that one cool too? So those are just some ideas that you could think about when you're trying to develop yours. Now, are you lost? Do you need some help? I'll give you some hints for a few minutes, and then I want you to stop the video, go away for a couple of days, for a day, for a couple of hours, and then come back and we'll recap and show you how some of these solutions were created. Not sure where to start? Well, let me give you some hints. I'm going to base my hints on the program we did where we had the little basketball player moving across the screen. Okay, now think of it like this. If it's a car race, really, I'm going to basically have 2 basketball players going across the screen. I could have that as the race, actually. So how do I do that? Well, I've already got a spot for the first player. Why don't I make another picture box? Okay, so I'll go down here and grab another picture box, and I'll put it right underneath the first one. Okay, roughly the same size. And I'll have to call this one pick player new or something like that. Now remember, I'm just giving you some hints, so I'm going to take the lazy way out. I'm not going to go and find some new pictures or anything like that. I'm going to basically have the same pictures again. So let's go into the code, and I'll show you what other changes you have to make, and then hopefully that'll give you at least a kickstart to what you have to do. Now we already have one image array that has 8 images, so that's okay. I'm going to call this other one image new, square brackets, actually, no, let me start off first of all. What am I saying? Image, and then I'm going to call this images new, and then equals new image square bracket 8. So in yours, you might have one set of images that have 7 pictures, and another one might have 12. So you wouldn't make those obviously the same numbers. So make sure you modify it according to your situation. This same thing with the count. I'm going to have 2 counters because even though in this one, obviously they're both the same, it might not be true. So I'm going to have int count new, and I'm going to start that off at 1 also, obviously. This direction stuff I won't need. I could comment it out. I'm going to leave it for now, but it's not crucial. This is what you're looking at right now. So when you're going to have a 2-car race, a 2-plane race, you're going to have 2 completely new sets of images, store them in arrays, and then 2 counters, one to kickstart the one and one to kickstart the other. Now again, same thing here. I'm going to have a separate loop, and it might go to 12, 13, 14, whatever. And in my case, obviously, because I'm taking the easy way out, I'm just doing it from 1 to 7 again. And this one's going to be called images new. Okay, and I'm storing the first image in there. And let me see if I can just copy and paste this, and then obviously change it for my situation. So this one is images new, is going to go into pick player. I think I called it new. Let me see again what I called it. So this one right here, I called it pick player new, yeah. Okay, so I'll sneak in here again and pick player new, pick player new. Okay, so we're set up. Now we've got our timers, and we don't need to make 7 or 8 timers. You can do a lot of the logic in these 2 timers, but if you feel like adding 3 timers or a little bit more, that's up to you. Just for the sake of this example, I'm going to stick with this. And this first timer is obviously moving the first player, like making them dance around. This one will make the second player dance around. Pick images new, type in the word new there. It's obviously not count. See how I had count there? This is going to be count new. All right, so I'll put that there, and I got to change that to new, and this one to count new. All right, so we're doing pretty good so far. This one is where it gets more challenging, okay? Now, I'm not going to give you all the hints here because I want you to do a little bit of thinking, but when you move the players, you're not going to move them 5 over. I want it to be like a game, right? So you're going to have to use random numbers and make the players move a certain amount, and hopefully they're not the same amount. So you make it kind of a really interesting race. All right, so why don't we throw randomize up here at the top? Random R, like we usually use, new random bracket bracket semicolon, and we'll slide down here. Now here's the part that needs the random numbers. See, we're going to pick some numbers for the movement of the first player, then pick another number for the movement of the second player, and just keep going across and across and across. So we'll start off and we'll say integer move equals r dot next, and I don't know how much you want to make a move across, from maybe nothing to, I don't know, 4 pixels, maybe even that's too much, 3 pixels, 2 pixels, whatever you decide to do, okay? And that'll be the move, and then this player right here gets to move that far across the screen. Do you see how it's going to become more of a realistic game when you use random numbers and then you move each one a certain amount? Now for the second one, same kind of idea. We're going to copy and paste just to save us a bit of time, but obviously we've got to change the variables. We're going to pick a random move again. Now we don't need to declare it again, so I better actually do this to be more professional. I'm going to declare it once here, int move, okay, and we'll start it off at 0, and then we don't have to say the int word again. We just, when we use it, okay, and now we're set. Now again, this is not for the first player again, so this is for the new one. And this if statement stuff, I'm not going to tell you. I'll tell you after when we take it up. That's going to be kind of a bit of a challenge. How are you going to know who gets to the edge of the screen first? Let's just see for now if this even works without any errors, and at least it'll give you an idea how it's supposed to go. Yeah, there they go. Okay, and it doesn't look like they're tied, but it looks like one's a little bit, yeah, the other one's slightly ahead right now. So you see how this is happening right here, and those players are moving across the screen. You could change these if you think they're going too slow. Pick bigger numbers from just 0 to 10 or something like that. Looks like the top player is going to win. But in my program, you're not going to know because I haven't put in the if statements to say who won. All it's going to do is hit the wall and probably go right through and keep on dancing. Okay, so hopefully that's enough hints for you. Take a break. If you want to come back to this in a couple of days, whatever, but when you think you're ready to look at the full solutions of my former students, you can look at them. For now, make this one of your first challenges so you start to figure out how to make a simple, neat game. Okay, so take care, and we'll see you in the second half of this video. Here's the first student sample that I'm going to quickly go through. So you've got your 2 images. You've also got the stop sign. It starts off the race for us. The neat thing about this program, and you got to make sure you get a nice image like this, you got to try to make your images transparent. Hopefully you find transparent GIFs because then they blend in with everything. And then you see that work. That was a cool effect. Okay, and then it figures out who won. So let's take a look at the code. I'm not going to beat it to death. All right, I'm just going to give you a basic overview of what's happening. But obviously the first timer, what we've got going here is it's cycling through the animation for the cars, the wheel spinning, the bus wheel spinning. You've seen that before, okay? And the student did a nice job there. Second timer is for the light that changes colors. Isn't that cool? Okay, so again, not going to beat this to death, but at least you get an idea. You know, how many timers should I have used? How many timers should I have used? Nice. The stoplight should have had a timer all by itself, and there it is, and that's what it does. And then once it gets to the end, we turn on the third timer, and that's where the race begins, right? And that's where the dirty work is. Let's take a look. Timer number 3, the student was picking numbers between 8 and I guess 14 pixels. And then what they were doing is moving the car or the bus that amount of time. And then this is trying kind of a way to figure out when they're hitting the wall, okay? And then they would turn off that timer. Here's the bus, random numbers, see if they hit the wall, okay? And then here's the logic this particular student used to figure out when a particular person won. Okay, so lots of different ways to do it, but it's kind of neat. Hopefully you were on the same path and you got that. This is obviously the trickiest part. You can pause the video here if you want and analyze it a bit more. I'm not going to hide it from you. Obviously, you can look at it anytime you want. The reset, if you're wondering, all that does is make the objects move back to a particular location on the screen. And again, it's kind of like trial and error. You don't know exactly where to put them, so you have to make up some numbers until you get it to be what you feel is the right location. Here's our second demo, and I don't know if you can see over here the clouds. All right, so the student in a way gets these clouds to move this way while these two planes are moving that way. I thought that was really cool. Let me just run it again if you forgot what it looked like. So there's the clouds going from right to left and the planes going from left to right. Isn't that neat? That's really cool. And then you reset and they go back to where they were. Let's quickly go through some of the code just to give you a basic idea. And again, I'm not going to beat this to death, but at least it'll showcase how the student did it. Timer 1, let's go into the underground for a sec. So just like the last one, that is controlling the animation of the two planes that are cycling through either the propellers or whatever else, okay? The second timer is controlling the movements of the clouds and the two airplanes. And here you go down here. This is randomly picking, this is from the random number generator, randomly picking numbers between 10, I guess 27, and forcing those two planes to move to the right. Okay, this is how this student determined whether the Red Baron or the other one, the Blue Rocket, won the race. Okay, so isn't that cool? And this stuff right in here, this is how you're making the clouds go the opposite way. Notice they've got like a little accumulator here, and we're subtracting 17. So we're not using random numbers for the clouds, obviously. They're always going to go across at a set pattern. But isn't that cool? With just a little bit of change, all of a sudden you've made kind of a neat program, and it really has a nice visual effect. So there you have kind of a neat practical application of animation incorporating our first simple game. Now we're going to kick it up a notch and learn some more advanced techniques that don't rely on the left and the right. We're going to use another technique called the draw image technique, and that'll be our next step in our evolution. And then the goal of the next little set of lectures is to develop a little falling objects game where objects fall from the sky and you make your little man at the bottom go left and right with your cursor keys and catch them for points. Okay, so that's the next logical step, and it incorporates a lot of the ideas we've been doing. Okay, so thanks for listening, and we'll see you in the next lesson or lecture. Welcome back, and in this lecture what we're going to do is again move objects across the screen, but this time using a technique that uses the draw image method. Hopefully you've unzipped the demos for today, and what I'm going to do right now is load up the first program we're going to take a look at, which is called Draw Image Animation Intro. And I'll give it a run and then we'll talk about the specifics. So when I press this button here, you're seeing two soccer balls go down the screen. Okay, now what you may or may not see, you'll see in a second when I display the actual main form. What we're going to do now is we're not going to use a picture box that we're feeding images in as we did in the last example. So we're not going to have some sort of generic picture box that we're going to feed stuff into and then make that move across the screen. What we're going to do now is have a panel, and we actually could have put it right on the form, but we're going to take these images and actually place them on a location, in this case the panel, and then obviously move them down a bit more and then move them down a bit more, and you get the sort of simulation of a dropping ball from the sky. Okay, so the key point is here that we're not placing it now into a picture box that we force to move with the dot left and top. We're basically just drawing them at a location on the screen that we want. Now, let's take a look at the specifics. Let's go into the underground. And first off, since we're drawing them right on the screen now, not putting them in a picture box, we're going to use the graphics, and we're declaring it publicly so the entire world knows about it. And initially, because we're dropping them from the sky, we're going to need some variable that makes the Y number become, I guess, 0 at the beginning, and then 10, 15, or whatever we decide to go down by. In FormLoad, we make an instance of the panel class, so that when we use the letter G, that will mean we're always putting stuff in the panel. Okay. Next, when we press the button to start the thing, we turn the timer on if it was off, or vice versa. And we initially tell the computer to start at Y equals 0. So when we make these things drop from the sky, they're initially going to start off right at the very top, when that's Y equals 0. Okay, now we get into the timer. And every tick of the timer, every 1/10 of a second or whatever we decide, we are going to draw at initially Y0 and always X10, which means we're going to go about 10 over pixels. And at the beginning, obviously, we're at the very top. And this is where we're going to have our first sort of soccer ball. Okay, let's go through the mechanics of it. This line, I'm not going to tell you what it does yet. Okay, in a second, I'll explain this to you. This part right in here, what I've decided to do is, I don't know how big my screen is, okay? But what I'm going to do is I'm going to cut it into 40ths. Let's pretend my screen was 80 pixels high, all right? Then there would be 80 divided by 40, which would be 2. And what that's going to mean for me is that I'm going to make the ball drop in 2 pixel increments. So it's just going to go down a little bit at a time by 2 pixels. You could make it go down faster by making it a bigger number or a smaller number, or whatever you want to do to fool around with it, okay? And we will experiment with that too to see what that affects. Okay, here is the actual new command that we're using in this particular lecture. We're using g.drawImage, and the way that drawImage works is you tell the computer the image you want to draw, and that is the first ball, and this one is the second one, okay? Because I'm dropping 2 balls at a time. This is the location that I'm dropping it from. So remember, I made image X 10, so I go 10 over and no down. Okay, so this isn't down at all yet. Pick ball width. I make it the exact same size that the ball is, depending on the width of the ball, obviously, and the same size of the ball in terms of the height. So it'll basically draw it right there at that size. This one right here basically draws the second soccer ball, but notice the only difference, image X plus 50. So wherever I moved, and in this case I moved 10 over, now move another 50 over from there, and then draw the ball there. So they're both going to be going down sort of side by side. When I get to the bottom, and hopefully you understand this logic now, when I get to the bottom, remember, the way you figure that out is you figure out the top of the height of whatever your object is. And now we don't have the word top, but we have the variable image Y. So the Y position plus how high the ball is. If those two add up to the ground, which is panel1.height, then turn it off because we've hit the ground. Okay, let's run it one more time, and then I'm going to start fooling around with some of the variables in there to make you appreciate what they're doing. So there they go, all the way down again. Okay, and they stop. Now, I told you I wasn't going to explain this one line, but now I'm going to comment out this line for a second, because you have to understand how animation works. So I'm going to run it again, and then you'll see the importance of that line. It's all that trailing effect now. See, what you do when you do animation is you display something on the screen, you leave it there for a fraction of a second, and then you have to wipe it out. So how do you wipe it out? Well, this line here that I've commented temporarily out, this was my way to wipe out whatever location the ball was at, and then have it move down a bit and then redraw it. So this is very important. If I don't put that in there, it doesn't wipe out any of the previous stuff, and I've got these fragments left over. So that's how you sort of refresh the screen, clear it out, and then draw it in a new location. And that's kind of like the science of animation. So I definitely need that. So I'm going to put that back. Another thing that I need you to appreciate is that you still don't get what this divided by 40 is. Well, let's divide it by, instead of 40, 10. So think about it. If it was an 80 high, you divide it by 10, that's 8. That means it's going to go down by 8s. Does that mean it's going to go faster or slower? Well, let's see. And hopefully this plays well on your screen. Sometimes you won't be able to notice what the supposed change was. We'll see in a second. All right, here we go. Yeah, did you notice they went down a lot faster? A lot faster. Okay, so if you change that to a bigger number, instead of, let's go 100. Let's see what that does. Now they're going down super slow. Okay, so you can control the speed of your game by using timers and also doing the mathematics inside of it. So there's two ways to control it: the tick value, and of course now we're changing it by what it's going down by. All right, and that's the basics of how you do this new type of animation, moving things across the screen using draw image. And what we're going to do, like we did in the previous lectures, is we'll experiment a little bit again. Let's figure out how to make it go across the screen this time instead, or up or down, but at least give you a basic idea. We're not going to do every combination again, but once you get the handle on one or two combinations, you should understand how you incorporate draw image instead of the dot left and dot right. Okay, let's try this combination. I want to have, it doesn't have to be both soccer balls. I want to have one of the soccer balls at least start maybe a little bit over here and go across the screen that way. Okay, so what would I need to change in this program to do that? Let's go in here and we'll take a look. So you notice how it has int image y. Why don't we change that to an x? Because now we're going to go across the screen instead of up and down. What else do we need to change? Down here, it's yelling at me, yeah, because I got rid of it. So I'm going to change that to image x. And that's going to start at 0. It's going to start at the left-hand side. This one right here. Now, I got to guess a number here. Like, how far down do I want to start? Let's go down about 50. That might be right, it might not. We'll see in a second. And it's always going to be 50 down. So that'll be like maybe halfway, I'm not sure, but you know, it could be around there. This line's good. This line's going to change now too. Okay, because now we're going to figure out how to go across a certain amount, maybe by 5s or 2s or whatever. So it's going to be the panel width, and not divided by 100. Let's divide it by 10. Okay, and that should be good. Let's see what we've got to change here. First of all, I'm not going to draw both the balls, so I'm going to comment that one out. I'm just going to draw the one, just to give you the idea how it works. So pick ball image, and then image X, Y, that looks good. Everything else looks good. I think we can try it out. Let's see what happens. Okay, there it goes across the screen. That was pretty fast, actually. And you know what? It went through the wall. So we got to change one of our if statements there. So first of all, it went too fast. So let's slow it down a bit. So instead of dividing it by 10, let's divide it by 40 like we had before. That's going to slow it down for sure. This in here, what do we change? Well, where the X is at any moment in time, plus how wide the ball is. So that's called the width. If it's greater than the panel width, we'll stop. Okay, and that should work, and hopefully it goes slower so we can see it this time. Yeah, there it goes slower, and then it hits the wall and it stops. Okay, so I'm not going to go through every possible combination, but I think you start to get the idea what's involved here. It's a slightly new technique. It does not use left and top. We use now draw image that draws it right on the screen. Now you could, if you wanted to, not even use a panel and put it right on the form. And in future lessons, I will do that also. Now, we got to have a bouncing example. I'd be remiss if I didn't show you the bouncing one. So I've got one already set up for us. And it's in your demos that you unzip for this particular lecture. And it's called bouncing. And it's the same sort of soccer ball thing. And they are dropping from the sky. And they bounce back up. Okay, now there's a little hint on what I'm going to do in my next lecture in here too. You'll notice that the background's green. I don't want to really tell you what's going on yet. Just understand that the ball is bouncing and it's working. It's bouncing the top and the bottom, which I didn't show you the last time in the previous lecture. Let's take a look at how I do that and discuss the consequences of it. Okay, so first of all, graphics G, that's good. We're going down, we're not going across, so we're back to image Y. It's like the Y variable, right? I'm using a technique so that because sometimes I'm going to be going in one direction and sometimes I'm going to go in another direction, I'm going to incorporate this direction variable, which I call now image direction. All right, the rest looks pretty well the same. The timer, if it's off, we turn it on. We initialize this. This is slightly new from the previous one we just did. I have a variable now called image direction. I set it to 1. And when it hits the bottom of the ground, I will change the sign to negative so it works its way back up, and then vice versa, and continue that process. Here's how we drop the image from the sky. We move it over 10 over. This is really, really important. We always clear the screen. If we don't clear the screen, it'll have those fragments left over. This is how we're going to make the computer go down. Now you'll notice this one extra feature here, okay? Image direction times. And it's going to be times 1 as we work our way down. When we hit the bottom, that'll change to -1, and it'll be basically subtracting by whatever and working its way up. Here is what I taught you in this lecture. This is the new command called draw image. This is the ball that we're using this time. This one is called pick ball transparent, and I'll tell you what that means in the next lecture. It's just another ball. It's a soccer ball again. It's slightly improved, but it's the same picture. This is the location X, this is the location Y, and this is the width and height. So really basic. This is how you determine when you're on the ground. All right, we've done that several times now. You take a look at your Y position plus the height of the ball. If it's bigger than the panel, what you do is you reset your Y position so the ball is slightly above the ground. You also make the direction -1. And I don't know if you can tell on your computer when you play this. This is kind of a chintzy sound. It's called the console beep. We're going to learn more sophisticated sounds in about another 2 or 3 lectures. Now, that's the bottom. What if it hits the top? Well, when it hits the top, we'll be at 0. So if we hit the top, make the Y value 0, so you're at the very top again. Reset the direction back to +1 and do another little beep. So one more time to finish it off so you understand. So we're working our way down. And then when we hit the ground, we reset the position. So we don't want to reset the top of the soccer ball to the very, very bottom, right? So that's why this line here has a little bit of extra. So it's the panel height minus the height of the ball. So we're a little bit up here. So it makes it look more realistic. So it doesn't go all the way down too far. Okay, so there is some bouncing off the wall. And our last example, and again, I'd be remiss if I didn't do something with the dancing man, my favorite guy, the basketball player, because these images that we're dropping now with this new thing called draw image are static. Okay, and we want them to bounce around or dance around or whatever. So I've got one more example I want to go through, and hopefully you see the pattern. I've not taken a humongous step making it too complicated. So this last one here is, I think, called drawing image moving flipbook. Okay, so remember that one I drew. I'll run it for you really quickly. And on purpose, I've displayed this. So you got to make sure you understand the basic idea. We're not putting that dancing man in a little picture box that we're moving. We're putting them on basically a panel, like a window inside a window, okay? And I made this guy dance around so you could see that it was active. Now, professionally, you would usually make that invisible, so you don't see that. But I just, for the sake of you seeing the sort of hidden behind the scenes what's going on. So there's the dancing guy, and when I start him, he moves across the screen like we learned before, but this time he actually moves too. So I just stopped it in the program because it doesn't have every combination. But anyway, that's the program. Let's look at the code very quickly. A little nice review. So what we have here, first of all, is the dancing man, which is 7 images, right? We stored in an image array. So we got to remember to count them. We're going to go from 1 to 7. This stuff here we've done before. This solid brush you actually don't need in this program, so I'm going to rub it out. It's not crucial, and I have to stop the program to do that, sorry. Okay, so I'll rub it out. And what we do here now is we load up the image array. We've done this before. We load up all the dribbling people. We store that image into the picture box. Now you go, oh, you told me you're not using picture boxes. That picture box is this one right here. This is where we're feeding the man. But once we take that and throw it up here, we are actually storing it on the panel. Okay, so the dancing man is there, but we don't actually move this box. Okay, we take this and draw it in different locations on the panel. Okay, let's go back into the underground. So it's showtime. We press the click button to begin, and if the timer was off, we turn it on. We tell the computer to start at x equals 0 on the left-hand side, and we tell it to go from left to right. And remember, this is crucial. We wipe out the screen just in case there's any fragments. Okay, and when we turn it off, we turn the whole timer off. Now, 2 timers are going on, right? So when we, if the timer 2 is false, we turn it on. Okay, and this other timer, it's been playing all along. All right, I turned it on initially, so that's why when you pressed run, you're wondering, why is he dancing right away? Because it was already on. Okay, and I'm getting rid of this line here too because I erased it from before. Okay, so that's why he's playing right away. I didn't start him when I pressed this button. All that does is move. Okay, so let's take a look at that command to make sure we understand that. So here is the second timer that we turn on. The first timer was automatically on. So we start at a particular value, 40 down, which is about halfway down the screen. This is your bread and butter. That wipes out the image to give you the simulation of the illusion of animation. This is how we're going to go across the screen. This is how we draw that dancing player because he's in pick player. Right? Remember, this is called pick player. Okay, so we're feeding it in there. So down here, we take the image, like the picture box. We're going to draw it onto the panel. We're going to put it at that location. That's the width and height of the player. If we get to the right-hand side, we tell the computer to go back a bit. And again, I use a little bit of a trick here. I don't want it to go right at the edge of the screen. I want it to simulate that it doesn't go through the wall. We change directions and we beep. When we hit the left-hand side, we change the value to X and we change the direction back to 1. And that gives you the full simulation. I stopped it last time. I won't stop it this time. So it bounces off the wall. Looks pretty realistic. And again, the corny beep sound, we're going to do real sound effects later on. And you'll notice here it doesn't go all the way to the wall because of that problem with the bounding box, which means when I drew that, I had a bunch of white space, especially on the left-hand side and a little bit on the right-hand side. But there you have it, a nice little introduction to animation again, moving objects across the screen, this time using this new draw image technique. Okay, so in the next lecture, I'll give away some more secrets that I made as improvements to here. I didn't want to mention them while I was doing this. Watch it in the next lecture. It's called transparency. In this lecture, we're going to look at the issue of transparency. And this is a direct follow-up from the previous lecture. What we're going to do is discuss how by using transparency, you can blend in objects and create nice animations that flow with any color background. And we'll use a couple of techniques. We'll use some programs that I've purchased that are professional programs. And there also is lots of free web-based versions of software that you can use to create transparencies. And we'll look at both and give you some neat ways to clear up images to make them look nice. Now to start off, I actually want to go back to the first example we did in the last lecture called Draw Image Animation Intro. And this one had the 2 soccer balls. And you must have been wondering, why has he got 2 soccer balls? He's proven his point. The balls are going down. Great. Well, I want to take a closer look at them today. And I don't know how good it's going to come out on your screen, so I will do something crazy in a second. But these 2 images, one is with a white background on it. I have a soccer ball I found on the internet, and it had white around it. And another one, I think it's this one right here, is the same image, but you can see through the white. So it's kind of like, we call it transparent. And when you see it white on white, you're not going to notice it. So what I'm going to do right now, just to prove my point, is I'm going to go over here to the background, and I'm just going to pick some color. It doesn't matter what, but it's definitely don't want to pick white. I'll pick green. Okay? And just want to show you for a second when you run it, what it looks like. So you'll notice that first one there, and I'm going to turn them back on in a second. This is from the leftover from the previous lesson. See that white right there with the background? That is not transparent. It doesn't look good. So what I'm going to do for a second is I'm going to go back in, and we're going to go into the code, and instead of moving the white one across the screen, I'm going to move this one. Actually, we could probably move both of them, but just to emphasize one first, I'm going to comment that one out, and everything else I think should be the same. Let's just take a look for a sec. Okay, so you notice how it's much smoother. Now that one started over about 50 over. I probably should have gotten rid of that. I will. Actually, I'll get rid of that for a second. But you're starting to see the difference, right? You start to see that that one does not have any white around it. So what's the big deal? Well, that image, which is this one right here, has had transparency applied to it. And the GIF images can have that property applied to it, and PNGs can have image transparency applied to it. And you might not have just a green stupid background. You're going to have a nice background, maybe outer space background or a park background or a car scene background, and that stupidity of having the white around it is going to make it look kind of dorky. All right, so this is without transparency and this is with transparency. So how do you create these transparencies so you can blend them nicely in your programs? Well, there's several techniques. There are programs that you can install on your computer, or you can go on the internet, and I'll show you both right now. How about I start with Fireworks? Okay, so I found this is a professional program. This is from Adobe, and I found a soccer ball online, not the one that I have in my program, another one. And the first thing you'll notice is that there's all this white around the soccer ball. The second thing I want you to notice is up here, JPG. So this image that has white background is a JPEG. That's not good because JPEGs cannot be converted into transparencies. So what you need to do first of all, and you can do it in this program, is resave it, but as a GIF. Okay, so right here is GIF, and now we're going to put it into a specific folder that I've made up in my lecture demos, and I'll snake my way down. You can do this also if you want. In the demos for this section, this couple of lectures, I have a folder called Images. And what I'm going to do is I'm going to call this the lecture soccer ball. Okay, so I've saved it now. So this now I'm going to close, and I'm going to reopen the soccer ball that I just saved, but as a GIF. All right, so I'm in the Images folder, and I'm going to load in, I hope the one that I loaded in right there, lecture soccer ball, good, and it's a GIF. Now, by doing that, I am now allowed to create a transparency version of this. And the way you do that is, first of all, you go to this image preview in Fireworks. And then what we do is we can set a transparency. So no transparency, we're going to change it to index transparency. And then we're going to export. And we're going to call this transparent lecture soccer ball, and press save. All right, and one more step. We're going to close this one off. We're going to reopen it. And this one's called transparent lecture. Okay, now you should notice the first thing is that it's all checkerboard background now, as opposed to white. And that is how you create a transparent image that you can incorporate into your Visual C# programs. Okay, so that's the steps involved. And then you would just use that when you created it. And if you're not sure what I'm talking about, you can go here and you can create a new picture box if you want. We will. We'll put a little picture box here just to prove it. And then when you name your picture box, we'll call this pick new soccer. Okay, and we'll call it that. Now the most important thing is to get the picture. So there's the image plus the 3 dots. We'll look for a local resource and we'll import it. And again, we'll sneak up a little bit into this folder right here, and we're looking for transparent lecture soccer ball, and then we'll press OK. Now you'll say, where is it? Where is it? So remember, you might have to do that thing with the size mode of either auto size or stretch, and then we can sort of align it nice. Okay, so that is transparent. Now, when you put it up here, you see how it sort of blends into the green. This one here, it's still the white background, all right? And this one here, again, blends into the green. So that's the difference between having that solid white that would look stupid and having something transparent. Now, you're probably not going to have Fireworks on your computer. If you're lucky enough to have it, great. It's a decent program. There's also Photoshop would probably do this. But if you don't have any of those programs, there's a way to do it also on the internet. We'll take a look at that in a second. Now, Pixlr Editor is one of my favorite ones. It's also a free web-based way to work with pictures. Now, it doesn't let you make them transparent. So I'm going to actually use two programs. And if you find a better one, please let me know. But this program lets you open a picture from your computer. Okay, so we're going to sneak down to where we were a few minutes ago. And we're going to load in that image again of the soccer ball. And that was just called soccer ball JPEG. Okay, and again, you notice it's really white and it's a JPEG. Okay, so you can't make it transparent yet. But what this program lets you do is resave it and change the format. So it even gives you little hints here. Look at what it says. Now, it doesn't do GIF, although it does PNG. So it's good. I want to do a PNG. And it even says, hey, if you want to do PNGs, those are good for transparent full quality. So I'm going to press it. Okay, and then I'm going to press OK, and hopefully it prompts me to save it somewhere on my hard drive. And this one we'll call lecture soccer ball, but notice it'll have .png on it, so I'll know which one's which, and I'll press save. Okay, so that's the first step. So I don't need this program anymore, and I'll get out of it. And now I'm going to go to this other one that I found. It's called Online Image Editor, and again, it's free. All right. And it makes transparencies, and actually a really cool way to do transparencies. I hope I don't mess it up, but it's a neat program. So first thing you do is you choose a file, and remember I got to pick the one I just did, so let's make sure I pick it. What was it called? Lecture Soccer Ball PNG, there it is. And then you press upload, and in a second you'll see it switch to a different screen, and actually I'll widen this out now so you can see it a little better. Let's widen it that way too. Okay, and there is our soccer ball. It still has the white around it, which I don't want, but now in this program we're going to use it to make it transparent. Now I don't see anything here that says transparencies, so you go to this next tab, Wizards, and there it is right there, transparency with a cute little diamond on it. I'm going to press it, and I just leave these settings here. I don't fool around with them. Basically what you're going to do with your finger is you're going to tell the computer where you want the transparency. I'm just going to press here, and you'll notice in a matter of seconds everything is now transparent. And you notice that showed a checkerboard to tell you that you've made it transparent. Now I'm going to goof around here for a second, and let's pretend I wanted to make this part of the soccer ball transparent. I'm going to press right there, and look what it did. It just made that little piece of the soccer ball see-through too, which is kind of cool. Or you've just wrecked your soccer ball, whatever way you want to think of it. So this is a really neat program, and obviously it better have a save or this work is wasted. There it is, save. Okay, and we're going to save it on a local hard drive. And we got to work our way to that folder again so that we put it in the right spot. Okay, and we're in here, and we're in images. And oh, it's got even a funny little thing at the front. So you know what? That's going to be an easy way to remember what I did. OIE and then transparent PNG. I'll just press save. Okay, and now we got to prove it to ourselves that this worked. So we'll pop up that program from before again, and we'll make another picture box. Okay, very quickly. I won't even name the picture box. I don't really care. Let's just get it in there to see if it actually did the job. And we'll go to a local import, and we'll snake our way to images, and it's got that funny beginning, right? There it is right there. And we'll press OK. And again, you won't see it, so we're going to have to put the stretch property on it. And there it is. And just for fun, I'm going to drag it over the green. And look what it did. I think you can see it. Remember how I fooled around with that little transparency and I made one part of the soccer ball see through too? Isn't that cool? Okay, so these are some of the graphic skills I'm trying to give you that make your programs blend into any background. And you can really see it in this one. This is actually really well done. Actually, I think it's better than Fireworks. So the whole background became transparent, and just the parts that I wanted the soccer ball in that little hole in the middle, which is kind of cute. All right, and you notice also that we have a little bit of extra space here. Okay, so there's ways to trim that. You can load up a program and crop it so that it just takes a certain part. So there's all these little things that you can make your program look a bit more professional. Okay, so there you have a little bit of graphics knowledge. And actually, I'm going to scoot back just for a second to Fireworks to show you how you could trim that. It's several techniques. The most common one you probably know is where you crop stuff, but there's a really cool one in Fireworks I want to show you. A little bit of bonus action here. I just reminded myself when I did this, hey, I got a really cool way to trim the fat, so to speak, from this soccer ball. So I loaded in the one I just did a few minutes ago online. I put it into Fireworks. They can all talk to each other. It's all good. But you should notice here that it has this extra fat here along the sides. And you're going, well, who cares? Well, remember, when you get really close to the wall and you think you've hit the wall, this ball is going to stop right there because its bounding box is so big. It's got this extra stuff that you don't really want if you're making a decent game. So there's a really cool feature in Fireworks called Trim, and I think it's in Modify. And I'll slide the screen down so you can see where Modify is. So it's in Modify, Canvas, and then Trim Canvas. Now watch what's going to happen to it. Let me show you the before. Okay, so this is extra white space here. Here's the main ball, obviously, but there's white space around it. I'm going to go to Modify, Canvas, Trim. And you see how it gets really tight now? And now when I save it, that's going to be perfect for games or whatever else I want to do, whatever animation. Whoops, I had to save it to the right spot though. Okay, so and I'll give it a different name too and stuff like that. I'll call it new. Okay, so that's a neat feature. Some programs also have that feature called Trim. If they don't, you can use cropping where you click on this thing right here and then you pick a section of it that you want. And then you cut it. Okay, now I've just ruined it all, obviously, but you could also use that technique to help you fix or trim up things. Okay, guys, so that was a nice little in-between break between programming and our next topic, which is collision detection. Getting things to move across the screen under keyboard control. All kinds of cool things coming up as we get to our next sort of game that we're going to develop, which is called a falling objects game. We'll do that in a couple lectures from now. Okay, so hang on tight and thanks for listening. Hey guys, how's it going? I'm really excited about this lesson. In this lesson, we're going to take a look at how do you figure out when two things, people, objects hit each other. So we're going to learn about collision detection. And the second thing we're going to do is let's try to avoid those people coming at me. So I'm going to start teaching you how to use the keyboard commands to control your car, your man running across the screen. So we're going to do some really neat things here. We're getting closer to having enough concepts to develop a second decent game. So hang on, it's going to be a great lesson. Okay, so first thing I need to describe to you is collision detection. And I'm going to do a little bit of doodling on the screen to give you sort of like the background on how we're going to develop the coding. Let's say we've got two objects, and we'll call this one object A, and we're going to call this one object B. Now object B is going to hit object A right around here. So this is object B. So when did that collision occur? So basically what we'd have to know is if we know the top location of object A, so whatever that is, the X or the Y, I mean, we're going to call it top. So the A top plus the height of object A. So if we get those two pieces of information, and if those two added up is greater than the top of B, that means there's been a collision. So you see how this is all of A, and it's smashed into B, which is from here down. And that is a computer term, A top plus A height greater than B top. Now that's not the only collision that could happen. We have to also consider, well, what if this is A and B came in from the top, from there? Then we have another set of if statements, okay? And then that set of if statements, basically, you would have to worry about A top being greater than B top plus the height. So you start doing all those combinations. Let's do another combination. you could have A and B comes in from this angle. Okay, now what would that combination be? Well, in that combination, there'd be a collision if A dot left, and I'll try to squeeze this one in this time. A dot left is less than B dot left plus B dot width. So I know it's a bit of a scribbling there, but do you see the idea? So like this location right here, is it less than this location? If it is, B crossed over into A. So there's 4 possibilities, and I'll just scribble the last one up here. This is where B comes in from this side on A. So you have to consider all those 4 possibilities. Now there are other techniques, and there's actually some languages have built-in collision commands. But right now I want to show you numerically all the thinking that would be involved in a collision. So we need like 4 if statements, or we can combine them in one big if statement saying, is this true, and this true, and this true, and this true? And if it is, we have collision. So now let's get rid of all this garbage in front of our screen and actually load up the program to demonstrate the idea. So it's in our demos, zipped, unzipped hopefully from before, and it's called Collision Detection Demo. And we'll give it a quick run, and then we'll talk about how it works. So we've got this man. He's not going to move around. He's just going to stay there and tense up because he's going to get hit in the head with a soccer ball in a second. And the way we'll know is we're going to make a little sound effect, and we're going to bounce back the other way. Okay, so let's take a look at how we did it. We'll review some of the ideas we've done from before, plus introduce, obviously, collision. So we're going to be using graphics, and we're going to use the draw image like we did in the last lecture. We're moving down the screen, so we're going to use image Y as a variable for the Y position. And we're using the direction to change from +1 to -1. We make an instance of the panel. If it's not on, if it's false, we turn the timer on. We initialize at 0 for the height. The direction is 1. And we clear the screen just in case there's anything there, because we're going to be animating. Remember, we want all that garbage to be disappeared. Timer off means we've stopped the game. Okay, so here is the main part of the animation now. So this part in here is my kind of crazy way to mathematically come up with the soccer ball being sort of in the center. Okay, so I take the panel width minus the size of the ball divided by 2, and that's my magic number. Now, you could have just made up a number. If it looked reasonable, it's fine. So this isn't crucial. Okay, this is important, you know that. That's the trick that we use to make something look like it's animating, the illusion of animation. It wipes it out, and then we redraw it. This is what I've decided to do in this question. I've decided to cut up the screen in hundredths. So if the screen is 1,000 divided by 100 is 10, I would be going down in 10 pixels. Let me just move this over a bit so you can see this next part a little bit better. Okay, this is how I draw the soccer ball on the screen, and you've seen me do it before. You put it at this location and this size. Now the crazy stuff. Now the crazy stuff, I don't know if I'm going to be able to show you all in one shot, but you know all those different conditions. There's 4 conditions to have collision. You could come from the top, the bottom, the left, or the right. We have to worry about every one of those, and I put it in one gigantic if statement. And here's what I'm going to do. Where the ball is in terms of its x position, plus its width, if that's greater than the left side of the man, we have collision. Okay, so here's the man at the bottom. Okay, and it's saying, and this is one of 4 possibilities. This isn't the one that's probably going to happen, tell you the truth. But if this was the soccer ball, okay, let's just do a little bounding box for the man for a second. So this is the soccer ball, and it comes in from this side. Okay, so what this line is saying is if the x position of the soccer ball plus how wide it is crosses over the left side of the man, you have collision. Okay, so there you have it now as a real computer statement. It's that kind of logic you have to apply to all 4 sides of the bounding box. One of those is going to work. Okay, so hopefully all of them end up being the correct ones. here is the second one where you come in from the right-hand side. This is the one where you're coming in from the top, and then this is the one you're coming in from the bottom. All right. Now, if that condition is true, we have collision. So now what we have to do is figure out how we're going to go back to the top. So let me just draw the man here for a second. And the ball has hit him in the head. Now we have to figure out the location of our next move. So basically we take the top of the man's head, take away the height of the ball, and that puts us right here. So we start our path upwards from that point on. When we get to the top, we'll be at 0. And then when the image is less than 0, we reset to 0 right there. And we change our direction to go back down. And there is, in a nutshell, collision detection and then being able to reverse paths upon collision. In our next step, what we'll do is now take this idea and have the object at the bottom get out of the way. Try not to get hit, avoid. So we're going to introduce the keyboard movement. Now to demonstrate the keyboard movement, what we'll do is we'll load in my next demo. Okay, and these are all in your unzipped folders that you did for yesterday and today's lectures. And this one's called keyboard detection. Okay, and we'll load it up. Okay, it's going to look basically the same as the last one. I'll give it a run right now. And what you'll see now is the object down at the bottom, and I'm using the J and L keys to move. Now you see quite a bit of flicker too. We'll figure that out after. Well, yep, we got him. And then you can move out of the way though. Okay, so you don't always have to get hit. You can move out of the way and the player is moving back and forth. All right, so the first thing you're going to have to realize when you do keyboard detection, there's a special thing in C# that you have to do to the form. Even though we're working inside the panel, you have to do this special key wake up command. And it's a property actually. And we'll slide up and it's called key preview true. Very often students forget to put that property in. If you don't, it doesn't work. Okay, so make sure you're on the form. You're not on one of these things, you're just on the form and you set the key preview to true. That's an important thing. Then what we're going to do is, you know how we have mouse down and mouse up? There's key down also. Okay, and we're going to use that command to wake up the keyboard and then say, hey, which key are you pressing, by the way, when you're putting your finger down on the key? And then that'll determine the path that we want to go. Okay, let's go into the code and take a look. Okay, so at the top, we have a couple of new variables that we haven't seen before, man X and man Y. So that's going to be the location of the man that's going to go back and forth, because I'm going to make that basketball guy now move across. He's not going to dribble yet, but he's going to move across. Okay, let's move down a little bit. Right here, nothing super major, but we've got a couple of key lines here. We want to line up that man down at the bottom. So you've got the entire screen here. So there's a little bit of calculation involved. That guy that's going to be trying to avoid the soccer ball now, he lives down here. Okay, and we got to figure out roughly, you know, the height and the X. Let's do the height first. Panel height, so the entire height of the screen, less the height of the person. That'll line us up right there. So that's good. Okay, got that one. Second one I kind of made up. I want to put him sort of in the middle of the screen, right? So I figured out what's the width of the whole screen. Okay, less the width of him divided by 2, and that'll give me roughly the middle of the screen. Okay, so that'll put him right here. All right, that's important to know where he's going to be. Now, as he moves side to side, this won't change, the Y, but this X is going to change. It might go 5 more to the right, 5 less, and go backwards. Okay, so you have to realize that. Here's how we clear the screen, obviously. And then this is how we draw the man initially down at the bottom. Okay, he's living at that location. Okay, and right there is the position of him. Okay, the position of him. And then there's his width and height. Okay, let's slide down a bit. Now we get into the timer. The timer you've basically seen before. This is the X position. Okay, this will clear the screen. This is how fast the soccer ball is going to go down. But now we're doing 2 things. We're dropping the soccer ball, okay, which is based on image X and Y. and we're displaying the man, okay? And which is, that's the location of the man, and that's where he is down here. Okay, now, this checks for collision. I showed you that in the last example. If there is collision, we beep, we make the ball bounce back up in the opposite direction. He might also hit the ground, and he's going to hit the top. Okay, so how do you actually get the keys to wake up and do what I tell them to do? Well, there's a new command called form image key down. Now, how did I get that? Well, if you forgot, you click on the form and then you have to click on the lightning bolt. And you're going, well, how come you don't click on the panel? It's all connected to the form. And then if you go through these, there's one called key down. So you have to click on the lightning bolt and then the event associated with the form. Remember how there was that mouse stuff way down here? Mouse, hover, enter, down, all that stuff. There's one called key down. Let's double click on it. This is the key down. And in the key down, it sends you an event that happened based on a key code. And all you do is you say, make it equal to whatever key you decide to use. So I decided in this one to use L to go to the right and J to go to the left. So when I go to the right, wherever the man used to be, I'm going to add 5 more to his X position. If I press the J key, he goes 5 backwards. And then I redraw it. And I noticed when I was redrawing, I've got man X. All of this right here can actually be man Y because I declared them up at the top. So I think I'm going to also change. I think I've got another spot here too, same thing. This isn't wrong, but I have a nice little succinct little variable that I had already pre-made, so why not use it? And I don't think I see it anywhere else. If I do later on, we'll test it out and modify it. But there now is when I'm in the key down event, the person is going to move a little bit to the right or a little bit to the left, depending on what I decided. Now, if you're not sure how I got these, watch. It's really cool. If you type in the word keys dot, it gives you all the different keys you can press down, right? And obviously I just pressed the letter L, but you can use other keys and we'll discuss other ones later on in the course. Okay, time to test it out. One more time, so we press start, and so I'm pressing the J key, it goes backwards by -5. I press the L keys, it goes forward, and this time I'm going to avoid it, so it's going to bounce off the ground and come back through the other end. All right, so sometimes you can have a bouncer. This one came out the other end. So there was a technique we did before when we were doing collisions against the wall. So this one bounces the other way. I threw that in just for the sake of doing something different. And if you can't remember how you do that again, this is how, if it goes right to the ground, you make it come out the other end. And that's actually so far out the other end that it's off the screen. It starts up here in negative territory and glides gently through the top. Okay, so there you have collision detection and keyboard movement. And now, just to incorporate a dancing man, let's finish up with the last example. Now, as usual, I'd be remiss if we didn't have the dancing guy. He's not just moving back and forth statically, but actually moving. So let's go to fully animated keyboard, and it's this one right here. Okay, and I'll load it up, show it to you very quickly. And you're going to notice something that we're going to try to fix a little bit of in our next lecture. So a little bit of flicker, not a lot, but there is flicker. Okay, and we'll take a look at one of the techniques, and actually I do a little bit of it in this one because there is quite a bit of flicker when it goes back and forth. So you're going to see in this example that I'm going to take up with you right now a little bit of an extra little feature that I added. So first thing, very quickly, we now have 2 timers. Obviously, we have the timer to control the dancing man. And if you forget that, we've done that quite a few times. So now we cycle through the images, we load them in. I'm not going to spend a lot of time explaining that. Let's slide up to the top. The one extra feature in this one is when I was doing the last example and a couple before that, the way that we did the animation, we drew the man and we drew the soccer ball, and then we wiped out the entire screen and then redrew it again, which is okay. But as you get more and more objects, you're going to get a lot of flicker. So here's one simple solution. There's better ones than this that we'll talk about in future lessons. But what I did is I create a solid brush. So what I'm going to do is I'm going to simulate a square the size of the man, and I'm also going to simulate a square the size of the soccer ball. And I'm just going to paint over those little sections, not the entire screen. And that should reduce a little bit of the flicker. Now, to do that, here's what I've got to do. When I draw my objects, what I'm going to do is I'm going to draw a little rectangle right over the screen. And first of all, remember, to draw rectangles, you need solid brush. So if you're wondering why did you do that, that's why I did it. Okay. Now, where do I use it? Let me go down and I'll show you. As I have the ball and the man moving around, what I do is just before I move them, I draw 2 green or whatever the color is at that moment over top of those objects. So you see right here, instead of doing that clear to the background color, now what I do is I draw rectangles that match the size of each one of them. And again, this one from the last section here could be man Y. So if you're wondering how come it's not that, you can have man Y there. Okay, so that's just going to draw a rectangle right over them. And then you draw the 2 objects, and then you check for collision like before. Here again, same thing. When you start moving the man in the key down position, what you do first is you fill the location of the man at that moment. And again, this could be man Y. You fill it up at that moment, and that wipes out the man, and then you redraw him in a new position down here. Okay, and that does reduce a little bit of the flicker. I don't know if you can really tell that much of a difference, but that reduces a little bit of the going back and forth. If I didn't have that in there, you would see them flicker even more. Now, is this the best solution? No. We're going to show you some other techniques in a few lectures. One of them is called back buffering, which really is the best way, because imagine, I'm redrawing this in green, but what if I've got like a really funny background with all kinds of different colors? Then this technique wouldn't work. So I'm right now depending on the fact that I've got a paintbrush that's in green, but it's not going to work when you have a multicolored background. So another little option, a little bit of extra, and just in case you wanted to see that. But that's the next step in the process as we get even more sophisticated developing software. Welcome back, and in this lecture we continue tweaking. So what have we done so far? We've gotten some objects to move across the screen. We initially used the dot left and top commands. In the last couple of lectures, we've used the draw image command, and this is the one we're going to focus in on. And today what we're going to do is eliminate all use of picture boxes. So basically everything is going to be loaded in from an external file, all our images, all our background images too. And when we redraw the screen, instead of just wiping it out with a base color, we're going to have a real background. So the background is going to be used to wipe out our objects and initiate and continue our animation. So it's going to be a little bit of tweaking. And the reason for this is, one, to improve the look of the screen, and to improve the speed and reduce the flicker. So that's our objective. And as we do this, we're getting closer to creating our second game. In this lecture, we're going to focus on one program. I'm not going to do a bunch of them in this one, but because it's so important, I've really emphasized the documentation. And when we do small programs, it really doesn't matter. But as you start building more detailed and complex programs, it really is important to document fully everything you're doing, to explain to the user, and in my situation, explain to you guys what I'm doing. So this one, after you hear me explain it and watch the video, you can actually load it up on your computer and analyze it even more. Okay, now very quickly I will do a quick run, as I always do. All right, let's see what happens. So basically it's the same program as before, except the background is changed now. It's not just a simple green color. All right, and here it's going to go all the way down, and it's going to go through and come back up the other end. This time I'll hit it with my head, okay, just to show you the collision's working, and then it bounces back up and hits the top. Okay, so this is the basic program now. So now we don't really care what the background is. We don't have to worry about, oh, is it green? If I got to repaint it green, we're going to redraw the whole screen in the background. Let's look at the code. And it's fully documented. So if there's stuff that I've added on, okay, I wanted to make sure you realized it. Now, in this particular example, you don't notice any picture boxes anymore. No picture boxes, okay? We've got our panel, as we've done all the time, and everything else is loaded from a file. let's go into the underground and take a look at each thing. So initially, we're definitely still going to use an array of images for the basketball player. The background is now also an image, okay, which we will load in a little section down below. The man is an image. The ball is an image, okay. We're going to have a counter for the dribbler. Obviously, we're using graphics, so we are going to make an instance of that class in a second. This keeps track of the position of the soccer ball dropping from the sky. This is for the direction. This is for the man down below. So everything's very structured, okay? And as I mentioned here in the comments, we don't use any picture boxes anymore. Everything's an image object, and that we're going to load in, okay? Because we're using a multicolored background, I mentioned here that I can't use the solid brush. That was a little trick I showed you in the previous lecture to try to reduce the flicker so that we zeroed in on just the rectangular shape around the person and the ball, but can't use that trick anymore, okay? So that's gone. Now in form load, we make an instance of the graphics class and make it point to the panel. So every time we use G, it's going to be drawing on the panel. I've commented out these now that used to be there. I don't like to erase them so that you can look back and see what did he change. Okay, this is how we load in the background and the ball. So now I have the ball, the soccer ball that's transparent that I load in. I've done that lots of times. But now I'm also loading in the background. Now notice, both of these are going into variables that represent images, okay? They're not getting loaded into picture boxes or anything like that anymore. This you've seen a ton of times. This is the loop that grabs all the 7 images of the dribbler. This takes the first image of the dribbler and stores it into man. What the heck is man? Man is an image, okay? Everything's an image now. So nothing is being stored on the screen. This line right here, set focus, is used a lot when we use the keyboard, okay? It's just a way to say, hey, wake up, main screen, I'm going to start pressing on you, so you better know what I'm pressing. Okay, now let's click on begin. When we click on begin and the timer was off, we turn it on, obviously, and we make the man point to the middle of the screen and right at the bottom. And remember, we did the calculations for this before, how we made the man line up so he was level to the ground. This is going to be the information we need for the ball dropping from the sky. Now, this is how we used to wipe out stuff. We're not going to do that anymore. The way we're going to redraw the screen, so to speak, is we're going to use a draw image. And here's another form of the draw image where you feed it the image you want to draw and then the starting 2 points. Now, you got to be careful here, I got to admit. When you have a screen like this, I knew my background screen is at least as big as my screen, okay? Because I haven't included the last 2 numbers, which is the width and height. So what it'll do is it'll start drawing the background here and fill up the whole screen. So if you have a really gigantic background, it might make it even bigger than this screen, but you'll only see this part of it, okay? So that's what that's doing. It's drawing the entire background right on the screen. Now, the order is important. So I'm going to draw the background first, and then I'm going to put the people on top of the background, not the other way around. Otherwise, it wipes it out. So here is the initial position of the man at the bottom, the dribbler. Okay, and then we're ready to actually start doing our main animation. Before I do the main animation, I might as well slide down. Okay, remember, this is how you get the guy dancing. This is the timer 2 that's being used to make the dribbler dribble. Okay, so here's now the main animation. In the main animation, this is how we did it in the last example, last lecture, where I was trying to make it a little bit better than the one before, okay? But instead of wiping out the screen with the back color or the fill rectangle, which won't work now when we redraw the graphic over the current state, we use this, okay? So this is going to be like our main technique, and we're going to carry this through for the next, half dozen lectures from here on in. This is how I'm going to make the soccer ball drop from the sky. You've seen me use that a ton of times. This is the old way again, how we used to draw from the picture boxes, those images and the man. We don't do that anymore. Now we use GDraw and we draw a ball image object. And here is the location, okay? And then we draw a man. and here is the location. And again, we don't need to specify the last two parameters, which represent the width and height of the ball. If you don't put them in, they automatically default to what size they happen to be. If you wanted to make them skinnier or smaller, you could go in there and modify them, but we're going to leave them like that. There is our collision check routine. That's a pretty long thing. We went through that a previous lecture. This is what happens if we collide into somebody. We want to bounce back the other way. This is if we go down to the bottom. We come all the way back up to the top and through the roof, so to speak. And this is if we hit the wall at the top. Okay? Now the key down event. And again, I've got some notes here for you. Sometimes in the key down event, and this is even something that's new for this, I threw this in here, but it was overkill. I'm already redrawing the screen in the one tick routine, the timer routine here, timer 1 tick. And while I was moving this guy, I said, you know what, maybe I have to redraw him here. But when I put it in, there was way too much flicker. So this is something that you can't just sort of prejudge or know ahead of time unless you experiment. That's what I love about graphics. You just trial and error a lot of it. Obviously you got to know some coding too, but when you're running, you go, oh, that didn't look too good. So you say, well, let's tweak it a bit more. So even though I've been teaching you this today in this lecture, in this particular case, it was overkill to include this also in the key down event. So I commented it out. All we need in the key down event basically is check what key you pressed and make the guy go a bit to the right or a bit to the left. Okay, we don't need to redraw them or anything. It'll all take care of itself in this timer because timer works fast enough that it'll recover from what you pressed and get back to the timer event and redraw in here instead of having to put it all in here. Now, was I smart enough to know that when I did this the first time? No. I put it in and I go, oh, geez, that doesn't look too good. So you don't know until you try it. And now when we run it one more time, okay, so when you move it, not that bad. It's fairly smooth. You don't get a lot of flicker. Again, it's hard for me to judge when you see it on your computer at home, but it's going fairly smooth, reducing the flicker. And again, this is a really basic animation. This is all I could find, and this is all I wanted to do, but you could change the background to something even crazier. Obviously, you're going to have different objects falling from the sky, and you're going to create a game in a couple of lectures that have multiple objects falling from the sky. So it's really important to try to reduce the flicker because the more things you have being drawn on the screen, the more intense it is for the computer and it starts to lag a little bit. So you want to try to make it as efficient as possible. Okay, so this is all we're doing in this lesson. We're just about at games. The next thing I want to do in our next lecture is discuss now, get rid of the stupid beep. Okay, again, we're tweaking. So let's make a real sound effect. We're going to get sounds from the internet, maybe sounds that you create yourself, and incorporate them in your game. Okay, so thanks for listening, and we'll see you in the next lecture. In this lecture, we're going to look at how to play sound effects in C#. We will look at two methods. We will look at a method that incorporates the media player that you're probably familiar with that's part of Windows. And the second technique will use a special class built into C# called the System Media class, which will be used for little short bursts of sound, whereas the media player will play maybe our background music. Okay, so let's take a look at sound effects in C#. Let's get our hands dirty in this one, and we'll start from scratch, and we'll do it together. We'll start up, and we'll call this sound effects, and we'll click OK. And we'll call this form sound effects. And we'll put a little title on it. And this one's specifically for the media player, okay? This one, it's kind of tricky to find out where it is, so I want to make sure you know how to do this one. The other one we'll show you in another example. So let's call this media player demo. Okay, and I'll even throw a button up here. I'm not going to get too formal with the button though. So that's not going to be the important part. Now, you know how you have all these different controls here on the side? I don't see one for like playing music, sound, anything. I don't see a media player. But literally there's thousands of other ones that you can attach to the toolbar. I think I've shown you a few of them, but here is how you get to all of them. Down here at the very bottom, hopefully you can see that, I'm going to right click on it. I'm going to click on Choose Items. Now, I pre-did this before the video, so it only took a couple of seconds. If this is the first time you're doing it at home, it might take a minute or two, even longer, depending on how powerful your computer is. Now, these are all the other things that you can attach to the toolbox and then drag them in. There's all kinds of really cool things. And the one we're looking at right now is the .NET framework components. And then there's these COM components, and it chugs away, and there's all kinds of things there. If you have Flash installed on your computer, you can drop a Flash object on there. There's tons of them. I have no idea what most of them are. Some of them are useful, some of them aren't. They're all in there. It basically scans your computer for any things that it can attach as an object, a little control that you can add to a C# program. There's universal windows here. Some of them, again, I recognize, some of them I don't. WPM, but we're going to look in the COM component. Oh, there's accordions, all kinds of neat stuff here. Let's look in the COM component, and we're going to work our way down to W for window. Whoa, did I pass it? Just about there. So window, there it is, Windows Media Player, right? And I'm going to check it, and then I'm going to press OK. Now, where to go? There it is way down here at the bottom. All right, and what I'm going to do is I'm going to drag it onto the form. Takes a few seconds to work itself out. Now, this is where it's up to you. Do you really want to display this on your form, or do you want to hide it? Okay, you don't really want people to know about it, but it's there. There's the Windows Media Player. If you blow it right up, you'll get the screen and everything. It's actually kind of cool. Or you can hide it. Okay, you can make it visible false. So let's slide over here for a second. So visible, we're going to make it false. Okay, now you're saying, it's still there. Well, when you run it, you won't see it. Okay, so there it is, and obviously you don't see it now. Now, we're going to make this button have it play a sound or sound effect or whatever. Now, where do you get sounds from? Well, you can go on the internet and get them, and I'm going to show you that in a couple of minutes. But for now, I've already got a sound that I copied, and it's on my hard drive, and there it is right there, world.wave. Okay, now before I get rolling, I have to make sure I save this, and I'm going to copy this into the bin folder. So let me pop up here again, and I'll do a save all. Okay, and let's find out where I saved this. Remember, I called it sound effects, so I'm going to slide up here. There it is right there. Okay, so sound effects in there, I'm going to have to copy that sound I just showed you. So let me sneak back in here again. And I'm going to copy this, and I got to put it in the bin folder. Okay, so I'll paste it in here. Just like it's the same place where you put your pictures and stuff like that, your backgrounds. You're going to put your sounds there too now, all in that folder. So the computer's going to have an easy way to get to it. Now we're going to come back here. Now this, it's got a big long name to it. AX Windows Media Player 1. Okay, so I got to remember that. Well, as soon as I start typing it, it'll help me out, obviously. But that's what it's called. So I'm going to double click in here. It's pretty easy to use. Okay, so what you do is you go AX, and see, it knows already what I want. Dot, what are the choices? We want URL equals, and now we got to make it point to where my stuff is. Remember how you make a stuff point? You go application dot startup path, right? And actually, you can just click on it, and then we got to attach. We always do that ampersand, and then a quote backslash. Okay, and I think it was called world.wave, and then put a semicolon at the end. And that's all it takes to play a sound. Now, you're going to see in the next example, sometimes you want like a background music playing and then sound effects going at the same time. Well, you can't use this one and another one at the same time because they'll stop each other. So one will start and the other one will stop. So you're going to see a trick in the next example. I'm going to use this for background music, and it'll keep playing. And then I'll have another thing called the system media methods and class that will allow us short bursts of sound, and they won't collide or stop one or the other. They'll be able to play at the same time. Anyway, let's see if this one actually works. Okay, I've got my speakers up pretty good. And when I press this button, it plays the sound, as corny as that sound is. And that's all it takes to do sound effects. Okay, basically you take a sound that you find on the internet and then you put it in the bin debug folder and make point to it, and then add the Windows Media Player and .url, and that points to it. All right, now let's look at one of my pre-made demos, which is going back and going to that game stuff we've been talking about, and I sort of incorporated it. Now it's called Sound Demo 1, and I'll load it up. And I'll give it a quick run. And yes, that's the falling objects, the soccer guy, and he can move. And there's different sound effects. So that's the background music. It's not that long, but that was the background. So he got hit in the head. I got a sound for that. Now when he hits the top, I think I got a different sound for that too. There's a sound there. And I'm going to let him go right to the bottom, and I think I got a sound effect for that one. Okay, so you can use multiple sound effects. Now, if that opening music had been long enough, it would still be playing now too. And it comes out the other end. So those are a bunch of different sound effects. And you see, I wanted you to know that we were using Media Player and a few other things, okay? And that few other things is what I want to show you right now. Okay, so first of all, you realize that the sounds that I'm using, and I'll work my way into that folder to show you. So you go on the internet, and I'm going to show you a site in a few minutes. You go on the internet, you find some demos. Let's sneak all the way in here. WAV files are good. MP3s are good. Okay, those are the basic ones. Waves. In this one, I used all waves. Cheering wave, wall hit, world wave, and mist, and paddle wave. Okay, so there's all kinds of different sound effects that you can use and employ in your game. Okay, let's slide up. First thing you have to know, and this is like really, really important, the computer doesn't put it in for you if you don't do this. You have to actually handwrite that line in using system.media. And it's needed for the sound player class. That's the formal name for that. What this allows you to do is you don't need like to have something dragged on from the toolbox to use this. This is a special thing that you actually code. So it's a little bit different, and it allows you to have quick bursts of sound. These sounds won't interfere with the media player sound. So that's why I'm saying you could use that for your background music and play that throughout your entire game, while these are being used for like shooting or whatever else. Okay, let's take a look at these lines here. Now, probably been a while since we used some of that object-oriented stuff again, but here it is again. This is a class, the sound player class, okay? And we're making an instance of it. And the first one we're going to do is called wall, and we'll make a new object of it. And then we've got a mist object and a cheering object. This other stuff you've seen a million times. I'm not going to talk about it again. In the load event, these objects that you named up here, now there's a property called sound location, which basically says, where are these sounds that I'm going to remember in this word called mist, which is going to hold a sound. You know how we have images? Now we have one for sounds, okay? So this is the wall, and it's located at wall hit and then cheering, okay? These things here are different ways to load the files. You can load them asynchronously or with the load command, okay? Asynchronously means they can do them at the same time. With the load command, it says wait until I load it up, don't do anything else, okay? I like the asynchronous better. It's a little bit faster. Okay, but it doesn't matter. All right, so we're basically set now to use the sounds. We declared them up here as objects. Then we told the computer where they lived. And then we sort of loaded them, and they're in now their memory. Okay, and they're ready to be spewed out when I tell them to. So where do I tell them to do it? Well, the first one, as soon as I start my fictitious game, let's say, when I click on OK, begin, there is the first sound. That one has nothing to do with the three I just showed you. That was the one that uses the media player. And that, if it was long enough, would play throughout your entire game, uninterrupted. Okay, now, as the action begins, like you get hit in the head or that hits the ground or something, you should have a different sound for each event. So notice here, this is when the guy gets hit with the soccer ball. And look what you do to play the sound. You just say the name of the sound, .play. Pretty easy, right? It was just setting it up had to be a bit of a pain. Let's say it goes right to the ground. Mist sound effect. Okay, and what if it goes at the top? Wall sound effect. All right, so different things for different situations, and you play them depending on which situation you want. Okay, so it's kind of cool, and that's all it takes to do sound effects. I've listed a couple of sites in the resources that are kind of good places to get sound effects. They're free. You have to join up to some of them, but there's no cost involved. Here's one that I really like called Freesound. And basically you type in what you're looking for. I'm looking for a bang sound, okay? And you press the search, and it'll come back with a number of answers. This is a wave, this is an MP3. I think this one is a .aiff, which I would steer away from, but it may work also. Let's say you wanted this one right here. You could just take a look at it first, listen to it. Okay, and you could try this one. All right, so if you like that one, you could investigate further by clicking on it, and you go to this screen. It gives you a nice little sound description of it. And then when you wanted to get it, you would press download. And there you see the name of it. Now, remember, if we wanted to put it in the exact spot where we have our stuff, you have to make sure you work your way down into the exact folder where you're going to use it. And what we'll do is work our way down into here, into the bin, and then debug. And we don't have another MP3, so that's why you don't see all the other sounds. You're going, where's the other sounds? This is our first MP3. There it is now, saved as an MP3 file. And now let's pop up Visual C# and have it point to it. So it's got a funny name, so I better pop it up for a second. And actually, I could even rename it, so I could make it sound something more reasonable. Bang would be all right. Do I have anything else with bang? No, I don't have anything else with bang in it. Okay, so I'll rename it to something a little bit easier to work with. And then see this line here that uses the Windows Media Player? That would be a great candidate for it, because I'm pretty sure the media player plays MP3. So bang.mp3, and then we'll give it a try. All right, so when we start, it's going to get a little scary. Okay, so that was the initial gunshot. All right, so it does work, and that's the process. Now, I think I've tried this before, but these other ones here that use the sound player class, they only work with WAV files, so those ones you have to use waves. The media player is a bit more forgiving, MP3s, WAV files. I'm pretty sure those are going to work on there. And the other ones I wouldn't take a chance with. I know that I saw another one called a .aiff, which is more for Mac computers. Might not work on our system. You could give it a try, but stick with waves and MP3s and you should be all right. So that's sound effects and how we're going to incorporate them into our gaming. So we're going to wrap up our next lecture with sort of a nice little application that's going to give you a hint on creating your own Falling Objects game. Take care, and we'll see you in the next lecture. It's finally here. In this lecture, we introduce you to the Falling Objects game. What I'll do is give you a sort of a background of how to develop your solution and then give you a few hints. Okay, let's start off and give you a rough idea what I want the game to look like. So you're going to have a main panel that you're going to play your game in, and you're going to keep track of the number of helmets you catch. Now, it could be any object. It doesn't have to be helmets, obviously. This will tell you when the game is over. There'll be a countdown timer. You can see it right here, counting down, and there's a start and exit button. And the start changes to stop after you start up the program. So these objects, I'm going to have 4 objects, maybe 5. I'd like to have 5 actually, fall from the sky, and you're going to have a person down here going back and forth catching them. Some of them will fall faster than others, so you can make it so that you can give certain ones a higher point value. Here are the specifics if you want to follow along to this particular game. It's going to be a 60-second time limit. You'll have a timer in the text box work its way down from 60 down to 0. Now, like I said, the score will depend on the speed of the object. So you can randomly give each object that's falling from the sky different speeds, and depending on the speed that you caught that object at, you're going to give yourself more or less points. And again, this is something that you can modify to your liking. I've just given you sort of a guideline here. You can stop the game anytime before the 60-second time limit is up, and you should include some sound effects as you catch them. Maybe a certain sound effect for a higher point value and a certain sound effect for a lower point value. But at least this gives you a rough idea what I'd like it to look like. Okay? Now the thought process to develop the game. My first instinct, and you should also have this first instinct, is didn't we do a program like this? Haven't I been showing you this stupid soccer ball falling from the sky and the guy at the bottom getting hit in the head or sometimes running away from it? So that should be your guide. So if you don't remember that, well, obviously I hope you do. We've been doing this type of thing, and we've been moving this player left and right, and we've been testing out collision and sound effects and stuff like that. Okay, so let's take a look at this again, and then we're going to notice that this isn't going to be good enough. So this one here basically has the man at the bottom. That's cool. And that image that's falling from the sky, that's for the one soccer ball. Okay? And then when we get into the main loop, which is in this timer down here, we're getting to it. Okay? This timer here, what we do is we redraw the background. That will be the same in your game too. We make the Y value of that soccer ball go down a certain amount. Okay? Now there's where we're going to get our first little problem. That's for that soccer ball. Do we have to make another one for the other soccer ball? Let's say we had 5 soccer balls falling. Yeah, you would have to. And then here we have to draw the ball. Now, would we need 5 of these for the 5 different soccer balls dropping from the sky if that's what we were dropping? Yeah, you would need 5 of those. This is checking for the collision of the first soccer ball. Would we need 5 of these? Yes, you would need 5 of these. So you're starting to see that actually this is okay. This would only be one because there's only one man. And this would be the loop for the animation. That's okay. It's just in here, it can get really ugly. So even though this is a good start, and this will tell you how to make the objects fall and collide and everything else, we got a problem, and you know what's going to save us? The dreaded arrays. Okay, so let me give you my second set of hints that'll even help you a bit more. All right, what I've done in the resources for this particular lecture, I've included some sample games, developing them from the most simplistic technique all the way to the one that I'm going to show you. Let you use that as the guide to do this particular problem. Okay, so it's called New Beach Balls Image Array Background. Okay, it's quite long, but let me load it up, and we'll have a number of the issues solved. And it doesn't show you the full solution. It doesn't have the countdown timer. It does display game over. It does display the current hits when you do them, and obviously it starts and stops. Okay, let me just give you a brief run. And it's my corny version of it. There's my player at the bottom, and he just got a point. Okay, and certain ones are falling faster than others. This one looks like it's moving pretty fast. I'm going to go over and hit it. Okay, so, and some of them I miss, obviously, and it's keeping track of the points. I'm not doing that marking or the scoring scheme too either. I'm just using generic, just you get 1 point if you get hit in the head. Now this one's going super slow, and you got a point. Okay, so you see how it works. Also, while we're here, notice that the objects falling in the sky are wider than my man, and that's going to be important when I show you the logic that I used to program this game. Okay, so I'm going to stop. Okay, so that's kind of what I want your game to look like. Obviously, it has one more feature. It has the countdown timer, which is probably going to involve another timer. Look at these timers down here. The game timer, the balls, the things dropping from the sky, this guy that's dribbling down there. I've got them all set up and ready to use. Okay. So, like I said, arrays to the rescue. When you have to keep track of more than one object, it's stupid to give them all separate names and then have to have separate if statements for each one. It'd be better if we could put them in an array and loop through them. And even if we had 100 guys, the program wouldn't change in size. We would just go from 1 to 100 instead of 1 to 3 or 4 or 5 or whatever number of objects you're going to have to cycle through as they drop from the sky. Now, let's take a look at the code. And we'll work our way up and try to reason it out. And what I've tried to do, again, really important, is comment everything. So one of the key things as we get better at software development is we plan out our solutions. We make sure we document everything we do. Okay, and then we have to program it and test it and debug it and everything else. Okay, so First of all, we are obviously going to draw on a panel, so we declare a graphic, which I decided to call my graphics. We're going to use random numbers, and the place they're going to come in is we're going to randomly pick the speeds that the little objects, whatever your objects are, that are going to fall from the sky. We are going to have 5, no, actually, is it 5 or 4? We're going to have a number of objects, okay? In our particular one, we're going to have 4 objects, okay? And again, let me just check, because sometimes you can have 5, sometimes you can have 4. I have 4 of them dropping from the sky, okay? It's up to you how many you want to drop from the sky. So when you have 4 objects, you always declare it as 5, one more than what it is. Now, each one of those objects, and here's the tricky part, okay? It's almost like, okay, here's an object dropping from the sky. Okay, it's one of the array values, but associated with this is also going to be its position. Like, where is it in terms of X and Y? We got to know that, okay? Because we're going to do some math later to figure out if you hit the guy in the head. Okay, so that's also a set of array values. Okay, you can't store them in separate variables. They got to be an array. So there's an array there. So there's an array for the actual picture. There's an array for the X and Y positions. And I want to know how fast this particular sign is dropping from the sky. So I need an array for the ball speed. So you see how this is super crucial to the solution. And this is how you're going to make this program, instead of being 500 lines, maybe 50 lines. Okay, so you need to use arrays. This stuff in here I'll mention right now, but you'll get more into it later on in the program. The size of the object that we're dropping from the sky, I'm going to keep that in a variable called ball size. Background image, that's going to be something I'm going to load in from the hard drive. Same with the image of the man. Okay, so we're going to use no picture boxes. Everything's going to be in objects and image objects. Okay, this is the dancing man. There's 7 of those pictures, so I declare it to 8. This is the X position. Hey, what happened to Y? Well, he only goes side to side. He doesn't go up and down, at least in my game. If you want to change yours, you can, but mine just goes side to side along the bottom. This is the initial value that he's going to start going through all the images of him dribbling. Okay, this is kind of a little cool thing that I throw in just to make sure that the game hasn't started. I initialize it to false, and then I check to see, is it false? Because if it is, then we can start the game because it hasn't been started yet. Here's form load. This is where I make an instance of my graphics class and make it point to the panel, which I've called beach balls. Load in the background picture, that space picture. This loads in the 4 objects I'm going to use in my game. This loads in the image of the man, which we've seen a million times, and then stores it into that variable. Now some crazy logic, okay? And I'm going to widen this a little bit so you can see it better. And this is kind of a reminder to me if I ever went back to this game a month or 2 later and I had forgotten why I had done something. See, when you drop the object from the sky, you might have to scale them. You might have them be too big or too small, okay? So my first idea was to use the actual size of one of the signs, but they were too small. Okay, they basically just took up a little tiny part of the screen. All right, and just to show you, you can uncomment the line below. So what I'm going to do for a second is see where it says ball size. All right, so I have a variable, and what I'm going to do is make the ball size the actual width of the actual sign. Okay, and I'm going to comment this one out. So I'm going to use that original one, and let's see how bad I wreck it. Now look how tiny they are. All right, and again, how did I know that? I didn't. When I test out the program the first time, I go, oh, that didn't look too good. So we got a problem. Now, what could you do to fix that? There's several things. I did my fix in math inside the program, but you could also fix it by scaling it in a drawing program. Okay, but that's basically the first initial idea. Okay, I'm going to have this size, and I'm going to use this mathematically somewhere. So what I do is I use the width just to prove it to you that it was too small. Okay, so what I did basically is resize the objects so they look better on my screen. You might not need to do this. Depends on the images you're using. It might be big enough, okay? Also remember, in my program, the following objects must be wider than the dribbler because I'm going to use a special if statement, okay? Now, what I did was I tried this next. I tried a little crazy formula. And what I did is I said, let me go with the width of the whole screen and divide it by 4. All right, and then it got a little bit too crazy. Okay, and then I tried another combination. What I did was the signs were a little too big and spaced out, so I took a little bit off each until they looked right. That's the neat thing about graphics. There's always some trial and error. Below is what I finally came up with. So this is the ball size that I decided to use for each of the objects falling from the sky. And again, how did I come up with that? I at first thought, okay, divide the whole screen by 4, but that was way too big, and then I shrunk it a little bit more. But this became my ball size. So this is the part you're going to fool around with a little bit. X10 means that's where the first object is going to fall from the sky. And now what I do is I do a loop that goes from 1 to 4, and I locate each one and store that into my one-dimensional array. Okay, so like I said, the first one gets stored at 10. Then what I do is, so if I've got my screen here, this first one's going to start coming down from here, 10 over. Okay, the next one is going to come down from where this one started, plus the size of this shape, which I've called ball size. Remember, I did that formula, plus an extra 20. So it puts it right about here. Okay, and then the next one goes over another 20, and then another 20, and hopefully that lines up nice. And all the time I'm saving the position in terms of X of these shapes that I'm going to use. Okay, so this is lining up all the shapes. Next. Okay, this is the key down event. I'll just do it in any order. It doesn't really matter. The key down event you've seen before. I just wanted to make sure that the game had started. So if the game hadn't started and you're pressing the keys and going crazy, you're not going to be able to move the man. When the flag is true, which means the game has been started, then you can move the man. And this is the basic stuff we've used before. And actually, let me show you where I turn on that flag. When I press start, okay, if the button equals start, that means, okay, now set the flag to true, which means now you can actually start moving the man around. I draw my background. I initialize a couple of text boxes and variables, okay? Then what I also do here now, which is kind of cool, is I've already lined up where I want my little images that are dropping from the sky to fall down. Now, here's another thing though. When they come from the sky, I want them to come in nice and slow. So what I do is they come in from up here, which is negative territory. You've seen me use this trick before. So when I initialize the program, they come in up here and they gradually come in, which is kind of nice. It makes it look cool. Here is the other one-dimensional array that I need, that I'm using. This is going to be the speed of these 4 objects, and they're all going to get random numbers between 1 and 6 actually. So they could go down as fast as 6 pixels every time through, or only 1 pixel. Okay, it'll depend. Now, the man near the center, this is basically where I want to sort of locate that man. He's going to be sort of halfway over in the middle of the screen. And then I draw the status at that moment. Okay, now if I press to stop the game, then I turn the flag off, and now I can't, move around on my keys again. And then the last thing we do when we start the game is we have to turn all our timers on. So there's a bunch of timers I use, obviously the game timer, there's a countdown timer thing, and there's a dribbler timer, and they all get enabled. Okay. Now, this one here that's just counting down to make sure the game doesn't finish, this is the tick timer, and I've set it so that it stops the entire game after 60 seconds. So I've set it to 60,000, I think, and let me just check here. We can see what the timer is. Whoops, I don't want to start the game again. I just want to look at it. So down here, time game is set to 60,000. Okay, we're in the home stretch now. This is the main part of the game, okay? And again, this is hints. You can slow it down, watch it again if you want, print out this program, do what you want. So every time I come into the timer, I'm going to slap the whole background on top of it. That's how you're going to get the illusion of animation. And now the power of arrays. We're going to be dropping 4 objects, okay? If you see the size of this, you would have had to repeat this 4 times if you didn't use it with arrays. So every time we go through the 4 objects, we're going to move that particular Y position for that particular object, object number 1, and whatever the random number was for the speed of that particular object. So if the first object goes down by 5 pixels, then it ends up down here now, okay? Now, I'm not really going to pay attention to where these balls are as they're dropping from the sky until that ball gets to basically on top of my head. So this basketball player down here, as these objects drop, when it gets to right about this level, I'm going to start to wake up. Now I'm worried. Now I got to know, hey, did it hit me? Okay, so this is what this first line's saying right here. Is the shape that's dropping from the sky on top or at that same level as his head? It might be over here. Who knows? Okay, but it's at this level now. So what do? Next, what I do is I kind of say two things at once. And I'm going to really draw this bigger to exaggerate it. I want to make sure that this is farther left than the man and this is farther right. Now, how do you say that? Well, the ball position minus 20 is going to be less than the man's X position. And then the ball position plus the ball size plus 20. So I'm going to go a little bit over to the right is greater than the man plus his width. So this is saying is the shape that I'm dropping right on top of him. And is it slightly over to the left of him and slightly over to the right of him? And this plus 20 is kind of like a little fudge factor, a little thing that just to make sure that it works. I'm going to go a little bit over a bit more than the actual number. Okay. And now if that's true, I sort of took the easy way out. I just did console beep. What I expect you to do is some really nice sound effect. Also, again, I took the easy way out. I only gave the guy 1 point. What I would expect from you guys here is a series of if statements that would depend on the speed of the ball. So you would say, listen, if the speed was less than 3 or more than 4 or whatever, give them a certain number of points. And again, my ball speeds were only between 1 and 6. You could change yours to whatever you want. Now, if this collision does happen, okay, that particular ball that was dropping down that hit me in the head, I move that to off the screen and let it start coming down again. But I also have to give it a new speed again so that it might be this time only 1 or 2. Okay, now what if you didn't get hit with the ball went all the way to the ground? Well, that's okay. Then again, same, make it go off the screen and pick a random number between 1 and 6. And there's kind of a weird way to do it. And if that's freaking you out, we'll put it back to 1 and 7. Okay, no problem there. Same difference. And then every time through this entire thing, you always redraw the man and you redraw the ball. Now, the thing is, notice, you're drawing sign square bracket I, not the particular sign. And it's at ball position X square bracket I, ball position Y square bracket I. This is the size of the ball that's dropping, and it's sort of rectangular or actually like a square shape in my particular example. Okay, so a lot of stuff to think about, and even for something simple like this, you can see all the mechanics of what you're doing. And again, if you think I went too fast to explain it, I've got tons of comments there to help you understand it. Good luck. What you should do now is take a break even for a week and try this out. We're not going to take it up after. This one's pretty close to the answer already, but I'm going to give you a chance to change the pictures and things like that. Before I go, a couple of cool sites you could use. This one's called Icon Finder, and some of it's free, some of it isn't. Okay, if you click on the free ones, there's all kinds of cool pictures. Look at that one right there. That's a nice high quality PNG that you could use. Here's a cool site for sound effects. You're looking for a particular dog sound, you can go to this site and it'll give you a choice of WAV or MP3. Well, good luck and see you in the next lecture. Welcome back. Hey, how'd you make out on that falling objects game? I hope you came up with something really neat. And if you want to, send it to me and I'll take a look. Well, we're at the almost end of the line. Our last 4 or so lectures are going to discuss some advanced graphics techniques. And what we'll do today is take a look at a technique called back buffering, which is hopefully going to reduce some of the flicker you may have experienced creating your last game. Okay, so hopefully you'll join us and it'll be really interesting. Okay, now one of the issues with graphics and especially with slower computers and some of the techniques we've been using is once you start getting a lot of objects on the screen starts to flicker. Our programs can't handle it. Maybe your computer can't handle it. And it's okay when you have one object falling from the sky and you have one guy at the bottom. But as soon as you introduce more objects and a lot of stuff going on, the end result is going to be a flickering effect. Okay, so what the developers at Visual Studio, C#, whoever did is they designed a technique which would allow for what's called double buffering. It's kind of clever, and here is kind of my rough, goofy way to explain it. So this is going to be the screen where you're playing your game, okay? And you might have all kinds of stuff happening. You got objects coming down, you got a guy down here running around, you might have other things shooting things. And if you were to display all of those events as they occurred, it would be flickering like crazy. So what somebody developed is they said, okay, do whatever you need to and put it in sort of an imaginary other screen, another image screen. So all of this crazy stuff is happening here, and images are getting put on the screen, maybe bullets are being fired, and every fraction of a second after we've completed one complete cycle of our draw images, whatever, we slap that back to the main screen. So in essence, you're not seeing one little itsy bitsy thing showing and then another one and then another one. That's why you get the flicker. All that happens in a screen that you don't see. And then at a certain clock cycle, we take that screen at that moment in time and we slap it back to the screen that you do see. And this effect actually reduces flicker. Okay, and this is called back buffering, or sometimes they call it double buffering. Okay, so that's the technique I want to show you today, and it's really a piece of cake. There's nothing crazy about it. All you got to do is do a little setting, and then you're ready to roll. All right, so the demos for this particular lecture, you should unzip those files, and we're going to go through a number of them today. So let's start off with animation 1, and I'll just run it for a second. You won't notice anything spectacular, but we've got two little tiny cars, and when I press start, they're going to go across the screen. Okay, no big deal. If there was 10 of them, might be a bigger deal, but you get the basic idea that we've got a slightly nice animation. Now, what's this new stuff? Well, at the very top of your program, I don't think you've ever written anything inside of this public, whatever your program happens to be called. Okay, usually there's this word initialize components. In there, I want you to type in this one word or this one sentence here. This dot double buffered equals true. That's it. Now, what's all this above it? Well, this is where I explained that back buffering or double buffering, as I mentioned to you a few seconds ago. Okay, so it's there for you to look at. This set of 3 commands used to be how it was done, maybe in Visual Studio 2008, maybe even in 2010. But the most recent versions, they've got it down to 1 line. So isn't that beautiful? Okay. Next, we are just using 2 images. We're not using any picture boxes anymore. That's old school. Okay. So we're going to grab a picture of a background and a car. Now we're going to repeat the car twice, so it's not like 2 different cars, kind of a lazy way out. This variable will have us start at a certain value, 0 or close to 0, and then work our way from left side of the screen to the right side. Okay. I don't know if you remember this. Remember that paint technique? Remember when you click on a form and not double click on it, but then you go to the lightning bolt and then you go to the paint routine. Okay, so we're going to use that technique, which redraws the screen. So what we do in the paint routine is we make an instance of the class, which we're going to call G. So everything's going to be G dot something. And then instead of putting all the stuff in there, I'm going to be kind of cool and I'm going to make a method. And I'm going to call it draw stuff. I know it's kind of a stupid name, but I'm going to pass to it the graphic that I just gave birth to in this paint technique. So all our dirty work is going to happen in draw stuff. It won't happen in paint. All right. So every time the screen gets repainted, refreshed, it'll go to draw stuff and it'll do whatever it's told to do. Okay. Now, what do we have in draw stuff? Well, every instance, whatever we decide to redraw, we're going to draw the background. Okay. And then we'll draw the red car at position X, comma 10, which means it's X over wherever that happens to be. I'll show you the initial number in a second. And then 10 down. And then the red car underneath it will be still the same part over, but 60 down. Now, what's the X? Well, in form load, it starts off at 0. Okay, and the start button, start stop, uses the traditional technique we've used before, dot enabled. Okay, so if it's on, turn it off. If it's off, turn it on. And then we get ready to roll. And basically, this timer here basically just makes the computer update the X value to more than what it was, okay, so that it will have the position of the car, and they'll be both going over it. So they're going to be tied the whole time. It's not going to be like a race that nobody's going to win. There's no random numbers. When it does get past the width of the screen, it's going to start off a little bit off screen at -100 and slowly come back Let me just show you that for a second so you know that it is coming back. So once they go through the wall, it'll come back out the other way. Okay, so that again is something that involved in that if statement. What's this word down here? Well, I'm going to show it off in a second. Not yet. I want to do it in order. So first thing, you're going, big deal. That didn't flicker, so what was so special about it? Well, let me see. Let me comment that line out for a second. And I hope this shows up on your screen at home. But watch when I've taken that off and it's just using standard techniques. Do you see that flicker? Okay, so it's pretty bad in that one. I don't know why it's so bad. We've had better ones than that, but that's all because I don't have double buffering on. Now, once I put that in there, the flickering should be reduced or almost gone. Okay, so there is in essence why we're doing what we're doing in this lecture, okay, to reduce the flicker in games. Now, even if I have 25 objects, this is going to help. All that flickering, all that stuff is going to happen off screen, and then every instant that I say to refresh the screen, it's going to slap it back on in one unit of time, okay? The whole thing will be there all on at the same time. Now, there's one extra command I haven't talked about that I'm going to mention right now. Once you paint the screen, great. And then unless you tell it, can you paint it again for me, please? It might not do it. And here's the proof. There's this command called invalidate. And if you don't call it after you update the screen, by that I mean you make the X 10 more than what it was, or you move yourself down or whatever, and then you say, okay, now show that, it won't do it. Watch, I'm going to press stop, and it's painted the first image, and now it's stuck there because you haven't told it to repaint the screen. So it's really important when you do this kind of work that you add and invalidate. Sometimes people add them in a couple of spots. I'm just going to put it right there. So every time I update the X value of how far I've moved across the screen, I'm going to tell the computer, hey, can you go back up and paint again, please? Which we'll call draw stuff. So watch this now with the invalidate in there. And we get our motion across the screen. Okay, so this technique is called back buffering. It incorporates this command right here, and of course this invalidate, which refreshes or repaints the screen. Let's take a look at another example. Okay, second example, kind of cool. I did not draw this one. You'll see in a second why, but it's neat. It's a multi-frame animation, and I'll slide this down over here. This is a series of images I got off the internet. It's a karate kicking baby, and we'll move it across the screen. So again, you're seeing the back buffering technique. A lot of images that we're cycling through, fairly realistic. I don't know how good it looks on your screen at home, but there is the same idea now with a multi-frame animation. So it reviews that idea. Let's go through it again to make sure you remember how we did this. Okay, so again, one line. This double buffer true, and it goes inside of that routine, just right where the initialized component is. Okay, this time we have a background, of course, and we're going to use an image of a baby, but I'm not going to load it here because I got to go through a bunch of different images of the baby. So I'm going to use a loop, and you'll see that in a second. Okay, there's 14 images, by the way, of the baby, and there's the counter, which I will start at 1 in a second. Now, when we press form load, all right, that will initialize a number of things for us. This X is going to be the position of the baby as it goes across the screen. This count will be how many babies. Okay, so we'll start count 1 to 14. This is how we load all the pictures of the babies. All right, and they're all GIFs. All right, you've seen that a million times. And this stores the first image into the image object baby. When we press start, we enable the timer as usual. This one uses a second timer, okay? And we've done this technique several times. You should know that by now. The second timer cycles through the images of the baby. When we get to more than 14, there isn't such a thing. We go back to 1. Notice there, I've snuck in the invalidate. Anytime you get nervous and you think, should I refresh the screen? I put 1 there, and I think I put 1 there. Now, you don't want to get too carried away with invalidate, then it gets too crazy. You might even cause flicker by doing it too often. But those are 2 safe spots for me that I know once I've done some math, I'd like to refresh the screen, and once I redraw the baby, it'd be nice to refresh the screen, okay? And you play it by ear. Sometimes you don't need both. Get rid of one or the other and see how it looks. Okay, so there it is. Basically the same technique, except now we had a set of frames of images that we cycle through. Okay, so there's our second example of back buffering and a new type of animation technique. Okay, our final example in this lecture is animation number 3. Okay, and we'll load it up and give it a little run for a second so you see it. Okay, I don't know if you can read that very well. Turn the numlock on, and then you're going to move with the left and right arrows with the 4 and 6 keys. Okay, so once I start, I'll do that, and you shoot with the 8. Oh, shoot with the 8. Oh, that's interesting. Am I actually going to shoot? Let me see. So this is moving the baby left and right. I'm using the number pad key on my computer. And let me see what it does with number 8. Oh, so I put my finger down on 8 and it made a sort of explosion sound. That's good. I need that. I'm going to use that in our next project challenge coming up in a couple of lectures. So I move left and right. The baby's dancing around like my basketball player, but this time I didn't draw this. I got it off the internet. It looks a little bit more realistic, obviously, when I put my finger down. That could actually shoot something in a future game. Yeah, that's cool. How did I do that? Let's take a look. So again, pretty basic stuff. This time I'm not going to use 2 timers, okay? Because I'm not letting the baby take off by itself. I'm controlling it. So if you're wondering where's the other timer, this timer is for the cycling of the baby images, which I showed you before. But this time we don't use another timer to make it go across the screen. I tell it when to go across the screen. All right, let's do a little prep work, and we'll go into the underground like we usually do. Start at the very top. Again, there's your this double buffered true. Piece of cake. I love that. So easy to do. Got a background image. There's the baby. Did that from before. Here's some new stuff. Okay, and I'm going to slide up here. And actually, this is going to be a little reminder. A couple of reminders, actually. This I taught you several lectures ago. This may be here by default now, but just in case it isn't, when you do double buffering, you know, it's nice to be sure. I'll highlight that right now. Sometimes you have to physically hand type that in, okay? Maybe not, maybe just check, okay? I know for sure there's system drawing. Double buffering is part of the drawing 2D. If you don't see it there, hand type that in also. And of course, from a previous lecture I showed you that to do music, sound effects, you need to add that. Okay, now let's slide down. We declare the sound player class, and we're going to make an object of it, which I call explosion. All right, so short bursts of sounds, I like using this. I don't like using the media player. I'd rather go this way. All right, in form load, I'll slide down to form load. We've done this already before. This is how you load in the image, but this is how you take the sound and store it into that particular object, which is a sound player object. And then this is how we load it in, and this one is called asynchronously. Now, this is the way I like the best. Okay, so this points to where that sound is on the computer, and then we load it in asynchronously. And now we're basically set. Okay, the rest of it we've seen before. So what happens this time? Well, did you notice I typed in some words? All right, so I wanted a nice little review in this one. And the words are up here and down here, just to give the player a little bit of an idea what they're supposed to be doing. So when I do that, that all happens in draw stuff. So I declare a font and a solid brush, and I draw the background, okay? And I draw string those words, I draw string those words, and then I actually draw the baby at position X, okay? So again, we use the paint event, but all we do there is call draw stuff. All our dirty work happens in draw stuff. Don't put anything else in paint. Okay, so that's kind of cool. Let's take a look at the keyboard event. So we'll go down to the bottom here, and we use the key down event. And because we're using the number pads, if we press the numpad 6, we're going to go to the right. If we press the 4, we go to the left. And if we press the 8 key, we're going to play an explosion sound, and then we're going to invalidate. Now, we don't want to get too crazy with invalidates. We've got a couple there, but at least they'll refresh the screen and display the results at that moment in time. One other reminder with the key down event, remember you have to make sure you put the key press event, and I'll see if I can find it here. Okay, so there it is, key preview set to true. So remember you do that to initialize the key down event, so it will work on your screen. So that's our first introduction to some advanced graphics techniques. I leave you with a little problem. Change this program right here. Add your own background. Go and find a strip of animation, tear it apart and add it to it, and see the effects now using double buffering, okay? And this new technique where we're going to paint and use draw stuff, okay? See you in the next lecture where we'll learn to use the mouse now in this double buffering technique. In today's lecture, we look at double buffering again, and this time how it can be used with the mouse. And the second half of the lecture, we will look at how you can use double buffering in a panel. Okay, so two nice little ideas to continue our path through advanced animation. Our base of operation in today's lecture will be a program called, well, what do you know, mouse. Okay, so it's in the resources for the last couple of lectures. I'm going to load it up. And it's kind of cool program. You're going to get a taste for, we're getting close to creating our next game, and it's going to be a bit more sophisticated, and I'll give you an example of what I'm talking about. So this one, it's almost like I've got crosshairs when I'm moving across the screen, and when I find something pop up, not that it's going to pop up right now, I'm going to put my finger down on the mouse, and I've got an explosion. Okay, so it's kind of like it knows exactly where I am, and I'm going to press down and create a little explosion sound. Okay, let's take a look at all the techniques that I use to do this. First thing, we do not use picture boxes, nothing. Okay, this one doesn't even have a start button. So what we're using obviously is the paint event that we've been talking about. We're using the back buffering. Let's go into the code and we'll start from the top and work our way down. So the first word here, that's it. This double buffered equals true. That'll make us create the double buffering technique. In this particular one, we've got the background image of those little whack-a-mole type spots. And I've also got a little image I found on the internet of kind of an explosion. We are going to have an explosion sound, so we're using the sound player. And again, I'll remind you, you always need to type in using System Media by hand yourself. And you may also need to hand type that in also. Now, in this particular program, for the first time in recent memory, we are going to use mice to shoot or aim things, and we need to know where they are. Okay, like you actually are looking at crosshair right there. So in a sense, we need to know the X and Y position of the crosshair of the mouse in my program. This is kind of a cool thing. Bool, remember, is a kind of variable that only has true or false. That's the only things it can hold in its brain. And what we're going to do is when I put my finger down on the mouse, I'm going to make the clicked equal to true to say, okay, I have my finger down, now draw the image of the explosion. If my finger is up, don't draw the image of the explosion. So we'll be going into the paint routine and constantly drawing everything. Sometimes we won't draw certain things, sometimes we will. Here is our paint event, speaking of the paint event. And remember, we put everything that we draw in draw stuff. Okay, now before I go to draw stuff, let me do a couple of little things, get them out of the way. Form load, we're loading in the explosion sound, okay, that we're going to use. And now we start the main process, okay? So we start moving around, You know how we move around. We've done it before. There's mouse move, all right? And this E.X and E.Y will tell us where we are at any moment in time. And I want the computer to remember that. And remember, these variables are known to the entire world. Remember, we declared them publicly above everything else. Okay, that's important. Okay, so that'll remember where they are at any moment in time. So let's take a look at the first thing where we're just drawing the crosshairs. How did we do that? Forget about the explosion for now. We're just doing a mouse move. See how I'm moving the mouse? So I want to know what's making that show up. So at any moment in time, this is where we're going to be because of the mouse move. Invalidate forces us to repaint. So it forces us to redraw those two lines, those crosshairs. How do you do that? Well, I did that with a pen. Remember, you draw lines with a pen. And we draw the one line and the other line, the vertical and the horizontal. Let's see if we can understand the math behind it. So here's our screen. At any moment in time, I move my mouse, and let's pretend I happen to be right there at that moment in time. How do I tell the computer to draw a line that goes from there to there and there to there. Well, let's see. So at any moment in time, to draw the first part of it, you would draw from mouse X. So I'm right there, remember. So I'm this far over, that much X, right? And 0. So that's how much to go over and 0. So that means put yourself right there. Okay, I get it. So these two numbers tell me to go right here, right? The second two numbers still tell me to go this far over, but then how far down? Client size height, remember that? That means to go all the way down to the bottom. Oh, I get it, okay. So that's the first point, and that's the second point. Now draw a line between those two endpoints. So this first pen draws the vertical axis, okay, the y-axis, so to speak. The second one, hopefully we can understand it too. I'll get rid of some of the scribbly stuff, and we'll redraw it to make sure we understand it. Okay, so we're here. I've already drawn this one, nice. Okay, let's figure out what's going on here now. This one says start at 0, mouse Y. 0, does that mean for the X? So don't go over at all. So start somewhere along this edge, but then how far down? Mouse Y down. So see where I am right now? I'm down at this level. So this says go nothing over and down to right about here. So there's my first point. This says now draw from the client size width. All right, so go all the way across. All right, and then mouse Y, go down to the same level as the mouse right there. So that's how you get your second point. So now we've got our first point, these two guys. We've got our second point, these two guys, and we draw a line from there to there. And that's how we draw the crosshairs. Isn't that cool? Okay, taking the numbers that we're feeding it with the mouse movement. Now, what's this stuff? If clicked equals true. Haven't taught it to you yet. Let's go to that right now. And actually, let me run it one more time. The click is not going to happen. So you know when I'm moving around right now, I'm doing these two lines, or 3 lines, but I'm not doing this because clicked is not true. Click is false right now. Why is click false? Because initially, when we start the program, we told the computer to make clicked false. So what makes it true? Well, the instant I put my finger down, remember how you do that stuff? You go over to the lightning bolt and you go to mouse down. So the instant I put my mouse down, and it's the left mouse button, then make click true, which means, hey, I give you now permission to make an explosion sound. Now here's the problem, and I'm going to backtrack in a few minutes to show you how I came up with this. But this was not what I considered my first solution. This is the enhanced solution. But anyway, I'll go with this one, then I'll explain what happened the first time I did it. This tells the computer now, good, you are now allowed to draw an explosion sound, but then it turns on this timer. It's almost like I'm saying, I'm gonna let you draw the explosion, but I'm only gonna give you a couple seconds to do it. Don't try to show off and have that explosion last for 10 minutes, okay? So this turns a timer on. Let's see what happens in this timer. The timer sort of wakes up for a 1/10 of a second, or I can't remember what I set it to. I think I set it to 200. Okay, so it doesn't stay on for too long. All right, it's not a 1/10 of a second, it's a 1/5 of a second. Let me just double check, press the timer, and let's go to properties here. Okay, and the timer setting is, yes, I said it was 200, right? So it's a 1/5 of a second. So it's going to take off, let the explosion do its thing for a 1/5 of a second, and then when the timer wakes up again, it's going to turn the click back to false, and the timer is going to turn itself off. So there isn't a lot of time. Now, when we invalidate, it's going to sneak there really fast, draw, and maybe stay there for a fraction of a second, and then that's it. So when we come to the draw stuff, while the timer's doing its thing, and you're hurrying and saying, come on, please, please, let me get the explosion in, I go, yes, the click is true, draw the explosion, and then make the noise. And then it might come back here again and draw a bit more of it, because a 1/5 of a second hasn't expired yet. But eventually it will expire and we're done. Okay, so that's the technique. Now it's kind of weird why I did that. I'll show you in a second. But anyway, what it does is when I press down, okay, if I press down and keep my finger down on the mouse, it's not going to explode again. All right, it does it for 200 whatever's, jiffies they're called, a fifth of a second, and that's it. When I let go, it doesn't do anything else. Now if I go down again and again and come back up, it will do that effect. All right, so that's the technique. Now another thing I need to talk about for a second before I wrap up the mouse movement is how to figure this out. Okay, so I'm going to draw the mouse explosion, the explosion right there. That's the variable that remembers the picture. This is the X and this is the Y. Now, how did I get it there? So when I'm right here and I want to make an explosion, what I got to do actually is, because the computer always talks in top and left, if I just said, okay, put the explosion exactly where I happen to be right now, which is like dead center right there, I'd press down here, but the explosion would be a little bit down and to the left because this is the top corner. Okay, so what I did is I took the box and put it sort of in the middle, so that means I got to go back and up a bit. That's why I'm doing a little bit of subtracting here, because I want the explosion to be dead middle of that. If I didn't, it'd be the top corner. Now, as I mentioned, you must be wondering, how did you come up with this crazy idea of making the timer show up for a second, letting the mouse have access to the explosion for a fifth of a second? Actually, I didn't at the beginning. Here was my first look at it, and to me this made the most sense at the beginning, the mouse up event. Basically, I put my finger down on the mouse, and then when I let go, it would put the click event back to false. So here's what happens when I use this technique. So I put my finger down, and my finger's still down on the mouse, and so the explosion doesn't go away. And then I let go. And then if I put my finger down, the explosion doesn't go away until I lift it up. Well, watch, I'm going to walk around with it. Well, that gets a little bit stupid. I'm walking around my finger down on the mouse until I let go, the explosion doesn't go away. So that was my first try at it before I updated it to the newer version, okay? So there you have it, using the mouse with some sound effects, some crosshairs, giving you some ideas for a future possible game. Let's finish up with a little bonus action. I'm going to show you how you could use double buffering inside a panel. So this last example is called Dynagraphics. Kind of a cool program. I'm not going to get too deep into it because it's a bit more advanced, but I want to show it to you first because it actually has a neat effect to it. So I'm going to drag with the mouse, and then I'm going to let go. And then notice how it speeds up as it goes along. You can use a mathematical expression to simulate that. So let's take a look at this program. Now, as I mentioned, I'm not going to go too deep into this program, but I want to highlight a couple of key things. First of all, we're going to use a rectangular class, and we're going to call the object R. You'll notice that I used that several times in there. There's our double buffering, but we're not going to do it here this time, all right? Because we're going to instance it in the panel. Now, you know how we had form paint? Well, there's our panel paint, so we use that same draw stuff technique. Okay, but I want us to go down to the very bottom. The way that you're going to create this double buffering in the panel is you're going to have to make a subclass. Do you sort of remember that from before when we did object-oriented programming? We called it inheritance, right? So you create this class called panel, which is like a daughter or a child of the master class called panel, right? And then you do this double buffered equals true in there. And now you can reference the panel. So every time you say G dot whatever, like we're doing right here, you're actually referencing the panel as opposed to the form. Now, if you want to spend a few minutes looking at this, there's all kinds of neat stuff in here. One of the ones that I think is really interesting is that it does almost like a collision technique built into the language. So this is saying, is my mouse inside the rectangle? Because the rectangle is that R object dot contains. So if my mouse is somewhere inside the rectangle, it allows me to drag it and drop it. Kind of cool, but it's probably beyond the scope of this introductory course. But I just wanted to show you some of the things you can do, and it is possible to create animations and everything in a panel using back buffering. Okay, so thanks for listening, and on to our next lesson. Welcome back, guys, and congratulations for getting this far. It's been a long process, and hopefully it's been rewarding, and we're now at the final stages of the course. What we're going to do over the next couple of lectures is take a look at game development. We're going to start off with something very simple, using back buffering and more advanced graphics. and we'll develop that and incorporate different features into the game. And in our second lecture, we'll finish off with a space shooter game. And then it's up to you. What can you dream up? Okay, so hopefully you're along for the ride. And again, congratulations for making this far. And let's take a look at the new topic. All right, let's get started. Hopefully you've unzipped the resources for today's lecture. And we'll start off with, and I don't laugh at the names, the Baby Game Keyboard version 1. That's what we'll load up first. And, we're dropped in here. This is good because I have to know what keys to press. Okay, just going to give you a sample run for a second. We'll start the game. So the baby's moving across, move down. Oh, I hit it. So what I'm doing is I'm chasing that other baby. And when I make contact with it, I get a point. And I also make that explosion sound. So you can see the totals being added up and how much time I have left. Okay, so kind of a corny kind of example, but it's going to prove my point, and we're going to develop it from there to more complex applications. Okay, so first of all, as you can tell, there's nothing on the screen. I don't use a panel. I don't have picture boxes. I'm just going to put everything on the screen. Okay, let's double click into the underground, and we'll start from the top down. We'll do a detailed analysis of this one, and then the other ones, they basically are these ones with one or two features. Okay, so we're using double buffering. All right, don't forget the system media and the drawing 2D for the double buffering. We have in this one the background, okay, and we have an image of an explosion. We are going to use the sound player class. We've seen this before. Here is our first sort of new command. I'm going to have an image of the baby, all right, and that baby has a location, X, Y. I need to know where that is. Now, there's also an image of a cycling baby. That's the one that's moving around, okay? And I'm going to initialize that and have a counter that's going to go from 1 to whatever. There's a baby I'm chasing too, right? And that one doesn't dance around. It's just very static. And what I do, as you'll find out in a few minutes, I usually pick a random number between 1 and about 14, and I pick one of the positions of the baby from the strip of images, and I make that what I'm chasing, okay? So that baby also needs an X and a Y. Okay, so a lot of, things you have to keep in your head all the way through the whole process. Where does this guy live? Where does this guy live? So locations are really important. We're also going to keep track of a score and a countdown and a bool hit to say, did that object get hit? If it did, make an explosion. If it didn't, don't do an explosion. This is new, okay? We're going to keep track of a timer to remember how long we've been playing. So we're not going to use the regular timer that comes with C#. We're going to use another built-in one. I'll show you it in a few seconds. Okay, so there's some initialization. You've seen this before. Draw stuff, I'm going to wait to explain to you. I'm going to slide down. Okay, in form load, we initially put the original baby that animates at position X and Y, about a third of the way across the screen, a third of the way down. The baby I'm chasing initially is going to be hidden off screen. Okay, we'll get to that particular baby in a second. This loads in all the images that make up all the frames of the dancing baby. This is the first image that goes into the baby. And originally I say put in the 14th image into the target. Okay, later on they'll be random. Loading in the sound effect. You've seen me do that before. This is a little bit of the new stuff here now. I want to keep the baby on screen for a certain amount of time, but I don't want to keep it there forever because then there's no challenge to the game. So I pick a random number from 3,000 to about almost 8,000 milliseconds. So it's between about 3 and 8 seconds, okay, roughly. Now, at that moment, what I want to do is remember what time it was, because now I start the clock working. And the instant that I remember what time it was when I initialized that baby, I'm going to count it down. And then when it's past that certain frame time, okay, then I'm going to change and make the baby go to a different position. So this is the time right now. This is the time I'm going to keep the baby on the screen, let's say 5 seconds. So I'll take the difference between what it is right now and what it was a microsecond ago, and that difference I'll keep track of until it gets to 5 seconds, and then I go, hey, time's up, change the baby's position. Okay, now, a little bit down, you've seen that before. That's how we cycle through the babies, and we do an invalidation scheme there. These are the keyboard commands to move the baby left, right. Oh, we do some up and down this time too, right? Which is good. Okay. This is the countdown timer for the entire game, and it'll display it on the screen. This right here figures out if I've made contact with the baby, okay? So I check for a tick, I check for a collision every time there's a timer tick, all right? And if there is a collision, I give the score a 1 and I initialize the hit to true because we're going to make an explosion sound. And I'm not going to go through this humongous if statement, but you know what's going on here, except for this last line, okay? So if there's a collision, and I've already given myself a point for the collision, sometimes I don't move off the baby fast enough. So what I do is the instant I do the first collision, I set hit to true, okay? And then when I get back to this line, because hit is true, it's, it says here if hit is false, I've already hit the baby. So I'm not going to give myself 10,000 points while I'm on top of the baby still. So what happens is once you make a collision, set the hit to true, and when it comes back to this line again, if it comes back fast enough, it will not give you more points. So it's kind of a neat little extra feature that I've added to the end there. That's important. You're going to see that in all the examples I do. In the initialize routine, once we start the program, we give the baby locations a certain number and a target. So initially in initialize, we set it to false. We set the count to 1. We come up with a random number for the new baby position. So every time we hit the baby, we're going to initialize again a current new location for the baby. We'll add a new frame time and we'll remember the time it is and validate. So there is the new game routine if we need to use it, okay? And it's called initialize. Okay, now to the main part of the program. We'll slide up here now into the draw stuff routine. Now in the draw stuff routine, we're always going to draw some information on the screen to keep track of, and that will be for the timer and the score. Okay, so we've got a couple of fonts we're going to use and the solid brush and the color. Now, as we're drawing stuff, I want to know what time it is right now, this instant. So I'm going to compare the instant time right now to what it was when it was set to put the baby at a location. If the difference between those two is greater than the frame time, that's it, it's over. Move that baby. You didn't hit it, too bad. And we go to initialize. And initialize, I just showed you a few seconds ago, was the routine that reset everybody. Okay, hit the false, gave them new positions to go to and go from there. Okay, let's slide back up. Sorry for the screen going so fast. Next, you're going to do this every time. You're going to redraw the screen here after moving the baby target. This reduces flicker. So we're going to draw the background, draw the score, the time, the baby, and the target baby. Now, if the time was up, great, we did that. Otherwise, you do this, okay? So you draw the score, the left, the baby, and you also check if you've hit it, okay? Now, remember, if there was a collision, hit was set to true. So this is like the cool way to say hit is true. So if hit is true, draw the explosion, play the explosion sound, and then initialize. So that now move the baby to a new location. Now we do have one more if. What if the countdown timer is 0? Game over. And we stop the game. Now how do you stop the game? I have a method called stop game. And all I do is turn off all the timers. So there you have, in a sort of brief little synopsis, the development of this game, okay, from beginning to end. And hopefully I've covered all the ideas. All right, what we're going to do now is add one little feature to each one of these games. So let me just quickly go through this again. We covered the draw stuff. And again, we only draw stuff during this particular if statement, okay? We have our load routine that initializes all the variables. We've got our timers either going on or off, depending on whether we start the game or stop. This is how we move the keyboard around and always invalidate just to make it smooth. Every timer tick, we're checking for the score and seeing if we hit anything. And the big thing here was we don't want to get 10,000 points every time we hit it. So once we hit it once, and the flag is false, great, we give them a point. But when the flag is true and we've come back here, don't give them a point. Just move away and go to the next one. Okay, so there is the first iteration of this game. Okay, here's our second iteration. You're going to laugh, but I thought it was kind of cool. So we start the game, and again, the baby's chasing the other baby. It's going up and down, but now he's going to get a little bit lazy, all right? So when he thinks it's in striking distance, he's going to shoot a fireball threw his stomach at him. Okay, and I don't know where that baby just went. Let's see if it shows up there. Oh, there it is again. Let's go up and get it and shoot a fireball. Okay, so there is the second iteration. So how do we create a fireball or some sort of flamethrower to come out towards it? Okay, let's take a look at the code. So again, we're not going to focus too much on all the new stuff now, but I did introduce a new image, the flame. So there it is right there. I did introduce a new sound, the laser sound, so I need that. And now the flame, okay? So when I shoot the flame, I know where it is, X and a Y. I need those numbers. And I also need a DX, which is kind of like a weird command. It comes from actually calculus, which maybe you've done, maybe you haven't, but it's the difference, the rate of change. So this flame, we're going to make it move at a certain speed. And sometimes we're going to make it move at 0, which means it's not going to move at all. Okay? Because I always want to draw the flame, even when it's not going to be shot. You'll see this little trick I use in a second, but that's going to be kind of a crucial trick I'm going to use. That's called the rate of flame movement. Okay, and the rest of it looks the same. We got the timer tick stuff. Okay, there's no problem there. Here's the draw stuff. This is how you get the clock time. And at that moment, it tracks it. So environment tick tock is a tick count. That's another command we did before. Now here's the thing that some students don't get when I show you this. How can you always draw the flame? You're always drawing the flame. Well, you know what? Most of the time, it's not even going to be on screen. So in actuality, I'm kind of drawing the flame, but it's going to be off screen. You'll see what I mean in a second. Actually, let me go down and I'll show you right now. Look where it is right now in form load. When I start the game, the position of the flame is off screen, and the DX, meaning the difference of rate of change, how it's going to move across the screen, is 0. So when you think you're drawing it and I didn't press it, well, I'm drawing it, but I'm drawing it off screen. Nobody sees it, and you don't hear it or anything like that. Now, rest of the game, I play the game, and I draw the flame, but again, it's off screen. The only time I actually make it show up on screen is when I press a certain key. So this value here may or may not be on screen right now. Now, how do I know that I'm going to draw that on screen? So I'm going to go down to my key down event. Now look at this. If I press the number 2 key, I take where I am right now and I go a little bit beyond that. Okay, so what I do is if I know I'm right here, this is the object and it's ready to shoot the flame, this is my XY position. So really I'm going to go about 35 over from that and then down about 10 to put me right about there. So that's where I'm getting these numbers from. So that's going to be the position of the flame, and DX is 15, meaning it's going to go by 15s across the screen towards the object that I'm trying to shoot. Okay, and then I make a little laser sound. Now, this doesn't draw anything. All this does is come back to the draw routine. Okay, and in the draw routine, it's always drawing the flame at the X and Y positions. Okay, and the DX implies that wherever it is, it's going to move when it gets to this timer, which I'll show you in a sec. Okay, there's the timer, and see what's happening right here? Every time you go onto the timer, now the DX is whatever number you told the computer right there. So if you told it 15, because your finger is down, every time we get to the timer now, we're going to add 15 as the flame goes across. Now, if the flame gets to the side of the screen without hitting anybody, then reset the flame speed, so to speak, to 0 and throw it off screen. Okay, you're done. All right, and again, we've got the collision detection now, but the collision detection, the first one was if the two babies hit each other. Now we've got the flame worrying about that, right? So now instead of just the baby and the position of the baby, now we've got the flame and the width of the flame. And again, same idea works there. And if the hit is false. So it's getting a bit more tricky, adding one more feature to it. And the whole idea of this trick is that the position of the flame is most of the time off screen until the person puts their finger down and says, I'm ready to shoot, so to speak. This doesn't wake up. The instant it wakes up, these values are given numbers. This is based on where the person's body is, and then go over 35 and down. And this is the difference of the flame movement. Now the flame's going to start moving and it's going to have a location on the screen. So kind of different, but that's the next iteration. Okay, here we go. Last iteration. You're going to laugh at this one. This last one's called the Baby Game Mouse version. Okay, and I've got it loaded up. This one's too easy. Would not be a good game for a mouse, but let me just start it off. So now I can just move my mouse and chase the baby, which is like too easy. I can also press my finger down on the mouse and shoot if I can find the baby that way. And the keys are still available to me, but I've got the mouse going now. So this is the last iteration. Okay, let's look at the code. We'll go into the underground and we'll work our way from the top to the bottom. Most of it should look familiar. As we get to new stuff, I'll tell you. So we've got all our images. There's flames, explosions, background sounds. We've got all our sound effects that we need. We've got our image of the baby and the position of it. That's how we cycle through the dancing baby. There's the target that we're chasing. Again, it needs an X and a Y. There's our flames. Okay, you need an X and a Y and a difference of flames. We got our score count, Boolean, random numbers. Everything looks good so far. There's our draw stuff. Nothing changed there. We have all our fonts that we need to put our images and text on the screen. That's the counter built into C#. That is kind of like a little clock that we're going to use. And we're going to compare the clock right now minus what it was when we set the frame time. And if the difference is over the frame time, let's say it was 3 seconds, then we move the baby, get lost, and put the baby in a new position. Okay? If we don't put the baby in a new position, we always display the background, the score, the time, the baby, the target, the flame. Now, if we hit the baby, either with the flames of the keyboard or in this case the mouse, we are going to make an explosion and make the sound. And then we'll initialize and put the baby to a new spot. Are we done? If the countdown to 0, then we stop the game. Initially, we load the positions of the flame and the baby off screen. You don't see them, and then we put them on the screen as necessary. This is all the images we use, and let's work our way down. Starts a new game. We turn all the timers on, stop the game, turn them off. This cycles through all 14 babies. Here's our keys. If we press the keyboard number 2, we initialize the flame and set the difference there so that it goes across the screen in 15s. There's the countdown. Here is the tick event, which every second or 2 or less, it updates the difference of the flame. Now, most of the time when it comes here, DX is going to be 0 because we didn't press the flame to shoot it. So it'll do this line, but it won't add anything to it. It'll be 0. Now, if it actually has a number and that number gets to bigger than the size of the screen on the right hand side, we set it back to 0 and throw it off the screen. Here's how we know if the baby hit the target baby or the flame hit it. Come on, mice. Okay, those are the initialization routines again. There's the new game, and we're finally at the mouse. Now, at any moment in time when we're moving the mouse, the E.X and E.Y send to the image of the baby the X and Y positions, and that will move the baby to wherever it is. The instant you put your finger down on the mouse, and it's the left button, you, just like you did with the keyboard, move a little bit over from the body of the man and down, and that's where you're going to initialize the flame, and then you're going to make the flame go across the screen in pixels, 15 pixels at a time. Okay, so kind of a lot of stuff to throw at you, but it's really repeating the same material over and over again. So there you have a quick little introduction into game development from really something very simple with the keyboard, then shooting something like bullets or gun flames at people, and then using the mouse to shoot or chase. Of course, chasing being kind of unfair. Okay, so there's our first iteration of our game development, and then we're going to take a look at even a better one in the next lecture. We're going to do a space shooter game that's got the whole package in it. Welcome back, guys, to lecture number 2 in our game development final episode, so to speak. So today we finish up basically the course, and we're going to take a look at just one game and really focus in on it. The last lecture, we went fairly fast. I apologize for that, but we covered a basic idea and made small modifications to it. Today, it's just one game. We're going to focus in on it. We sort of repeat some of the ideas I taught you yesterday. So I want to make sure that I show you one technique. I don't show you a totally different technique. I want to stick with that. I'm trying to be consistent. And what we'll do today is focus in on this one game, discuss all the features of it, and then maybe give you some ideas for something you could do. Okay, so the game that we're going to look at is called Space Shooter. I've loaded it up already. It's in the demos from yesterday's lecture, Space Shooter game. And I'll just pop up the main screen. So before we get rolling and demonstrate the game, remember, the basic idea when you develop a game is that you have some sort of loop. It could be a timer, whatever, and you're basically checking for the keyboard or the mouse. So then in the game, you're constantly saying, hey, did he press something? Let me do something. Then you basically update the positions of all the objects in the game. You make them go over by 5 or go up by 5 or something. Then you draw them at those new positions, and then you refresh the screen so they show up. So we do that invalidate. And you just continue this cycle, this game loop over and over again. So let me show you the Space Shooter, which I think I've probably demonstrated several times throughout the course, but here we are now today with the actual game, and we're going to analyze it. So we're going to have a little section up here for the current score, and time left is going to be like a timer or a counter to count down. And it says to turn on the numlock because we're going to use the 4 and 6 keys to move. This doesn't move up or down, it just moves side to side, and we're going to shoot with the 8 key. And then when we press, basically, music's going to start, a little background music, and there's going to be an object flying and bouncing off the screen. And we're going to try to shoot it with our sort of missile. Now, once we shoot it, another object will appear. Now, what we'd like to do in this game is have that object come from a different spot all the time. Because if we know it's always going to appear from a certain spot, it doesn't make the game very fair. So right now, it's always coming from that one spot. And I'm going to show you how you can change that also. And obviously, I can move along the bottom too. And the speed isn't great. I don't know how well it shows up on your screen. There are other ways to do this in more advanced courses, but for our purposes, it's kind of a neat little next step, so to speak, in the process. So there is the game, a little bit of background music, and other sound effects occurring at the same time. Okay, so let me stop that, and we'll take a look at the code from beginning to end. Now, as I explain this code, it should look very familiar because it's the code that we dealt with yesterday, but only I'm going to focus today just on this one game. Now, over here on the side, you can see right now I use the media player. That one's going to be for the background music that you saw or heard. And the other one's going to be with the sound player class. Okay, let's take a look at the code inside. And we'll work from top to bottom. And we'll remind ourselves of a couple of ideas. So we're adding double buffering. So we type that in. We're using the sound player class. So we use media. Okay, here is how we turn double buffering on. We've done that many times. Okay, and if you'll see, you'll go, hey, this is like the one he just did the day before. Yeah, I'm trying to be consistent. Do it the same way each time. So we have a background, and I'm going to load that off my computer. I'm going to have a bullet, or what I call a bullet. It's going to be like a little tiny rocket that I fire out from my big rocket ship. I'm going to have an explosion. Okay. And I'm going to have the object that's attacking us, so to speak. It actually can't kill us, although that would be a nice feature too, to come in at us and we're trying to get it. Okay, so those are the main objects in my game. Now, each one of those things needs to have a position, remember? So the position of the ship at the bottom, we're going to store that into X and Y. Those things we're shooting at, those are the targets. That's going to have an X and Y. And the speed they're coming down at us is a dx and dy. So it just means how far over to the x and how far down to the y are those moving. And we can change those numbers to make them come faster or slower. The bullet, which isn't really a bullet, it's a little mini missile or rocket ship that I'm firing, also needs a position, and it needs a dy. Dy meaning how's it going to move? Now this one only moves straight up and down. It doesn't move side to side. So that's why I don't have an x for that one. Okay, obviously we're going to keep track of the score. The bool hit, that's how we're going to know whether to make an explosion or not. The ship at the bottom is a little animated ship, so we have a bunch of images for it. the image of the ship itself is stored in that variable ship, and it has a counter that will loop through from 1 to 16 for all the ships. Countdown is for the game to count down to say it's over. Of course, we're going to use some random numbers, and I'll show you where in a few minutes. The game itself is going to have 3 sounds: the explosion sound, and the laser sound, and some other background music that I'll show you in a few minutes also. Okay, so we instantiate the graphics so that we draw on the form. And the draw stuff routine looks pretty well the same as we've been used to. We've got some stuff that we're going to display as text, so we need some fonts for that. We always redraw the background. That gives you the illusion of animation. This is some more text that we draw on the screen. This set it up, and then this actually displays it. This is how we draw the ship at any moment in time. It's at position XY. This is that object flying in from the top that's bouncing off the walls, the T-bird. We draw that constantly. And again, the same trick here. The bullet, or that mini ship I'm firing at the target, I draw it, but do I really draw it? It's off the screen most of the time. But I put that line in there because I constantly draw it. It's kind of an easy way to save space, and the trick is that you're going to have the position of it off screen most of the time. Now, if there is a hit, and that'll be done in another routine, you draw the explosion sound and you make the explosion sound, and then you call initialize, because now you have to restart the target from the top. Countdown. Hey, are we at 0? If we are, stop the game. Now, when we initially load the game, we hit the false, obviously, and we should. Score 0, countdown 60. We start at 60 and work our way down. We initially have the little thing that we're going to shoot at come out from 120 over and 5 down. And this is where you could make your game more challenging. Instead of it being always from the same spot, pick random numbers so that you don't know where it's going to come from. And that would be a nice feature to add. The bullets that we're going to shoot with, right now I've hidden them off screen. They could be in negative territory, positive territory, but you don't see them, okay? So that's one of the tricks. Once we need the bullet, we'll put it close to the spaceship, just above it, and then we'll aim it and shoot it, okay? But for now, they're off screen, and we're drawing them really off screen. This loads in all the images that we need. It stores the first image of the ship into the ship image object. Okay, right here we set up the location of the rocket ship near the bottom of the screen, okay? This loads in all our sound effects, and I like using asynchronous, so you see that right there. Button start turns on all our timers and initializes the game. The initialize routine here initializes to false, so what happens here is that once you do hit the target, this is where you go constantly in the program to reset the position. And again, I put a little target off screen, and then I put it at 120 and 5. And again, right here, you can use random numbers to make it look better. The target speed, the way that it bounces off the wall, it's going to go 20 over and 10 down. And when it hits the wall, it's going to bounce in the opposite direction. Now, as I mentioned here, you could use random numbers also for the speed. So if you wanted to, not only could you have it come out from a different spot, but come at a different speed. So it really would be a much more challenging game. And again, here we have the bullets off screen, and the bullet DY, meaning the speed that the bullet moves up, is initially 0. And that's the same trick we used when we did the flame throwing in the baby game in the previous lecture. Here is new game. This is you do at the very, very, very beginning of the entire game. This plays that background music that you saw me do, okay? That's the background music that constantly plays throughout the game. There's stop game, you've seen that before. There's the timer tick to cycle through all the images of the spaceship at the bottom. Here's our key down event, which you've seen before. 5 is going to make me go 5 to the right. I mean, the 6 key is going to make me go 5 to the right. The 4 key is going to make me go backwards 5. The number 8 key is how I shoot, and in this one, I'm not shooting from the body of the little baby, but I've got that spaceship down at the bottom, and it's shooting up at the screen. So what I say to myself is, this is where our sort of key point is. Now go over 35 and go down a little bit. So it's almost like it's going to come out of the spaceship. And then bullet Y, oh, minus 20, what does that mean? Well, when you go up, you're actually subtracting. Remember, in the terms of height of the screen, this is 0 and this is a big number. Let's pretend it's 1,000. So from where you are, you have to go to like a big number to a small number. So you're actually subtracting. So that's important. That's the dy that will kick in once we start the position here. Okay, it'll just keep subtracting, subtracting, subtracting. It's working its way up towards whatever it's shooting at. Okay, and obviously we play a little laser sound. In the timer tick, we are going to update the bullet if there is a bullet. Now, most of the time, that dy right there is going to be a big fat 0. So it's going to do the math, but it's going to do nothing. The target also is moving constantly, bouncing off the screen, going crazy. Now, the bullet that we shot, if we shot it, and now it has gotten to the very top, set it back to 0 and throw it off the screen. That crazy target that's bouncing off the wall, look at all 4 things that it could do. Does it bounce off the right, the bottom, the left, the top? As it bounces, make it go in the opposite direction. So those are all the sort of collision against the wall checks. Here's our classic collision routine, and you better know at the very back is that part where it says hit equals false. And again, what I'm trying to tell you here is the computer is so fast, when you hit something sometimes and you think you've gotten your points, it comes back here so fast that it would give you more points. So what you have to do, the instant you hit it the one time, set a flag to true or something, so that if by chance it's so fast that it comes back here before everything gets cleared up, you say, hey, listen, is this the first time ever that you hit me? Because if it is, I'll let you get points. But if it isn't, you're not going to get any more points. Okay, so that flag is important, and sometimes you don't realize this until you make your game, and all of a sudden you've clicked on a guy or you hit a guy and you see your points going up by thousands and thousands. You go, what the heck happened there? Because it's stuck to it, or it's so fast that it came back to here and gave you more points. And there is, in a nutshell, the game. Okay, and if you think about it, I didn't really show you a ton more than I had before. I threw in, instead of the little flamethrower, I threw in a bullet, and the bullet goes straight up and down. So it's, instead of a dx, which means it would go across by a certain amount, it's a dy. But everything else is the same. So, you know, this time one topic, and I did it exactly the same mold as the other ones. So there you have it. A simple application that developed and used a lot of the concepts. We used, arrays, we used if statements, loops, methods, all kinds of different things that we taught you in the course. So there you go. That is an introduction to C# using applications as much as I could. Okay, guys, I really am passionate about this material, and what I hope you got from throughout the course is that I wanted to do it in a simplistic way. It wasn't meant for software engineers or anything. It was kids that are starting to get the urge to program, because it's such an exciting field that has so many doors you can open. And just because you learn C# doesn't mean you're trapped in this language now. Lots of languages are very similar to this. Java, very similar to this language. If you learn any other language, you're going to get to know the same construction, the same if statements, the same kinds of loops, that'll be easy for you to go from one language to another. But at least here you saw not only the theory of the language, but a lot of practical applications. You go, oh, so that's how they did that. And you see the background, and now you get to appreciate that. In the final lecture, I'm just going to do a little wrap up, tell you what you can do next, and thank you for taking the course. Hi guys, welcome to the wrap-up lecture on our introduction to C# programming. And a sincere point of thank you for taking the course. I appreciate the time you put into it. Hopefully you got something out of it. And again, the perspective of the course was for, in quotes, teens to be introduced to software development. And I tried to do it from a perspective where you just didn't learn the code and that was it. I tried to do practical applications from the real world that would allow you to see how these commands could be used for practical things that you see every day, from a cash register to working in a doctor's office to taking a look at graphs from science and math that you would work on. So hopefully you appreciate that. And of course, we finished off with some games that a lot of students like to see, especially teenagers. Now, in terms of what you could do after this, certainly arrays, you're going to need to learn a lot more about arrays, especially multi-dimensional arrays. Recursion, a really neat topic, is a topic that you should become familiar with. And the number one topic is object-oriented programming. We just touched the surface of it. We hit it in a few spots, but really to become a serious programmer, you're going to have to learn quite a bit of object-oriented programming. So if you're looking for another course, that would be a direction to go into. Now, speaking of other courses, I may eventually make the second level to this one also. Stay tuned for that. But for now, this is goodbye, and thanks for taking the course. Hi guys, welcome to my new section on programming challenges. This new section serves to extend the idea of coding and computational thinking by offering a series of advanced problems that review many of the major components we've covered in the course. So what I'd like to do for the next couple of minutes is just give you an idea of the types of questions I'm going to ask and how I'd like them to be solved. Let's say, for instance, you decide to do programming challenge number 1, as you see on screen right now. Each programming challenge will have a PDF file which will clearly show you the question, and then I also will have the full solution. Now, within that solution will be some data file that you can use. What I'd like you to do, obviously, is not look at the solution first, just use the data file to help you create your solution. Once you've downloaded all the important information, you should have somewhere on your hard drive something that looks like this. So you would have had the PDF file that you downloaded. This is going to be the question that you're going to work on. And then you would have a zipped up file that contains the actual code. Once you unzip it, you would get a folder that looks like this. Inside that folder would be a number of pieces of information. Again, the problem statement as a PDF file, the actual solution in the C# folder, and these two other folders. This one is going to contain the data file that you're going to use to solve the question. Each one of these questions involves loading a data file and then using that information to solve whatever problem I ask you to solve. We'll review some of that also in a minute. And that's your solution. And then I've got two other more challenging data sets that you could also use to test out the solution to make sure it works. Okay, so that's all the information that you've got set up in your file. Now, just for fun, let's take a look at a problem, the first one that you may want to try. Here it is right here. It's called the 4 in a row problem. And after you read the question and try to figure out what they're trying to do, you must realize that these numbers that they give you, they're going to be stored in a data file. They're not going to be created or used via input or text boxes, okay? And then I'm going to give you a sample output that I want your solution to look like. After you get that to work, and hopefully you get it to work, I include two other sample cases, okay? And here is a second set of data, and I show you a second set of solutions that your program should be able to handle. So even if you've got your first set to work, try these out. These might be a bit more challenging, a bit more tricky, that sort of test the limits of the solution. And then I've got a second set of data, and again, another set of solutions. So each one of the questions you're going to see, and there's roughly about 10 of them, are going to have this format. There's going to be a statement of the problem, okay, above. There's going to be a simple set of data for you to try out in a simple solution, and then a second and third set to take your testing of your program to the full maximum limit. Now, as I mentioned, the solution to the question is in here. And the only reason I want to show you this part right now, I'm not going to show you the full solution, but I'm going to show you a couple of things that maybe you need a refresher on. So remember, when you create your project, what you're going to do in a folder in the bin is create your data file, or copy and paste mine over there, whatever you want to do, but that's where you're going to store your data file. So for this particular question, there's the data file that I have already in the debug folder. Okay, so you need to make sure you make a text file, and it's going to be your data for the particular question that you're going to work on. Let's, for fun, load up the program and sort of review how you load in a data file if you forgot how to do that, and just give you a basic setup of how I want a typical solution to look like. And again, I'm not going to try to show you the full solution. I want you to try it yourself, but obviously you give it a good try, and if you don't get it, you can obviously look at mine after to see how I did it. Okay, so most of these solutions, I want them to have this particular format. Basically, you're going to have a button on the screen and probably some sort of text box, combo box, something where you're going to put your solution to the question. So just for example, I'm just going to run this. And what you're going to see basically is just a simple screen with a button. and then a text box in this case that has multiple lines turned on, and scroll bar on the right hand side. And here we go. So basically, when you press this, there's not going to be any prompting. It's basically going to grab the numbers from the data file and then print out the solution to the question at hand. Okay, so there is a typical solution. And in this one, only one of these numbers with a sum of 4 consecutive integers. So that's a kind of an interesting solution. Okay, now let's review some of the ideas that you need to make this program work. And in general, every time you do one of these questions, you're going to use a data file. So you're going to have to hand type that back in, okay, using System.io to tell the computer you're going to use a data file. Now, you can use lots of methods. You can do it any way you want. You can do it all in one little routine. It's up to you. But let's review how to make a data file load up. So you have to remember startup path. You're going to make it point to the debug folder, which by default is the application startup path. Then you're going to attach the name of the file. So in this particular case, our text file is called 4.txt. And each question, I tell you exactly what to call your data file. Then you activate the stream reader, and now you're ready to roll. And most of these, you're going to have some sort of loop that's going to go on forever and ever until you get to the end. Usually the end will be a blank. Okay, sometimes it's a special number, and if it's a special number, instead of a blank, you will change this to whatever special number or word that is the end of the file. Okay, but usually it'll be just go to the last blank line. Okay, so you use a while not finished. If you remember that, you're going to read in a line. And remember, when you read in a line, it's a text file, so it's a text. So you have to make sure to convert it if you need to do any math to it later on. Okay, and without giving away too much more, I use a method in this one that will return a value, and you can sort of see the beginning of the method there without giving away the rest of the answer. Okay, but I wanted to make sure you remembered how to use a data file, so you have to make sure you add that at the beginning. Okay, if you don't, it won't work. And then this is the basic setup of a data file, and then you use some sort of loop. Usually I like using this while not finished. Read a line. If it's the blank, you're finished, get out. If it isn't, then do the question that you're assigned in the problem for this particular challenge. Okay, so hopefully that gives you a basic idea of how everything works, and all the questions are fully solved for you. Okay, and if even after you look at the solutions you still don't get a solution, please message me and I'll be more than happy to explain them further. But hopefully this acts as a nice little recap of all the material you've learned in the course, pushes you a little bit more, challenges you to show you some of the more challenging things you can do with what we've learned. Okay, thanks for listening and good luck. Good luck with all the problems.